everyone and welcome to the AWS DevOps full course. In today's world of cloud computing and rapid software delivery, combining the power of Amazon Web Services with DevOps practices has become essential. This course is designed to help you master the tools, technologies, and processes required to build, automate, and deploy applications at scale using AWS. You will learn how to set up CI/CD pipelines, manage infrastructure as code, automate deployments, and monitor systems efficiently. From version control with Git to tools like Jenkins, Docker, CloudFormation, code pipeline, and much more, this course covers everything you need to become a skilled AWS DevOps engineer. Whether you're starting your DevOps journey or looking to upskill with AWS, this course will guide you step by step with hands-on projects and real-world examples. So before we get started, please like, share, and subscribe to Edureka's YouTube channel and hit the bell icon to stay updated on the latest content from Edureka. Also, check out Edureka's DevOps certification training course with Gen AI. This course is designed to equip learners with the skills to master AI-integrated DevOps across the entire software delivery lifecycle. Through hands-on learning, you will gain expertise in building intelligent, automated, and secure CI/CD pipelines. This comprehensive course covers essential tools like Git, Jenkins, Terraform, Ansible, Docker, Kubernetes, and monitoring frameworks, while also integrating AI-driven solutions for code generation, testing, and analytics. So check out the course link given in the description box below. Now, let's get started with our first topic, that is Introduction to AWS.
So what exactly is AWS? Well, AWS is Amazon Web Services and it is one of the best cloud service providers in the market. Well, it is a complete software suite or a cloud service provider which is highly secure. It provides you with various compute, storage, database, and n number of other services, which we would be discussing in further slides as well. And when you talk about the market, it is the best and it has various reasons to be the best in the market. One being its flexibility, its scalability, and its pricing. Other reasons being its compute capacity. Now, why is it so important, the compute capacity? Well, if you talk about the compute capacity, you need to understand one thing. If you take all the other cloud service providers in the market and you combine their compute capacity, that is, you leave out AWS and you take all others into consideration, the space would be somewhere equal to say X. And if you compare it with AWS, it is 6X. So AWS has more compute capacity, which is 6 times more than all the other service providers that are there in the market. So that is a huge amount. So these are the reasons that make AWS one of the best in the market. And let's try to find out what are the other reasons about AWS that make it so good. What are the services, features, and its uses basically. So I would be discussing some use cases now. If you're talking about a manufacturing organization, now their main focus is to manufacture goods, but most of the businesses, they focus so much on various other services or practices that need to be taken care of that they cannot focus on the manufacturing goal. Now this is where AWS steps in. It takes care of all the IT infrastructure and management. That means businesses are free to focus on manufacturing and they can actually go ahead and expand a lot. Architecture consulting. Now their main concern is prototyping and rendering. AWS takes care of both the issues. It lets you have automated or speed up rendering as far as prototyping is concerned. And that is why architectural business benefit a lot when you talk about using AWS or any cloud provider, but AWS being the best in the market, again, their services are the best. Media company. Now, as far as a media company goes, their main concern is generating content and the place to dump it or to store it. Again, AWS takes care of all these situations or both these situations. Large enterprises. When you talk about large enterprises, their reach is worldwide. So they have to reach their customers and their employees globally or across different places. So AWS gives you that option because it has a global architecture and your reach can be very wide as far as these points are concerned. Now, advantages of AWS. As I've mentioned, I won't say advantages exactly. I would say features as well. Flexibility. Now, as far as AWS is concerned, it is highly flexible. Now, there are various reasons to support it. And one of the major reasons is it's very cost effective. Let us try to understand these 2 points together rather. Now, when you talk about flexibility, the first concern you should have is you are dealing with big organizations. They have a lot of data that needs to be managed, deployed, and taken care of. Now, when you talk about a cloud provider, if it is flexible, all these things are taken care of. The second thing is it is highly cost effective. Now, when I say cost effective, AWS takes care of almost every aspect. If you are a beginner or a learner, they have something called as a free tier. That means you have sufficient resources to use for free, and that too for one long year. So you would have sufficient hands-on without paying anything. Plus, it has something called as pay-as-you-go model. Now, when I say pay-as-you-go model, what it does is it charges you only for the services which you're using and only for the time being you're using them. Again, that lets you scale up nicely, and hence you end up paying very less. Since you are paying very less, and since you have so many options when you're actually buying its services, what that does is that gives you a lot of flexibility. Scalability. Again, the first 2 points are related to this point. Now, how is that? Now, when I say scalability, what happens is, as I've mentioned, it is very affordable. So you're paying on hourly basis. If you're using a particular service for 1 hour, you'll be paying it only for 1 hour. That is how flexible it is. And what that does is that gives you a freedom to scale up and even scale down. Since it is easy to scale up, it is always advisable that you start with less and then scale as per your needs. Plus, there are quite a few services that are there which can be automatically scheduled. Now, what that means is you'd be using them only when there is an uptime, and in downtime, you can miss those get automatically shut down. So you do not have to worry about that as well. So when you talk about scalability, scaling up and down is very easy as far as AWS goes. Security. Again, now security has been a topic of debate when you talk about cloud services especially. But AWS puts all those questions to rest. It has great security mechanism, plus it provides you with various compliance programs that again help you take care of security. And when you talk about real-time security, even that is taken care of. You can take care of all the suspicious activities that are there, and not you, AWS takes care of all those things, and you're let free to focus on your business rather. So these are the advantages which I feel that AWS adds value to. And apart from that, there are quite a few other points, like we have automated scheduling, which I just mentioned. You have various integrated APIs. Now these APIs, they're available in different programming languages, and that makes it architecturally very strong to switch from one programming language to another. So these are some of the features I feel that make AWS a wonderful, wonderful service provider in the market. So let's move further and try to understand other things as far as AWS is concerned. It's global architecture. When you talk about AWS, as I've mentioned, it is the best service provider in the market. So what makes AWS this popular? One of the reasons is its architecture. Now, when I talk about its architecture, it is very widely spread and it covers almost every area that needs to be covered. So let's try to understand how it works exactly. Well, if you talk about AWS architecture, now the architecture is divided into two major parts, that is regions and availability zones. Now, when you talk about the regions and availability zones, regions are nothing but different locations across the world where they have their various data centers put up. Now, as far as one region goes, it might have more than one data center. And these data centers are known as availability zone. You being a consumer or an individual, you can actually access these services by sitting anywhere in the world. To give you an example, if I'm sitting in some part of the world, say for example, I'm in Japan right now, I can actually have access to the services or data centers that are there in US right now. So that is how it works. You can choose your region and accordingly you can pick your availability zones and use those. So you do not have to worry about anything. Domains of AWS. Now, when you talk about its domains, the first domain that we are going to discuss is compute. And when you talk about compute, the first thing that should come to your mind is EC2. Now, when I say EC2, it is Elastic Cloud Compute. And what it does is it lets you have a resizable compute capacity. It's more of a raw server where you can host your websites, and it is a clean slate. Now, what do I mean by this? Say, for example, you go ahead and buy a laptop. It is a clean device where you can have your own OS. You can choose which OS you want and all those things. Accordingly, your EC2 is again a clean slate and you can do so many things with it. Now, next you have Elastic Beanstalk, which lets you deploy your various applications on AWS. And the only thing you need to know about this thing is you do not have to worry about the underlying architecture. Now, it is very similar to your EC2. And the only difference between the two is, as far as your Elastic Beanstalk is concerned, you can think of it as something that has predefined libraries, whereas your EC2 is a clean slate. Now, when I say predefined libraries, say for example, you want to use Java. As far as EC2 goes, now this is just an example, don't take it literally. You'll have to say, for example, install everything from the beginning and start fresh. But as far as your Elastic Beanstalk is concerned, it has this predefined libraries and you can just go ahead and use those because there's an underlying architecture which is defined. Let me say it again. I just gave you an example. Don't take these sentences literally. So next we have migration. When you talk about migration, you need to understand one thing. AWS has a global architecture and there would be a requirement for migration. And what AWS does is it lets you have physical migration as well. That means you can physically move your data to the data center which you desire. Now, why do we need to do that? Say, for example, I'm sending an email to somebody. I can do that through internet. But imagine if I have to give somebody a movie. So instead of sending it online, I can actually go ahead and give it to someone if that person is means reachable for me. And that way it would be more better for me. My data remains secure and so many other things. So same is with data migration as well. And when you talk about AWS, it has something called as Snowball, which actually lets you move this data physically. Now it's a storage service and it actually helps you in migration a lot. Security and compliance. Now, when you talk about security, we have various services like I have IAM, we have KMS. Now, when I say IAM, it is nothing but your identification and authentication management tool. We have KMS, which lets you actually go ahead and create your own public and private keys, and that helps you keep your system secure. Then we have storage. Now, when I talk about storage, again, AWS has quite a few services to offer to you. We have something called as your S3. Now, S3, it works as a bucket object kind of a thing. Your storage place is called as a bucket and your object which you store in are nothing but your files. Now, these objects have to be stored in their root files, which act as the buckets basically. And then we have something called as your CloudFront, which is nothing but your content delivery network. We have something called as Glacier. Now, when you talk about Glacier, you can think of it as a place where you can store archives because it is highly affordable. Next, we have networking. Now, when you talk about networking, we have services like VPC, Direct Connect, Route 53, which is a DNS. Now, when I say VPC, it is a virtual network which actually lets you move or launch your resources. That is your AWS resources basically. When you talk about Direct Connect, you can think of it as a leased internet connection which can be used within AWS. Next on this list, we have something called as messaging. Yes, AWS assures secured messaging, and there are quite a few applications to take care of that as well. Now we have something called as CloudTrail, we have OpsWorks, all these things, they help you in messaging or communicating with other parties basically. Databases. Now storage and databases are similar, but you have to understand one difference. When you talk about your storage, that is where you store your executable files. So that is the difference between the two. And when you talk about databases, we have something called as your Aurora, which is something which is very SQL like and it lets you perform various SQL options at a very faster rate. And what Amazon claims is it is 5 times faster than what SQL is. So yes, when you talk about Aurora, again, a great service to have. We also have something called as DynamoDB, which is a non-relational DBMS. And when you talk about non-relational DBMS, I won't be discussing that, but this helps you in dealing with various unstructured data sources as well. Next on this list, we have the last domain, that is the management tools. Now, when you talk about management tools, we have something called as CloudWatch, which is a monitoring tool, and it lets you set alarms and all those things. So this was about AWS and its basics, as in the points which we just discussed, that is what it is, its uses, its advantages, its domain, its global architecture. So yes, guys, what I've done is I've gone ahead and I've switched into my AWS account. The first thing you need to understand is what AWS does is it offers you a free tier. Now, while I was talking about these things, I just rushed through it because I knew that I was going to give you a demo on these things. So, and I wanted to discuss this thing in detail. Now, when you talk about AWS, if you're a beginner, this is where you start. Now, what AWS does is it provides you with its free tier, which is accessible to you for 12 months. And there are quite a few services which we just discussed, which are available to you for free. And when I say free, there's certain limitations on it, as in these many hours is what you can use it for, and this is the amount of memory or storage you can use in total, and all those things, and its capacity and everything. Based on that, you have different instances which you can create and all those things. Now, what AWS does is it gives you these services for free, and as long as you stay in the limits that AWS has set, you won't be charged anything. And trust me, when it is for learning purposes, that is more than enough. And let's quickly go ahead and take a look at these services first, and then there are a few other points which I would like to discuss as well. But firstly, the free tier services. Now, say this is what it has to offer to you: 12 months of free and always free products. When you talk about EC2, which is one of its most popular compute services, 750 hours, and that is per month. Next, you have Amazon Quick Site, which gives you 1 GB of spice capacity. Now, I won't get into the details of these things, as in what spice capacity is and all those things. When you have time, I would suggest that you go ahead and explore these things, as in what do these things do. Today, we are going to focus more on the EC2 part. So for now, let's quickly take a look at these one by one first. Amazon RDS, which gives you 750 hours of your T2 micro instance. Amazon S3, which is a storage, which again gives you 5 GB of standard storage. And AWS Lambda, 1 million free requests per month. So there are some of the videos here actually which would introduce you to these things that would help you get started with how to creating an account and all those things. And this is the other important point which I would like to mention. When you do create an AWS account, the first thing you need to consider is they would be asking you for your credit card details. So how does the login process work? Firstly, you go there, you give in your email ID and your basic details, as in why do you want to use it and all those things. Next, what it would do is just to verify your account, it would ask you for your credit card details. Even the debit card details work. I've actually tried those. So you can go ahead and give your credit card or debit card details. And when you do that, what it does is it subtracts a very small amount from your account. I did this in India and I know that I was charged 2 rupees, which is fairly less. And that was again refunded back to me in 2 to 3 working days. The only reason they cut those 2 rupees was just for the verification purpose that my account is up and running and I am a legitimate user. Now, as long as you stay in the limits, you won't be charged anything. But if you do cross those limits, you'll be charged. Now, you might be worried, as in, what if I do cross the limit? Would I be charged? Yes, you would be. But the fact is, you actually won't go beyond it. And even if you do, you'll be notified saying that you are going about the limit or above the limit. Even when your free subscription ends, you're notified saying that do you want to enter your billing details and do you want to start billing? And if you say yes, only then you'd be charged for the subsequent months. And that is a very stringent process. You don't have to worry about it. That is, you won't be losing out on any money as long as you follow these rules. So if you do not have an account, my suggestion would be you go ahead, you log into AWS and create your free tier account, which is a very easy and 2 to 3 step process. Once you've done that, these are the services that are available to you and you can go ahead and use all of these services on your own. Next, we have something called as your simple monthly calculator. Now, this is a very useful app to have. What it does is whatever service which you are going to use, you can enter in the detail and accordingly you'll be given the price as well. Now, this is something for use after your free tier ends so that you know that if I have to use these services, how much would I be charged? And this thing will tell you in total. Now, if you can take a look at here, you have these services. Say, for example, I want to add an EC2 service. An instance gets added here. I can put in the description. Now it is Linux T1.micro instance. And this is what my monthly cost is. I can go ahead and I can change the number of instances here to suit my need. And accordingly, everything would get verified as in, okay, this is the cost and all those things. So if I enter these values, my AWS calculates all the values accordingly for my storage, for my compute, and there are the other details which you can go ahead and fill in here. And once you've done that, you can actually come here and you can check your estimate monthly bill, because once you save those details there or once you calculate those details, here would be your monthly expense because you would be dealing with more than one instances. So your different costs are added together and a total is given to you here. And you can actually go ahead and save it and share it with others, because yes, you might be required to exchange these details with some of your colleagues or whatever it is. And to do that, you have an option here as well, which is provided by AWS. There was a query on Stack Overflow once, as in, can I do that? And AWS quickly responded by going ahead and solving this issue and giving them with this save and share button. So yeah, this is your calculator, your monthly AWS calculator, which lets you take care of your usage and gives you the bill accordingly. So if you're worried about as in how much you're going to spend by using AWS or its services, you can always come here and calculate that as well. Now that being said, let's quickly move to the demo part and see what all we can do with the AWS. Now I have my account here and I've logged in actually. So these are the services that are there at my disposal rather. So I'm just going to go ahead and open one of these. Say for example, I open my EC2 service. My internet is a little slow today, so yep. As you can see, I have one running instance, I have one key pair, I have 3 security groups. As we move further, we would be dealing with these and we would be implementing or creating new instances and all those things. So firstly, what I want to do is I want to go ahead and create a key pair. Now, why do I need to do that? The first thing you need to understand is when you create a key pair, what you're doing is you're actually going ahead and you're creating your SSH key. Now, when I say SSH key, that is something but a secure shell key. Now, this key is very useful when you talk about certain OSs because that helps you establish your connection. When you talk about Windows, you do not need to do that. So, but still, you would be needing an SSH key. Now, you might wonder why. The reason you'd be needing it is because given on the longer run, even if you're using Windows, you'd be required to put in an admin login, and for that you'd be requiring this key anyways. If you're on using this application on your Linux OS, in that case, it is a must that you generate the key first. One more thing you need to understand is once you generate this key, you need to take care that you do not lose it because once it's gone forever. So that is one precaution you need to take. So let's first start by creating a key pair here. And as we move further, you'd understand why did I create one. So I say create my second key because I believe I've created a key in this account prior to this. Second key, I say create, and there you go, I have a key. Now my second key is something which I basically have it here. I'll just cut it from here and I'll paste it in one of my folders basically. So let's say I'm here and I say I need a new folder. I come here, I say AWS demo, and I put my key in here. I would be needing this, that is why I'm doing it. Now you can see that the extension here is .pem. You might get other extensions depending upon the system which you're using and the OSs that it's running or using. So depending on that, this extension might vary. It's preferable that it is .pem. So yep, we have this key now and let's see what we can do with it. I'm gonna go ahead and select this key, unselect this for now. And I have all the information as far as this key is concerned. Now, as I've already mentioned that security is very important when you talk about your cloud services. So it is very important that you define a proper security group to take care of all these things. So before we create an instance, let's quickly go ahead and create a security group first. I come here. I've actually gone ahead and created a security group. So I would want to go ahead and create one more. So I would say create. Now, when I do that, I need to give a name to it, say this security. For today's demo, I say security demo description. For reference sake is what I would say. There you go. And we'll be going ahead and adding in rules here. And then where do I want certain rules? Because you can go ahead and define certain rules. How do you want to give access to your system and all those things? So I say, as far as my accesses are concerned, I'd be wanting an SSH rule. See, the port range is given to you because you can communicate with the system through these ports basically. And then I can go ahead and add more. I can say HTTP. There you go. I say I would be needing HTTPS as well. And since I'm using Windows, I would go for RDP. Now these are the different port names that are there. Now, as far as these groups are concerned, so you can see that this has 00000 security because you would be wanting these ports to be available to others as well. Because why? You're dealing with data exchange and all those things. So these are the ports that need to be active. Now you have your SSH and your RDP. Yes, for now they're secured here. I can actually go ahead and change it here for the simplicity sake. If I have it something like this, or maybe like this is how it would look like. And for the sake of being easy to use, I'd be having it like this. But as far as you are concerned, you need to consider better practices for this. You have different sources here. Why? Because you have an option to customize it. You can go ahead and customize those because there are certain services which you would be wanting to use differently. And it is very important that your system is secured because since certain services would be accessing your data, it is important that access is denied to them in certain cases where it's not required. And that is why you need to consider your security practices. Now, as far as this demo goes, this is a basic thing which we are doing and we can ignore our security policies here. This is just for the demo sake and I would be creating a simple security group. So this sources, bear with it for now. Now I say create And there you go. My security group is created. It is security demo here. That is the name. Now let us move further and go ahead and create one of the instances that we can do. So I go to services. I say EC2 and I say launch an instance or create an instance. Now there are quite a few instances here. We have Linux and all those things. I would be going for Microsoft Windows. Let me just go ahead and pick one. We can actually go ahead and pick any. The only thing we need to consider is whether it's eligible for you. Now, when I say eligible, I mean eligible for your free tier basically. So let us go ahead and pick one of these. I would say base 2012 server. Let us see whether it's doable for us. Yep. Now this is selected by default because it's free tier eligible and we're actually going to go ahead and use it. Now, when you're creating an instance, you need to understand one thing. These are the details that are there about the instance. And these are some of the points you need to consider. When you say review and launch, you can just click on it. You would directly be taken to the last step and all the by default admits are given to you. But now that we are doing it for the first time here, I would want to do it step by step. There's nothing we are doing. We are just selecting the by default thing, but I just want you to see what all it has to offer to you. Say, for example, when you pick a general purpose T2 instance, number of CPUs, 1, your memory, 1 GB basically. And these are the other details as in network performances, low to moderate and all those things. So I say next. These are the details which I can enter in as in the number of instances, purchasing options, network, subnet, and all these things. Is there an IAM rule and all those things? So yeah, for now, I'm not going to make any changes again here and I'm just going to say next. As you can see the size, I have 30 GBs of total available with me. And these are the details about it, IOPS and all those things. So you can just go ahead and say next. Now you have an option here whether you want to go ahead and add a tag and all those things, and you can do that. Or you can just go ahead and say next. You have a wizard here. And there you go. I have my 7th step where I can go ahead and launch my instance. You can see I have a notification here saying that improve its security. As I mentioned that we are doing it for the demo sake and I've chosen few basic ones. So I do not have to worry about anything. My ports are open and those are accessible. So the thing is my AWS is warning me as in you should not have it that way. So when you do go ahead and implement it on larger scales, you need to take care that your security groups are well defined and properly defined. For now, let's go ahead and say launch. Now it would ask you to pick a key pair. As I've mentioned that key pair is important whether you're using it on Windows or not, but you need to go ahead and define a key pair. So I would go ahead and select an existing one because we created one. Proceed with a key pair. Okay. I say I acknowledge and I say launch. And it says that your instance is now launching. So what I'm going to do is I'm going to go ahead and view the launch log and it gives me details as in what are inbound rules and all those things are mentioned here. How do I connect to my instances and all those things. There's an information here. I can just go ahead and say view instances. And there you go. I have both of my instances here and the details are given to me as in what are the details. Now I've gone ahead and I'm stuck with this availability zone as far as I'm concerned, which is Mumbai for my case. You can go ahead and pick an availability zone for your sake, but make sure you stay consistent with it because that would be more convenient for you. That is for your different instances. Status checks as far as this goes. Everything is okay here. This was the instance which I launched yesterday. This is the one which I've launched today, which is still initializing. So there you go. You have one here. Yeah, so this was about going ahead and creating an instance as far as AWS is concerned. Now, what we can do is we can go ahead and try and do other things as far as your AWS is concerned. Now, the other points which we need to discuss are, can we connect this instance to a server? And the answer to this question is yes, we can do that. Meanwhile, what I want is I want my instance to refresh first and everything needs to be in place before we do that. Yeah, so there you go. Now as you can see the status checks, as far as the checks are concerned, it is complete and we can go ahead and we can connect to a server now. So I was talking about the different servers that you can go ahead and connect to. Now, if you're using a Linux machine, you need to understand one thing, that you have to go ahead into your terminal and then you have to connect to your server. But when you talk about Windows, the process is a little different. Let us see how we can do that using Windows. Say for example, I select this instance here, the second one, I say connect. So what I'll have to do is I'll have to go ahead and download a remote desktop file for that. And how do I do that? I do this. I say connect. It would be asking me for my admin password here. It would give me an error because I need the password here, and I guess I missed out on the password. Just bear with me. Let me just generate the password and I'll get back to you on this. Okay, so how do I do that? What I'm going to do is I'm going to get into my previous instance, this one, and I'm just going to connect or try to connect it because I have one here already. So as you can see, I have this option here which says get me a password. As far as my administrator or username is concerned, it is administrator. And when I say get password, I'll be clicking here and it would be asking me to choose a file. Say for example, I go ahead and I choose one of the files. Now I had downloaded the password last time, or the key rather. Now that is why you need the key. When you store it at some place, you'd be asked for this key and you have to enter it here. And when you say decrypt password, there you go. You'll be getting your password here, which is this. Now I would be copying this password for my reference sake. Control C, just to give you a demo again. I'll download it. I'll close it. And I would say connect. It would ask for the admin password and I say take this. Do you want to connect despite these certification errors? Yes. And there you go. I've connected to the server here and this is the file which I created the last time. There you have it. So this is how you go ahead and actually create your instance and connect to the server. You can go ahead and create another files here. You can say new, you can have your options. It's just like your nice operating system where you can do so many things. Yes, it's more of a clean slate and it's fully available to you to go ahead and edit it the way you want to. So this is what we did right now. We've actually gone ahead and we've created an SSH key. The reason we did was because we wanted to log in here. Second thing, we went ahead and we created a security group. Yes, it wasn't great, but you can actually set security rules as per your needs. Then you can go ahead and launch your instance and then you can connect to a server you want to. Now this is what I have here. I can actually go ahead and do other things as well. What are the other things that I can do? Well, I can go ahead and I can set alarm for my systems. And how do I do that? Now I have something called as my CloudWatch here under my management tools. Now when I come here, I can go ahead and set alarms as well. What kind of alarms? Say for example, I want to monitor my system and I want to make sure that the usage as far as my system is concerned, it does not go above maybe say 70%. And if it does go above 70% and that happens for 5 continuous minutes, I want my system to throw in an alarm for me. So can I do that? Yes, I can actually go ahead and do that. I can create an alarm and I can do that accordingly. I click here on alarm. I say my EC2 metrics basically, or I just type EC2 here. All the services are here. And since we are creating an alarm for utilization, let's select that. You get all the details here as in how much is the usage and all those things. You can come here and define the alarm name, say CPU usage greater than 70%, say, and you say throw an alarm when usage exceeds 70%. There you go, 70. And I move down and I say notify me. How do I do that? Send notification to new list. Suppose I enter in some email ID. Now take this for example. Suppose I go ahead and use this account here and I say create an alarm. Okay, there has to be a name as well. Say VPT for example. And congratulations, your alarm has been created. It says insufficient data because there's pending information here. You need to understand one thing. When you do create an alarm, the email ID you enter in, AWS would go ahead and it would give in a message to the email ID or in the email ID saying that this is something that is trying to happen here. Do you want to be notified when the usage goes this far? And if the user says yes, or he or she confirms that that can be done, in that case, AWS would configure this status saying that yes, it is no longer pending, and the status would be displayed here and this would turn to green. So this is how you actually go ahead and create your own alarm as far as AWS is concerned.
Let me ask you a quick question. Have you ever thought about how companies like Netflix, Airbnb, or Spotify manage their data? run their application, and scale so efficiently? The secret lies in the power of the cloud. And for many top companies, AWS is a backbone of their success. With 63% of IT professionals finding it tough to recruit cloud talent, AWS certifications are your gateway to a high-demand career. Salaries for AWS roles in India are around 10 lakh rupees, and in US they reach up to $120,000. Cloud jobs are set to grow by 28% in the next 5 years. According to Gartner, by 2025, 51% of IT spending will shift to the public cloud. So if you're looking to future-proof your career, AWS certification could be the ultimate step forward. With that said, hello everyone, let's dive into AWS certifications and explore how they can help you boost your career in the cloud computing world. In this video, I'm giving you deep knowledge on 12 AWS certifications across 4 different categories, covering the essentials like exam format, question count, and the ideal candidates for each certification. We'll also highlight newly added certifications, including the AI practitioner for foundational AI skills and machine learning specialty. Stick around till the end to discover which certification best aligns with your experience and goals, and the key skills you'll need to master to succeed in each exam. So, let's understand what exactly is AWS certification now. AWS certification is a program designed to validate your skills and expertise in using Amazon Web Services, or AWS, the leading cloud computing platform powering businesses and applications worldwide. AWS offers a wide range of cloud services, from storage and computing power to machine learning and artificial intelligence. And AWS certification shows that you have the knowledge to leverage these tools effectively. Now we'll understand why is AWS certification important. So, why should you care about AWS certification? Well, it's industry recognized and highly valued by employers. Getting certified proves to potential employers that you have the skills needed to design, implement, and manage cloud-based solutions using AWS. And trust me, that can set you apart from other candidates. Whether you're looking to switch careers or advance your current role, AWS certification can open doors to new job opportunities, career advancements, and even higher salaries. Next, let's explore the various AWS certification levels and what they entail. AWS offers a total of 12 certifications across 4 levels: Foundational, Associate, Professional, and Specialty. Each level caters to different expertise, from beginner to advanced cloud professionals. Here's a quick breakdown of each category. First, we have the Foundational level. This is a knowledge-based certification for those who want a foundational understanding of AWS Cloud. The best part, no prior experience is needed for this level. There are 2 certifications here, the AWS Certified Cloud Practitioner and the AWS Certified AI Practitioner. These are perfect for beginners looking to get started with AWS. Next is the Associate level. These are role-based certifications that showcase your knowledge and skills on AWS, helping you build credibility as an AWS cloud professional, while no AWS experience is needed. Some prior cloud or strong on-premises IT experience is recommended. This level includes 5 certifications: AWS Certified SysOps Administrator Associate, AWS Certified Developer Associate, AWS Certified Solutions Architect Associate, AWS Certified Data Engineer Associate, and AWS Certified Machine Learning Engineer Associate. Moving on to the professional level. These certifications validate advanced skills needed to design secure, optimized, and modern applications on AWS, as well as to automate processes. For this level, AWS recommends at least 2 years of prior cloud experience. Here, we have AWS Certified Solutions Architect Professional and AWS Certified DevOps Engineer Professional. These exams are for advanced users who can handle complex AWS environments. Finally, there is a specialty level. This level lets you dive deeper and become a trusted advisor in specific strategic levels. For these certifications, check the exam guides on AWS sites for the recommended experience. Specialty certifications include AWS Certified Advanced Networking Specialty, AWS Certified Machine Learning Specialty, and AWS Certified Security Specialty. Each of these focuses on a particular field within AWS, giving you an edge in specialized roles. Whether you're just starting or looking to specialize, there is an AWS certification that's right for you. So first, let's see the foundational level certification. Let's dive deep into the details of the AWS Certified Cloud Practitioner certification. Starting with the category. This certification falls under the foundational level It's aimed at individuals who want to get a higher level understanding of AWS Cloud, even if they are new to IT or cloud computing. Then we have the exam duration. You'll have 90 minutes to complete the exam. Exam format is that the exam consists of 65 questions. You'll see a mix of multiple choice and multiple response questions. The cost of the exam is $100 USD. Remember, pricing may vary slightly with foreign exchange rates, so check AWS exam pricing for up-to-date details. Then, where to take the test? You can take the exam at the Pearson VUE Testing Center or through an online proctored exam. The certification is accessible in multiple languages, including English, Japanese, Korean, etc. Now we'll cover what the AWS Certified Cloud Practitioner exam tests on you. You'll need to know these points as well. First, explain the value of the AWS Cloud and how it benefits organizations. Understand the AWS Share Responsibility model to know what responsibilities lie with AWS and what remains with the customer. Understand security best practices for keeping data and also applications secure. Understand AWS cloud costs and billing practices to effectively manage and forecast cloud expenses. Describe core AWS services like compute, network, database, and storage. Lastly, identify AWS services for common use cases to solve different business problems. To prepare for the AWS Certified Cloud Practitioner exam, here are the key concepts you should have the basic understanding of. First, AWS cloud concepts for a broad understanding of the cloud. Security and compliance in AWS, including best practices to safeguard data. Core AWS services that are most commonly used. And last is economics of AWS cloud to understand costs and also value. Now let's see the job tasks that are out of scope. For this exam, you are not expected to perform technical tasks like coding, designing cloud architectures, troubleshooting, implementing, or load and perform testing. And that's the overview of AWS Certified Cloud Practitioner certification. It's an ideal starting point for anyone looking to build foundational cloud skills and understand AWS at a higher level. Now let's see the AWS Certified AI Practitioner. Let's take a structured look at AWS Certified AI Practitioner certification, especially if you're aiming to validate your skills in artificial intelligence and machine learning on AWS. The category is the certification fails under the foundational level. It's meant for individuals who work with AI and ML technologies on AWS, even if they're not directly building solutions. The exam duration is 90 minutes. The exam format is you'll encounter 65 questions, covering multiple choice and multiple response types. The cost for the certification is $100 USD. As always, check AWS official pricing page for any variations based on exchange rates. And then, intent candidates. The certification is perfect for those who may not necessarily build AI/ML solutions but are familiar with these technologies on AWS. Testing options are, you have flexibility here. You can take the exam at the Pearson VUE Testing Center or through an online proctored exam. Next, languages offered. The exam is available in English, Japanese, Korean, and so on. The certification validates your understanding of in-demand concepts in artificial intelligence, machine learning, and generative AI. This can sharpen your competitive edge and position as well for your career growth and better earning opportunities. Now let's get into what this exam covers. Candidates are expected to demonstrate the ability to understand AI, ML, and generative AI concepts, methods, and strategies, particularly how they apply on AWS. Ask relevant questions within their organization to determine the best uses of AI/ML technologies. Determine the correct type of AI/ML technologies for specific use cases. Lastly, use AI/ML and generative AI technologies responsibly to ensure ethical and effective deployment. Next, let's see the recommended AWS knowledge. Although you do not need extensive AWS experience, familiarity with a few key areas can be helpful. Those are core AWS services like Amazon EC2, S3, AWS Lambda, and SageMaker. An understanding of AWS's shared responsibility model, especially around security and compliance. AWS identity and access management for resource access control. Lastly, knowledge of AWS's global infrastructure and service pricing models. Now let's move on to job tasks that are out of the scope. For this exam, you won't be expected to perform technical tasks such as developing AI/ML model, conducting data engineering, hyperparameter tuning, and implementing security protocols for AI systems. This certification focuses on more practical AI/ML knowledge rather than hands-on development. Now let's look at the exam content. The exam includes a mix of question types to assess your knowledge, such as multiple choice and multiple response questions, where you'll pick one or more correct answers. Ordering questions, where you'll arrange responses in the correct sequence. Matching questions, where you'll match items based on prompts. Lastly, case studies, where you'll analyze a scenario with multiple questions to assess your applied knowledge. And that's a structured look at the AWS Certified AI Practitioner certification. Perfect for professionals seeking to deepen their understanding of AI and ML concepts on AWS and to start their AI journey on a solid foundation. Now let's dive into the AWS Certified Solutions Architect Associate certification. This is one of the most popular AWS certifications and an ideal choice if you're looking to deepen your cloud architecture skills. The category of the certification is at associate level, perfect for those with foundational AWS knowledge or IT experience, whether in the cloud or on-premises. The exam duration is you will have 130 minutes to complete the exam. The exam format includes 65 questions, mostly multiple choice or multiple response. The cost is $150 USD. Be sure to check AWS's official pricing page for any regional cost variations. The testing options are, you have the option to take this exam at the Pearson VUE Testing Center or through an online proctored exam. The languages that they offer is, this exam is available in English, French, German, Italian, and so on. This certification is designed for those who want to architect cost-optimized, high-performing cloud solutions on AWS. Let's cover the core skills the exam assesses. Candidates should be able to design solutions with AWS services to meet current and projected business needs. Develop architectures that are secure, resilient, high-performing, and cost-optimized. Lastly, review existing solutions and identify areas for improvement. And next, target candidate description. The ideal candidate should have at least 1 year of hands-on experience designing cloud solutions using AWS services. Now understand the exam content. There are two main question types on the exam. Multiple choice, where you'll select the one correct answer. Multiple responses, where 2 or more answers may be correct out of 5 or more options. One more important thing is, unanswered questions are scored as incorrect, but there are no penalty for guessing. Remember, the exam includes 50 scored questions and 15 unscored questions. AWS gathers data from these unscored questions to evaluate them for future use, and they won't affect your overall score. Next, about the exam results. The exam is scored on the scale from 100 to 1000, with a minimum passing score of 720. This compensatory scoring model means you do not need to pass each section individually, only the overall exam. Your results will include a classification of your performance in each section, giving you insight into your strengths and areas to improve. Some sections carry more weight, meaning they have more questions and can impact your score more heavily. Moving ahead, let's explore AWS Certified Developer Associate certification. This is a key certification if you are looking to enhance your skills in AWS cloud development. The category is, the certification is at associate level, ideal for developers who are ready to showcase their cloud development skills and understand AWS environments. The exam duration is 130 minutes long. The exam format is, it consists of 65 questions including multiple choice and multiple response formats. The cost of this exam is $150 USD. Check AWS's pricing page for additional regional cost details. The testing options are, you can take this exam at a Pearson VUE Testing Center or through an online proctored option. The languages offered are, this exam is available in English, Japanese, Korean, and so on. The AWS Certified Developer Associate certification validates your skills in developing, optimizing, packaging, and deploying AWS applications. It's great for anyone starting out in AWS or working in IT or cloud development roles. This exam is designed to assess the skills like, we'll break down what skills the AWS Certified Developer Associate exam is designed to assess, including developing and optimizing applications on AWS, deploying applications using CI/CD workflows, securing applications code and managing data protection, identifying and resolving application issues. The target candidate description is, ideally candidates that have 1+ years of hands-on experience developing application using AWS services. Now let's see the recommended AWS knowledge. You should know how to develop and secure applications using AWS Service APIs, the AWS CLI, and the SDKs. Use a CI/CD pipeline to deploy applications on AWS as well. Now let's see out-of-scope tasks. This exam doesn't cover some tasks like designing architectures. Let's understand exam content. The questions are a mix of multiple choice and multiple response types, where you need to choose one or more correct answers. There are 50 scored questions that affect your final score and 15 unscored questions to evaluate your future use. Moving forward, let's dive into the AWS Certified SysOps Administrator Associate certification. This certification is perfect for those in a cloud operations role and looking to prove their skills in monitoring and maintaining AWS workloads. The category is, this certification is at associate level, ideal for system administrators or those focused on AWS cloud operations. The exam duration is 130 minutes long. The exam format includes 65 questions with multiple choice and multiple response types. The cost for the exam is $150 USD. For additional pricing details, check the AWS website. The testing options are, you can take the exam at the Pearson VUE Testing Center or online through a proctored exam. The languages that they offer is, the exam is available in English, Japanese, Korean, and simplified Chinese. The AWS Certified SysOps Administrator Associate certification validates your expertise in monitoring AWS workloads, implementing security controls, and applying networking concepts. It's ideal if you are in an IT role involving AWS cloud administration. Now we'll walk through the core areas this exam covers, including supporting and maintaining AWS workloads based on AWS well-architectured framework, operating workloads using the AWS Management Console and CLI, implementing security controls for compliance, monitoring, logging, and troubleshooting AWS systems, applying networking concepts like DNS and TCP/IP. Lastly, performing business continuity and disaster recovery procedures. The target candidate description is, ideally, candidates have 1 year of hands-on experience managing AWS workloads, with skills in networking, security, and troubleshooting. The recommended AWS knowledge and experience are, candidates should have at least 1 year of experience with AWS technology, proficiency with the AWS Management Console and CLI, and an understanding of the AWS well-architectured framework. Now, about the exam content. The questions are a mix of multiple choice and multiple response, with 50 scored questions that impact your score and 15 unscored questions that AWS uses for future testing. Now, the another certification, so-called AWS Certified Data Engineer Associate exam. If you are looking to prove your skills in managing data on AWS, this certification is for you. The exam is an associate level certification, so it's perfect for those with some experience in data engineering, but not quite for experts. You have 130 minutes to complete the exam, which is about 2 hours and 10 minutes. There are 65 questions in total. Some will be multiple choice and some will be multiple response. The cost is $150 USD. Now let's see where you can take it. You can take the exam either at a Pearson VUE Test Center or online with a proctor watching you from home. The exam is available in English, Japanese, Korean, and simplified Chinese. Basically, this certification is all about working with data on AWS. The exam checks your skills in tasks like ingesting and transforming data, getting data ready for use, creating data pipelines, that is orchestrating how data moves and changes, designing data models, making sure data is organized in the right way. Lastly, maintaining data quality, keeping your data clean, secure, and properly governed. The exam also tests your ability to monitor and optimize data pipelines, ensuring things run smoothly and cost-effectively. Who should take the exam? The exam is meant for people with about 2 to 3 years of experience in data engineering and at least 1 to 2 years of hands-on AWS experience. What you should already know. You should know how to set up and maintain ETL pipeline, that is extract, transform, load for data. Use basic programming concepts to build these pipelines. Understand how to use Git for version control and data lakes for storing data. Lastly, have a general understanding of networking, storage, and computing. In AWS, you should know how to use AWS services to build and manage data pipelines. This includes things like encryption, data protection, and logging. You should also be able to write SQL queries on AWS services to analyze data. Moving ahead, understand about the certification exam. This exam will have two types of questions. Multiple choice, in which one correct answer is given. Multiple responses, where you'll need to pick more than one correct answer. Next we have is AWS Certified Machine Learning Engineer Associate. Alright, let's break down what you need to know for AWS Certified Machine Learning Engineer Associate exam. The duration and questions are, you'll have 130 minutes to complete 65 questions. The cost of the exam fee is $150 USD. Where to take the exam? You can choose to take the exam either at a Pearson VUE test center or online with the proctor. The exam is offered in English, Japanese, Korean, and simplified Chinese. The certification is aimed at individuals with at least 1 year of experience using Amazon SageMaker and other machine learning tools on AWS. If you're a backend software developer, DevOps engineer, data engineer, MLOps engineer, or data scientist, this is for you. Now, the target candidate should have a year of experience using SageMaker and also be familiar with related AWS services. Here's what you should already know before taking the exam. A basic understanding of common ML algorithms and when to use them. Knowledge of data engineering, like how to ingest and transform data for ML pipelines. Experience with CI/CD pipelines and infrastructure as a code. Lastly, familiarity with software engineering best practices for creating clean, reusable code. Now on the AWS side, make sure you also know how to use SageMaker for building and deploying models. Work with AWS data services for preparing data for ML models. Deploy applications and infrastructure on AWS. Use monitoring tools for logging and troubleshooting ML systems. Set up automated CI/CD pipelines using AWS services. Lastly, understand AWS security best practices for identity management, encryption, and data protection. Now let's dive into the AWS Certified Solutions Architect Professional exam. Here's what you need to know. This is for professionals with at least 2 years of hands-on experience designing and deploying cloud architecture on AWS. Before you dive into the exam, you should be comfortable with the tools like AWS CLI, AWS APIs, AWS CloudFormation, and the AWS Management Console. Plus, knowing a scripting language and having experience with both Windows and Linux environments is a plus. You should also have the skills to provide best practice guidance on architecture across multiple applications and enterprise projects. Map business goals to architectural needs. Make architectural recommendations for implementing and deploying applications on AWS. Design hybrid architectures using AWS technologies like VPN and AWS Direct Connection. Lastly, set up continuous integration and deployment processes on AWS. We look at the format, question types, and also everything you need to know. You'll have 180 minutes to answer 75 questions, which will be in either multiple choice or multiple response format. The exam costs $300 USD. You can take the exam at a Pearson VUE test center or choose it on online proctored exam. To earn the certification, you need to pass SAP C02 exam. And don't worry, there is an exam guide to help you prep. Now let's dive into the AWS Certified Security Specialty exam. Who should take this exam? This exam is for professionals working on security roles. If you're securing AWS products or services, the certification is for you. I know you will be having the doubt of experience level, right? The ideal candidate should have 3 to 5 years of experience in designing security solutions, with at least 2 years of hands-on experience securing AWS workloads. Before you take this exam, you should have a knowledge of the AWS Shared Responsibility model, security controls on AWS environments, logging and monitoring strategies, vulnerability management and security automation, integrating AWS security services with third-party tools, disaster recovery controls like backup strategies. Lastly, cryptography, key management, and identity access management. Now let's talk about the AWS Certified DevOps Engineer Professional exam and how it can level up your career in cloud engineering. Who should take this exam? This exam is designed for individuals at least having 2 years of experience working with AWS environments. It's for professionals who want to demonstrate their expertise in provisioning, operating, and managing distributed systems on AWS. Before you take the exam, you should be familiar with programming, that is, experience in at least one high-level programming language. Infrastructure automation, building highly automated infrastructures. Next is operating systems. administering different operating systems. DevOps methodologies, understanding modern development and operation processes. Next comes continuous delivery systems, implementing and managing continuous delivery systems on AWS. Security and governance, automating security controls, compliance validation, and governance processes. Last is the monitoring and logging, defining and deploying monitoring, metrics, and also logging systems on AWS. Now let's understand about the exam. You'll have 180 minutes to answer 75 questions in multiple choice and multiple response formats. The exam costs $300. And about location, you can take the exam either at a Pearson VUE test center or online with a proctor. Next, here's the key knowledge you need before taking the exam. 2+ years of experience, provisioning, operating and managing AWS environments. Experience with software development lifecycle and programming or scripting. Automating infrastructure and understanding modern development processes. Lastly, securing AWS infrastructure is also recommended knowledge. The exam consists of 2 types of questions. Multiple choice, where 1 correct answer and 3 distractors. Multiple responses, 2 or more correct answers from a list of 5 or more options. Now let's dive into the AWS Certified Security Specialty Exam and see how the certification can set you apart in cloud security. The exam category is a specialty level certification, perfect for those who want to showcase expertise in AWS security solutions. I know you will have a doubt of how exam is like. You'll have 170 minutes to complete 65 questions in both multiple choice and multiple response formats. The exam costs $300. Where can you take this exam? You have 2 options for taking the exam. An in-person test at Pearson VUE testing centers or an online proctored exam. This exam is offered in 6 languages like English, Japanese, Korean and so on. Now let's see what is the certification about. The AWS Certified Security Specialty validates your skills in creating and implementing secure AWS solutions. It tests your knowledge of data classification and AWS data protection mechanisms, data encryption methods and how to implement them on AWS. Lastly, secure internet protocols and AWS mechanisms for securing data transfers. Who should take this exam? If you're in a security role, this certification is a great way to validate your skills. The exam is designed for candidates who have a solid understanding of data classifications, encryption, and secure internet protocols. 2 or more years of production deployment experience in AWS security services. Lastly, the ability to make the trade-off decisions regarding costs, security, and deployment complexity. What knowledge should you have? Candidates should have the following experience and understanding of AWS Shared Responsibility Model and its practical application, security controls for AWS environments, logging and monitoring strategies, vulnerability management and security automation, how to integrate AWS security services with third-party tools, cryptography, key management, and identity access management. Lastly, threat detection and incident response strategies. The exam consists of 2 types of questions. That is multiple choice, where 1 correct answer with 3 distractors. Next, multiple response, 2 or more correct answers from a list of 5 or more options. And remember, unanswered questions are scored as incorrect, so there is no penalty for guessing. Ready to become AWS certified? This certification is a great way to validate your security expertise and gain confidence in your ability to secure AWS solutions. Now, we are diving into the AWS Certified Machine Learning Specialty Certification, designed for anyone serious about ML development in the AWS cloud. What does this credential do? It's designed to help organizations identify and grow talent for critical cloud initiatives. If you are into building, training, tuning, and deploying machine learning models on AWS, this certification can be a game changer. Who is this exam for? This certification is perfect for developers and data scientists with over 2 years of hands-on experience in machine learning or deep learning on AWS. You should also be comfortable with the intuition behind ML algorithms, basic hyperparameter optimization, familiarity with ML and deep learning frameworks. Lastly, best practices in model training, deployment, and operations. How do you earn the certification? To earn the certification, you will need to pass the AWS Certified Machine Learning Specialty Exam. The test includes 65 questions with a mix of multiple choice and multiple response formats. What about the logistics? You will have 180 minutes to finish the exam. It costs $300. and is available at both Pearson VUE testing centers and as an online proctored exam. The exam is offered in 4 languages: English, Japanese, Korean, and simplified Chinese. Now let's see what knowledge will you be tested on. The exam validates a candidate's ability to select the right ML approach for a business problem, choose the right AWS services to implement ML solutions. Lastly, design and implement scalable, cost-effective, secure ML solutions on AWS. Let's see the ideal candidates. Those who have 2+ years of experience in developing, architecting, and managing ML workloads on AWS are the best fit. Additionally, target candidates should understand basic ML algorithm intuition, hyperparameter tuning, frameworks for ML and deep learning. Lastly, best practices for training, deployment, and operations. Next, let's see how are the questions structured. The exam has 2 types of questions: multiple choice, where 1 correct answer with 3 distractors, and then multiple response, 2 or more correct answers out of list of 5 or more. As same for every certification, there is no penalty for guessing. So if you're unsure, go ahead and make an educated guess. Moving forward, let's explore the last certification, that is AWS Certified Advanced Networking Specialty Certification. Ideal for those ready to make their networking skills to next level with AWS. Now let's see what is the certification about. This credential is designed to validate expertise in designing and managing network architecture across AWS services, helping companies identify professionals with the right skills for complex cloud networking tasks. We will also see who should consider taking this exam. This certification is aimed at individuals with 5 years of hands-on experience in networking, specifically in architecting and implementing network solutions. Recommended experience includes in-depth knowledge of AWS technologies and security best practices, familiarity with advanced networking architecture like IPVPN, MPLS, and VPLS, experience with automation tools for designing, implementing, and optimizing network architectures, including routing and multi-region setups. Lastly, knowledge of CIDR, subnetting, AWS WAF, IDS, IPS, DDoS protection, and EDOS mitigation. Now let's see how do you earn the certification. To achieve this, you'll need to pass the AWS Certified Advanced Networking Specialty exam. It consists of 65 questions in both multiple choice and multiple response formats. What's the exam logistics? You'll have 170 minutes to complete the exam, which costs $300 USD. You can take it at a Pearson VUE testing center or through online proctoring. The exam is available in English, Japanese, Korean, and simplified Chinese. Let's see the skills that will be assessed. The certification will validate your ability to design and implement hybrid and cloud-based networking solutions using AWS, operate and maintain network architectures for AWS and hybrid environments, use AWS tools for deploying and automating networking tasks. Lastly, secure AWS networks using native AWS networking tools and services. Now let's see what kind of candidate is the best fit for the certification. Ideally, candidates should have at least 5 years of networking experience and 2+ years in cloud and hybrid networking. Key knowledge areas include AWS networking details and how they integrate with other AWS services, security best practices for AWS. Lastly, understand of AWS compute and storage options. How are the questions structured? You will encounter multiple choice questions with 1 correct answer and 3 distractors, multiple response questions with 2 or more correct answers among 5 or more options. So, if you're serious about building secure, reliable network architectures on AWS, the AWS Certified Advanced Networking Specialty Certification can be an invaluable credential for your career. So, that wraps up our overview of all the AWS certifications. So, if you've got your certification, you'll have access to great career opportunities. Now let's go to the career opportunities. You could work as a cloud architect, solution architect, DevOps engineer, data engineer, or security specialist. The pay will depend on your experience and where you are based. But these roles offer excellent career growth and good salaries. Let me tell you some exam preparation tips. Once certified, you'll have an amazing career opportunities. But before you go, here are some quick exam preparation tips. First, use AWS free training. Hands-on labs and practice exams are the must. Apply AWS tools. Practice using AWS in real-world scenarios. Next, take practice exams. Familiarize yourself with the exam format. Then, focus on core concepts. Pay attention to key topics like security and costs. Lastly, AWS forums. Get tips from the community. With these tips, you'll be ready to pass the exam and boost your career.
Why do we need AWS? So the first thing we see is that it helps scale your operations. Now, basically, scalability is extremely important when it comes to business agility, because the more you scale your operations, the more profits you have and the more efficient you get, right? So there are services such as Elastic Load Balancer, which helps you scale, or certain services, computational services are there, which helps you scale your resources. Then we come to reliability. Now, the fact that AWS basically is extremely reliable because it is very secure and it is global in nature. So the infrastructure of AWS is global and can be accessed from anywhere, right? So the fact that it is so global and so widespread makes it extremely reliable because it is used all over the world. Next, we come to cost effective. Now, cost effective is extremely important when it comes to AWS because more than 80% of companies have been using AWS right now, and the fact that they have moved to AWS is because of the fact that it is extremely cost effective and helps save them a lot of money, thereby scaling their operations and then meeting their business goals as well, or financial goals that they have. So all of these things are interconnected, right? Now, next we talk about business agility. Now, business agility is all about being efficient. Now, the more efficient you get, the more agile your business will be. Now, efficiency can be in terms of productivity, can be in terms of financial stability, and it has to improve your company's overall revenue, right? So the last one is high speed deployment. Now, every service that you have on AWS will basically have high speed deployment. So it doesn't really take a long time to create a service from scratch and deploy it on AWS so that you can use it from anywhere around the world, right? So next we come to the various AWS services that are there. Now these can be grouped into various ones such as compute, so that there are computational services that AWS provides users. Then we see that there are storage services as well. Now storage services are extremely in use and one of the most popular ones after compute. Then there is the database services that are there. Now these can be NoSQL databases or relational databases as well. And then there is networking services that are there. Now networking services are extremely important, mostly because of the web hosting and as well as tracking your website and stuff like that. You need that as well. And finally, we have analytics. So analytics is also extremely important to basically see how your resources on AWS are doing. Now, there are various other services, but these are like the 5 pillars of AWS, right? So let's talk about these services. The first service is basically a compute service called Elastic Compute Cloud. So the EC2 is basically a service that offers its users the compute platform they need. So it has an option of 475 various instances and choices of processor that the user can have, as well as storage and networking as well, with an option of which operating system you want to run it on as well. So it has extremely wide range of options that it provides its users, and it's most in use, and it's probably one of the most used services on AWS. So the next thing we see is AWS Lambda. So the AWS Lambda is basically a serverless event-driven compute service that lets you run code for virtually any sort of application or backend service that you have, right? And you do not have to provision separate servers for that. So that is what Lambda helps you do. It's basically something that is a compute service for any sort of backend application service that you have, or managerless service. So the next thing we see is storage. Now storage is basically extremely important. It comes right after compute, and the most popular storage service is the AWS S3, which is the simple storage device. Now, the AWS S3 is basically an object storage service. So you can store data in it, which can be anything, starting from a picture to, let's say, a text document, right? It offers its users very high scalability, right? And extremely high data availability and security. So it offers its users the option for making public access blocked or available. It offers its users the chance to create policies so that you can access or not access, delete or not delete certain things that you store in the S3, right? Next, we talk about the Elastic File System, which is the AWS EFS, right? Which is basically, it helps you automatically grow or shrink as you add or remove files in it, right? So that is why it's called the Elastic File System. It can basically dynamically allocate certain data storage in it. You basically need to specify a certain limit and it can dynamically allocate the resources within itself, right? So next we talk about the database services that are there. So basically there is DynamoDB. So next we come to Amazon DynamoDB. Now DynamoDB is a NoSQL database. Now that is basically something that has no relational tables and attributes as such, but it has data in it, right? Now what DynamoDB does is basically it is very serverless and it has based on key value, right? Now it is very high performance and it can get any application back to scale, which is why it is extremely in use when it comes to database services in Amazon, right? So the next thing we talk about is the Amazon Aurora. Now, the Amazon Aurora is another database service, but instead of NoSQL, unlike DynamoDB, it is based on MySQL and PostgreSQL, right? So these are two basic compatible SQL servers that you have, and after that you need basically a compatible relational database built for the cloud that combines the performance and the availability of traditional databases, right? So it's extremely cost effective and open source as well. So this is very easy to use and change, because you can always change anything that you do on an open source service or a software. So then we talk about the networking services. Now, when it comes to networking services, we have Amazon Virtual Private Cloud, which is the VPC. Now, this VPC gives you full control over your virtual networks or the environments that you have. So this includes the resource placement, security, all of this, right? So after this, we talk about the Amazon API Gateway. Now, Amazon API Gateway is a fully managed service that makes, so it is not managerless or serverless. So it makes it very easy for developers to create, publish, or maintain an API, repeat, or maintain an API at any scale as such. So it's extremely easy to use, and it's one of the most popular networking AWS services that are there. So then finally we come to analytics. So we have the Amazon Athena. Now, the Amazon Athena is a very interactive query service that AWS has, and it's very easy to use and analyze data that you have in certain other services that are integrated into it, such as the S3. And basically, you use standard SQL, give these commands, and it is always pay only as you use. Right? So you only have to pay for the queries that you run, and you don't have to pay for anything else when you use Amazon Athena. So then we look at AWS EMR. So EMR is a cloud big data platform which is used for running large scale distributed data processing jobs, right? So interactive SQL queries are used basically along with ML applications, and this is how you basically use EMR. Now you can use other frameworks such as Apache Spark, Hive, Presto, etc., and it's basically used for big data analytics, and you can use a bit of NLP, a bit of ML in that, and mostly it's used for data processing, and you integrate a bit of SQL in that as well. So up next we come for the demo for AWS services. So basically what you do is you create an account on AWS, and when you do that, you can log in with your password and your credentials as well. And this is what you come to, the AWS Management Console, right? So what you can see here is you have a various options of various services that are there. Now these services can be different from analytics to application integration, VR, and compute, and these are various other services. So let's check out some of the services, right? So the first thing we check out is, let's say, DynamoDB. So you type DynamoDB here. So this is DynamoDB. It's basically a service for databases. So you can create a table without actually having to use any SQL as such. So you can just give the table name. I can give it as table 1, right? So the next you specify the partition key that you have to have. Partition key is basically the primary key. So the primary key is always something that is uniquely identified with. So in here, instead of primary key, it's just called partition key. So let's just keep the partition key, which is basically different primary key here, as number. So it's going to be a number type, or we can keep it as, yeah, we can just keep it as number. So next is about sort key. Now sort key is something that allows you to sort all of the data that is there using the same primary key. So that is used as sorting, which is an optional feature, so we can or cannot do it. So we'll just use default settings, which is the fastest way to do it. And there can or cannot be tags. Now basically tags are optional values that you add, that you can basically assign to certain data that you have in the table, right? So what you can do right now is just create table, and your table will be created. It will take certain amount of time to do that, because AWS takes a bit of time, but it should be done in about 5 minutes. So as you can see here, the table has actually been created with the name of the table being table 1. The status is active because it has just been created, and partition key is basically the primary key that is there, that is going to have some sort of number in it, which is going to be unique for every sort of data that we enter, which is why it is the partition key. And you will basically have to see the read and write capacity mode. So we can just enter this table right here, right? And check out what is there. So here is the general information that is there. So the partition key, the sort key, if it was there, if we checked it. So there are no active alarms that we have set, and it is active. So item summary, so there are no real items, right? So we have to add an item. So let's do that. Let's add items. So we can just go to explore table items. So this is a table that we have. So what we can do is we can just go to create item, because there are no items here in the table. So this is going to be, let's say, 17, and that is the primary key that we have. Now let's say there's going to be a string attribute that you need. So let's say the roll number was the roll number of a student, and now what you can do is you can just add another attribute here, just like when you do with relational databases, as, let's say, name, and it's type string. So you can add, let's say, Jake, for example, and you can add another value if you need. Now this can be different if you want. It can be binary, it can be string set, anything. So this is basically another attribute that we can add. So this is the type, which is list. Now the list can be different. Now we can have different types of things in a list. Now this list can be third language, let's just say, right? So we can insert any sort of field here, and this can be string, right? So you can just add string here. All of these will have, let's just say, first will be Hindi, this will be English, and we can have another field of string, let's say Punjabi. Yeah. So repeat. You can have Hindi, English, and you come to the third one, and you can basically have Punjabi, let's say. and you create these items, right? And you create the first item. So this is literally one item that is there in your table right now. So you can just check what is there in your table, and you can see this is the only items that's there as number 17, which is the primary key, which is basically the partition key. This third language, which is basically string, and a list of different things such as Hindi, English, and Punjabi, and the name is J. Now, what you can do here is you can create another item because there's just one item and you cannot really have a primary key if you don't have another item, right? So let's just say this is 26, right? And after that, you'll have to add a new attribute. So this one is also, let's say, name, and let's say name is same, which is Jake. And for example, if we do something different, if this is the same and it's non-redundant, and then we basically go and do the same with this, we go to list, insert a few fields like Hindi, English, and let's say for this one, we change it to Bengali. So this is basically two different things. So this is added as a new different attribute because I hadn't put it under third language, right? So if I had put it under third language, it would have come under this. So these two would have been together, but since the name is basically the same attribute for both items that are there, so this is basically under the same name. And you have another attribute here, which is new value, right? So what you can do here is you have various things you can do here, right? You can edit the entire thing. You can set it as, let's say, 19 and save those changes. Okay, and right after that, if you basically recreate this item, it is updated and set as 19, right? So basically what you can do here is you can basically carry out any action. So we can just see about the updation. Now after updation, we can basically see there are various actions we can do. We can just delete item, and since that item has been selected, 19 is now deleted and the only thing that is there is 26. So this is how DynamoDB works. Up next we come to basically Amazon S3, right? So Amazon DynamoDB was a database service and S3 is a storage service that we're going to talk about. Now Amazon S3 is all about creating buckets. Now buckets are basically used to store information. They're used as storage, right? This is a storage service. So what you can do here is you can go to create bucket. Now what you can do is you can name your bucket. Let's say I name it 1, right? After that, so you can basically choose the region you're from. So I'm here in India, I'll be choosing Mumbai. And if you don't have an existing bucket and if you don't have settings for your bucket, you can basically choose any existing bucket that you have. But since I do not really have an existing bucket, I cannot choose an existing bucket to have settings from. So this is our first bucket they're making. Now the next thing we see is ACL. ACL is basically related to account ownership, right? Object ownership in the account. So you can choose to block public access in your bucket, right? So, and versioning is basically anything to do with multiple versions or variants of your bucket. So basically it is used to recover, right? So when you lose a certain file or a bucket or certain data, if you have versioning enabled, what it will help you do is it'll help you get a certain copy of the same data that you had. And tags like one before is help you to associate to your bucket. So this is optional, you can or cannot. So you can choose to enable encryption, which is basically used to encrypt and protect your data, or you can choose to disable it, and it is disabled right now. So let's just create this bucket, which is going to be called product one, and we go create bucket. So basically you've created this bucket right now, right? So if you go check out this bucket, what you can see is this is the bucket that is there. right? So you can upload any sort of object that you have. Okay, let's say for example, so basically this is one of the data that you can have in your bucket. Now this can be used as destination and you can upload this, and it has basically been uploaded successfully. Now what you can see here is this S3 bucket has this file in it, right? So this file has this 6 KB download.3 PNG file in it, right? So this is how you can store data in S3, right? Now if you basically go back to buckets, what you can do here is see that there is some sort of data in the bucket, right? And you can see the kind of storage it has. That gives you an option of standard storage or other parts of storages. So then we come to permissions. Now permissions is basically something that you use to authenticate users in your system. Now users in your system will basically have to be authenticated before they access any content or data that you have in your bucket. So basically what you can do here is you can change public access. So public access, the moment you have blocked, nobody can access your data that is there in the bucket, and you could basically edit this. And to confirm this, you just have to write confirm, right? So public access is on, so there is no such bucket policy, right? So you can add certain bucket policy. So you can just go here and you can see the policy that is there in your system, and this is the policy that is there which has allowed public access. And what you can do is this is basically the rules that you set. After that you can just go to management. Now, what management does is basically, so this can show you different things that you can do with S3, such as lifecycle status. Lifecycle status is something that you use when you want to store a certain bucket or a certain amount of data in a bucket for a certain point of time, and then migrate it to another bucket, or migrate all the data in the existing bucket to another bucket, or delete the bucket or something like that. But the data has to migrate. So what you can do is you create lifecycle rule. So you can name all of this, and you can basically choose a scope for the rule, and you can type all of this, basically the type of filter you want. So any type of filter that you want in your lifecycle thing, which is basically making it easier for the destination to be chosen. And you can also have tags. Now basically you can add actions or rules that you can have, and after that you can just create the rule that you have with create rule, and your lifecycle rule is created. So after that we see there's replication. So this is about data replication. So data replication is basically you want to basically add a certain set of rules to a more than one data in some bucket. Okay, so what you can do here is you can have another name for it, let's say 098, right? And after that you can choose the source bucket. So this is my bucket that I've chosen, so this is the source bucket. And the limit also, you'll have to have the destination bucket, but I don't have destination because I've created just the one bucket. All you have to do is create another bucket and you can just store that there. And what you can do after that is you create this. Now after this, what you can see is encryption. Encryption is something which is extremely important when it comes to data redundancy, because when you're coming to replicate data for basically storage purposes or recovery purposes, encryption is extremely important because it maintains the integrity of the data, right? So all of this, and then we talk about the access points. Now access points is basically the different points you can access your data or the S3 bucket in. So access point is different policies that you can have. So what you can see here is these are the different policies that you can have for access points that are there, right? So let's just check it out now. this is very optional when it comes to the security, which is the public access right now, right? And we are creating access point, which is, let's say, access point. So this is the name of the bucket that you have for access point, which is mine, and this is the region that we have, which is Mumbai here. So this is virtual private cloud. So you will have to mention the ID of the virtual private cloud, right? So if you have created a VPC, you will have to be creating that, and then after that you can just save it once you have that HTML policy that you need to basically set the rules, and then you can just create the access point, right? So up next we come to AWS CloudTrail. So this is something that is used for logging. Now logging is something that you do when you want to monitor your account activity. So what you do in CloudTrail is you help create trails, and let's see here, you create a trail, and this is the name of the trail, which is management events, let's say, right? And you just create the trail. Okay, so this is basically one management event, which is a trail. Now what you can do here is you can do various things, which is, it is logging data, and this shows you where the location of the logs are being stored. This is basically SNS, which is simple notification delivery service, which is being disabled, but you can always enable that. What you can do is just stop logging data or start logging data. I will just stop it for now, and you can always choose to edit this, right? So let's go here. What you can see is the details. The name of the trail is management events, let's say. What you do here is you go to S3, you create a new S3 bucket. Since I don't have it, I'll be creating one. This is the name, but you can just use an existing S3 bucket if you have it. So you can have encryption, which is something which is important for maintaining the integrity of the data. And apart from that, which we have log file SNS or all of that here, right? So let's just see that. So what you can do here is that you can go to CloudTrail, you can go here to the dashboard that is there, right? So over here, what you can see is this is the name of the trail that you've made, which is management events, which is off, which is not logging data right now. So this is the event history tab, which is basically a tab which shows you all of the things that has happened inside CloudTrail and all of the things that the user has done, and other certain things in services which are associated or integrated with AWS is also visible. So here you can see that I have stopped logging. So that has been here. It's been logged. The data has been logged, right? So apart from that, we can see start logging, all of the things that you can see here. Let's say create trail, right? So all of this is there, and you can see put bucket policy, and register scalable things. So these are all, username is root, which is my user. Now this is S3, which is an integrated service with CloudTrail. So you can see what is going on inside S3 as well in CloudTrail. Now this is extremely useful for users because it is something which helps them keep track of their services which they have running on AWS, right? So this is an overview of some of the services that AWS provides us with. So in conclusion, what we can see is that more than 80% of organizations have moved to the AWS cloud. And as of 2021, it accounts for over 13% of Amazon's yearly revenue, right? So AWS makes sure your organization's operations run very smoothly and much more scalably and secure. So cloud is definitely the future, and AWS is something which is proof of that, right? AWS is basically taking over the entire computer industry, and it is basically here to stay for the long run.
AWS Management Console is a web interface for managing AWS resources. It provides access to all the various services offered by AWS. It also provides information related to our account like billing. The AWS Management Console provides easy access to services and resources and does not require prior expertise in APIs and SDKs. Firstly, let us know how to set up an AWS account. Since I have already signed up for an AWS account, you can see that I only need to sign in. But if you're a first-time user, you need to sign up for the AWS account first. To set up an AWS account, follow these steps. First, navigate to the given URL. In step 1, enter your email ID and password. In step 2, enter your debit card details. Now, AWS does not charge for services and resources used up to the free limit. We enter the debit card details as it wants to ensure that you're a legit user with a legit bank account. Next, enter your phone number to receive the verification code. Next, enter the verification code you have received. AWS provides 4 support plans: Basic, Developer, Business, and Enterprise. Since we are just beginning, I have chosen the Basic support plan. You can choose any support plan and complete the sign-up process. This is how we set up our AWS account. Now, you must be thinking, what if we exceed the free usage limit? In that case, you also have the option to set up alarms before free usage exceeds. You can keep a check on the charges of AWS services. The charges for AWS services are estimated and sent several times daily to CloudWatch. The alarm can be set for a user-defined threshold limit. When the charges exceed this limit, the alarm alerts the user. Before we set up alarms, we need to enable the billing alerts. To enable billing alerts, you must be signed in to the AWS Management Console. For consolidated accounts, the user can view the billing information for each of the linked accounts if he is logged in as the paying user. You cannot view those members' accounts' billing information which are part of the Amazon Partner Network, as billing metrics for APN accounts are not published to CloudWatch. It is important to note that once enabled, the billing alerts cannot be disabled. To enable billing alerts, follow the steps as shown. Navigate to the CloudWatch console. In the navigation pane, select Alarms. Since I've already enabled alarms, but you need to check the checkbox for Receive Billing Alert and click on Save Preferences. The billing alerts will be enabled. To create billing alarms, follow the steps as shown. Navigate to the CloudWatch console and change the region to North Virginia, that is US East. In the navigation pane, select Matrix, then All Matrix, then select Billing and Total Estimated Charge. Check the checkbox next to US dollars. Go to the Graph Matrix tab and click on the Create Alarm icon. The Create Alarm page is displayed. Choose the threshold type and whenever estimated charges is as what you want. Then define the threshold limit. I have defined it as 200 US dollars. Then click Next and we reach the step 2. Select the alarm state trigger and select an SNS topic. Enter the email ID where you want to receive your notification. Then click Next. Enter the name and description for your alarm and click Next. In the Preview and Create page, verify the information and conditions and click on Create Alarm. The alarm will be created, as you can see. To delete a billing alarm, follow the steps as shown. Open the CloudWatch console and ensure that the region is US East, that is North Virginia. In the navigation pane, choose All Alarms and check the checkbox next to the alarm you want to delete. In the Actions drop-down, click on Delete and in the prompt box, click Delete again. The alarm is deleted. Now let us talk about the services offered by AWS and ways to access those. There are 3 ways to access the AWS services. The first one is through the search box. In the search box, type the service that you need. The next is through the recently visited section. The services accessed recently appear in the recently visited section on the home page. You can access a service from there. The third is through the services option. Click on the services option on the screen and see all services. There are a range of services offered which are classified into different categories as you can see. You can access any service from here. Next on the navigation pane, we have the search box. As we have already seen, in the search box, you can type for the service or resource that you need. Next on the navigation pane, we have the AWS Cloud Shell. It is a browser-based shell that enables the user to manage the AWS resources. Some Cloud Shell features include direct access to command line, pre-installed development tools, and sharing of files. Now let us look at some advantages of Cloud Shell. They include that it works well with AWS Management Console functions, it supports multi-cloud deployments, It is automatically updated. There is no cost for up to 1 GB of storage, and the environment can be customized and retained. AWS also provides us with some tutorials. For example, you can learn how to launch a virtual machine. As you can see, there are some tutorials of small durations that help you perform different tasks through the AWS Management Console. All these are available under the Build a Solution title on the home page. Some common tutorials include launch a virtual machine, build a web app, build using virtual servers, register a domain, connect to an IoT service, and start migrating to AWS. Next on the navigation pane, we have the bell icon. Any issues, scheduled changes, or other notifications appear when we click the bell icon. It has the following features: open issues, scheduled changes, other notifications, and event log. In the account option on the navigation pane, the information related to your account is available. My account displays the details of the user. If the user is connected to several other users, they are arranged in an organization, and the organization's details are displayed. You can also view service quotas, billing dashboard, and security credentials. Next, you have the option to choose your country and region. Certain services are global, which means they are available globally from anywhere, while there are a few other services that are exclusive to a particular region only. AWS Management Console also provides you help and support for your problems and queries. Support Center is available where we can resolve our doubts. We can seek expert help. There are forums where we can discuss our queries. There is documentation, training, and getting started resource center. You can also view details related to your account's billing information. You can view bills, orders and invoices, credit, purchase orders, cost and usage reports, cost categories, etc.
So how does one choose a service? Well, there are quite a few parameters which one needs to consider. As far as the best service providers in the market is concerned, they consider these parameters. Customer friendly. It is very important that a service provider is customer friendly because different businesses have different needs. And if the customer needs are met, then the customer would be happy. And as far as the service provider is concerned, that is what their aim is. If you talk about Amazon, it has the best customer service, and Amazon proudly claims that if you've ever used one of their services, you'd know that we are the best service providers in the market. Next, we have transparency. Now, it is very important that a service provider is transparent. Now, what do I mean by this? What happens is most of the times people are forced to pay money upfront and then they're given access to the services. This does not give them any time or have any kind of demo with the services that are provided by the service provider. This is where AWS is different. What it does is it offers you free tier. Now, what this free tier does is it lets you use all of its services for free, and that too for 1 year. So you have sufficient demo or access to the services which AWS has to offer to you. And then you can take a call whether you want to go ahead and pay for these services or not. Pocket friendly. AWS is highly pocket friendly. Why am I saying this? Say for example, you have to go ahead and buy a server. Now AWS lets you have a server for 1 month at a meager price of $5 only. And this is highly affordable. So these are few of the important points which people need to consider when they go ahead and pick a service. And when you talk about AWS, it meets all of these needs. So let us move further and try to understand the different pricing fundamentals which AWS has. Now AWS considers these three fundamentals, that is compute, storage, and data transfer. If you talk about compute, what AWS does is it charges you on hourly basis. That is, you can use their compute and their processing services at a very less price, and also you'd pay only for those resources which you've used. And again, when you talk about time constraint, if you're using those services only for 1 hour, you'd be paying only for 1 hour. Next, we have storage. What AWS does is it charges you per gigabyte. That is, even if you use very less space, you'd be paying only for that space. And since it is almost as less as 1 GB, that is, you have to pay only for 1 GB, what this does is you don't have to worry about scaling, because if you're using more resources, you'd be paying accordingly. So yes, when you talk about storage, this is a very important point and AWS has it covered. Next, we have data transfer. Now, when you talk about data transfer, again, AWS charges you per gigabyte and it charges you only for the data that goes out. So yes, This again is an important point, and based on all these points, what AWS has done is it has gone ahead and it has built various pricing models. So let us move further and take a look at those pricing models one by one. Now AWS has these three pricing models, that is pay less as you get more, pay as you go, and save when you reserve. Let's first talk about pay as you go. As I've already mentioned, AWS has a very flexible pricing model. Now, what do I mean by this? AWS charges you on hourly basis, plus it charges you only for the compute capacity and the resources which you are using. So if you need a particular resource for 1 hour and you need n number of or n amount of compute capacity, you'd be paying only for that thing. Say for example, your requirement is 40 GB for first month, but what happens is you end up only using 10 GB. Now in this case, your 30 GB of space is wasted, and this is when you pay upfront. But if you're paying on hourly basis and only for the resources which you're using, you're actually saving up all the cost which you would otherwise pay. Secondly, we have something called as pay less as you get more. Yes, more the services you use as far as AWS is concerned, it charges you fairly less. You have a chance of saving up to 70% of your total cost, and that is a very nice feature to have. You also have something called as save when you reserve. Now, if you know how much resources and the compute capacity that you're going to use in near future, what you can do is you can go ahead and reserve these services in advance. Now, in that case, AWS charges you fairly less compared to the other models. So let us go ahead and take a look at these one by one. Firstly, we have no upfront costs. Now, what this means is you can go ahead and reserve your resources and your services in advance, but you're not paying anything. But what happens here is you are paying an amount which is lesser than the previous two mentioned models, that is pay as you go and pay less as you use more. But this thing is still costlier compared to the other subtypes of this model, that is partial upfront cost and full upfront cost. Now, when you talk about partial upfront cost, you are paying a partial lump sum amount which is less than the total amount, and you are reserving all your instances and all those things. But this is comparatively affordable when you compare it with no upfront costs. It is, however, costlier than the last one, that is full upfront payment or costs. In the last point, that is full upfront costs, what you do is you decide, okay, these are the amount of resources which I'm going to use, and this is the compute capacity which I need, and accordingly you book all those resources and you make an upfront payment. Now, since you're making an upfront payment, this is the most affordable of all the pricing models that are there. But for this, you need to be assured that these are the minimum resources which I'm going to use, and if required, I will have to scale up but not scale down. So this is about different pricing models as far as AWS is concerned. So let us move further and try to understand the next point. Now, how does one go ahead and calculate the savings which one makes? Well, AWS has provided you with an AWS calculator. Now, what does this AWS calculator do? It lets you calculate your monthly expenses. That is the services which you've used and all those things. Hence, you can keep a track of all the money which you're supposed to invest. Apart from that, it also provides you with various templates which lets you appraise your complete solution. There's one more variant as far as the calculator is concerned. It is called as TCO, that is total cost of ownership. Now it is little different than the normal AWS calculator. What it does is it basically lets you calculate or compare one service's price with the other service. It also lets you compare the infrastructure solution which AWS has to offer to you, and this might vary from business to business. So when you talk about the total cost of ownership for which you might invest, this is the calculator which you should go for. Now, when you talk about the AWS calculator or the TCO calculator, I would be giving you a small demo, or once I walk you through the AWS website, I would be telling you as in how do these calculators work. I hope this point is clear to all of you. So let's move further and try to understand the next point. Now, AWS also has to offer you a free tier, which I mentioned in the past. So let us move ahead and try to understand what this is exactly. Now, as I've mentioned, AWS has various services to provide to you, and those services will have the subtypes as well. So all these services are available to you for free for 1 year, and this is the access which AWS provides to you. Say for example, you have a service called as Amazon Elastic Cloud Compute. This is one of the most popular services as far as AWS is concerned. And when you talk about its access, what AWS does is it lets you access 750 hours of this service on any of your OSs, whether it's your Linux, whether it's your Windows, you can have access to this thing. And when it comes to using this service, 750 hours is sufficient if you're trying to get started with AWS. Then you have other services like Elastic Load Balancer, you have Elastic Block Storage, you have Amazon Web Services. And based on the usage, they have different capacities which are made available to you for free. Now, AWS won't charge you for any of these things. And when you need a demo, I feel these resources are more than enough. Again, once I switch into the website, I would be talking about the free tier as well. So let's do one thing. Let's actually go ahead and first take a look at these resources or these services one by one. That is, let's try to understand what free tier is and what these calculators are with the help of the AWS website. So what I'm going to do is I'm just going to go ahead and switch into the AWS website. So yeah, what I've done is I've actually gone ahead and I've opened AWS free tier. Now this is what it looks like. Basically, these are all the resources which it has to offer. But before we do that, what you need to understand is you need to create an account here. To do that, you'll have to go ahead and enter your debit card or credit card details. Now, AWS won't charge you as long as you use all these services in the limits which AWS has mentioned. And to be honest, those are fairly large limits. So you won't be exceeding that if you're just using or having a demo of these services. So how does one do that? One goes ahead and gives in their credit card or their debit card details. AWS will charge you $1, that is 1 USD, for some verification purpose. And within 10 minutes, that amount would be refunded back into your account again. So this is only for the verification purpose. And after that, if you overuse the resources, then AWS would charge you. So what you have to do is you have to just go ahead and create an account here. Now, these are the free tier services which AWS has to provide. It has something called as Elastic Cloud Compute, that is EC2. And as I've mentioned, it has 750 hours of it. You have Amazon QuickSight, which is used for analytics basically, and it is available in 1 GB of your Spice capacity. Now, I won't get into the details of what Spice capacity and all those things are. You have something called as Amazon RDS, which is for storage. And again, it provides you with a capacity of 750 hours per month, which is again very high. You have Amazon S3, you have Amazon Lambda. Now, these are fairly popular services. And as far as the space or the capacity which is mentioned here, it is more than enough or sufficient. AWS also provides you with various tutorials that will help you get started here. So if this is your concern, I would suggest that you just go ahead and log into AWS's website, have an account there, and you're good to go. As far as once you sign in, how it looks, I'll show you that as well. You can just go ahead and log in. Now I have an account already on AWS. For some reason, my internet is very slow today. There you go, it takes eternity. Yes, so once you log in, this is how it looks like. You can go ahead and you can actually create your own instances and all those things. Say for example, you have something called as EC2. You can go ahead and you can specify all the details, as in this will show you how many instances are running and all those things. For now, there's nothing that is running here, so there's 0 instances that are running. So you can actually go ahead and create your instances and do all those things. You can launch your instances, say for example, and you get to select as in what OS and what all do you need to do for it. So yes, but then this is not the discussion for today. So I'll just go ahead and skip this part and I will switch to something called as the calculator. As far as the free tier is concerned, these are all the services that are available to you and you can actually go ahead and use those. Now next we have something called as our simple monthly calculator or AWS calculator. Now it gives you your monthly estimate, as in for all the services which you've used. All you have to do is you have to go ahead and add the details, as in what is the description, how many instances are you using, its usage, and the type of the instance. Now the T1 and all those, the micro instances and all those, these are the details that have been covered in a session called as AWS tutorial by Edureka. If you want to have details about those, you can actually go ahead and view that video as well. Now this is where you talk about the billing option, whether it's on demand and all those things. You're free to go ahead and choose a plan for you. As you can see, it's visible here. And once you do that, once you've filled in all these details, your storage, your compute capacities, your elastic IPs and all those things, you finally need to come here and you just need to say that there's an option here which actually lets you submit all these values. And once you do that, you'll have the final result, as in, okay, this is your usage till time and this is the predicted usage and all those things. Then you have something called as your TCO. Now this is more global or more general kind of an application. Now this is something that deals with your interim expenses and all those things. This is for the overall expenses, as in the total cost of ownership. You can select the currency here, as in you have an option of paying in different currencies. Since it's a global leader, you have options to pay in different currencies as well. Say for example, you're somewhere in India, you would be paying in rupees, and you can select that option here as well. Apart from that, what is the environment which you need to compare it against? Because yes, as I mentioned, that you can compare different architectures, so you can go ahead and select that as well. You have various other features. Say for example, you can go ahead and put in the details for the servers, whether those are physical servers, virtual servers, and all that. Your storage. Now there are storage types here. Say for example, you have SAN, you have NAS, you have object. You just need to fill in these things, and then you need to calculate your TCO as well, and you'll have the total cost of ownership too. So these are different calculators, and this is how the free tier as far as AWS is concerned works. So you're actually free to go ahead and explore these things because it is available to you freely, and you can just have access to this and get the know-how as in how AWS works. I hope this is clear to all of you. So let's move further and continue with our discussion as far as the pricing video is concerned. Now that we've understood what the AWS free tier is, let us move further and consider this final point of discussion, that is cost optimization. Now this is a very important point. As I've already mentioned that money is very important when you talk about businesses. It is also very important that you are able to optimize all the money that you are investing in various projects. Now this is where AWS is very good because it helps you optimize your cost a lot. Yes, it has great pricing models, but apart from that, it also lets you use those wisely so you can optimize your cost. Let us take a look at these points one by one. Right size your services. Now, as I've mentioned, it is easier to upscale, but it is not easy to downscale. So it is always wise to start with lesser resources and lesser compute capacity. So this is where right sizing becomes very important, and AWS lets you do that. Since I've mentioned that it has highly flexible pricing model, you can actually go ahead and choose minimum resources, start with small, and then upscale according to your needs. We also have something called as reservation benefits, which I've again discussed in the past. You can go ahead and choose the models which actually meet your requirements, and you can actually go ahead and reserve few of the resources upfront which you're very sure about, and yes, you end up paying less again. Elasticity benefits. Now what AWS does is it provides you with various tools. It also provides you with something called as scheduler. Now these time schedulers, what they do is they let you switch off and switch on your various resources that might fluctuate when you talk about their usages. Say for example, you have services like EC2, RDS. Now these are instance based services, and when you talk about their usage, that might not be constant throughout the various hours of the day. So you can decide to switch off and switch on these resources so that they're used optimally, and you end up paying only for the hours for which you've used those services. So this is where time schedulers do come into picture, and this is where AWS has great elasticity or great flexibility. Finally, in this list, we have something called as track and manage services. Now, AWS provides you with various tools and softwares that actually go ahead and let you keep track of all the real-time usage and measurements that you're concerned with. Now, what this does is this actually helps you optimize your usage. How? Because there are tools that let you build real-time dashboards and all those things. Now, since you have those, you can analyze all the traffic, all the data, and all the resources which you're using. And thus you can cut down on a lot of cost, or you can just go ahead and optimize a lot of money and cost that you're investing in your projects. So these are the points that are very important when you consider cost optimization. And this was probably the last point when you talk about our today's session, that is AWS pricing. So if you're concerned about going ahead and picking a proper cloud service provider, I would say that choose AWS, and it would definitely ensure that you sleep with a lot of cost optimized.
Now moving on to our first topic, what is Amazon VPC? Amazon Virtual Private Cloud is a service that lets you launch AWS resources in a logically isolated virtual network that you define, which means you will have a part of AWS cloud that can be used only by your AWS resources and can be accessed only by you or the people you permit to access. Now these people could be your business partners, your employees, or anyone you want. You will have complete control over your virtual networking environment, which would include selecting your own IP addresses range, creating of subnets, and configuration of route tables and network gateway. I will explain all this term in some time. Now, Amazon VPC allows you to create multiple layers of security, including security groups and network access control list, which will help you control access to your Amazon EC2 instances in each subnet. You can use IPv4 and IPv6 for most resources in your virtual private cloud, which will help you ensure secure and easy access to resources and applications. Now that you have some idea about what exactly is AWS VPC, let us move on to our next topic and see how does it work. But before we get into the working part, I would like to explain the terms which I mentioned before. So if you're wondering what are subnets, these are logical subdivision of a larger network. You can launch your AWS resources into a specified subnet. And when I say AWS resources, I mean your EC2 instances and so on. There are two types of subnet, the public and the private. You use a public subnet for resources that must be connected to the internet. And with a private subnet, the resources won't be connected to the internet. Now, another interesting point is IP addresses of all the subnet in a network will start with the same prefix. Next we have is a route table. Now, a route table contains a set of rules called route that are used to determine where the traffic in a VPC is directed. You can explicitly associate a subnet with a particular route table, otherwise the subnet is implicitly associated with the main route table. Each route in a route table specifies the range of IP addresses where you want your traffic to go, which is the destination, and the gateway, which is the network interface or connection through which to send the traffic, which is the target. Now, as I've mentioned about public subnets and private subnet, let us see the difference between them. So in a public subnet, resources are exposed to the internet using the internet gateway. They make use of both public and private IPs and are mainly used for external facing applications like web servers where you want your information to be visible to the users. Whereas in the public subnet, resources are not exposed to the outer world and it uses only the public IPs. They are mainly used for backend applications like database and application servers. Now that you have some idea about subnet and route table, let us move on to the working of VPC and understand it. Now, if your account was created after 4th of December 2013, your account comes with a default VPC that has a default subnet in each availability zone. We will see this in the demo part. Now, your default VPC includes an internet gateway and has the benefits of advanced feature provided by EC2 VPC and is ready for you to use. Now, if you launch your instance in a default VPC and do not specify a subnet where to launch your instance, the instance is automatically launched in your default subnet, which is a public subnet. You can also create your own VPC and configure it as you want. This is known as a non-default VPC. Now, the subnets that you create in your non-default VPC and any additional subnet that you create in your default VPC are called as non-default subnets. Now you can see we have something called an internet gateway. Now an internet gateway is a gateway that allows your instances to connect to the internet. You can do this through Amazon EC2 Network Edge. Each instances that you launch in your default subnet has a private IPv4 address and a public IPv4 address, as you can see here. By default, each instance that you launch in a non-default subnet has a private IPv4 address but not a public IPv4 address unless you specifically assign it. These instances can only communicate with each other but cannot access the internet. But you can enable internet access for these instances by attaching the internet gateway to its VPC and associating an elastic IP address with the instance. Now, how can you connect your VPC to other VPC or to your on-premises network? So for this, you can create a VPC peering connection between the two VPCs that enables you to route traffic between them privately. Now, instances in either VPC can communicate with each other as if they were in the same network. You can also create a transit gateway and use it as an interconnection between your VPC and your on-premises network. The transit gateway acts as a regional virtual router for traffic flowing between its attachment, which could include VPC, VPN connection, AWS Direct Connect gateways, and transit gateway peering connections. Now I hope you have some idea about the working of VPC. Let us move on to our next topic and see some of the use cases of VPC. With Amazon VPC, you can host a simple web application such as a blog or a simple website with additional layer of privacy and security. You can help securing the website by creating security group rule, which will allow the web servers to respond to inbound requests from the internet while simultaneously prohibiting the web servers from initiating outbound connection to the internet. Now what this means is you can control your data traffic in and out of your VPC. You can create a VPC that supports this use case by selecting VPC with a single public subnet only from the Amazon VPC console wizard. With VPC, you can also host multi-tier web application and strictly enforce access and security restriction between a web servers, application servers, and databases. You can launch web servers in a publicly accessible subnet while running your application servers and databases in a private subnet. This will ensure that your application servers and databases cannot be directly accessed from the internet. To create a VPC that supports this use case, you can select VPC with public and private subnet in the Amazon VPC console wizard. With Amazon VPC, you can also backup and recover your data after a disaster. By using Amazon VPC for disaster recovery, you will receive all the benefits of a disaster recovery site at a fraction of the cost. You can periodically backup critical data from your data center to a small number of Amazon EC2 instances with Amazon EBS volume. Or you can also import your virtual machine images to Amazon EC2. To ensure business continuity, Amazon VPC allows you to quickly launch replacement compute capacity in AWS. These were some of the use cases of using VPC. Now let us move on to our next topic and see an overview of the other networking concepts in AWS. First, let us talk about Elastic Load Balancer. Elastic Load Balancing automatically distributes your incoming traffic across multiple targets. The targets could be EC2 instances, containers, and IP address in one or more availability zones. It will monitor the health of your registered target and route traffic only to the healthy target. It scales your load balancer as your incoming traffic changes over time. You can add and remove compute resources from your load balancer as your need changes. It will not disturb the overall flow of requests to your application. Now, Elastic Load Balancing offers 4 types of load balancer. First is the classic load balancer, which provides basic load balancing across multiple Amazon EC2 instances, and it operates both at request level and the connection level. A classic load balancer is intended for applications that were built within the EC2 classic network. Second, we have Application Load Balancer. It is best suited for load balancing of HTTP and HTTPS traffics and provides advanced request routing, which is helpful in modern application architecture, including microservices and containers. Third, we have Network Load Balancer, which is best suitable for load balancing of TCP, UDP, TLS, where extreme performance is required. A network load balancer routes traffic to targets within Amazon VPC and is capable of handling millions of requests per second while managing ultra-low latencies. Fourth, we have the Gateway Load Balancer. It is used to deploy, scale, and run third-party virtual networking appliances. Gateway Load Balancer is transparent to the source and destination of traffic, which makes it well suitable for working with third-party appliances for security, network analytics, and other use cases. This was about Elastic Load Balancer. Now let us take a look at AWS Direct Connect. AWS Direct Connect is a cloud service solution that makes it easier for you to establish a dedicated network connection from your on-premises to AWS Cloud. Using AWS Direct Connect, you can establish a private connection between AWS Cloud and your data centers or your office. You can increase the bandwidth throughput and provide a more consistent network experience than internet-based connections. AWS Direct Connect is also compatible with all the AWS services and is available in the speed starting from 50 Mbps and can be scaled up to 100 GB per second. It helps you build hybrid environment, which allows you to use the benefits of AWS and continue to utilize your existing infrastructure. Now let us move on to our next service, which is Route 53. Amazon Route 53 is a highly available and scalable cloud domain name system or DNS web service. It is designed to give developers and businesses a reliable and cost-effective way to route end users to internet applications by translating names into numerical IP addresses. This can be used for computers to connect to each other. Now Route 53 performs 3 main functions. First one is it registers your domain name. Every website needs a name, be it edureka.co or anything like facebook.com. So Route 53 lets you register a name for a website or web application known as a domain name. The second function is it routes internet traffic to the resources for your domain. So when a user opens a web browser and enters your domain name or the subdomain name in the address bar, Route 53 helps connect the browser with your website or web application. The third function is it checks the health of your resources. Route 53 sends automated requests over the internet to a resource, such as a web server, to verify if it is reachable, available, and functional. You can also choose to receive notification when a resource becomes unavailable and choose to route internet traffic away from the unhealthy resources. Now these were some of the networking services in AWS. Now let us move on to a demo part where I will teach you how you can create a VPC, your subnet, your route table, and an internet gateway. So for our demo, I've logged in into my AWS console. If you do not have an AWS account yet and want to practice AWS services, I would highly recommend you to create an AWS free tier account where you can access more than 75 AWS services for free for a year. So a point to remember is your VPC will be set in this region. In my case, it is Ohio. You can see there are so many regions available here. Your VPC can be set in your selected location. Now let us start a demo. We'll search for VPC. You can just search over here, VPC. Here it is. Now when you click on your VPC, you can see there is a default VPC as I mentioned before. It will also have a default subnet inside it. So now let us create our own VPC. So I click on create VPC. So it will ask us to name our VPC. Let me name it demo VPC. Now when you create a VPC, you must specify a range of IPv4 address for the VPC in the CIDR block, which stands for classless inter-domain routing. We will go for the primary CIDR block, which is 10.0.0.0/16. Now mention 16 over here, which means 16 bits is reserved for my VPC network. Now we'll go with the default. I do not want any IPv6 CIDR block. Next we have tenancy. Now here you can see we have two options. One is default, the other one is dedicated. So what dedicated means is you can run your instances in your VPC on a single tenant or a dedicated hardware. So we'll just stick to default here and create our VPC. Then you'll get a message saying you have successfully created your VPC. This is your VPC ID and this is your VPC name. Now let us create a subnet. Now as I've told you in the theory session, a default subnet is created. And you see we have 3 default subnets over here. When I just scroll here, you see the 3 default subnets are created in 3 different availability zones. So each availability zone has one subnet in it. So now let us create a new subnet. We have to select a VPC from here. This is a VPC. Next we'll come down and we'll name our subnet. Let us name it demo subnet. Now we have to select the availability zone. We have 3 availability zones in Ohio. We'll just select one of these. Now we also have to mention our IPv4 CIDR block for our subnet. So we'll just set it to 24. So when I type 24 over here, it means 24-bit is reserved for my VPC network. Now the starting of the IP address of the subnet should be the same as the starting address of your VPC. Now after this, let us create a subnet. This might take a few seconds and you can see you have successfully created your subnet. This is your subnet ID and this is your subnet name. Next we'll create our internet gateway. We'll get back to route table in a few minutes. Now as you can see there is a default internet gateway, but we will go ahead and create our own internet gateway. So here it will ask us to name our gateway. Let's just name it demo internet gateway and just create our internet gateway. It is very simple. Now our internet gateway is created. This is our internet gateway ID, but the state is detached. Now you can go attach your VPC to your internet gateway. Just click on attach to a VPC over here and just select a VPC from here. Here is our VPC, so we'll just select it and now attach internet gateway. So here the state is attached. Now let us move on to the next step and create a route table. Now as I've mentioned before, route table determines where the network traffic from a VPC is directed. Now these are some of the default route tables, but we'll create a new route table. So now we have to name a route table. Let us name it demo route table. And we have to attach a VPC to it. Here is a VPC. Let us create it. We'll get a message saying a following route table was created. And here is the route table ID. We'll close it. So after we create a route table, we have to associate a subnet to it. So we'll just click on route table over here. Go to subnet association. Edit subnet association. Now select a subnet. So this is a subnet, demo subnet. So we'll save it over here. After the subnet association, we have to edit the route to access the internet gateway. So we click on route, edit our routes. Now let us add another route. So the destination will give 0.0.00. Now this means your traffic can flow anywhere. The target will keep it as internet gateway. So we're trying to access our internet gateway. So we'll select this and then save the route. Now we get a message saying route successfully edited. We close it. Now with this, we have created a VPC, a subnet, a route table, and an internet gateway. Now let us see if we can launch an instance in our VPC. But let me go to New tab, AWS Management Console. Let me type EC2 over here. I'll go to Instances. I'll go to Launch Instances. Here, let me launch in Window instance. So I'll select Window. Now I'll select this instance and then go to Configure Instance. Now here under Network, I'll remove the default VPC network and set my network. I'll change the subnet also. And we also have to change the auto assign public IP to enable. We will enable this to create a public IP. So after this, we'll make no changes. Go to Review and Launch. Before that, let us create a security group. Let us just name it Demo Security Group. And now Review and Launch. We'll use an existing key pair and now launch our instance. Now let us click on View Instance. Now this might take a couple of minutes. While our instance is getting created, let us go back to a VPC. We go to VPC dashboard, and here you can see there are two VPC. One is a default VPC and the other one which we have created. And there are 4 subnets. 3 are defaults and 1 which we have created. There are 2 default route table and 1 which we created. There was 1 internet gateway which was default, and then we created another one. Now let us check our EC2 instance. We'll refresh it. Now you can see 2-on-2 status check is passed. So we'll click on our instance ID. Now this is our instance ID. This is a public IPv4 address, a public IPv4 address. Now when we come down and see the VPC ID over here, you can see the instance was created in our VPC ID. That is the name of our VPC, and it is also created in our subnet, which is the demo subnet. And you can also see it was set up in the availability zone you had mentioned. Now the instance can be used only by me or the people I permit. A part of AWS Virtual Cloud was given to me to run my resources.
Now again guys, if you are completely new to AWS, that is Amazon Web Services, please go through the other videos that we have in our stack or in our playlist on YouTube. Probably those would hold you in a much better state to understand some of the terms that I would be using. As we move further, I would be talking about these terms as well, but we won't be getting into the depth of the terminologies here because we assume that the fact that you're here, you have some understanding of what AWS is. So let's just move further and try to understand these practices. So when I say EC2, it is Elastic Cloud Compute, a computation service offered by AWS. Now, what does this service do? Well, basically what it does is it lets you create ROST servers on which you can host your websites and other applications that you have. So that is what EC2 stands for. So what are the practices that you can do to make sure that your AWS or your account or your infrastructure in general is in a better state? So these are some of the practices. AMI hardening is the first one. Now AMI, Amazon Machine Image, what it does is if you have an EC2 server, basically what it does is it lets you make a copy of it, take an image of it and use it as a template to generate similar kind of instances. So what can you do with this template? Well, the first problem is if you are having an infrastructure or an application that has multiple instances, in that case, replicating your instances each time won't make a lot of sense because you need a secure and a more robust AMI. So can you define certain properties for it? Yes, you can actually define certain properties and harden your AMIs in a much better way. Say, for example, you have your SSH, which is nothing but your secured shell host. In that case, what you can do is you can change these hosts so that your account is more secure. Apart from that, you can ensure that you actually have proper IAM users and VPC accesses that are given to your so-called instance so that it is secure on a higher level or at a better level. VPC port location. Now, when I say VPC port location, virtual private cloud, as we know, what it does is it brings in n number of instances under one umbrella. That means you need these instances to communicate with each other. As I've already mentioned, you won't be dealing with one single instance, right? So in this case, you want these instances to communicate. And how do they do that? You use VPC. But what are the problems with VPC? The major problem is security concern. Who gets to access your VPCs? Now, basically what you can do is you can limit your IP addresses. It is advised that you block your IP addresses. You do not give any random IP address to access your VPC. But then there are certain VPCs which need to be accessed by certain IP addresses. In that case, you can make your ports or your VPCs open for certain IP addresses only. Private subnets. Now, all your applications should fall under private subnets. There is an exception. You have your load balancers and stuff like that, which do not fall under your private subnets, but you have to ensure that remaining stuff, it falls under your private subnets and they are properly secured. Microservice architecture. Now, what is a microservice architecture? Well, microservice architecture, what it does is it helps you break down your architecture into simpler portions or simpler manageable services. Now, to give you an example, suppose you have your e-commerce website, something like Amazon. So you have so many verticals. I mean, you have your payment, billing, your security, your front end, back end, number of verticals, that is the products that are sold, different products for male, female, and stuff like that. So all these needs to be arranged into a more manageable system, right? So what happens here is instead of having one monolithic architecture for these individual verticals, if you can have a different service that caters the need better on longer run. Why? Even if one vertical goes down, the other verticals are working smoothly. That means these verticals aren't dependent on each other. So introducing this kind of architecture into AWS would definitely help, because if suppose your billing goes down, maybe your login credentials or your login form still works. So for people who just need to log in, they can do that. And for people who want to build, probably they might have to wait. But again, at least one service is working. So that is what microservice architecture helps you do. So implementing these kind of architectures also becomes important. Environment-based keys. Now, again, when you talk about accessing your EC2, you cannot just go ahead and access your EC2. You need to give in some password details. Now, how do you have or how do you get in your password details? You do not log in with your username and ID. Here, when you create an instance, with that you create a user key and its password. Those are called as your SSH keys again, which are used to log into your instance. So it is important that you have individual keys for your different environments. You have key for your development environment. You have one more key for your administrative environment. What this does is, suppose if I have a developer person, I would give him access only to the dev environment because probably he or she is not concerned with the administrative environment and I do not want them to have that access. So this helps me in better organization and keeping my resources safer. So having environment based keys also work well. And finally, LDAP authentication. Now, if I have n number of environment based keys, I have n number of users and stuff like that. So authenticating these logins or these user credentials can be a tedious task. So instead of doing it manually, there is something called as LDAP authentication that helps you automate this process and saves you from the tedious efforts that you would otherwise put in. So yes, this also becomes an important practice when you talk about EC2. So yeah, these are some of the practices. Now let's move further and talk about something else, IAM, that is identification and access management basically. Now here, as the name suggests, what you do is you actually manage and govern the access given to the users that are using your AWS services. So let us move further and take a look at some of the practices that ensure that IAM is taken care of properly. Roles for teams. Again, I talked about the importance of having environment-based keys. This is a little similar. You should have roles defined in hierarchy so that you can give proper access to proper people. Suppose I'm creating an IAM user. For people who do not know what IAM user is, it is nothing but it is a second level login where I do not give root access to everyone. Instead, I give access to individuals where they have access to certain resources only. So that is what an IAM user is. So my root user would be having access to everything that happens, but my IAM user would be having access only to certain resources. So when you do assign these IAM roles or accesses to your individuals or employees, if you have roles defined for your teams, you can know how much access to give to which individual. That is why roles for teams actually play in very well. So it is important one has a structured approach and proper roles defined for their teams. Service specific access. We've discussed this already. If you are into development, probably the services that concern development, you should have access to only those services, and accordingly should be your IAM user access given to you. You should have read only access. Now, this is not true always. Now, but yeah, in some cases, say for example, you are a fresher maybe or somebody who has recently joined in the company, and I do not want you as an individual to access all my resources or make changes to those. Instead, I just want you to get a view of those. So probably I would give you read only access. So probably you can understand everything that is happening, but cannot make any changes to the stuff that is there. So read only access also becomes important. So when it comes to identification and access management, you need to follow these practices. There are a couple of more, but these are the important ones. S3 practices. So what is S3? S3 stands for Simple Storage Service. Now, it is a storage service provided by AWS, and what it does is it takes in your data in the form of objects and stores it in buckets or in containers, which are called as buckets. So what are the best practices that you can do or relate to S3? What you can do is you can have content specific names. Now, why do we need to do this? What AWS does is it names its services, or it not its services, rather S3. What it does is, in order to create S3 buckets, what you have to do is you have to give specific or unique names to your resources. So if there is a name that is already taken, you cannot use it. It is not allowed. So in that case, you would be forced to use longer names. To give you an example, suppose if Edureka does not work out, you might be required to enter something like Edureka certification, Edureka training. So depending on that, the size of your name would go much bigger than what you expect. So in that case, having content specific names helps. Say for example, I am talking about an AWS course, maybe a master's course with Edureka. So probably my name should be something like Edureka Masters AWS. So it creates an hierarchy, and what it also does is it makes it simple to understand the names. So having this practice is actually a good habit. Create bucket policies. Again, this becomes very important. Why is that? Now, who needs to access your buckets? It also becomes important. What kind of data are you storing in that bucket? And which people do you want to access your particular bucket? So to control these things, you need to give proper bucket access as well. Archive buckets to Glacier. Now, what is Glacier? Let's first understand S3 a little more. Now, S3 is a simple storage service which lets you store and retrieve data at standard pace, but it is costlier compared to a service called as Glacier. Now, Glacier again, it lets you store data, but it is specific for archival data and it is much cheaper. Why is that? First, understand archival data. This data is data that you do not want to access every day. To give you an example, suppose I want my birth certificate. For that, I would have to go to a hospital, right? So if you remember the old school traditional method where we had everything put in papers, probably if I did go there and tell them that give me my birth certificate after 25 years or my 30 years of my age, what would happen there is probably they would tell me that you have to wait for maybe a couple of days, couple of hours, and then come back to take that document because that document is not retrievable right now. So there are certain things where the data that is stored is not required frequently, like in the case of my birth certificate, right? But if it was some medication or prescription that I took maybe from a medical store, they would have a copy of it in the system, right? Which I can readily take it right away. Why? Because probably that is more required information. So try to relate this example with S3 and Glacier. Your S3 is like your medical system where you get your data right away. You go there, you tell them, I need this, I had done this or this stuff. So they would give you the data right away that, yes, this is the record we have. But for my birth certificate, it is more or it is similar to Glacier where you store in data which you do not require frequently, probably once in a lifetime or maybe 5 times in your life. So similarly, the data that you do not need every day, I need it maybe once in a while, I can put it in Glacier. So the fact that I cannot retrieve it right away, it is cheaper. So what best practice would be, it is to move your S3 data to Glacier in case if you're not using that data every day. That would help you save a lot of money. Version your objects. Yes, this is very important again. When I say versioning your objects, what I'm trying to symbolize or lay emphasis on is the fact that if you put in your data into your S3 bucket, you can constantly make updates or keep a fresh copy of the recent update. As in, when you create a version, you're stating that this is the recent entry to my data. So what that does is, in case if you want to go back, you can go back to the freshest copy that you've stored. So versioning also helps. So these are some of the practices that concerns S3. So let's just move further and try to understand some of the security practices. Now, if you talk about cloud computing, people have always doubted whether cloud platforms are secure or not. But that question or that debate has been put to rest a while ago. People know that cloud platforms are very secure, and these are some of the practices that ensure that your cloud platforms can be a lot more secure than what you think right now. So what you should do is you should never share your root account credentials with anyone. As I've already mentioned, you have a root account using which you can create different IAM users, which can be assigned to people who have specific responsibilities. So they would be answering or solving or having access only to those resources that they need. So if you share your root account details with anyone, probably they might misuse your resources, and that might lead to hampering your overall security of the infrastructure. So make sure that that does not happen. Remove unwanted users. Say, for example, somebody leaves your company. Now, having an IAM user with that credential won't be good, because if that person still has access to those resources, probably he can hamper you again. Enable two-factor authentication. Yes, you can have a number of other devices which generate 4 to 6 digit codes. So once you do log in with the credentials, if you are associated with these kind of applications, probably this would ensure that the user has to log in twice, and so that the system stays more secure than what it is already. Use IAM logins. Yes, now this again is important. I've already mentioned, if you need users to have access to your resources, give them limited access. They need not have to have access to everything that is being used. So this is one practice which again becomes very important. Billing practices. So how can you optimize cost? Well, if you talk about cloud computing, it ensures that you don't pay a lot of money. I mean, because you're paying for the resources that you're using and only for the time duration you're using those resources. So the amount is very less. But still, at times when you talk about huge infrastructures and architectures, you might be forced to shell out a lot of money. So how do you prevent or how do you optimize this further? Well, there are certain practices. If you do implement those practices, definitely you can save a lot of money. One practice that you can do is billing budgets. Now, what it does is you can pre-state, okay, I want to use these many resources for this duration of time. So AWS gives you a predefined budget. Okay, this is the amount you'd be paying, and these are the resources you would be using. So if you do set an alarm, AWS would alarm you saying that, okay, you are reaching a particular limit of your resources. Keep check of those resources. And this is where billing budgets help you a lot. What billing budget also does is it ensures that each individual service, it has its own proper billing budget as well. Say, for example, S3 charges might be different. Your different services like EC2 and all, if you have your certain servers running, your database is running. So in that case, the charges vary. So if you're using a particular resource, you'd be charged only for those resources. And accordingly, you can set budgets as well. So that helps you in the longer run. IAM billing. Yes, now billing access is given to few users only. You do not have IAM billing access in general to start with. But if you want certain users to have access to your billing so that they can help you better plan your expense and maybe help your organization with the finance stuff, probably you can have some IAM users having certain billing accesses as well. Multiple credit card payments. Now, what AWS does is it gives you a facility where you can have multiple credit cards linked with your account. So if you're using a particular credit card and while paying the bill, you reach its limit, you might switch to the other credit card as well. This again helps in the longer run. Regional taxation. Yes, now based on the region where you are based in, your taxes might vary. But in general, if you allocate this particular service, now there is a tab available in your billing department where you can activate this notion. And once you do that, AWS keeps track of all the resources that you've used and the money you've paid. So when you're filing your ITR income tax returns, that is, probably you can always put in the details given by AWS. You can generate a copy of it and say that I've paid my money here. So probably that would help you with the taxation part as well. And finally, you should have multi-account consolidation. Now, this is opposite of what we discussed in the third pointer. Not opposite, but a little contradicting to that point. And how is that? Well, when you talk about multi-account consolidation, what it says is if you have multiple resources or that are linked to each other, if you want to pay them in one go, instead of paying them individually, you can have those resources consolidated in one place and have a consolidated billing account for it. So when a bill is generated, instead of paying maybe 4 or 5 bills one by one, you can do it in one go, paying all of them added together. So yeah, these are some of the best practices that concern billing. And more or less, these were the practices I wanted to talk about.
What is DevOps? DevOps is basically a combination of two words, development and operations. So what do we get when we combine these two? Simply speaking, DevOps is a culture that implements technology in order to promote collaboration between development and operations team to deploy code to production faster in an automated and repeatable way. The goal of DevOps is to increase an organization's speed when it comes to delivering applications and services. Many companies have successfully implemented DevOps to enhance their user experience. Let's take for example, Facebook's mobile app, which is updated every 2 weeks, effectively telling users, you can have what you want and you can have it now. Ever wondered how Facebook is able to do this so smoothly? It's the DevOps philosophy that helps Facebook ensure that its apps aren't outdated and that its users get the best experience. Facebook accomplishes this through a code ownership model that makes its developers responsible. That includes testing and supporting through production and delivery for each kernel of code they write and update. It's through policies like this that Facebook has developed a DevOps culture and has successfully accelerated its development lifecycle. Industries have started to gear up for the digital transformation by shifting their needs to weeks and months instead of years while maintaining high quality. As a result, we will soon see that DevOps engineers have more access and control of the end user than any other person in the enterprise. So what are you waiting for? Don't be in the sidelines when that happens. To master your skills, enroll in Edureka's DevOps certification program and become a leader.
Why do we need DevOps? The birth of DevOps occurred when there were some drawbacks with the existing software development models for application development. The first model we'll be addressing today is the waterfall model. So the waterfall model is a model of software development which is pretty straightforward and linear. So this model follows a top-down approach, as you can see in the image. It has various phases starting with requirements gathering and analysis. So the first phase is where you get the requirements from the client for developing an application. So after this, you try to analyze these requirements that you've acquired. Next comes the design phase where you prepare a blueprint of the software. So in this phase, you think about how the software is actually going to look like. Once the design is ready, you proceed further with the implementation phase where you begin with the coding for the application. So here the team of developers work together on various components of the application. And once the application is developed, it is tested in the verification phase, that is the fourth phase. Here there are various tests conducted on the application such as unit testing, integration testing, performance testing, etc. After all of these tests on the applications are done, it is finally deployed on the production servers. At last, that is the fifth phase, is the maintenance phase. So in this phase, the application is monitored for performance. So any issues related to the performance of the application are resolved in this phase. But unfortunately, this model, that is the waterfall model, has some major drawbacks. So the first drawback is gathering and documenting your requirements each step of the way can be extremely time consuming, not to also mention difficult. It is hard to assume things about your product so early into the project. And because of the same reason, your assumptions might be flawed and different from what the customer expects. The second drawback is that now if the above case is true, your customers are basically dissatisfied with your delivered product. Adding changes to the product can be expensive and most of all difficult to implement. So the third drawback is that in general, the risk is extremely high with the waterfall approach because the scope for mistakes is extremely high. If things go wrong, fixing them can be hard as you have to go a couple of steps back. The next model is the Agile model. So Agile is an iterative based software development approach where the software project is broken down into various iterations or sprints. So every iteration has phases like the waterfall model, such as requirements gathering, design, development, testing, and maintenance. You can see each of these iteration in the image. So each of this iteration generally lasts for about 2 to 8 weeks. So the difference between Agile and waterfall model is that you release the application with some high priority features in the first iteration. After its release, the end users or the customers can give you feedback about the performance of the application. So the necessary changes are made to the application along with some new features. And once these features are added to this application, it is again released, which is in the second iteration. This procedure is repeated until the desired software quality is finally achieved. Now, in spite of being used often, the Agile method has a few disadvantages. The first one is that for the approach to work, all the members of the team must be completely dedicated to the project. That is, everyone must be involved equally if you want the whole team to learn and do better on the next run. And this is mainly because Agile focuses on quick delivery. There might be an issue with hitting deadline. The second drawback is that the approach may seem extremely simple, but it is hard to execute. So it requires commitment and for everyone to be on the same page, ideally in the same physical space. The third drawback is that documentation can sometimes be ignored. Because Agile methodology focuses on working software over comprehensive documentation, things might sometimes get lost through each stage and iteration. As a result, the final product can feel different from what it was first planned. So these are the few drawbacks that the Agile model or the Agile methodology gives us. So in delivering valuable software to customers, development and operation teams are always in conflict with each other. While development wants to deliver its changes to customers quickly, operations want stability, which means not changing the production systems too often. So the gap between the development and operations team occurs on three different levels. The first one is the incentives gap. This is because of different goals of development and operations. The second one is the process gap, which is the result from different approaches of development and operations and how to manage changes, bring them to production, and maintain them there. The third one is the tools gap, which results from the fact that development and operations often use their own tools to do their own work. And this is resulting from the fact that development and operations often use their own tools to do their work. As a result, from all of these reasons, development and operations often act like silos, as they are two distinct teams. So the conflict between development and operations is because of two reasons. The first one is need for change. This is because development results in change. That is, they're always working on new features, bug fixes, etc. It wants the change to quickly roll out to production. And the second one is fear of change. Once the software is finally delivered, the operations department avoids making changes to the software to ensure stability. This is the major conflict between both of these teams. So this is where DevOps comes into picture. DevOps links software development to operations. I hope that is clear. That is, DevOps bridges the gap between agile software development and operations experiences. It is important to know that DevOps is a set of principles to break down silos. Specifically, DevOps is all about culture, automation, measurement, and sharing. So the first one is culture. So in culture, people and processes comes first. If you don't have a culture, all automation attempts will be fruitless. The relationship is important in culture because its functions include engage early, engage often, destroy silos, be open to options, and stop blaming. And the second one is automation. So once you understand your culture, you can simply start with automation, right? Now you can finalize various tools to achieve automation for DevOps. That is, tools for release management, provisioning, configuration management, systems integration, monitoring and control, and orchestration becomes extremely important pieces for DevOps. The third is measurement. So if you cannot measure, you cannot improve. Makes sense, right? A successful DevOps implementation will always measure everything it can as often as it can. Performance metrics, process metrics, people metrics, capacity planning, trend analysis, fault finding, etc. All of these have to always be measured. So the last one is DevOps is about sharing. Sharing is the loop back in the cycle. So creating a culture where people share ideas and problems is extremely critical. So exposing ideas can create great open feedback that in the end it helps to improve shared ideas, share metrics, give DevOps shell access, see what technology can be leveraged, etc. So DevOps is all about these four particular features. I hope this is clear. So now let's move on to the next part of today's session, that is Introduction to DevOps. So finally, we will address what is DevOps. DevOps is simply a combination of two words. You can see that. One is the software development and the second one is operations. So this allows a single team to handle the entire application lifecycle. That is from development to testing, deployment, and finally operations. So DevOps really helps you to reduce the disconnection between software developers, quality assurance engineers, and system administrators. That is, it basically promotes collaboration between the development and operations team to deploy code to production faster in an automated and repeatable way. So DevOps basically helps to increase organization speed to deliver applications and services. It also allows organizations to serve their customers better and compete more strongly in the market. It can be also defined in another way, that is, it is also a sequence of development and IT operations with better communication and collaboration. So in the market, it has become one of the most valuable business disciplines for enterprises or organizations. With the help of DevOps, the quality and speed of the application delivery has improved to an extremely great extent. Organizations that have adopted DevOps notice a 22% improvement in software quality and a 17% improvement in application deployment frequency. They have also achieved a 22% hike in customer satisfaction. Overall, a 19% of revenue hikes as a result of the successful DevOps implementation has been achieved. Moving on, DevOps workflow is another important concept. So what is a DevOps workflow? So it basically provides a visual overview of the sequence in which input is provided. Also, it tells about which one action is performed and output is generated for an operations process. So basically, DevOps workflow allows the ability to separate and arrange the jobs which are top requested by the users. Also, this workflow gives the ability to mirror their ideal process in the configuration jobs. Moving on, let's see some of the DevOps principles. So the main principles of DevOps are continuous delivery, automation, and fast reaction to the feedback. But there are 6 other principles that we'll be discussing today. The first one is the end-to-end responsibility. So DevOps teams need to provide performance support until they become the end of life. It enhances the responsibility and the quality of the products engineered. The second one is continuous improvement. DevOps culture focuses on continuous improvement to minimize waste. That is, it continuously speeds up the growth of the products or the services that has been offered. The third one is automate everything. Automation is an essential part of the DevOps process. We'll be discussing about this later on in this session. This is for the software development and also for the entire infrastructure landscape. The fourth one is custom-centric action. So the DevOps team must be customer-centric so that they should continuously invest in products and services. The fifth one is monitor and test everything. The DevOps team needs to have robust monitoring and testing procedures. The last one is work as one team. In the DevOps culture, role of the designers, developers, and testers are already defined. So all they need to do is work as one team with complete collaboration. These principles are achieved through several DevOps practices, which include frequent deployments, quality assurance automation, continuous delivery, validating ideas as early as possible, and in-team collaboration. Now let's move on to the third topic of today's session, companies using DevOps. By now, you must have figured out that DevOps helps to increase an organization's speed to deliver applications and services. This is exactly why many organizations such as Amazon, Netflix, Etsy, HP, Adobe, and many other organizations are adopting DevOps and its practices. We will now discuss how Amazon makes use of DevOps to increase their work efficiency. You must be aware that Amazon is one of the biggest e-commerce companies in the world. But way back in time, their website followed a traditional monolithic architecture. So in this type of architecture, all the processes are coupled together and run as a single service. Over time, as the code and the source files grew, it became hard to scale, maintain, and upgrade their applications on physical servers. So what did Amazon do? Amazon simply solved the problem of the monolithic architecture by moving from physical servers to cloud-based Amazon Web Services. You all must have heard of AWS. Currently, AWS follows a microservice architecture. In Amazon, there are basically three types of microservices. They are users, threads, and posts. Developers here apply frequent but small changes over their code via version control tools like Git and GitHub. Practices like code deployment help fix bugs and adds new features to improve the underlying software application. AWS Code Deploy is one such service that keeps track of deployments and simplifies the entire software release process. Amazon also uses Apollo. Apollo is a simple one-click internal deployment tool. So Apollo's job is to deploy a specified set of software across a group of hosts. On the other hand, practices like configuration management and infrastructure as code help to monitor and make changes in the software. It keeps track of the system's performance and resources used by developers. So in this way, the testing team can identify problems way before in hand and fix them immediately. So this is how Amazon implement DevOps and its practices. Now let's move on and understand one major concept of DevOps, that is the DevOps lifecycle. So if you're into DevOps from quite some time now, you must have heard at least one of these DevOps phases, that is continuous development, continuous integration, continuous testing, continuous deployment, and continuous monitoring. So all of these phases that I just mentioned make up the DevOps lifecycle. As you can see on the screen, and as I've already mentioned, all of these phases make up the DevOps lifecycle. The first phase is the continuous development phase. So this is the phase that involves planning and coding of the software. So the vision of the project is decided during the planning phase, and the developers begin developing the code for the application. There are no DevOps tools that are required for planning, but there are a number of tools for maintaining the code. The code can be written in any language, but it is mainly maintained by using version control tools. So here, maintaining the code is referred to as source code management. So some of the most popular version control tools are Git, SVN, Mercurial, CVS, etc. Also, tools like Ant, Maven, Gradle can be used in this phase for building or packaging the code into an executable file that can eventually be forwarded to any of the next phases. The next phase in the DevOps lifecycle is continuous testing. So this is the stage where the developed software is continuously tested for bugs. For continuous testing, automation testing tools like Selenium, TestNG, JUnit, etc. are used. So basically the tools that I just mentioned right now allow quality assurances to test multiple code bases thoroughly in parallel to ensure there are no flaws in the functionality. So what automation testing does is it saves a lot of time, effort, and labor for executing the test instead of doing this manually, right? Also in this phase, Docker containers can be used for simulating the test environment. Selenium here does the automation testing, and the reports are generated by TestNG. So this entire testing phase can be automated with the help of a continuous integration tool called Jenkins. We'll talk about Jenkins later on in this session. So now let me explain you this with an example. Suppose you've written a Selenium code in Java to test your application. Now what you can do is you can build this code using Ant or Maven, and once the code is built, it is tested for user acceptance testing. So this entire process can be automated using Jenkins. Besides that, the report generation is a very big plus point. The task of evaluating the test cases that failed in a test suite gets simpler. We can also schedule the execution of test cases at predefined times. Once the entire testing is done, the code is continuously integrated with the existing code. The third phase of this life cycle is continuous integration. So now this stage is the heart of the entire DevOps lifecycle. It is a software development practice in which the developers require to commit changes to the source code more frequently. This may be on a daily or a weekly basis. So every commit is then built, and this allows early detection of problems if they are present. Building code does not involve compilation, but it also includes code review, unit testing, integration testing, and packaging. The code that is supporting new functionality is continuously integrated with the existing code. Since there is continuous development of software, the updated code needs to be integrated continuously as well as smoothly with the systems to reflect changes to the end users. As I've already said in the previous slide, Jenkins is a very popular tool used in this phase. So whenever there is a change in the Git repository, Jenkins simply fetches the updated code and it prepares a build of that code, which is in an executable file. So once this entire build is performed, it is then forwarded to the test server or the production server. Now let's move on to the fourth phase of the cycle, that is the continuous deployment phase. So this is the stage where the code is deployed to the production servers. It is very important to ensure that the code is correctly deployed on all the servers. Now before moving on, let us understand a few things about configuration management and containerization tools. Now these set of tools help in achieving continuous deployment. Firstly, I will talk about configuration management. It is basically the act of establishing and maintaining consistency in an application's functional requirements and performance. So let me put this in simple words. It is the act of releasing deployments to servers, scheduling updates, and most importantly, keeping the configurations consistent across all the servers. Since the new code is deployed on a continuous basis, configuration management tools play an extremely important role in executing tasks quickly and frequently. Now, some popular tools that are used here are Puppet, Chef, SaltStack, and Ansible. Containerization tools also play an equally important role in the deployment stage. Docker is one of the most popular tools used for this purpose. Basically, these tools help produce consistency across development, test, staging, and production environments. Besides this, they also help in scaling up and scaling down of instances very swiftly. Basically, containerization tools help in maintaining consistency across the environments where the application is deployed, developed, and tested. Using these tools, there is no scope of errors or failures in the production environment as they package and replicate the same dependencies and packages used in the development or testing or staging environment. Basically, it makes your application easy to run on different computers. The next stage is the continuous monitoring stage. This is the last stage in the DevOps lifecycle. This is a very crucial stage where you continuously monitor the performance of your application. So here, vital information about the use of the software is recorded. This information is processed to recognize the proper functionality of the application. The system errors such as low memory, server not reachable, etc. are resolved in this phase. The root cause of any issue is determined in this phase. It also maintains security and availability of the services. Also, if there are any network issues, they are resolved in this phase. That is, it helps us automatically fix the problem as soon as they're detected. So now this practice involves the participation of the operations team who will monitor the user activity for bugs or any improper behavior of the system. The most popular tools used for this phase is Splunk, ELK Stack, Nagios, New Relic, and Sensui. So what these tools do is they help you monitor the application's performance and the servers very closely, and they also eventually enable you to check the health of the system proactively. Now, using these tools, they can also improve productivity and increase the reliability of the systems, which in turn reduces IT support costs. Any major issues, if found, are reported to the development team so that it can be fixed in the continuous development phase. This also leads to a faster resolution of the problems. The stages are carried out on loop continuously till you achieve the desired product quality. Therefore, almost all of the major IT companies have shifted to DevOps for building their products. Moving on, if you want to become a DevOps engineer or be a part of this ideology, it is extremely important for you to be familiar with some DevOps related tools. Today, I will be talking about 7 important DevOps tools. Now, before we understand the tools DevOps engineers use, it is important to understand containers. So, what are containers? Containers allow you to package your application and its dependencies together into one manifest that can be version controlled, allowing for easy replication of your application across developers on your team and machines in your cluster. This is exactly why container-based microservices architectures have profoundly changed the way development and operation teams test and deploy software. Containers really help companies modernize by making it easier to scale and deploy applications. But they have also introduced new challenges and complexity by creating an entirely new infrastructure ecosystem. IT companies are now deploying thousands of container instances daily, and that's a complexity of scale they have to manage. How do they do it? Here is where Kubernetes comes to the rescue. Kubernetes is a container management technology developed in Google to manage containerized applications in different kinds of environments, like physical, virtual, cloud infrastructure, etc. So it really is just an open source system which helps in creating and managing containerization of applications. Its container management responsibilities include container deployment, scaling and descaling of containers, and container load balancing. It is extremely important to remember that Kubernetes is not a containerization platform, it is a multi-container management solution. Now let's move on and discuss some of the features of Kubernetes. The first one is automated scheduling. So Kubernetes provides an advanced scheduler to launch containers on cluster nodes based on their resource requirements and other constraints, while not sacrificing availability. The second feature is self-healing capabilities. So Kubernetes allows you to replace and reschedule containers when nodes die. It also kills containers that do not respond to user-defined health checks and does not advertise them to clients until they are ready to serve. The third feature is automated rollouts and rollback. So what Kubernetes does is it rolls out changes to the application or its configuration while monitoring your application health to ensure it does not kill all your instances at the same time. So if something goes wrong with Kubernetes, you can simply roll back the change. The fourth feature is horizontal scaling and load balancing. Kubernetes can scale up and scale down the application as per the requirements with a simple command, using a user interface or automatically based on CPU usage. Now let us understand the architecture. The Kubernetes architecture has two main components. The first one is the master node, the second one is the worker node. So the master node is responsible for the management of Kubernetes cluster. It is mainly the entry point for all administrative tasks. There can always be more than one master node in the cluster to check for fault tolerance. So there are a few components in the master node that I'd like to discuss. The first one is the API server. So here the API server is the entry point for all the REST commands used to control the cluster. The second one is the controller manager. It is a daemon that regulates the Kubernetes cluster and manages different non-terminating control loops. The third one is the scheduler. So the scheduler schedules the tasks to worker nodes. So what it really does is it stores the resource usage information for each worker node. The fourth one is the etcd. So the etcd is simple distributed consistent key value store. So what it mainly is used for is to share configuration and service discovery. Now that we know how the master nodes work, let's move on to the worker nodes. So these worker nodes contain all the necessary services to manage the networking between the containers, communicate with the master node, and assign resources to the scheduled containers. So the first component that I'll be talking about in this worker node is the Docker container. So Docker runs on each of the worker nodes and runs the configured pods. The second one is the kubelet. The kubelet gets the configuration of a pod from the API server and ensures that the described containers are up and running. The third one is kube proxy. So kube proxy acts as a network proxy and a load balancer for a service on a single worker node. The fourth one is pods. So a pod is one or more containers that logically run together on nodes. With this, we come to the end of the first tool in DevOps tool. Let's move on to the second tool, that is Docker. So what is a Docker? Docker is simply a containerization platform that packages your application and all its dependencies together in the form of containers to ensure that your application works seamlessly in any environment. So each application here will run on a separate container and will have its own set of libraries and dependencies. It must be really convenient to move around these containers, right? So containers also ensures that there is a process level isolation, meaning each application is independent of other applications, giving developers surety that they can build applications that will not interfere with one another. Now, the quality assurance team need not install all the dependent software and applications to test the code, and this helps them save lots and lots of time and energy. This also ensures that the working environment is consistent across all the individuals involved in the process, starting from development to deployment. So here the number of systems can be scaled up easily and the code can be deployed on them effortlessly. There are some basic concepts of Docker you must be aware of. That is Docker file, Docker image, and Docker container. So a Docker image is created by the sequence of commands written in a file called Docker file. When this Docker file is executed using a Docker command, it results into a Docker image with a name. So finally, when this image is executed by Docker run command, it will by itself start whatever application or service it must start on its execution. So I hope Docker file, Docker images, and Docker containers are clear. We'll understand what is Docker Hub now. So Docker Hub is basically a cloud registry where you can find Docker images uploaded by different communities. Also, you can develop your own image and upload on Docker Hub, but first you need to create an account at Docker Hub. So let's move on and understand what a Docker engine is. So the Docker engine is the heart of the system. It is simply the application that is installed on your host machine. Basically, it works like a client-server application. It uses a server, which is a type of a long-running program called a daemon process. It also uses a command line interface client. And finally, it uses an REST API, which is used for communication between the CLI client and Docker daemon. As per the image, in a Linux operating system, there is a client which can be accessed from the terminal and a host which runs the daemon. We build our images and run containers by passing commands from the CLI client to the daemon. However, in the case of Windows or Mac, there is an additional toolbox component inside the Docker host. So this Docker toolbox is an installer to quickly and easily install and set up a Docker environment on your Windows or your MacBook. So this toolbox installs Docker client, machine, Compose, which is only present in Mac, and VirtualBox. With this, we come to the end of Docker. We'll move on to the third tool of DevOps tools, that is Git. So Git is an extremely important tool for software developers. It is a free open source distributed version control system designed to handle everything from small to very large projects with speed and efficiency. It was created by Linus Torvalds in 2005 to develop Linux kernel. Git has the functionality, performance, security, and flexibility that most teams and individual developers need. It also serves as an important distributed version control DevOps tool. So Git is primarily used to manage a project comprising a set of code or text files that may change over time. Now, before we go further, let us take a step back to learn about version control systems and how Git came into existence. So version control is the management of changes to documents, computer programs, large websites, and other collection of information. There are basically two types of version control systems. The first one being centralized version control system. The second one is distributed version control system. So Git is a distributed version control system where every contributor, that is the user, has a local copy or clone of the main repository. What is a repository? A repository is simply a storage space for your project files. Here, everyone maintains a local repository of their own which contains all the files and metadata present in the main repository. So the local repository is usually on the local machine of the user. So every programmer maintains a local repository, which is actually the copy or clone of the central repository on their hard drive. The central repository may be present on a web hosting platform like GitHub. They can commit and update the local repository without any interference. They can also update their local repositories with new data from the central server by an operation called pull and affect changes to the main repository by an operation called push from the local repository. So I hope everyone understood how Git works. Now moving on, let us understand the role of Git in DevOps. So Git plays a very vital role when it comes to managing the code that the collaborators contribute to the shared repository. So this code is then extracted for performing continuous integration to create a build and test it on the test server and eventually deploy it to the production. Tools like Git enable communication between the development and the operations team. When you're developing a large project with a huge number of collaborators, it is extremely important to have communication between the collaborators while making changes within the project. Commit messages in Git play a very important role in communicating among the team. The bits and pieces that we all deploy lies in the version control system like Git. To succeed in DevOps, you need to have all of the communication in version control. Hence, Git plays a very vital role in succeeding at DevOps. Now let's move on to the next tool, that is Selenium. Selenium is one of the most widely used open source web user interface automation testing suite. It was originally developed by Jason Huggins in 2004 as an internal tool at ThoughtWorks. So Selenium supports automation across different browsers, platforms, and programming languages. So this tool can be easily deployed on platforms such as Windows, Linux, Solaris, and Macintosh. Moreover, it supports operating systems for mobile applications like Windows and Android. Selenium supports a wide variety of programming languages through the use of drivers specific to each language. Languages supported by Selenium include C#, Java, Perl, PHP, Python, and Ruby. Currently, Selenium WebDriver is the most popular with Java and C#. Selenium test scripts can be coded in any of the supported programming languages and can be run directly in most modern web browsers. Browsers supported by Selenium include Internet Explorer, Mozilla Firefox, Google Chrome, and Safari. So basically, it can be used to automate functional tests and can be integrated with automation test tools such as Maven, Jenkins, and Docker to achieve continuous testing. It can be also integrated with tools such as TestNG and JUnit for managing test cases and generating reports. So now moving on, what are the advantages of Selenium? Why should we choose Selenium? Since Selenium is open source, there is no licensing cost involved, which is a major advantage over other testing tools. There are many other reasons behind Selenium's ever-growing popularity. The first one is that test scripts can be written in any of the programming languages, that is Java, Python, C#, PHP, Ruby, Perl, .NET, etc. Tests can also be carried out in any of the operating systems, that is Windows, Mac, or Linux. Tests can also be carried out using any browser, that is Mozilla Firefox, Internet Explorer, Google Chrome, Safari, Opera. We've all discussed this in the previous slide. And the last use is that it can be integrated with Maven, Jenkins, and Docker to achieve continuous testing. So in short, Selenium can be used for automated testing. Also, because it has cross-browsers compatibility, it is more preferred. And it also increases test coverage and reduces test execution time. Now moving on, let us understand an important concept in Selenium, that is the Selenium Grid. Selenium Grid was developed by Patrick Lightbody and initially called it Hosted QA. It was used in a combination with remote control to run tests on remote machines. In fact, with Grid, multiple test scripts can be executed at the same time on multiple machines. Parallel execution is achieved with the help of hub node architecture. One machine will assume the role of hub and the others will be the nodes. Hub controls the test scripts running on various browsers inside various operating systems. Test scripts being executed on different nodes can be written in different programming languages. Grid is still in use and works with both WebDriver and remote control. So we'll be learning about the WebDriver in the next slide. However, maintaining a grid with all required browsers and operating systems is a very huge challenge. For this, there are multiple online platforms that provide an online Selenium grid that lets you access to run your Selenium automation scripts. For example, you can use Lambda test. It has more than 2,000 browser environments over which you can run your tests and truly automate cross-browser testing. Now let's understand what is Selenium WebDriver. Selenium WebDriver is a web-based automation testing framework that can test web pages initiated on various web browsers and various operating systems. In fact, you also have the freedom to write test scripts in different programming languages like Java, Perl, Python, etc. It is important to remember that Mozilla Firefox is Selenium WebDriver's default browser. Now, some benefits of Selenium WebDriver are that they support 7 programming languages, they test on various browsers, and they work on different operating systems. Also, it overcomes limitations of Selenium version 1, like file upload, download, pop-ups, and dialogues barrier. Now, let's move on to the next most important tool, that is Jenkins. Continuous integration is the most important part of DevOps that is used to integrate various DevOps stages. Jenkins is the most popular continuous integration tool. It is an open source automation tool written in Java with plugins built for continuous integration purposes. Jenkins is basically used to build and test your software projects continuously, making it easier for developers to integrate changes to the project and making it easier for users to obtain a fresh build. It also allows you to continuously deliver your software by integrating with a large number of testing and deployment technologies. So basically with Jenkins, organizations can accelerate the software development process through automation. Jenkins integrates development lifecycle processes of all kinds, including build, document, test, package, stage, deploy, static analysis, and much more. So this tool also achieves continuous integration with the help of plugins. Plugins are extremely important. It allows the integration of various DevOps stages. If you want to integrate a particular tool, you need to install that particular plugin for that tool. For example, Git, Maven to project, Amazon EC2, HTML publisher, etc. There are many advantages of Jenkins and I'd want to discuss each one of them in detail. So the first one is it is an open source tool with a great community support. The second one is it is extremely easy to install. The next one is it has more than 1,000 plugins to ease your work. Now, if a plugin does not exist, you can simply code it and share it with the community. The fourth advantage is it is free of cost. The last one is it is built with Java. Now, if you have been coding for some time now, you must be knowing that Java is portable to all the major platforms. So this gives an added advantage to Jenkins. So what makes Jenkins different from the other continuous integration tools? There are two reasons. The first one is adoption, the second one is plugins. So Jenkins is widespread with more than 147,000 active installations and over 1 million users around the world. The adoption of Jenkins is extremely high. The second one is that Jenkins is interconnected with well over 1,000 plugins that allow it to integrate with most of the development, testing, and deployment tools. So these two features, that is adoption and plugins, make it one of the best continuous integration tools currently available in the market. Now let's move on to the next tool of DevOps tools, that is Puppet. Today, the most mature tool for configuration management is Puppet. But I know you must be wondering why Puppet is so popular and what makes it unique when compared to other configuration management tools. Puppet is a configuration management tool that is used for deploying, configuring, and managing servers. So now let's understand the functions of Puppet. So the first one is it helps in defining distinct configurations for each and every host. And it also continuously checks and confirms whether the required configuration is in place and is not altered on the host. The second function is dynamic scaling up and scaling down of machines. The last one is it provides control over all your configured machines. So a centralized change gets propagated to all automatically. Puppet basically uses a master-slave architecture in which the master and slave communicate through a secure encrypted channel with the help of SSL. Now let's see this architecture in detail. So as you can see the diagram on the screen, the Puppet agent sends the facts to the Puppet master. Facts are basically key value data pair that represents some aspect of the slave state, such as its IP address, uptime, operating system, or whether it's a virtual machine. Puppet Master uses the facts to compile a catalog that defines how the slave should be configured. Catalog is a document that describes the desired state for each resource that Puppet Master manages on a slave. Puppet Slave reports back to the master indicating that the configuration is finally complete, which is visible in the Puppet dashboard. Now with this we come to the last tool of DevOps, NAG iOS. NAG iOS monitors your entire IT infrastructure to ensure systems, applications, servers, and business processes are functioning properly. It is an integral to the DevOps lifecycle. So it is basically used for continuously monitoring of systems, applications, servers, and business processes in a DevOps culture. So in the event of a failure, NAG iOS can alert technical staff of the problem, allowing them to begin remediation processes before outages affect business processes, end users, or customers. With this tool, you don't really have to explain why an unseen infrastructure outage affects your organization's bottom line. NAG iOS runs on a server, usually as a daemon or a service. It periodically runs plugins residing on the same server. They contact hosts or servers on your network or on the internet. One can view the status information using the web interface. You can also receive email or SMS notification if something happens. The NAG iOS daemon behaves like a scheduler that runs certain scripts at certain moments. It stores the results of those scripts and will run other scripts if these result changes. NAG-IOS also use plugins. So these are compiled executables or scripts that can be run from a command line to check the status or a host or a service. NAG-IOS also uses the results from the plugins to determine the current status of the hosts and services on your network. NAG-IOS is built on a server or agents architecture. Usually on a network, a NAG-IOS server is running on a host, and plugins interact with local and all the remote hosts that need to be monitored. So these plugins will send information to the scheduler, which displays that in a graphical user interface. With this, we come to the end of DevOps tools. Let's move on to the next part of the session, that is DevOps automation. Automation is the crucial need for DevOps practices. And automating everything is the fundamental principle of DevOps. We discussed this initially in the session. Automation kickstarts from the code generation on the developer's machine until the code is pushed to the code, and after that to monitor the application and system in the production. Automating infrastructure setup and configurations, software deployment is the key highlight of DevOps practice. DevOps practice is dependent on automation to make deliveries over a few hours and make frequent deliveries across platforms. Automation in DevOps boosts speed, consistency, higher accuracy, reliability, and increases the number of deliveries. Automation in DevOps encapsulates everything right from the building, deploying, and monitoring. In large DevOps teams that maintain extensive, massive IT infrastructure, the tools can be classified into 6 categories. That is infrastructure automation, configuration management, deployment automation, performance management, log management, and monitoring. So for infrastructure automation, a great example is the Amazon Web Services. Being a cloud service, you don't really need to be physically present in the data center. They're easy to scale on demand, and there are no upfront hardware costs. It can also be configured to provide more servers based on traffic automatically. For the second one, Chef is a great example. Chef is a handy DevOps tool for achieving speed, scale, and consistency. It can be used to ease out complex tasks and perform configuration management. With the help of this tool, the DevOps team can avoid making changes across 10,000 servers. Rather, they need to make changes in one place, which is automatically reflected in other servers. For deployment automation, Jenkins is a great example. As we have already discussed before, it helps facilitate continuous integration and testing. It integrates project changes more efficiently by quickly finding issues as soon as builds are deployed. For the fourth one, that is performance management, Application Dynamic is a great example. It offers real-time performance monitoring. The data that is collected by this tool helps developers to debug whenever an issue occurs. The fifth one, that is for log management, Splunk is a great example. This DevOps tool solves issues such as storing, aggregating, and analyzing all logs in one place. So for the last one, that is monitoring, NAG-IOS is a great example. It notifies people when infrastructure and related services go down. It is a tool for this purpose which helps the DevOps team to find and correct problems immediately.
Let's start out with what's version control. So to understand what is version control system, we need to understand first why we need a version control system. So we'll see why do we exactly need a version control system. So for that, let's take a scenario where there are 3 developers working remotely on a web application or a mobile application. Now for simplicity's sake, let's just assume that it is a streaming application and one of them is working on a streaming page. Let's call them developer 1. Developer 2 is working on a user information page and developer 3 is creating the payment portal. Now all 3 of them are done with their respective pages at 10 o'clock, 11 o'clock, and 12 o'clock, respectively. Now, the thing is, all 3 developers are working in isolation. There may be their own changes, there may be changes in somebody else's page. They're all kind of adding some new files or modifying older files, changing the source code or something like that throughout the course of this project. But how exactly are they going to collaborate considering that they are working remotely? The solution to this is a version control system. With this system, I'll tell you what happens. At 10 o'clock, developer 1 uploads all the files regarding the streaming page. With a version control system, this modification is recorded and updated to one central directory or folder. So every time you're modifying an older file or adding a new file, it creates a snapshot of the latest version or the latest update of the changes that you've made or all the files that you've uploaded. So the snapshot of your update at 10 o'clock is saved, and then when developer 2 adds their user info page, this modification is also saved as a snapshot. Now there are 2 snapshots saved, and finally the payment portal page is added, and this is the last modification done at 12 o'clock, and this is the most recent snapshot saved, along with other snapshots of other updates and modifications done throughout the course of this project. Every change in your project, a snapshot is created and your entire project is saved that way. And these snapshots are actually known as different versions, which are basically the state of your project at a particular time or at the current time. It means that it will contain the kind of files your project is storing at one particular time and what kind of changes you have made so far between the previous version and this particular version. And this is exactly how a version control system works. So version control system basically is a system that records changes to a file or a set of files over time so that you can record specific versions later. These versions are recorded in a repository and they can be recalled anytime from these repositories during the course of your project. So version control systems essentially are of 3 types. Now the local version control system is one of the simplest forms of VCS and has a database that keeps all the changes of the files under revision control. So all the files are saved by this one user and they manage all of the files. But it's actually really hard to maintain the changes of the file, and you can accidentally replace one or the other file that you need. It also needs something known as RCS or revision control system, which keeps patch sets or the differences between updates in a special format on your disk. All of this, your local version control systems maintains all the track of all the files within your local system. As a user, you can track specific versions later, and it basically works as an independent standalone system for an application. So your applications like spreadsheets and word processors have this control mechanism. So that's one type. Apart from this, you also have your centralized version control system, which basically uses a central server to store all the files and enables team collaboration. So it's not one local system, but multiple systems which work on a single repository to which users can directly access as a central server. So the repository is a central server that could be local or remote, which is directly connected to each of the programmer's workstation. And the third kind of VCS is a distributed version control system. Now these systems do not necessarily rely on a central server to store all the versions of a project file. In a distributed version control system, every contributor has a local copy or a clone of the main repository. So everyone maintains their own local repository, which contains all the files and the metadata present in the main repository. And they can push or commit or update the main repository if and when required. Now we are going to cover more on the latter 2 version control systems further in the session. So now let's try and understand in depth what's the difference between a centralized version control system and a distributed version control system. As I had mentioned before, in a centralized version control system, each programmer working on a branch on a project has absolute access to the central server. So the centralized version control system uses a central server to store all the files, and everybody on the team can directly access the central server as it is one single repository. So if you have 3 workstations, workstation 1, workstation 2, workstation 3, all of them can directly commit to the repository and get updates from the repository, which is your central server. The repository here indicates a server that could be local or remote, directly connected to each programmer's workstation. Every programmer can extract or update their workstations with the data present in the repository, or can make changes or updates or commit in the repository. And every operation is performed directly on this repository. Even though this seems pretty convenient when we are just talking about 3 people, to maintain a single repository like this has some major drawbacks. One of them is that it's not locally available, meaning every change that you have to make, you will have to be connected to a network to perform any action. Also, in any case, the central server getting crashed or corrupted will result in losing the entire data of the project. Also, another small thing which is revertible, but is if one person accidentally makes some unwanted updates. Instead of his or her local system, they will be making that changes directly in the central server. So recovering that part back will be again a time-consuming process. This is where distributed version control systems come to the rescue. Now, these systems do not necessarily rely on a central server to store all the versions of a project file. In the distributed version control system, each and every contributor has a local copy or a local workstation clone of the main repository. That is, everybody maintains a local repository of their own which contains all the files and metadata present in the main repository. You will understand it better if you take a look at the diagram. As you can see, every programmer maintains a local repository or a local copy on its own, which is actually the copy or clone of the central repository on their local hard drive. They can commit and update their local repository without any interference from one another. And then they can update their local repositories with new data from the central server by an operation called pull. Once they are done with their bit of the code, they can affect the changes of the main repository by an operation called push from their local repository. Now, this system or this act of cloning an entire repository to your workstation and making all the changes on a local repository gives you a couple of advantages over a centralized version control system. First of all the operations except push and pull are very fast because the tool only needs access to the hard drive and not a remote server. Hence, you do not always need to be connected via a network connection, or you always do not need an internet connection. Committing new change sets can be done locally without manipulating the data on the main repository. Once you have a group of change sets ready, you can push them all at once. So you complete your set of code on your local system and then you push all the files once and for all into the main repository. Third, since every contributor has a full copy of the project repository, they can share changes with one another on wanting to get some feedback before affecting the changes in the main repository. So this enhances the essence of collaboration amongst a development team. And finally, if the server gets crashed at any point in time, the lost data can be easily recovered from one of the contributors' local repository. And that is why distributed version control system has been picking up popularity over the past decade. So why version control is important? First of all, it helps collaboration. It allows remote development, shared workspace, and real-time updates. All versions of your code are preserved, hence it helps you manage versions of the same code. Easy rollback from current version. Suppose a part of your project has been headed to a wrong direction, you can easily roll back from the current version to the last version which was stable. Now, because you can reverse faulty updates, you can save time and hence it reduces downtime of your project development. And finally, it improves visibility. You can analyze and compare different versions, and that gives you like a 50-foot top view of your entire project, which just accelerates your product delivery. So now that you have a bare sense of what is version control and why do you need version control, let's understand one of the most popular version control systems that exists today, and that is Git. So Git is a distributed version control tool that supports distributed nonlinear workflows by providing data assurance from developing quality software. So basically what it does is that it lets you and your team of developers work together on the same project remotely from anywhere across the world. Your team members can work efficiently on files and easily merge their changes into one source without the fear of losing or deleting anything of importance due to the easy rollback feature. Git is primarily used to manage your project comprising of a set of code or text files that you may want to change from time to time. Now, Git is an integral part of DevOps. DevOps, as most of you might have the idea of, is the practice of bringing agility to the process of development and operations. A couple of years ago, it was this entirely revolutionary ideology which swept IT organizations worldwide, boosting project life cycles and in turn increasing profits. DevOps promoted communication between development engineers and operations participating together in the entire life cycle, from design through development process to production support. Now, in the entire life cycle of DevOps, starting from planning of the projects to its deployment and monitoring, Git plays a vital role. When it comes to managing the code that collaborators contribute to the shared repository, this code is extracted for performing continuous integration to create a build and test it on the test server and eventually deploy it to production. Tools like Git enable communication between the development and operations team. When you are developing a large project with a huge number of collaborators, it is extremely important to have communication between the collaborators, between the developers while making changes in the project. Commit messages in Git play a very important role in this particular collaboration or communication amongst the team. The bits and pieces that we deploy or update lies in this version control system, such as Git. To succeed in DevOps, you need to have all the communication in version control. Hence, Git plays an extremely vital role in succeeding at DevOps. And due to this very reason, Git has earned way more popularity compared to other version control tools available in the market, such as Apache Subversion, Concurrent Version Systems, and Mercurial. If you compare the interest of Git by time with other version control systems, you shall realize that larger companies' products are generally developed by developers using Git all around the globe. And some famous names out of them are Facebook, Yahoo, Zynga, Quora, Twitter, eBay, Salesforce, Microsoft, and many, many more. Now lately, all of Microsoft's new development work has been in Git features. Microsoft migrating .NET and many of its open source projects on GitHub, which are managed by Git. One of such projects is the LightGBM. It's a fast, distributed, high-performance gradient boosting framework based on the decision tree algorithms, which is used for ranking, classification, and many other machine learning tasks. Here, Git plays an important role in managing this distributed version of LightGBM by providing speed and accuracy. So basically, to enable version control, Git is your go-to solution. It's fast and suitable for handling massive code bases scattered across multiple developers, which makes it the most popular tool used today. Now that you know about Git, a terminology we'll be using a lot while talking about Git and GitHub is a repository. Now, repository, or a repo as it's most commonly known as, is a directory or a storage space where your projects can basically live. It can be local to a folder or your computer, or it can be a storage space in another online host such as your GitHub. And in this particular space, in this particular directory, you can keep your code files, text files, images, you name it, all of it inside a repository. Through the course of this, we shall also be talking about something known as GitHub, which is nothing but a central repository, the kind that we spoke about when we discussed centralized versus distributed version control systems. There's a central repository, and that is where all of your code will live. You have your local repository where you'll make the changes, and there you have the central repository to which you will push all of the changes. Yeah? And the central repository is something that all of the developers involved in this particular project, in a certain project, have access to. Alright, moving on, let's discuss a few Git features which make it so popular amongst organizations as well as individuals. First of all, it's economical. It's free and open source. Git is released under GPL's General Public Licenses, open source license. So you don't need to purchase Git. It is absolutely free. And since it's open source, you can modify the source code as per your requirement. Second is its speed. Now, since you do not have to connect to any network for performing all of the operations, it completes all the tasks really fast. Performance tests done by Mozilla showed it was an order of magnitude faster than other version control systems. Fetching version history from locally stored repository can be 100 times faster than fetching it from the remote server. So the core part of Git is written in C, which avoids runtime overheads associated with other high-level languages, which makes it extremely fast compared to other version control systems. Next is that Git supports non-linear development. Git supports rapid branching and merging and includes specific tools for visualization and navigation of a non-linear development history. A core assumption in Git is that a change will be merged more often than it's written, as it is passed around various reviewers. Hence, branches in Git are very lightweight and is only a reference to a single commit. With its parental commits, the full branch structure can be constructed. Next, let's talk about the robustness. Nearly every single task in Git is undoable. Git gives each developer a local copy of the entire development history and the changes copied from one repository to another. These changes are imported as additional development branches and can be merged and deleted and recovered the same way as a locally developed branch. Next is the snapshots, which are recorded changes made to a file rather than the file itself. Followed by which you have integrity, which means no changes can be made without Git recording it. Since every contributor has their own local repository, on the events of a system crash, the lost data can be recovered from any of the local repositories. You will always have a backup of all of your files, and none of the changes made to the central repository will go unlogged by Git. Git uses the SHA-1 or the secure hash function to name and identify objects within its repository, and every file, every commit is checksummed and retrieved by its checksum at the time of the checkout. The Git history is stored in such a way that the ID of a particular version, a commit in Git's terms, depends upon the complete development history leading up to that commit. Once it's published, it's not possible to change the old versions without it being recorded. Then it's a distributed system, which means every user has their own copy of the repository and the data is stored locally. Git gives each developer a local copy of the entire development history, and the changes are copied from one such repository to another. These changes are imported as additional development branches and can be merged in the same way as a locally developed branch. And finally, it's easy branching. Now, branch management with Git is very simple. It only takes a few seconds to create, delete, and merge branches. Feature branches provide an isolated environment for each change to your code base. So when a developer wants to start working on something, no matter how big or small, they can create a fresh new branch which is not interfering with the main branch, which ensures that the master branch or the main branch always contains production quality code. So any little experimentation that you want to do or little things that you want to try out can always be on a separate feature branch instead of the changes made to your master branch. Because ultimately, your master branch should contain your publishable product. So now that you know the basic features of Git, let's try and understand what the basic workflow of Git is, or how does Git work. So the basic overview of how Git works goes like this. You basically create a repository or a project with a Git hosting tool like Git or Bitbucket. You copy or clone the repository to your own local machine or your working directory. You add a file to your local repository and commit the changes, which basically means you save the changes. Then you push the changes to your master branch. Then you make changes to your file and commit. Then you pull the changes to your local machine. you create a branch or a version, make a change, commit the change, same process, open a pull request, and merge your branch to the master branch. Now this is a little complicated listening to it like this, but once we get on to our demonstration, I think things will be way more clear. You can still take a good look at this diagram, but if you don't get it, don't worry. I will be explaining these operations one by one when we get to the demonstration part of this Git tutorial. Moving on, let's get to the good part, the hands-on section, starting with the installation and setup of Git. Now there are two ways in which this goes. First of all, for Windows users, you need to install Git Bash for Windows. And for Linux users, you'll have to start by updating the package index and then install Git using the terminal. So first of all, for our learners using Windows, you'll have to log on to gitscm.com/downloads and then click on Downloads for Windows button and then run the executable file and follow through till you finally install Git Bash. I'm not going to install it completely as I already have Git Bash downloaded, but I'm still going to open the page to show you guys. All right. So the latest source release is Git 2.30.1 on the 8th of Feb, and you can just click on this button. The moment you click on this button, it's going to start downloading Git for you. And once you have the executable file, all you have to do is open it or run it in your own system, right? Next, for people using Linux, this is an example considering you are using Ubuntu. If you're using CentOS, a lot of the commands don't change, but instead of apt install, you will be using yum install for CentOS. So for that, now I'm going to open my terminal on a virtual machine. So here I have running an Ubuntu machine using the Oracle VirtualBox. So I'm going to start by running an update. All right, this is going to take a while. Kindly be patient. So here I have my Ubuntu running on a virtual machine. So to install Git on your Ubuntu machine, you have to start by updating. So this will take some time. We're going to use sudo apt update. If you're using CentOS, you will be using yum instead of apt. Let's clear that out, and then we're going to install Git. And then you can look for the Git version. Yeah? All right. Now that we have our Git installed, let's go ahead and look at the operations and commands that we are going to take a look at today. You have your repository setup, which include the commands init, clone, config, and alias. Then you have your save changes operations, which have your add, commit, diff, and stash. All of these commands we are going to go on and off and look at collectively mostly. Then we are going to look at the inspect operations, your inspect repository operations, of which the git status command is something we are also going to look at throughout this demonstration right from the beginning. So apart from that, you have your git log, git tag, and git blame commands. So you have your merge rebase command. So let's move on to our first set of git operations. First of all, you have your git init command, which basically creates a new empty git repository. Now this can be used to convert an existing unversioned project to a git repository or initiate an absolute fresh git repository. Now most other git commands are not available outside of the initialized repository. So this is usually the first command that you will run in a new project. That is, if you're using git bash. So when I run git init, it reinitializes an existing git repository, which I already have here. Now what this does is it reinitialized my existing git repository in this particular directory, in this .git directory. Yeah. what git init does is that it creates an empty git repository or reinitializes an existing one, like it did for me right now. It basically creates a .git directory with subdirectories and template files, and when you run the git init command in an existing repository, it will not overwrite the things that are already there. It'll rather pick up the newly added templates. So that's the repository initialized. You can go ahead and create some files in the directory or repository, whatever you call it. Now that is about initialization. Now, what about if there was an existing repository on Git that you had to act upon, that you had to make updates to, that you had to add files to, things like that? That's where you use the git clone utility. Yeah. Now you have the git clone utility, which you use to target an existing repository and create a clone or copy of this particular repository on your local machine. Now this is one of the features provided to you by a distributed version control system, as we had discussed before. So this is a blank file called Edureka rep with just the readme text file. Let me just go ahead and copy this. And then I can just git clone and paste its HTTPS URL. And as you can see, it's cloning this into Edureka rep. And now if I change directory to Edureka rep, you can see the readme file is right there. Yeah. So we're basically going to work off of this particular repository today, Edureka rep. Yeah. So now that we created a clone, moving on, we have the git config command, which basically is a convenience function that is used to set up your git configuration values on your global or local project level. This command is basically used to modify your configuration text file. So if I typed git config global user.email, and here I type, so there I gave in my email ID as the global user email ID. So if I ask for what the global user email ID is, it will return my ID back to me. Yeah. Basically, these configuration levels, like your username and your user ID, correspond to your .git config text files. Now, executing this basically will help you modify the configuration text file. Git uses this series of configuration files to determine non-default behavior that you may want. Yeah. So the first place Git looks for these values is in the system-wide configuration file, which contains settings that are applied to every user on this system. So basically, if you pass the option to your git config, it will read and write from this file specifically. And the next place the Git looks is the config/git config file, which is specific to each user. Now you can make Git read or write to this file by passing your global option, which is what I did. And the final command in the setup operations that we are going to look at is an alias. Now, alias, as the name suggests, is basically used to create shorter commands that map to longer commands. They enable more efficient workflows when you obviously have to use lesser keystrokes to execute a command. There are these lengthy commands which obviously kill a lot of your time. So these aliases you can use to shorten those commands. And these are also something that you will create via the git config command. There isn't really a direct way or a direct command of creating aliases. Yeah, this is just something I wanted to add in here along with the git config command. Like a very common alias created is CO for checkout or anything else, CK for checkout. So yeah, this is something that you can do using the git config command, just creating aliases. Moving on, let's look at operations that you use to add changes and save changes to your Git repository. Now, the first two commands here that we're going to look at are git add and git commit. Now, this combination is basically used to create these snapshots that I was talking about initially in the session, right? So basically what you do is first you use the git add command to add a change in your current directory or your working directory. And you add that to the staging area. It tells Git that you want to include a particular set of updates or changes in a particular file in the next commit. Then what you do is you move on to git commit after making the changes to your working tree. Then you use the git commit command, which captures a snapshot of your project's current state. So basically you use add to update the index using the current content found in your working tree, and then you basically prepare the content in the staging area for the next commit. Then you run the commit command to take that snapshot of your project's current status. Now remember, this is very important and you have to do it each time. You must use the add command to add any new modified files to the index. You can't directly commit anything without adding it to the stage area first. Now what I did was I quickly went ahead and added 3 files to my repository Edureka rep. So if I go into this repository, you can see there are 3 files: Edureka file 1, file 2, file 3. Now let's see if these files are in my index or not using the command git status. Now git status basically displays the state of the working directory and the staging area. It will list all the modified files which are ready to be added to the local repository. It lets you see which changes have been staged and which haven't, which files are being tracked by Git and not. So if I typed git status, you can see on your main branch, you have 3 untracked files, which are the 3 files that I just added: Edureka file 1, 2, and 3. These are not added to the index yet. This means I cannot commit these changes unless I added them explicitly to the index. So now we are going to add these 3 files. This command will update the index using the current content which is found in your working tree, as you can see in front of you, and then it'll prepare the content in the staging area for the next commit. So either I can just git add and put in the directory name, or I can just use git add with an extension of A, which means all, and this will add all of these files to the index which are in the directory but not updated in the index yet. Yeah, now I've done that. Let me go ahead and use git status again, and you can see all of these file names are written in green, and you can see changes to be committed written here, which means all of these changes are ready to be committed. They are added to the index. Now these files are added to the index. You are ready to commit them. Now, as I had mentioned before, we're going to commit them, and committing refers to recording the snapshots of the repository at any given time. So your committed snapshots will never change unless it's done explicitly. So I'm going to clear this, and we're going to commit this by typing git commit and then adding a tag or a message called committing 3 files. Let's try this out. As you can see, 3 files changed, 3 insertions. You can see our Edureka files 1, 2, 3 have been committed. The git commit command has committed the changes in the 3 files in your local repository. Now, if you want to commit a snapshot of all of the changes in your working directory at once, you can always go with commit-a. Now let me add a couple more files to my directory just to show you the difference between your files added to the index versus the ones that are not. If I type ls again, you can see there are 2 more files over here. As you can see, I have 2 other files. I'm just going to add the Edureka file 4 and not the file 5. And then I'm just going to git commit committing files And as you can see, only one file changed, only one insertion happened, and that only happened because Edureka file 5 is not added to the index. And even if I use the extension A, I cannot add Edureka file 5 because that has not been added to your index. Now if I just go ahead and add Edureka file 5, voila, the change has occurred in our Git repository. Now if I typed git status, there are no more files to add or commit. Our branch is ahead of the origin or main branch by 3 commits. And you can use git push to publish your local commits. Now what is git push? This is something we will cover later in this session. Now understand that before you affect the changes made to the central repository, you should always pull changes from the central repository to your local repository just to get the most updated version of your branch. You'll get all the work of your collaborators that have been contributing in the central repository. For that, you use the pull command. Now, as you can see, there's nothing to commit and your working tree is clean. There are other commands like the git status command, which you could use for similar purposes. For example, you have the git log command, which only operates on committed history. It basically will display to you the committed snapshots and will let you list the project history, filter it, and search for specific changes. So if you typed git log, it's going to show you all the commits that have happened since we started with this git file. Okay, here you can see at the bottom, your original main, there's your initial commit, right? Then our first commit where we committed 3 files, then we committed the 4th file, and finally when we committed file number 5, right? These are all the commits including the initial commit, the first one. Yeah, along with the author and the date and time. Remember when I told you about everything is recorded when you're using Git? This is what I meant. You can always access who made commits at what time and what commits were made when you use a version control system such as Git. Now at a point like this, I think it's crucial to mention one more command, which is the git tag, and it's used to basically capture a tag in history or a point in history that is used for a marked version release, right? So it's basically like a branch that doesn't change, and after being created, they have no further history of commits. Yeah, so that is one. And another one is git blame. Now the git blame function displays of the author's metadata attached to a specific committed line in a file. It's used to examine specific points in a file's history and get context as to who the last author was that modified that line. So if I went back and typed git blame Edureka file 5.txt, it's going to show who the person is that is to blame, who committed this particular file or made this particular change, right? It'll also, if you paid attention, give you the commit number. As you can see, this E9D63EFO commit number. This also has this E9D63EFO, which is the first few characters of this particular commit number. Yeah. So now that you know how to check the status of the changes and see who made the changes, it's time that you understand how you fetch changes from your remote repository to a local repository and how you push commits from your local repository to your remote repository. So here we are going to look at 2 commands called pull and push. Now first of all, you have the git pull command, which fetches changes from your remote repository to a local repository. Basically, it merges upstream changes in your local repository, which is a common task in Git-based collaborations. But at first, you need to set your central repository as the origin using the command git remote add origin And I'm going to add the link to my central repository, which is this. And as it says, the remote origin already exists. Now that your origin is set, and now we're going to pull our main branch. So I'm just going to type git pull origin main, and it says we are already up to date. Now, certain number of tutorials or documents that you might be following might even give you the command git pull origin master, in which case you're working on the master branch. Now, to know which branch you're at, you can just use the command git branch vv. Yeah, I'll tell you which branch are you working on. Yeah. So yeah, we are working on the main branch, and we are already up to date with the branch since my local repository was already updated with files from the main branch. This is the message of an up-to-date branch. Now you can also use git pull origin and your whatever branch name. Here I'm using main. That's a mistake on my part. Maybe I was trying to clear the screen. All right. So here, even if I pull from the branch using git pull origin and the branch name to my local git repository, you can see it's already up to date. So now my local git repository is now all updated with the recent changes. So now it's time to make the changes to your central repository by using the push command. So we're going to use the push command. This command transfers commits from your local repository to your remote repository, and it is basically the opposite of your pull operations. Pulling will import commits to your local repositories, whereas pushing will export commits to your remote repositories. It's going to ask you for your username. And password before it lets you push into your main branch there. So I've put in the username and password for my GitHub account. And with that, this has pushed the changes from my local repository to the remote repository along with all the necessary commits and internal objects. Now this has created a local branch in your destination repository. The use of git push is to publish your local changes to a central repository. After you've accumulated several local commits and are ready to share them with the rest of the team, you can then push them to your central repository by using the git push command. Now the files which have already been committed previously in the commit section and they were all push ready, you will use git push origin master to reflect these files in the master branch of your repository. All right. So let's go ahead to our repository and see if changes have been made. And yes, you can see all of our files on our GitHub repository. You have Edureka file 1, 2, 3, 4, and 5. All the 5 files that we had created on our local repository. Yeah, you have all these 5 files and the README file here. Here also you have the README file and all the 5 files that we had created. Now at this point in this Git tutorial, I hope you have understood the basic commands of Git. You have pulling, pushing, adding, committing, things like that. Now let's take a step further and understand the 3 basic commands of parallel development. Here I'm going to be talking about branching, merging, and rebasing. So first of all, let's talk about merging. Now, merging is a way to combine the work of different branches together. This will basically allow you to branch off, develop a new feature, and then combine it back in. As you can see in the diagram, it shows you 2 basically different branches, new branch and master. Now, when we merge the work of the new branch into the master, it creates a new commit, which contains all the work of the master and new branch. Now, if we merge the 2 branches with the merge command, as I had mentioned before, Git allows you for easy branching, which means you have parallel branches with your master branch that help you carry on your individual work while not interrupting your main product, which is your master branch or your main branch. So branches in Git are nothing but pointers to specific commits. Yeah. So Git generally prefers to keep its branches as lightweight as possible. Now, there are basically two kinds of branches via local and remote tracking branches. A local branch is just not the path of your working tree. On the other hand, the remote tracking branches have special purposes. Some of them are linking your work from your local repository to your central repository and automatically detecting which remote branches to get changes from when you do a git pull. So you can check what your local branch is by using git branch. So you know you are at your main branch. And the one thing you should understand, one thing is like a main mantra of people who use git are branch early and branch often. Yes. So to create a new branch, you're going to use a command git branch and your branch name. And in this case, I'm just going to use a branch name Edureka images. All right. And here you can see this diagram shows the workflow of a new branch that is created. When we create a new branch, it originates from the master branch itself. So since there's no storage or memory overhead with making many branches, it's usually easier to logically divide your work up than having big chunky branches. Hence, the branch often part. Now let's see how to commit using branches. Now branching includes the work of a particular commit along with all parent commits, right? So as you see, the new branch has detached itself from the master or the main branch, and hence it'll create a different path. So we are going to git check out the branch name, which in our case is Edureka images. And then we are going to git commit. So you have untracked files, Edureka images, and nothing added. So you made that branch. Now, merging is a way to combine the work of different branches together. So basically what this does is, now that we've branched off to something known as Edureka images, you can go ahead, add files to it, develop a new feature, and then combine it back into your main branch. Here you can see two different branches. You have your new branch and your main branch. And when we merge the work of a new branch into the main branch, it creates a new commit, which contains all the work of the main branch and the new branch. So now if we merge this branch, as you can see, it's already up to date. It's important to know that the branch name here should be the branch that you want to merge into the branch that you're currently checking out. So make sure that you are checked out of this destination branch. So let's just merge all the work of the branch Edureka images into your main branch. For that, I will first check out my main branch and then merge Edureka images with git merge Edureka images. And as you can see, all the data from the branch Edureka images has merged into the main branch. Now notice that merging in Git creates a special commit that has two unique parents. Now this is one way of merging into the main branch. There's also another way of combining the work between two branches, which is called rebasing. Now rebasing takes a set of commits, copies them, and stores them outside your repository. The advantage of rebasing is that it can also be used to make linear sequence commits. The commit log or the history of the repository stays clean if rebasing is done. Now our work from the new branch is placed right after master, and we have this nice linear sequence of commits. This command doesn't copy but moves all our work from the current branch to the master or the main branch. They look like they've been developed sequentially instead of having developed parallelly. So if I just did another branch called git branch Edureka images 2, and then maybe git checkout okay, then we git commit this, and then I could just git rebase main, and your current branch will be up to date. This command basically moves all of your work from your current branch to your master branch, and it'll basically look like it has been developed sequentially instead of having developed parallelly. Now, apart from these, there are certain operations that you ought to know. Firstly, archiving your repository. You can use this command. It stores all of your files and data in a zip file rather than a .git directory. This creates only a single snapshot, omitting version control completely though. This comes in handy when you want to send these files to a client for review who doesn't have Git installed in their computers. Apart from this, you can also bundle your repository, which basically turns your entire repository into a single file. This pushes the master branch or the main branch to a remote branch, only contained in a file instead of a repository. You could alternately change the repository, clone the repo bundle, create a copy, and use git log. But that is like 5 commands instead of 1. Why not just use 1 command? And finally, stashing uncommitted changes. When you want to undo adding a feature or any kind of added data temporarily, we can always stash them temporarily. You can use git status, stash status, and then you want to reapply the changes you stashed using git stash apply. Having said that, let's move on to another very important topic in this Git tutorial. Let's go through a brief introduction to SSH. Now, what is SSH? What is an SSH key? Now, an SSH key is an access credential for Secure Shell Network Protocol. It's basically an authenticated and encrypted secure network protocol and is used for remote communications between machines on an unsecured open network, for remote file transfer, network management, and remote operating system access. So basically, it's typically used to log into a remote machine and execute commands in it. But this also supports tunneling, forwarding TCP ports, and X11 conditions. It can transfer files using associated SSH file transfer or secure copy protocols. It provides you several alternative options for strong authentication and protects the communication security and integrity with very strong encryption. It's a secure alternative to the non-protected login protocols and insecure file transfer methods such as FTP. So basically, how do you create SSH keys? You start by using the command ssh-keygen, and then you'll be prompted to enter a file in which to save the key. So home, Edureka. Then we're going to enter a passphrase. I'm just going to leave it empty again. And you can see our identification has been saved in the file that we specified. And we have something known as a key fingerprint. And finally, what we have to do is add the new SSH key to the SSH agent. And then you will see identity added. And that's it. You have created an SSH key.
The need for GitHub. It is extremely important for software developers to work on a web-based platform to share their projects and collaborate with other developers. This platform must be a version control system, that is, it must enable multiple people to simultaneously work on a single project. Each person edits his or her own copy of the files and chooses when to share those changes with the rest of the team. This application must also be capable of hosting millions of programmers and hobbyists that download and evaluate each other's work. GitHub is one such platform of choice for developers that can host multiple programmers and review their code. GitHub has several competitors. For instance, GitLab. GitLab is an open source web interface and source control platform based on Git, whereas Microsoft Team Foundation Server is an enterprise-grade server for teams to share code, track work, and ship software for any language, all in a single package. Bitbucket, on the other hand, stores all of your Git and Mercurial source code in one place, with unlimited private repositories. So what really makes GitHub so powerful and popular among developers? GitHub is an open source platform, and the community is really what fuels it. Moreover, GitHub is the platform of choice for developers from various large corporations too. Microsoft is the #1 contributor to the system. but there are also Google, SAP, Airbnb, IBM, PayPal, and many others. Exposure and insight that you can get on GitHub are simply unmatched by any other platform. Here you can discover code written by others, learn from it, and even use it for your own projects. Versions control on GitHub works very much like Microsoft Office or Google Drive. It simply tracks all the changes made to your code and who makes them. You can always review the detailed change log that neatly hosts all of the relevant information. Using GitHub eliminates the need for complex corporate security solution because everything is on cloud. The platform protects code branches, verifies commit signing, and controls access. Now that we know why we need GitHub, let us understand what is GitHub. GitHub is a Git repository hosting service that provides a web-based graphical interface with many features. A repository is usually used to organize a single project. Repositories can contain folders, files, images, videos, spreadsheets, anything your project needs. Let's say, for example, a team wants to work on a particular project. Here they can simultaneously write and update their code to a central repository which is present on GitHub. So GitHub is a highly used software that is typically used for version control. It is helpful when more than just say one person is working on a project. For example, a software development team wants to build a website and everyone has to update their codes simultaneously while working on this project. In this case, GitHub helps them to build a centralized repository where everyone can upload, edit, and manage the code files. Most software projects have a bug tracker of some kind. GitHub's tracker is called Issues and has its very own section in every repository. Issues basically are a great way to keep track of tasks, enhancements, and bugs for your project. Moving on, people often get confused between the terms Git and GitHub. Now let me clearly explain the difference between them. Git is simply a version control system that lets you manage and track changes within your project, whereas GitHub is a cloud-based service that lets you manage Git repositories. So basically, Git is the tool and GitHub is the service. Now that we know the difference between Git and GitHub, let us move on and understand how these two work hand in hand. We already know that Git is a version control tool that will allow you to perform all kinds of operations to fetch data from the central server or push data to it, whereas GitHub is a code hosting platform for version control collaboration. GitHub is basically a company that allows you to host a central repository in a remote server. Now, without any further ado, let's get started with the demonstration on how to use GitHub. So for this demonstration, we're working on the website version of GitHub. There's another version of GitHub that is the desktop version, which you can download it to your personal computer. So we're simply going to search for GitHub in our search engine. The first link will lead you to the official website of GitHub. So I'm going to click on that. So this will redirect me to the main homepage of GitHub. As you can see, there is a search GitHub option. There are also two buttons that says sign in and sign up. If you're new to GitHub, you can simply enter in your credentials, that is a username, email, password, and sign up for GitHub. But if you already have an account like I do, I'm simply going to click on the sign in button and it'll redirect me to a page where I have to enter the credentials, that is my email address and password. I'm going to do that now and I'm going to click on the sign in button. Now, this is the main page of my account. As you can see, I have no repositories. It's all new, it's all fresh. But if you're not new to GitHub, you can view all of your repositories on the left-hand corner. Now, before we move on, I'm going to explain you all the features that are present within GitHub. So you can see a search bar here. So the search bar will allow you to look for profiles, certain keywords, look for different kinds of projects that are available on GitHub. All of those can be done using this bar here. And you can see 4 options next to the bar that says pull requests, issues, marketplace, explore. Pull requests we'll learn later on in this session, but the issues and marketplace we won't be discussing in this video for now. The explore button, on the other hand, is an extremely important and interesting button. So once I click on that, it'll redirect me to a page with some activities that are going on around in GitHub. You can see here they're trending repositories, they're trending developers, Basically, this is a feed that will allow you to interact with developers and other people, collaborators from all around the world, basically. In Instagram too, you have an explore button, which will allow you to interact with different people from all around the world. So the same concept is implied in the GitHub explore button too. So you can explore topics, you can explore trending repositories, developers. Basically, it's an interaction with other people from different parts of the world. So I hope that's clear. Now, the most important part of the session are the three buttons that are available in the right-hand corner of the navigation bar. So you can see there's a bell icon, there's a plus icon, there's a pixelated icon on the right-hand corner. So the bell icon allows you to read notifications of your activities that occur in GitHub. So that's what it really is. You can see the inbox will allow you to view all of the notifications. You can also view the unread notifications by clicking on this unread button. As of now, I don't have any notifications, so there's nothing available. You can also group these notifications by the date or repository by clicking on this group by button here. You can also view your saved notifications by clicking on here. And the done button, on the other hand, will let you mark all of your notifications that you're done with, your previous notifications. So these are the three important buttons you'll have to know in this bell icon. And the filters are not necessary as of now, so I'm not going to discuss that. This button, on the other hand, will allow you to manage your notification settings and your subscriptions too. So that's all for this bell icon. The next important button is this plus icon. As you can see, there are 5 drop-down options that appear here. The first one being new repository, followed by import repository, new gist, new organization, new project. So new repository we've already discussed previously in this session. A repository is a place where you create your files for your project. It's basically a storage space, right? So your repository can directly interact with your Git, right? So the new repository option will allow you to make files, a repository, to your GitHub account, right? The Git, on the other hand, the tool that which we use to make local repositories in our personal computer, can be directly pushed on. The local repositories can directly be pushed onto your GitHub account. So that's what the new repository button allows you to do so. But the new project, on the other hand, is a place to track issues, features, and other tasks that are related to the code within the repository. You can also connect with the DevOps build and deploy process, assign people to tasks, and so on by using this button. That is the new project button. So the difference between the new repository button and the new project button is that projects in GitHub are only a part of GitHub, but not Git. But the new repository option is a part of GitHub and Git. So that's the main difference between new repository and new project. I hope that's clear. So the next button will drop me down some interactions that I can make with my profile. So if I click on this your profile option, it will redirect me to a page where I can edit my profile. I can really create my identity using this page. So here, if I click the edit profile, I can add a bio about myself. I can add the company in which I'm working in, the location at where I am, the website, Twitter username, etc. All of that I can add here, all of the information about myself. I can also view the repositories I'm working on currently, or the repositories I've worked in the past, projects that I'm working on, the packages, and the entire contributions I've been making on GitHub from the last year. So basically, it allows me to build an identity, or it'll help me build my profile on GitHub. So I hope that's clear. Now, if I click on this button and if I want to sign out from a profile, I can simply scroll down and click on the sign out button here, and this will sign me out of my account. So that's all for getting started with GitHub. These are the basics on what GitHub is and what each of the button and options really do. Now, if I want to move back to the main page of my GitHub profile, I can simply click on this Octocat. That's GitHub's logo. So I'm just going to click on this Octocat logo, and here I'm back to my main page. Now, before we move on and work on the different operations and options within GitHub and learn different things about GitHub, I'm going to give you a brief overview on how to download the desktop version of GitHub. So I'm simply going to search for GitHub Desktop on my search engine, and I'm going to click on the first link that's available on this page. Now I can simply click on this button that says download for Windows 64-bit. That's compatible to my current version of my personal computer. If you have a Mac, you can simply click on the Mac version and download it to your desktop. But as I've already mentioned previously that we're going to work on the website version, so I'm going to simply switch back to this. Now let's quickly move on to the next part of the session. Create a repository. So firstly, let us understand what a repository is. It is simply a storage space for the correct project that you're working on. GitHub is a very popular central repository that allows you to share your files, whereas Git allows you to create local repositories that are present on the system you are working on. So you can basically push your local repository into GitHub and share it with other collaborators via the central one. Now that we know what a repository is and how it works, let's go on to the demonstration part and create our first repository. So you can do this in two ways. Either you can click on your create repository button that is present on the left side, or you can, as I've already mentioned in the previous part of the session, you can click on to this plus icon and you can click on the new repository option. So this will redirect you to a page that says create a new repository. You can add your repository name. I'm going to name my repository as Edureka and it's available. All of your repository names must be unique from one another to identify them easily. You can also add a description, which is optional. I'm just going to add the description. This is my first repository. And a description allows people or other collaborators to understand what your repository is all about. But as a good developer or a good programmer, you would definitely want to add a description and give an overview of what your repository is all about. There are two options now available that says private or public. Now you can choose your repository to either be public or private. So the private one lets you decide who can access your profile, whereas the public one lets anyone view and access your repository, but you can choose who can commit to it. That's the difference between public and private repository. I'm going to let my repository be public as of now. Now, if you scroll down, you can see that you can initialize your repository with three options. The first one being add a README file. The second one being add a git ignore file. You can always choose add a README text file to your project, which often contains information about the project and other necessary details the user must be aware of when he or she is accessing that particular project. Now, I want a README file for my repository, so I'm going to click on this button here. That's going to check it. The next option is add a .git ignore file. So this file will let you ignore a list of files when the user is pushing files to GitHub. That's what this option really does, but I'm going to let this be unchecked for now. For your repository to truly be open source, you will need to license it, so others are free to use, change, and distribute the software. You can simply click on choose a license option and pick the required license for your project. There are several licenses like MIT, GPL, Apache License 2.0, BSD, etc. But for this repository, we don't really need a license, so I'm going to untick this too. And now you can see there's a piece of information that says this will set master as the default branch, but I'm going to ignore this for now. I'm going to explain about branches later on in this session. So this is all you have to do to create your first new repository. You add a name, you choose a description, you add an optional description, you let your repository be either public or private, and you initialize your repository with either of these three options. And I'm simply going to click on my create repository option. Now this will redirect me to a page with all the information and the files that are currently present in my repository. You can see here my repository name is present here with the optional description that I gave, and the number of files. Currently we have only just one file, that's the readme text file, and that's present here. So this is all we have. Congratulations, you just created your first repository. Now you can see there are some options that says issues, pull requests, actions, projects, wiki, security, etc. We don't have to really talk about all of these right now. We will just learn about one option that says code here. So this is really important. If you click on this button, you can see that there's a link that is available here, an HTTPS link. So if you copy this link and paste it on your Git terminal that's present on your computer, you can download this entire project directly to your local system. So that's what the link is for. I hope that's clear. And the next option that says open with GitHub Desktop will allow you to open this entire repository in your GitHub Desktop version. And you can also, the last option that says download zip will allow you to download this entire repository in the form of zip files. So all of your project files will be within that zip file. So that's all you have to really know about your repository. and I'm going to click on the README text file that's available. It will take me to another page with some extra information about that file. You can see currently we have 2 lines and the memory space that is allocated to this file. So we currently have 2 lines, that is Edureka, and this is my first repository. And you can also see the number of contributors to this project. That is just one, that's just me for now. And you can view the history of the commits or the changes that have been performed in your file. So we'll come back to that part later on this session, but you can move back to your main page of this repository by clicking on the name button here. So Edureka is the name of my repository, so I'm going to click on that. So now I'm back to the main page of my repository. Before we learn how to create our first branch, let us understand what branches are. Branches allow you to work on other features that can be included and merged with the master branch if required. So what is the master branch? The master branch is the main branch where your project resides on. So all of the changes, all of the activities that you do with your main project lies or is on your default branch that is named as the master branch. So what really GitHub allows you to do is it allows you to create additional branches. So on these additional branches, you can work on the other features or you can experiment with your project. And if you're happy with this, you can simply merge these features to your main branch, that is your master branch. This is what branches are really for. So they simply allow you to work on other features. That's what branches are. So let's move on to the demonstration part and look at how we can create our own branches. So now if you look on the left corner, you can see a button that says master. So currently we're on the master branch, and there's only one branch, and the master branch, as I've already mentioned, is the default branch. So when you create a repository, you're automatically creating a master branch. So this is where your project will be residing on. And now if you want to create another branch, say let's name this branch 1 branch. So this is what I want to name my additional branch. I'm simply going to name it and I'm going to click on the enter button. So it will redirect me to a page. So this is the exact replica of your master branch, and you can work on this branch. You can work on any other feature, or you can add something, you can remove something, you can really experiment on this branch. And if you're happy with this, you can merge back this feature or the experimentation that you've been working on to your master branch, right? So you can see there's a README text file. It's exactly the same. There's the name of your repository, the description of the repository. You can click on the README text file and everything's the absolute same. You can quickly switch back to the main page. But the only difference is that you're currently on a branch named branch 1 branch. You're not on your master branch. Now, if you want to switch back to your master branch and work on it, you can click on this button and you'll find the master here. You can click on that and it will take you back to your master branch. Here you can work on your project. So there are currently 2 branches. You can see that, and everything's normal. Everything looks simple. That's all for branches. It's really easy. I hope it's clear. So you can look for branches here on this bar here that's present here. You can also create new ones in the same option. So that's all for branches. Let's move on to the next part of the session. Make a commit. Now, what are commits? Commits simply record changes to one or more files in your branches. So basically, they save the changes that you're making in your project. Git always assigns each commit a unique identification, which is called SHA or hash, that identifies the specific changes. So for any changes are made to your project files, you can simply go back and look at the version history or the history of each commit you've performed on your project files. So that's what really commits are all about. It's extremely easy. Let's go ahead and make our first commit. Now I'm going to switch to my branch 1 branch and I'm going to make my first commit. I'm going to click on my README text file. That's the only file currently in our repository. So we'll make the change in the README text file. There are 3 really important icons that are present in the right corner, as you can see. The first one is a PC icon that says open this file in GitHub desktop. So if you click on this file, this entire file will open in your GitHub desktop version. The next one, that is the pencil icon, will allow me to edit this particular file. That is my README text file. And the third icon is a bin icon, which will allow me to delete this file. Now, what we'll be working on is the pencil icon. That's the edit this file option. I'm going to click on this and I can simply view a space or a file that will allow me to make changes to my README text file, I'm going to add another line here that says this is my first commit. This is what I want to add to my README text file. And if I want to preview the changes, I'm going to click on this preview changes button. You can see that this is my first repository. This is my first commit. This is my first commit is the additional piece of information that will be adding to my README text file. And it's highlighted in blue, so we know that that's the additional information. I'm happy with this change. I'm going to switch back to my edit file. I'm going to scroll down. And if I want to add a description about the change that I'm performing to my file, I can do that. A good programmer would always add a description to the change that he's making to the project file. So other collaborators, when they view the commit or they view the change, they can read the extended description and understand what the change is about. So that's a good habit that you must follow. But as of now, we're not going to do that. So I'm going to leave this blank. As you can see, there are two radio buttons that are currently available. The first one says commit directly to the branch 1 branch. This will allow me to make the change or save or make the commit directly to my branch 1 branch only. So the change that I'm making currently is only implemented to my branch 1 branch. The second option allows me to create a new branch for this particular commit and start a pull request. We're not going to talk much about this option right now, but the first option is extremely important. So we'll let this be stuck on to the option that says commit directly to the branch 1 branch. And I'm going to click on the commit changes options. And this will simply implement the entire change to the file. You can see that the change is implemented. The additional piece of line that says this is my first commit is added to my README text file. Now, the interesting part is if I switch to my master branch, the change is not implemented in my master branch. So the change is only currently present in my branch 1 branch. And now if I want to view the history of the changes that I've made, I've already mentioned in the previous part of the session that the history button will allow me to do so. So I'm going to click on this history button and you can see that I made my first commit 23 minutes ago and I made my new commit 41 seconds ago. And there is also a hash number, unique hash identification number that allows me to distinguish between both of these changes. So all of my commits that I'll be making on this branch will be available here. So that's the main point of a version control system, isn't it? Understanding and keeping a record of all the changes that we're performing in our files and our projects. So this gives full justice to the word version control. So that is what GitHub is all about. Now that we learned how to make our first commit, let's move on to the next part of the session. Open and merge pull requests. So what are pull requests? Pull requests let you tell other developers about changes you've pushed to branch in a repository on GitHub. So once a pull request is open, you can acknowledge and review the changes with collaborators and add follow-up commits after which your changes are merged into the base branch. So there are two ways to create a pull request. The first one being pull request from a forked repository, and the second one being pull request from a branch within a repository. Currently in this demo, we will work on the second one, that is pull request from a branch within a repository. Now I'm simply going to switch to my demo part. Okay, now currently I'm on my master branch. I'm going to click on this pull request option that's here. Now it says branch 1 has had recent pushes 3 minutes ago, compare and pull request. I'm not going to click on that. I'm going to simply click on the new pull request option here. So this will allow me to compare the changes. There's a base branch and a compare branch. The base branch is the master branch and the compare branch, I will compare my master branch to my branch 1 branch. So this notification says that the merge between the branch 1 branch and master branch is definitely possible. So it's a green signal. So if I scroll down, I can view the difference between both the branches. So the left-hand side indicates the information that is present on the master branch, and the right hand indicates the information that is present in my branch 1 branch. Plus sign indicates the additional information that is present in my branch 1 branch. I'm happy with this. So I'm simply going to scroll up and create the pull request. I'm going to click on that. I can also leave a comment and I can preview the change. That's not necessary for now. So I'm going to go ahead and create the pull request. Now this will redirect me to a page. So this page says that the pull request has been opened. And now I can choose to merge this pull request. That is, I can merge the branch 1 branch to my master branch. So it says this branch has no conflicts with the base branch. Merging can be performed automatically. And that's good news, right? So I'm going to click on merge pull request and I'm going to confirm my merge, update my readme text file. I'm happy with that. So I'm just going to confirm it. Now it says pull request successfully merged and closed. You're all set. The one branch can be safely deleted. I'm not going to delete the branch. I'm going to compare both of the branches and see if my master branch is exactly the same as my one branch. So I'm going to click on this Edureka. I'm going to go to my main page of my repository. So my master branch has the additional piece of information that says this is my first commit. Now, if I switch to my one branch, it has the exact piece of information. So the information that was present in my one branch has been successfully implemented to my master branch. So that's all for the pull request part 2. We've reached the end of the demonstration part. Now let's quickly look at the case study of how Microsoft implemented GitHub. I'm pretty sure most of you have heard of Microsoft. Microsoft Corporation is an American multinational technology company. It develops, manufactures, licenses, supports, and sells different computer software, consumer electronics, personal computers, and other related services. So initially, Microsoft was against the use of the open source because they held very tightly to the Internet Protocol. They were completely hesitant to adapt to this new concept of sharing code to the entire world. But in 2010, they rethought this entire scenario, and now Microsoft is one of the biggest contributors to open source. Today, about 2,000 to 25,000 Microsoft engineers maintain TypeScript, .NET, Windows Terminal, DARP, Helm, and more than 1,000 other open source projects. So first what they did was they released new processes in measured containment. But later on, they released only licensed software. So here, developers can learn from the company's source code, but they couldn't really build on it. Eventually, the stigma died, and now even closed code like .NET is open source under an MIT license. Teams realize that they need to accept contributions to get feedback and learn from other developers. To organize and understand this approach, Microsoft created their Open Source Programs Office, which enables distribution and centralization of knowledge. So the OSPO provides the resources and maintainers to manage thousands of repositories and contributors effectively on GitHub. Even though Microsoft invests in its tools, they expect other individuals and organizations to lead the way. Microsoft believes that GitHub's value isn't in any one feature, but its entire community. GitHub is the place to collaborate, it's where everyone is, and where most of the entire world's open source is already happening. It's not just a feature, but the whole thing.
Let's first talk about why we need continuous integration. Let's talk about a scenario where we are not using continuous integration. Now, when we work in a development team, there are multiple developers. Now, all the developers work on different components for a project or for a code. A developer A may be writing code thinking scenario, let's say Python 1.0, and developer B will be writing code thinking of a scenario 1.2, 1.3, and so on. One of the biggest challenges that we face in an industry is how to make sure that all the developers' codes get collaborated and that we are having properly released getting deployed. That is the biggest challenge in the industry. Now, another challenge that most developers fail is debugging. Now, whenever you write a code, there are a lot of bugs and issues. Now, the code is often written thousands and thousands of lines. Now, if you don't have any proper continuous integration mechanism or a packaging mechanism, you'll see it takes days, even weeks and months to debug your code to make it 100% bug-free. Now, that is a challenge that really makes the development process very slow. So, how to test the code? Now, testing used to be a monotonous task. Now, there are teams used to spend months of a life cycle to make the code, complete the test code, and make sure it's bug-free. Now, what used to happen is, guys, two things. One is you are not able to deliver on time, and secondly, business never see value coming out of the IT. If businesses see IT not adding value, IT is not delivering product on time, they will start rethinking and giving a second thought. Why do we need to invest so much money in the IT industry or in the IT software? These things were hampering big time in the development and release of modern day deployment software cycles. In the modern day world, we want to make sure our deployment cycles are robust, we're able to get the main need of the market and deploy the product as soon as possible. But with this approach, we're not using the CI tools. It used to take 6 months to develop a product, deploy a product, and make it bug-free. Now things change drastically when we start using continuous integration. Now using continuous integration, we can deploy codes at the quickest. Amazon, for instance, deploys code every 11.6 seconds. Now how is that possible if you ask? It's because they are using the continuous integration mechanism. Using CI tools like Jenkins, where we can automate the process like building, packaging, deployment, testing, and so on, so that we can do all these things with the click of a button in a matter of seconds. CI process helps us to deploy multiple releases parallelly. Now, in one day, we can do thousands and thousands of releases without impacting our environment and making sure these releases are in line with our requirement. The CI tool has an awesome notification mechanism where it notifies instantly of any success or failures happening, so that if I have to debug the code or troubleshoot it, I will know exactly at the pinpoint location where it is failing. You can do multiple notification management mechanism like an email, an SMS, any ITSM tools. Now all those modern ways of notification are possible using the CI tools like Jenkins. Now we integrate these CI tools like Jenkins with modern day build and packaging tools like Maven and Gradle, so that we can automate the common problem which developers spend most of their time on. Now, developers spend half of their life cycle like packaging their code, code review, code deployment, unit testing. Now, all those things can be automated and can be done with the click of a button using these CI tools. Now, what is continuous integration? Now, we have talked about how it helps to save time, how it helps to save the energy, and how it helps to make release more frequent, and it helps us to streamline the process. Now, what actually is continuous integration? Now, if I go traditionally, continuous integration is basically, you can say, a process that helps us to combine or smoothen the automation of tasks like compiling the code, doing the testing, and deploying the code into our life cycles. So how does this continuous integration work? So developers who work on projects generally commit their code in any version tools like GitHub, GitLab, Gitbucket, SVN, etc. So using continuous integration, we pull the code from the version control system like Git, for example. Now we automate the process like code compiling, code testing, code review, and then finally deploy the code in the lowest lifecycle environment. You can say continuous integration is sort of a development practice where developers pull the code from the version control system and make the code deploy in the lower lifecycle environment. Now the beauty of using these CI tool is we can automate the process in such a way that whenever developers make a new commit or a new change in the version control system tools, we can create a sort of a pipeline, and the pipeline automatically picks the code from the VCS tools and compile it and then deploy the software. Another good thing about it is it does not require any human intervention. So once I have set up a pipeline, then I don't need to worry about running the code again and again or making any changes. It automatically happens in a fully automated process, as I mentioned a while back. Now we can use the process whenever a new commit happens, or you can run it on a scheduled basis or something. Now CI, or continuous integration, was first time proposed in 1991 as part of the Extreme Program concept. At that time, it was not adopted so well, but in the modern day industry, it has become the bread and butter of smoothing up release or for our development process. In a modern day world, continuous integration can be said as a practice of merging all developers, working copy to a mainstream where you can develop and deploy the code multiple times in the same day with as many changes as possible. Now, there is no limit of how many lines of code. It can be tens and thousands of lines of code, which can be compiled multiple times throughout the duration. Let's see a case study where we try to see how things change for an organization after it adopted to the CI, or continuous integration mode. Here we have picked up an example of Adobe to see how it helped in the development process. Adobe realized at some point at the time that they have not released very frequently. When this happened, their market percentage share was down as they were not following the continuous integration approach. Now they were using the native method of compiling the code, debugging the code, testing the code, because of which they were noticing that it used to take up to 6 months release updates. Now 6 months was a long duration, whereas their competitors were releasing very frequently, which was helping them to capture the market share. Adobe decided some point at a time that they need to change their software development and deployment strategies, and they tried to adopt the continuous integration mechanism. Once they adopted the continuous integration mechanism, they found that the response time was a lot better and a lot faster. Now they were able to deploy the updates more frequently with every time a change was made by a developer or new release was being released. And it helped them reduce the response times, and they were 60% more faster. The development teams were getting more effective, and they were able to really deploy losses far more in a better and structured way than what they were doing without using CI. You can see how CI helps industry. Amazon is the best case scenario. Amazon in modern day scenario deploy codes every 11.6 seconds, almost 5 times every minutes. Now this is all possible using the continuous integration. Now what is Jenkins? Now we've talked about what is CI, we've talked about why we need CI. Now let's talk about what is Jenkins and how does Jenkins fit in this particular picture. Now Jenkins is an open source automation server which helps us to automate the process of development relating to testing, deployment packaging, and others. It is a server-based system that run on software, Apache Tomcat. Now it supports VCS store like Git, Bitbucket, etc. It also supports build automation tools like Apache, Maven, and it helps to make and facilitate our continuous integration and continuous delivery process. Now Jenkins was first released in the year 2011 and it's completely open source software as a part of the MIT license. Jenkins is a plugin based profile. In Jenkins, you have got plugin which basically used to interact with different tools and components. In Jenkins, plugins are primarily released in language other than Java. Plugins are available to integrate Jenkins with most version control system tools and most databases. Using these plugins, we set up purposes, for example, unit testing. Now you can do compiling, you can do packaging. Now you can create some reports. Now you can do some logging. Now all these things are possible using plugins and Jenkins. Another important component that we've talked about in Jenkins, apart from plugins, is Jenkins notification, which we call it as Mailer. Using Mailer, guys, we can configure email notification. For instance, you can configure scenario. For example, you want mail notification when build is successful. Now all these things can be done using Mailer as the Jenkins component. Another important component in Jenkins is the SSH agent. Jenkins also follow a typical master-slave topology. Now, why do we need a master-slave topology and a CI tools like Jenkins? Now, when you work in the organization, we have got multiple teams which you want to build and deploy their own pipeline or deploy their own software project codes. Now, teams don't want the piece of code to be run on a server which is owned by some other teams. So what we can do is we can set up a master-slave topology where Jenkins may run on a server X. But you can connect multiple other servers which will act as a slave. So when you are deploying a code executing a pipeline, you can run those codes on those XYZ servers. Now this is the beauty of using Jenkins master-slave topology. Now another good thing about Jenkins is Jenkins can be deployed on any operating system. In Jenkins, you can use in a Windows mode, a Linux mode, a Mac mode. Now all these Jenkins jobs can be deployed on any operating system. It is not at all dependent. Now both master and slave needs to be of the same operating system. Another important core component of Jenkins call is JavaDoc. This is our plugin in Jenkins which basically is a part of Jenkins core that helps us to publish results like build action, build directory, what is the expected build output. All those things that we see in Jenkins, they all are happening using JavaDoc. Now let's talk about security injection. Apart from that, Jenkins have other sorts of authorization like project-based strategy, metric-based authorization, which help us to make Jenkins more secure. We'll talk more about this when we talk about the Jenkins overall. So as you can see on the diagram, Jenkins is pulling code from the source code control system like Git, Bitbucket, etc. To start deploying it in Jenkins, we have got a notification management system using Mailer, where if the build is successful, we get a WAR file or a zip file. We can define how we want the build to be created, and if it is a failure, it will send the notification management to a developer that something happened wrongly with the specific code lines and you need to rectify your codes. Now that is the beauty of using Jenkins. So Jenkins is still the bread and butter in the industry. There are some Jenkins competitors also in the market like GitLab Jenkins and some others. But by default, Jenkins is the to-go tool for the CI industry. So far we've talked about Jenkins. Now let's talk about what is pipelining in Jenkins. Now let's say I want to deploy a code. The code may have certain steps like first step I'm building the code, second step I'm compiling, then code reviewing, then packaging, then deploying. So how do I automate a combine of all these steps which can be executed in one go? Now to deploy all the scenario, we've created a delivery pipeline. Now pipeline is nothing but it's a combination of different steps or different tasks that we need to perform in order to deploy our code. Now using a pipeline instead of doing this task or code deployment manually, we combine them and deploy them as a sort of one common approach of a delivery pipeline. Now, there are multiple ways on how you can create a pipeline. The two most common ways or common approaches of using a pipeline, as you can see from scenario, a declarative approach. And the second one that is used in the industry is a scripted approach. This particular is an example of a Jenkins pipeline script. Here you are saying we are first doing a stage called build stage, where we will be combining multiple tasks. Like first we are using Java, then we are printing something called echo hello pipeline. Then we are using Maven as the build automation tool and try to deploy a package. And then we are doing a shell script output of what all things are present in that particular directory structure. This is a typical example of syntax of how to create a pipeline in Jenkins. Now let's talk about the two predominant pipelines that are used in the IT industry, scripted and declarative. Now let's talk about what is scripted and declarative and how they are different from each other. A scripted pipeline is a traditional Jenkins pipeline approach, and a declarative pipeline is a modern day pipeline approach that is used in the industry. In a scripted pipeline, the syntax was first strict, while in declarative pipeline we use something called as groovy syntax. When you use a declarative pipeline, you can get a code from any version system tool like Git. You can create something called as Jenkins file, and you can download Jenkins file from a virtual constant tool, and that can be used to run your Jenkins code. When you use a scripted pipeline, you define a code something called as a node block. But one declarative pipeline will define a code in a pipeline block, as we can see in the previous example. Now let's talk about what is Jenkins file and how it can be used. Now Jenkins file are like a text file where you define your entire structure and syntax of your Jenkins. You know only how to download the file, and in particular, you can just give the part of your Git repo. If it is true, then get the credential, the private repo, and it can pull all the contents from there and just execute your code. It is a modern deployment mechanism that we use when we work with a Jenkins pipeline. Using Jenkins pipeline, we use certain things which help us. Let's talk about this. First is code review. Now you do a Jenkins pipeline, you can easily review your code. Your code can be reviewed by multiple developers before being executed. Now how that works is, in Jenkins file, they are stored generally in a version control tool like Git. You can put something called as a pull request for a code review. Now different members of your team can review the code before you actually pull the Jenkins file and deploy it. Now you can do an audit trail, or refer to as a long audit. You can log each and every step's output that is being executed as part of the Jenkins file, and can see what is happening when the Jenkins file is getting executed. It's sort of like a verbose log. Then you can find a single place to store all your data or all your outputs. You don't need to have developers scattered here and there and writing their own codes for executing a Jenkins pipeline. Whole organization can approach a Jenkins file methodology where code can be stored in a VCS tools, and from there the code can be downloaded and can work as a single source for your entire pipeline. Now let's talk about the Jenkins workflow in particular. How does Jenkins workflow work? Jenkins workflow always starts with a version control system, or you can say a source code repository. Multiple developers collaborate and they put their code in a source code system like Git, from where Jenkins tries to pull the data from that source control system. For your system, there is no mandatory or the source code needs to be Git. It can be Bitbucket, SVN, whatever your organization uses with Jenkins server. Now we execute tasks like build, deploy, compiling, packaging, code reviewing. Now all these things happen using Jenkins server, where your Jenkins actually installed was running. Now Jenkins server can be any operating system. It can be a Windows machine, Ubuntu machine, Linux machine, or a Mac as well. It can be any operating system of today's modern world availability. Using this Jenkins server will execute our different tasks and scenarios. In Jenkins server, we use the mail functionality for the feedback mechanism. We notify developers the commit or the code deployment successfully or it is a failure. It also has some challenges. Now what can be done using the feedback mechanism? Possibly using the Jenkins server. So using Jenkins server, we always first deploy the code on a lower lifecycle environment. That is recommended standard practice. So what we do is we first deploy a QA server on a testing server, and once the code deployment is successful on the lower life cycle, then we go ahead and deploy the code on a production server. That is how the entire Jenkins workflow mainly particular interact first. Now guys, let's talk about the Jenkins installation and how to install Jenkins in a machine. As you all know, Jenkins by default run on 8080. So please make sure that if you're using any VMs in your organization, the port 8080 settings are open and configured so that it can be accessible. I will get into some of the prerequisites required for installing Jenkins first, which will go ahead and install Jenkins on a window box. Now there are a few first configuration that needs to be done, and I'll be covering those as well. So once I have Jenkins installed and configured properly, I will get into the user administrative part, then create few users, and I will get into some of the plugins for setting up various kinds of access permissions for these users, and I also put in some of the freestyle jobs. Freestyle job is basically nothing but a very simple job, and I will also show you the powerfulness of Jenkins by scheduling this particular job to run based upon time schedule. Then I will also connect Jenkins with GitHub. Now GitHub is a source code repository where I've got some repositories put up there. So using Jenkins, I will connect to GitHub, pull up a repository that is existing on GitHub onto the Jenkins box, and then run a few commands to build this particular repository that is pulled from the Jenkins sending out emails. Now it's a very, very important configuration of Jenkins or any other continuous integration server for that particular matter. Now, whenever there is any notification that has been sent as a part of either build going bad or by being good or building propagate to some environment and all these scenarios, now you will need the continuous integration servers to be sending out notification. So I will get into the bit of details of how to configure the Jenkins for sending out emails. Now, I will also get into the scenario where I will have a web application such as a Maven-based Java web application, which will be pulled from the GitHub repository, and I will deploy it into the Tomcat server. Now the Tomcat server will be locally running on my system. Eventually I will get into the other very, very important topic, which is the master slave configuration. It's a very important and pretty interesting topics where distributed builds is achieved using a master slave configuration. Now all this can be very, very easily based up using a plugin. So this is what I'm going to be covering as a part of this tutorial. Now, Jenkins is a web application that is written in Java, and there are various ways in which you can use and install Jenkins. Now, I've listed the popular 3 mechanisms in which Jenkins is usually installed in any system. Now, the topmost one is a window or a Linux-based services. So if at all you have a window like the way I have, and I'm going to use this mechanism for this demo, so I will download the MSI installer. So whenever you start as a service, it goes out and nicely install all that is required for my Jenkins, and I have a service that can be started or stopped based upon my needs. Any flavors of Linux is one of many other ways of running Jenkins in downloading this generic WAR file, and as long as you have a JDK installed. You can launch this WAR file by the command opening up a command box prompt or shell prompt defer to later on Linux box specifying jar and the name of this WAR file, typically bringing up your web application. And you can continue with your installation. Now, the only thing being, if at all you want to stop using Jenkins, you just go ahead and close this prompt, even into a control C, and then bringing down this prompt and in Jenkins server. And then you also have the other older versions of Jenkins where run popularly using this way, in which you already have a Java based web server running up and running. So you kind of drop in this WAR file into the root folders or the HTTP root folder of your web server. So Jenkins will explore and kind of bring up your application. All user credentials or user administration is all taken care by the Apache or the Tomcat server or the web server on which the Jenkins is running. This was a very old way of running, but still some people use it because if they don't want to maintain 2 servers, now if they already have a Java web service which is being nicely maintained and backup, now Jenkins can't run a test to it, alright? So either ways, it doesn't matter however you're going to bring up your Jenkins instance. The way we're going to operate Jenkins is all going to be very, very same or similar, but the subtle change in terms of user administration. Now, if at all you're launching it through any other web server, which will take care of the user administration. Otherwise, all the command or all the configuration or the way in which I'm going to run this demo is going to be same across any of these installation. Alright. As I mentioned earlier, Jenkins is nothing but a simple web application that is run in Java. So all that is needed is Java, preferably JDK 11 or 17 with a 2 GB RAM, which is a RAM for running the Jenkins. And also, like any other open source tool sets, when you install JDK, ensure that you set in the environment variables. Now Java home to point in the right directory Now this is something very specific to JDK. Now, but for any other open source tools that I've installed, there is always a preferred environment variable that we got to set in which is specific to that particular tools that if you're going to use. This is a generic thing that there is for you to know. Now for any other open source project, because the open source project discover themselves by using the environment variables. So as a general practice or a good practice, always set these environment variables according. So I already have a JDK 17 installed on my system. But in case you do not, what I will recommend is just navigate to the browser, to the Oracle homepage, just type in your search for install JDK page. Then you'll have the accept the license agreement. Now what I will recommend is just navigate on your browser to the Oracle homepage and just type in your search install JDK. Now you're gonna navigate to the down here and install the 64 installer, that is the .exe. Now let me show you once I've installed what I've done with regards to the path. So if you get into these environment variable, so I have just set in the Java home variable. Now you can go back to your this PC, go to C programs, go to Java, and then copy this part, then click in the environment variables. I'll select the first one, that is the edit the system environment variable, and we click on the environment variables and we'll set a path here. As you can see here, Java home, and we'll go down here on the path. So this is the path for your Java home screen. So simply click on edit and click on new, and we will just paste the path which we have just copied from the install.exe Java. So I've already installed it, as you can see there, C program files. I simply click on OK. So the only difference between the system variables and the user variables for daemon is this is control the whole system of the JDK, the system variables. So we want to edit in the system variables. So the path I've been changing here is in the system variables. All right. Now the home variable is where I have the SQLs and program friend of the JDK 17. Now you see this is my Java home. All right. Now one thing to do is ensure that in case you run Java or Java C, for a command, you ensure that you also add the path into this path variable, right? So if you see somewhere, I will say there you got the colon program files. Now you click on that and I'll show you the bin as well, which I've copied and pasted here as well. Okay. So simply just go back. So that's how you get the bin. Copy this path and paste it here, which I've already done it. So I'll just simply click on OK, OK, and OK. Now let me minimize the screen as well. So the next thing we need to do now is go to CMD to check if your Java has been installed on your system. So you simply type on Java space / version, and you can see I already have Java version 17.0.5 installed in my system and is up and running. So as you can see the runtime environments, and this is a 64-bit server. This is a VM virtual machine. Okay, so as you can see, Java is installed in my system and is up and ready. So the next thing we need to do now is install Jenkins. I'm just canceling that and open a new browser again, new tab, and type in jenkins.io. Now, as you can see, this is the homepage of Jenkins. All right. So you can even read the documentation, or you can simply click on download. Will take you to this page. Now here you can see the hardware and software requirements, then what packaging is required for downloading the installing Jenkins. So this is the part for, on the left hand side we have the LTS, and on the other side we have the, which is a more stable, and on the right hand side we have the regular weekly releases. So we'll definitely go for the stable LTS download, which is a long-term support, which is released every 12 weeks, whereas the regular releases changes weekly. So I'll be going ahead and scroll down and click on window. So as you can see, there are different parameters where you can have on Dockers, then you have Ubuntu, then you have the CentOS, Fedora, or the Windows, like I'm going to install in this case in this demo. Then but we have different aspects as well, like the FreeBSD, the CentOS, Mac OS, etc. So as you can see on the first stop, we have the .war. We can even install that and unzip that. But in this case, in this demo part, we'll simply click on Windows. So go on ahead and click Window, guys. Now you can see the download has started. So we just wait a few seconds until it's done installing the MSI. And as you can see, it's done. So this is my downloaded Jenkins instance. So what I'll be doing now is simply click on next. Now, as you can see guys, on top here, it's written the Jenkins run on localhost 8080. So keeping that in mind, click on next. As you can see, this is where our Jenkins is installed. That is in C and program files and by the name Jenkins. So you can always change this location where the Jenkins has been installed. But in this case, I'll rather keep it on the C drive itself. So the next thing you need to do now is we'll run server as a local system so that we don't have to put any administrator or the password. And so the next step now is we test the port. So as you can see, you got a green tick mark. So we'll click on next. Now you can see here that it has failed because there is no compatible Java version 11 or 17. But as you can remember guys, we have already installed Java 17 and we have already verified that we're using the command prompt where it has shown us the version Java 17. So what you need to do is simply click on change and select the Java 17 from Java 8. So simply click on Java 17, JDK 17 as you can see, click on next and click on the install part. Done and dusted. So I've already told you that Jenkins run on the localhost 8080, right? So we're gonna go localhost 8080 and hit on enter. Now as you can see, please wait while Jenkins is getting ready for work, right? So this will take a few minutes and then you'll be having to provide the credential of the administrator. All right, so just give it a few minutes while it's starting up. All right, now you have to provide the administrator password, right? So you can go ahead and go down out here. You can see the password is in the C and goes to the program data, then Jenkins. Then we have a .jenkins, then a secret, then you'll find the initial admin password. So we need to head out there. So what we need to do is we'll go down there. So I'm just going to minimize the screen now, minimize it once again. And as you remember, we go to the C. So you can see right where it is. I'll just show you, minimize the screen here so you can see and do it along with me. So you can see this in PC, then scroll down to C disk. Okay, this thing popped out, sorry. It's in this, so you have a program data, right? As you can see here down, there is no program data, right? So what you need to do is it's in the hidden file. So what you need to do now is click on the three buttons and view, click on show and click on the hidden items. Now let's see if it's there. Scroll down, program data, you can see at the last. Yeah, simply click on that, double click on it. As you can see, then we have to go to the folder name as Jenkins. Yeah, you can see on the top, Jenkins and .jenkins. Then we need to search for secrets. There it is, folder. And as you can see, there's an initial admin password. Now you simply click on that. We'll try with the notepad so we can copy. So simply copy that and paste it in the administrator password and click on continue. So in this case, I will not save it in my computer or system. So there are two installation plugins available, which is custom by Jenkins. One is they have suggested plugins, and the other one is you can select the plugins which you want to be installed. So in this scenario, I'll simply click on the install suggested by the Jenkins. So what happened is the plugins are all related to each other. So it's like the typical RPM kind of a problem where you try to install some plugins and got a dependency which is not installed and you get all those issues. In order to get rid of that, what Jenkins recommends is that there are a bunch of plugins that is already recommended and they are good to go, right? So just go ahead and blindly click on that recommended by the plugins, which is a suggested or custom by the Jenkins. And as you can see, these getting started process is going ahead. So it'll take a few minutes depending on your internet speed or on the system. Now you can see all these plugins are installing it for you. So it will take a few minutes time. So let's just wait till we get all the plugins installed in a system properly. So this is a good combination to kind of begin with, and keeping that in mind, Jenkins need a lot of bandwidth, right? Now in terms of network, so in case you know your network is not so good, it'll make for a few of these plugins will kind of fail, and these plugins are all are available on openly or mirrored site, and sometimes some of them may be down. So do not worry, in case some of these plugins kind of fail to install, you get an options to kind of retry installing them, but just ensure that you at least at the most 90 to 95% of all of these plugins are installed without any problem. As you can see, we are almost there. It's around 60% to 70%. Now once all these plugins are installed, Now my plugin in the installation is all good. There's no failure in any of the plugin. So after that, we've got to create this first username, that is the first admin user. So you need to give in the username, then the password, then you have to confirm your password, give it your full name and your email address, right? So we'll start it by giving the username. I'll keep it plain and simple. Now you got to remember these password and the confirm password, because if you kind of lose the, or you don't remember the password of the Jenkins, it'll be really hard to get back your account. So try to keep it as simple as possible, and keeping in mind that you have to remember the password, because getting back this account will be really difficult. All right, so I'll be putting the password as well. Give it my full name. Okay, my A is small, and go to the email address damandla.namare@Edureka.co. All right, so once it's all done, so just simply click on save and continue. So click on never, don't want to save the password. And as you remember, I've told you by default Jenkins run on localhost 8080, right? So you can simply click this, or you can copy this on, or just write save and finish. You can even copy this link, save and finish. Now start using Jenkins. All right, now that's kind of complete my Jenkins installation. As you can see, it was not that tough at all. Now the Jenkins is installed correctly. Now let me quickly walk you through some of the very minimal configuration that is required. Now these are kind of the first time configuration that is required. So, and also let me warn you, the UI is a little hard for many people to wrap their head around, especially the window guys. But if you're all a Java guys, you know how painful it is to write UI in Java. You kind of appreciate how the effort that has gone into the UI bottom line. It was a little hard to wrap your head around. It becomes like start using it, possibly you start liking it all right? So I will get into some of these important ones, something called as configuration system, or the configuration system. This is something kind of put in your configuration to complete your Jenkins instance. Now few things to kind of look out for. This is the home. Now configure system is where you kind of put in the configuration for your complete Jenkins instance. Now a few things to keep a lookout is the home directory. All right, now this is a Java home where all the configuration, all the workspace, anything and everything regarding Jenkins is stored out here in the system message. Now in the system message, you can put in some of the message on the system. You can just type anything you want, probably show up somewhere here on the menu. Now the number of executors is a very, very important configuration. This just lets Jenkins know at any point in time how many jobs or how many threads can be run. So you can kind of visualize like a thread that can be run on this particular instance. As a thumb rule, if at all you're on a single core system, the number of executor you should be good enough in case at any point if there is any multiple jobs that kind of get triggered at the same time. Now in case the number of executor are less compared to the number of jobs that are out there to open up the new, so you don't need to panic, because they will get queued up and eventually Jenkins will be get up and running. So just keep that in mind that whenever a new job kind of gets triggered in the CPU usage and the memory usage, in terms of the disk, it's like a very high of the Jenkins instance. So that's something you got to keep in mind. All right, the number of executors for my system is kind of a good label. For my Jenkins, I don't want any of these usage. So how do you want to use your Jenkins? This is good for me because I only have a primary server that is running. So I want to use this as low as possible. All right, as you can see, it's 2. Now this is usage. So I can leave everything to default. So what I want is I want this SMTP server configuration. Now Jenkins will be sending out some emails. What I've done here is I've configured the SMTP details of my personal email details. In case you are, in your organization, you want some sort of an email that is like an email ID that is set up for a Jenkins server. So you can specify the SMTP server details of your company so that you can authorize Jenkins to kind of like send out emails. But in case you want to try it out, like I have configured my personal email ID, which is of the Gmail, for sending out notification for the same TP server, will be the SMTP Gmail. So just write as username as so we have used SMTP authentication, and then we give the password. Now you can just send out an email to see if at all this configuration works again. Now Gmail will not allow you to allow anybody to send out notification on your behalf. So you just have to lower the security level of your Gmail ID so that you can allow programmatically somebody to send out email notification on your behalf. So I've already done that. So let's see if this works. Let's test it again since I've entered the wrong password. Let's see if this works or not. And it has given me a password has not accepted. So now as you can see, since my Gmail has not been set up, so what you have to do is you have to lower your security level of your Gmail ID so that you can be allowed to test your email configuration. All right. So simply click on save. So now we're heading back to the dashboard. Now we should go to the global tool configuration. Now look at the scenario where Jenkins is a continuous integration server. Now it does not know what kind of a code base it's going to pull and what kind of tool says is required or what is the code that is going to pull in and how it is going to build. So you'll have to put in all the tools that is required for building the appropriate kind of code that you're going to pull in from, like a source code repository. So for example, in case your source code is a Java code, and assuming that you have, because this demo, this is my laptop and I put all the configuration, JDK, everything on my laptop because I am a developer and I'm working on the laptop, but my country's integration servers will be known as a separate server without anything being installed on it. So in case I want Jenkins to, run on a Java code and I need to specify the JDK location of this out there. So, okay. Since I've already have the JDK installed and have already put in the Java home directly or rather and the environment correctly, so I don't need to do it. So now if at all you want the Jenkins server to use Git, now as you know that Git is a command bash or the command prompt for running Git and connecting to any other Git server. So you will need Git to be installed on that particular system. Now Gradle and Maven, if at all you have some Maven as you want to do this and any other tools that you're going to install on your system, which is your continuous integration server. So you'll have to come in here and try to configure it. And in case you have not configured, then Jenkins will not be able to find these tools for building your task. So since I don't want to install anything, we'll go back to manage system. Now you can see the configure global security. Now you can see this an SSH server. Now what does this mean if you ask me? Jenkins own user database. So this is nothing but the security access control which is set to Jenkins own user database. So what this mean is, Jenkins by default it uses files system where it stores all the usernames which hashes up like these username that kind of stores them as of it. So as of now, Jenkins is configured to use in your own database, assuming that you're running in an organization. So you will probably want to, have some sort of LDAP server, which will in turn have a control of your access to your Jenkins repository. So you will specify your LDAP server details, the root DN password or the managed DN. So the LDAP, as you can see, or the LDAP, which the Jenkins itself will tune in for your specific servers. Now you have the manager DN, the manager password. Now all these should be filled, all these details should be filled in case you want to connect your Jenkins instance with your LDAP server or any of the authentication server that you have in your organization. But for now, since I don't have any of these things, I'm going to use its own database. That's good enough, right? So I'll simply the Jenkins own user database. So I will set up some authorization methods. So for now, let me not get into any of these details of this. Just be aware that Jenkins can be connected for authorization to an LDAP server, or you can have Jenkins managing its own server, which is happening as of now. Let me put in a very, very simple job. All right. So let's create a new job in this video. So simply click on new item. Now simply you can add any item name here. So the most important here are the freestyle and pipeline. Now for the first demo, we'll click on the freestyle job and click on OK. So in the description, you can write anything in your description. This is an optional thing. So you can say this is my first job demo for. So in this demo, I don't want it to connect it to any source code for now. So I'm just going to leave it to none. Now we don't need to write any build environment as well. Now in this build step, we simply click on execute Windows on. So since I'm on the window box, I will say execute window bash command. All right. So what do you want to do? So let me just echo something. Echo hello world, this is hello, welcome to my first demo job in Edureka. Then we'll specify the date and time as well. So put in date, colon as time as well. So you can see it's a very simple command. You just have to put an echo and we have something along with the date and time. So we'll keep everything as simple as possible. So we'll save this job. So once it is shipped, so you can see there's a bill history. So once you have saved this job, the job name comes up here. As you can see, project first job. By mistakenly, I've written double T in my first job. Now, as you'll see here, there's some bills history. So there is nothing as of now because I've put in a job. I have not yet run it. All right. So let me try and bill it now. Now you can see there's a number, my first job. So you will see a date and you will see the time since I've clicked twice. So if I've come 1 and 2. Now, if you click on this, now you can see the console output. Now, if you click on this, now you can see it. And this is the output that is run. Hello, welcome to my first demo job in Edureka, along with the date and along with the time. Now, if you see this, now if we navigate this, we go back to here. Now, as you can see, there's a folder created as jobs, right? So this is the directory what I was mentioning earlier regarding Jenkins home. If you can just open it up wider, you can see this folder jobs. So this as mentioned earlier regarding Jenkins home. So all the job related stuff, it's specific to this particular Jenkins installation is all here. Now all the plugins that I install, the details in each of those plugins can be found here, right? So the workspace is where the jobs that I've created, whichever I'm running will, there'll be an individual folder specific to the jobs that has been put up there. All right. So one job, one quick run. That is how it looks like. So the workspace is where all the jobs that I've created, whichever I'm running, will, there'll be an individual folder specific to that jobs that has been made up. All right. So as you can see, there's a first job that we have just created just now. So one job, one quick run that we have done. That is how it's look like. It's pretty simple. Now let's go back. So let us put on a second job. So we can go back to dashboard, click on new items and say second job. Let's get the spelling correct this time. Second, I wrote second first again. Second job, and I can put a semicolon here, underscore. Second job. We click on freestyle again. Click on OK, and you can say this is my second. So I just want to demonstrate the powerfulness of the automation server and how simple it is to automate a job that is put on the Jenkins, which will be triggered automatically. Now remember what I've said earlier about Jenkins, because at the core of Jenkins is a very powerful automation server. All right, this is my second job. This is my second job, which will be triggered automatically. Okay, so in the build step, we'll put bash tabs, then we'll write here echo again. So we'll say here something as second job is going on here. The tools, with the tools of an automation tool. And then I'll give some date as well. Date, put in the time. But this time I'm going to demonstrate the powerfulness of the automation server that is there. So if you see here, there is a build trigger. So build can be triggered using various triggers that is there. So you'll get into the GitHub trigger or a hook or a webhook, which is kind of triggering. So we'll see that later on. But for now, what I want to do is I want to ensure that this job that I'm going to put in will be automatically triggered. Let's say every minute I'm on this job to be run on its own. So we'll put as build periodically and we will set the time. Now, if you can see here, there's a bunch of help. If you want to go through it, and you can go through it. Let's just put out very simple regular expression for scheduling this job every minute. All right. So 5 star is all I'm going to put in. 1, 2, 3, 4, 5. Now let me save this. Let's go back. So when you build periodically, is now you can see here. Now we just copy that. And now how do we check if it gets triggered every 15 minutes? So I just don't do anything but wait for 15 minutes. And if everything goes well, Jenkins will automatically trigger my second job in 15 minutes. Now you can see here, it's still processing. So we have to wait for 15 minutes. Now we can go through all this command of the scheduling time. So you can see how many stars required for each minute or for each hour. Now as you can see, it's done. You can just go and go here and go to console output. Now you can see the finish is success and you have this. Now we can go back and copy this and see if they're on your it's already there. You can go to workspace. You can see your second job has also been created automatically by Jenkins. Now that I have my Jenkins up and running, a few jobs that have been put up here on my Jenkins instance, I will need a way of controlling access to my Jenkins server. This is where I will use a plugin called a role-based access plugin and create a few rules. The rules are something like a global rule and a project rules for a specific role. I can have different rules and I can have user who have signed up, or the users from my create kind of assign to these roles so that each of these users fall into some category. This is my way of kind of controlling access to my Jenkins instance and ensuring that people don't do something unwanted. All right. So first thing first, let me go ahead and install a plugin for doing that. So we get into manage Jenkins, then we go to manage plugins. We will plugins, install plugins, we have advanced settings. So these are the available plugins, and then if you go to install, now these are the installed plugins. Now let's go and search for a role-based. Now you can see here, base authorization strategy. So this will happen is it enables user authorization using a role-based strategy. Now roles can be defined globally or for particular jobs or nodes selected by a regular expression. This is the plugins that we want. So we will install it without restart. So it's success. It looks good. Looks good. Now waiting for this. Yeah, success. Done now. So go back to the top page. Now one thing to remember, guys, is Jenkins is running on a Java using a Java instance. So typically many things will work the same way unless inherently you want it to restart. So, but a good practice is whenever you do some sort of a big installation or a big patches on your Jenkins instance, just ensure that you can restart it. Otherwise, there will be a difference in terms of what is installed in the system and what is there on the file system. So you'll need to flush out few of those settings later on. But for now, these are very small plugins. So this will run without any problem. But otherwise, if at all there are some plugins which they will need to restart, you can kindly go ahead and restart your Jenkins instance. But for now, I don't need that. So it looks good. I have installed the plugins. So where do I see my plugins and install the plugins? Which is specific to the user control to the access control. Now let's go to the configure global security. Now we can go ahead and check the authorization. You can see here authorization, role-based strategy popping out here, right? As you can see, the role-based strategy has been installed and has been shown here. This is because of my installation of my role-based plugin. So this is what I would want to enable because I already have my own database set up, and for the authorization part in that sense that you can do what I'm going to install. I mean, I've already installed a role-based strategy, right? Now I'm going to enable that strategy. So we'll simply click on role-based strategy, okay, and click on save. So now I'm going to enable that strategy. All right, now I will say, okay, now I've installed the role-based access plugin. Now I will need to just set it up and check, I will go ahead and create some roles, and it shows that I've assigned users as per these roles. So let me go to manage the configuration, manage Jenkins, and let's see how we can create our roles. Not here as well. So we can do manage and assign roles for creating a roles. Okay. Now you'll only be able to see this once and only when you have installed those plugins. Now I've enabled the plugins. Now I've enabled the role-based access control as well. Now we'll go ahead and create some rules for this particular Jenkins instance. So first I will manage roles. So this is at a very high level, which is a global role. Now there are some role to add which you can add by yourself, some item roles for some projects or something. So let me create a role which kind of visualize like a group. So we'll create our own called the developer. Typically the Jenkins instance or the CA instance are kind of owned up or controlled by a QA, guys. So that's why I'm creating a role called developer, and I'm adding this role at a global role. So I will add this here, and then I can click read as well. So we've given this administrator, right? So we add this. So as you can see here, you will see this develop a rule that there is each one of these options that you can hover here and sort of see what kind of permission you have given it to this developer role that you have just created. So you can read and write, then you can create some changes. We've given a permission as credential, which you can create. Then you can delete, then manage the domains. So this kind of help or the permission that they're giving it. So these are some kind of sort of a help for a permission specific. So you want to see it's like how it sounds a little different, but I will want to give you a very little permission for the developer. So from an administrator perspective, I just want him to have a read and write kind of a role credentials. Okay, let's read and write, and I can allow him to view as well. I don't want him to create agents or give him some delete. No, I don't want him to configure, build, provision, or connect or disconnect anything. So I'll just give him a read and a view. And I don't even want him to have access to my workspace as well. So I'll just give him now for run. So I won't even give him the access to that. Now we can give view as well. I don't want him to delete. And what am I doing here is just creating a global rules for the developers. And I've given him a very limited roles, in the sense that I don't want this developer to be able to run any agents, nor create jobs or build jobs or cancel jobs or configure jobs at the maximum. Right? So I just want him to read that is already put up there. Okay, so I will save now and create a rule. That is done. Now that I've created a rule. Now I still don't have any users that is in there in the system. So let me go ahead and create some users on the system. So we'll go back to Manage Jenkins and go to Manage Users. Now let me create another user, okay, by clicking on plus users, and we'll say this one as a developer. Give him some password and name him as develop23, and email. You can just simply give my email here and click on create users. Okay, 1, 2. So we have created. Now this developer 1, 2 is a user that I've configured, but still yet I have not set any rules for this particular user. So I will go to the manage and gain and will give him the manage and assign roles. So now we'll go manage and assign roles, and we'll assign role. So what you're gonna see, what I'm gonna do now is I'm gonna assign a role that is specific to that particular developer. So I'll find that particular user and assign him, or means the developer role that I've already configured the rules. Okay, so this is the role that we have created. So we will search the user that we have just created, developer 1, 2. Now I've assigned this. So go ahead and save the changes. Now let's go ahead and check the permission of this particular user by logging on to my main account and logging back as the developer one. Now let's log out from here. Log out and say developer 1. Now, if you remember, this role was created with very less privilege. So there you go. I have Jenkins, but I don't see a new item. I can't trigger a new jobs. I can't do anything. I see these jobs. However, I don't think I'll be able to start this job. Now, I don't have the permission to set forth at the maximum. So what I can do is look at this job, see. So this is a limited role that was created, and I've added this Damanang Lamare to that particular role, which was a developer role, so that the developers don't get to configure any of the jobs because the Jenkins instance is owned by a QA person. He doesn't want to give developer any ethnicity or right. So the rights that you set out by creating a developer roles, or any user who's tagged as a part of this developer role, will get the same kind of permission. And these permission can be, fine grained. It can be a project specific permission as well. But for now, I just demonstrate the high level permission that I've set. So let me quickly log out of this user and get back to my admin account. So because I need to continue my demo with the developer roles that was created. Now, one of the reasons for Jenkins being so popular, as I mentioned earlier, is the bunch of plugins, but it's got plugin for connecting anything and everything. Now you can find the Jenkins plugins, then you will see the index over here. There are so many plugins that are there. All of these are wonderful plugins. Whatever connectors that you will need if you want to connect Jenkins to the AWS instance, or you want to connect Jenkins to a Docker instance, or any of those containers, you will have a plugin. You can go and search up if you want to connect Jenkins to Bitbucket. Simply click on Big. So as you can see, these are available. So bottom line, Jenkins without plugin is nothing. So plugins is the heart of Jenkins for you to connect, or in order to connect Jenkins with any of the containers or any of the other sets of tools, you will need the plugins. Now, if you want to connect or you want to build a repository which has got Java and Melvin, you will need to install Maven and GTK on an instance. Now, if at all you're looking for a Microsoft build, you will need to have MS Build installed on your Jenkins instance, and the plugins that will be triggered MS Build. If at all you want to listen to some server-side webhooks, From GitHub, you will need a GitHub specific plugins. You want to connect to Jenkins, to AWS, you need those plugins. Now, if you want to connect Docker instance that is running anywhere in the world, as long as you have the URL, which is publicly reachable, you just have a Docker plugin that is installed on your Jenkins instance. So if you want to connect to a Docker instance that is running anywhere in the world, as long as you have the URL which is publicly reachable, you just have a plugin that is installed on your Jenkins instance. Now, SonarQube is one of the popular statistic code analysis, so you can connect a Jenkins build. You can build a jobs on Jenkins and push it to a SonarQube and get SonarQube to run analysis on that and get back the result in Jenkins. Now, all of these works very well because of the plugins. Now with that, let me connect our Jenkins instance to a GitHub. So now let us connect our Jenkins instance to a GitHub. Now I already have a very simple Java repository up on my GitHub instance. So let me connect Jenkins to this particular GitHub instance and pull out a job that is put up there. Right. So this is a very, very simple and repository is called Hello Java. And this is what is there in the repository. This is a simple class file. It's just got some one line of system .out. So this is already present on github.com at this place, and this will be the URL for this repository. So I will pick it up. So what I'll do is I will connect my Jenkins instance to go to my GitHub and provide my credential and pull out this repository, which is on the cloud hosted in the github.com, and get it to my Jenkins instance and then build this particular Java file. Now I'm keeping the source code very, very simple. It is just a Java file. Now, how do I build my Java file? How do I compile my Java file? I just say java.c and name. Now, the name of my class file is Hello Java. And how do I run my Java file? I will say Java and hello. Okay. So remember, I don't need to install any plugins now because what it all needs is a Git plugin. So Git plugin, which is already installed on this system. So let us go back, create a new items. We'll create a first job here. Let's say this is a Git first project. Now let it be a freestyle. Okay. Now we'll go to the source code management. Remember, right? We always have been keeping it on none. So in this part, we'll put it as Git. Now, as you remember earlier in examples, we do not use any source code because we were just putting up some echo kind of jobs that did not need any integration with any of the source code system. So now let us connect this. So I'm going to put up my source code and it will show up because the plugin is already there. Now I've already copied the HTTP address from the GitHub and simply paste it here. Now what is the credential? So I'll simply add that. If you add credential this time, so I'll just click and cancel. So if it just add Jenkins, so we'll add a username here. Now, if there are any errors in terms of not able to Jenkins to be able to find the Git or the git.exe, or if the credentials are wrong somewhere down here, so you'll see a red message, okay? Like something is not right. So for now, it's okay. Now I'm going to build trigger. Now, what will be there as a part of my build step? Because this repository just have the Java file correct, Hello Java. So in order for me to build this, I will say execute window bash command, and I'll say Java, hello, Java, Java. Now let's save this. Okay, so let me try to run this. Okay, build now. Click on this. Console output. Great. Now, as you can see here, there's a lot of executed Git on the behalf. It goes on there to provide my credentials, and so it pull out my repository and my default. Now we'll pull up the master branch. This is there on the post string, and the kind of builds this whole thing on Java C hello world. Finish, and it's given me a success. So it's kind of build this whole thing Java C hello to Java, and it runs this Java hello world. And there, as you can see, this is the output. It's there, and here you can see if you want to look at the content that was created on the repository. Now, if you can go there into my workspace, like I've showed earlier, you can just simply click here, and you can already see here it's been created Git first project, and it's saying hello. Now, as you can see, it's already there. Now, if you can go back, as you can see, and simply close that. Now, what it did was Jenkins on your behalf went over all the way to GitHub, pulled this repository from there, and then it brought it down to your local system on my Jenkins instance. Now it's compiled it and it ran this particular application. Now that I've integrated Jenkins successfully with Git, simply within the Java application,
Now let's start with the Docker use case. Imagine that you're working in a fast-paced IT department where issues keep popping up, asserts go untracked, and changes need approval. That is where IBM Control Desk comes in. It streamlines IT service management by centralizing incident, problem, and asset management into one easy-to-use platform. And it helps in solving problems faster with automation and intelligent workflows to improve service quality and keep things running. Let me tell you all what is IBM Control Desk. IBM Control Desk is an IT service management tool that helps manage and also support users and IT infrastructure. It builds on IBM Maximo Asset Management, a platform originally designed for managing physical and IT assets. Did you all know that even IBM faced challenges? IBM Control Desk, while a robust IT service management solution, faced several challenges in traditional environments. The deployment process was often complex, requiring extensive configuration and manual efforts that prolonged setup times. Its architecture was resource-intensive, leading to inefficiencies and also higher operational costs. Scalability was another significant hurdle, as adapting to increasing workloads required to major architectural adjustments, limiting its responsiveness to business needs. Additionally, maintenance and upgrade process were frequently causing downtime and increasing operational overhead. And also, the traditional on-premises setup was lagged and flexibility of modern cloud-based solutions, making integration with other tools more difficult and highlighting the need for a more modernized approach, such as containerization to improve performance, scalability, and ease of management. Imagine managing thousands of IT assets and services without scalable infrastructure. This is where the IBM Control Desk was before Docker. So, let's ever think why Docker was introduced into IBM Control Desk. In the IBM Control Desk case study, Docker was introduced to address the challenges associated with managing traditional IT service management applications. IBM Control Desk, a complex and resource-intensive platform, often faced issues with scalability, high resource consumption, and complex deployment process in traditional environments. Docker helped overcome these challenges by containerizing the application components, allowing for more efficient resource use, easier scaling, and simplified deployments. By using Docker, IBM Control Desk could quickly adapt to changes, reduce operational overhead, and also improve performance, aligning with modern DevOps and cloud-native practices. Here is a simplified explanation of the setup described, where a single VM on Red Hat Linux with 2 CPUs and 4 GB RAM hosts both the IBM Control Desk and the DB2 database. Application files are shared via NFS, that is making them accessible to Docker for container deployments. Here comes another step, that is building Docker images. They decided to strictly follow what is stated in the Maximo Asset Management. That is, Maximo Asset Management is a comprehensive software solution developed by IBM that helps organizations manage their assets effectively throughout their lifecycle. That is, it is a part of an IBM Watson IoT, that is Internet of Things, platform, and it's widely used in industries such as manufacturing, utilities, and also transportation and facilities management. A team built a Docker image for IBM Control Desk, like generating the WAR files and also for the UI. Using Docker files, server.xml, and also jvm.options, they built images for various applications including UI, cron, MEA, BROS, and also API. Since JMS wasn't provided, they created it from scratch. Based on the WebSphere Liberty docs, the service portal image built from the Node.js included certificates for secure communication. Next is that they deployed containers. Containers were deployed on an Ubuntu machine with 4 CPUs and 32 GB RAM. Each application had a container connected to a Docker network for inter-container communication. Docker Compose managed all resources using dockercompose.yml for configuration, including environment variables and host settings. The streamlined approach enhanced scalability, simplified management, and improved integration for IBM Control Desks. Let me tell you what Docker brought in change. Docker transformed IBM Control Desk by enabling containerization, improving resource efficiency and scalability. It simplified deployment, reduced downtime, and made updates easier through the component isolation. This enhanced system flexibility, reliability, and overall performance, making IBM Control Desk more agile and responsive. So, here is a condensed version of 4 points. First is the efficient containerization. Docker improved IBM Control Desk's resource efficiency and scalability by containerizing its components. They also streamlined deployment, enabled faster setup with fewer errors and reduced downtime. Easier maintenance too. Docker isolated components which made updates and maintenance more manageable and flexible. Enhanced agility work. Docker was also an enhanced agility that made approach for IBM Control Desk more agile and responsive to business needs, optimizing operations. Now let's see the overall solution bot. Involving Docker in IBM Control Desk brought a comprehensive solution by containerizing its application components, which improved resource utilization and scalability. This approach allowed faster and more consistent deployments, reducing setup errors and minimizing downtime. Docker also enabled seamless updates and maintenance by isolating different components, enhancing the system's flexibility and reliability. Furthermore, the streamlined modular architecture simplified operations, reduced operational cost, and increased responsiveness, ultimately transforming IBM Control Desk into a more efficient and agile IT service management platform. Let's see the key benefits brought. First is enhanced scalability. Containerization optimized resource and also simplified scaling as demand grew. Efficient deployment. Docker streamlined deployment, reducing errors and downtime for a more reliable setup. Simplified maintenance. Isolated components enabled easy updates, boosting flexibility and reliability. Last is the cost-effective operations. The modular setup cut costs and also improved responsiveness, making IBM Control Desk more agile. The result brought by this use case was, this article showed a case study using container technology to leverage the native support of WebSphere Liberty profile with the IBM Control Desk product. So, they found that they have more traditional product to container to evolve it toward a cloud-native-like architecture without any need of touch the code. That is, there were also no impact on the application level. This case study showed how container technology was used to transform IBM Control Desk into cloud-native-like architecture without changing the application code. Despite being a traditional product not originally designed by the microservices, containers allowed the IBM to modularize its components, mimicking microservices and improving scalability and flexibility. The process involved identifying dependent modules, that is by updating build scripts, deploying each module in its own container, setting up communication between them, and testing the setup. This approach shows that even traditional application can be modernized with containers, making deployment easier and more efficient. Now let's see why Docker is so necessary. First, Docker is portable. That is, they run app consistently across any environment. Second, they are lightweight. Containers use fewer resources than VMs, that is the virtual machines. Then their efficiency, faster setup times and better resource utilization. Next comes the scalability. Easily scale apps using container orchestration. Then is the consistency. Same behavior from development to production. DevOps integration has streamlined CI/CD pipelines. Next is the isolation. Securely run multiple applications on the same host. Last is the simplified dependency management. That is, package all dependencies in one container. Now, let's see the prerequisite to learn Docker. Docker simplifies creating consistent environments across workflows. But to fully harness its power, you'll first need a solid grasp on Linux, command line tools, and also the containerization basics. The three main programming languages needed are Python, JavaScript, and Golang. And the additional prerequisites needed are version control, that is, understanding Git or another version control system can be beneficial for managing code changes in Docker projects. Then is the networking concepts. A basic understanding of networking concepts like IP address, ports, and networking protocols can be helpful for configuring Docker networks. Last is the operating system. Familiarity with command line interfaces like CLI and basic system administration concepts. Next, let's see what is a container. A container technology was launched in 2013 as an open source Docker engine. It leveraged existing computing concepts around containers and specifically in the Linux world. Primitives known as C groups and also namespaces, Docker's technology is unique because it focuses on the requirements of developers and systems operators to separate application dependencies from infrastructure. A container is a lightweight, isolated unit that packages an application and its dependencies. It also ensures it runs consistently across different environments. Now let's see why Docker uses containers. Docker uses containers for its portability as it runs the same anywhere. Then for its efficiency that uses fewer resources than virtual machines. Then comes the scalability, where it can easily scale applications. Last is its consistency, that ensures the app behaves the same in all environments. Now, let's see what is Docker. A Docker is a platform that enables developers to design, develop, and deploy testing to manage applications in isolated, portable environments known as containers. Containers allow you to package an application and all its dependencies like libraries, configurations, etc. into a single unit, ensuring that app runs consistently across different environments. Next, coming to the benefits of Docker. The benefits of Docker are consistency, which runs applications the same way across development, testing, and production. Efficiency, Docker containers use fewer resources than VMs. They also run faster to start and also use less memory and storage. Scalability, Docker is commonly used in cloud environments and microservices architecture, making it easy to scale applications horizontally. Simplified CI/CD, Docker helps automate and streamline continuous integration and continuous deployment pipelines. We will look at the virtual machines versus containers and their differences. The architecture of the virtual machines is that VMs run on a full operating system on a hypervisor, and containers share the host OS kernel but isolate applications. The resource usage of the VMs are heavy, requiring more CPU, memory, and storage as they run separate OS instances. But containers are lightweight and efficient since they share the host OS. The start time of the VMs take minutes to boot, but the containers start in seconds. The portability of VMs are less portable, tied to OS and hypervisor. Containers are highly portable and run consistently across different environments. The performance of VMs have more overhead due to virtualizations, but containers offer near-native performance with minimal overhead. The use cases of the VMs are full isolation, legacy apps, and heavy resource needs. But in containers, we have fast scaling, microservices, cloud-native apps. Containers are ideal for lightweight, scalable deployments, while VMs are better for complete isolation and resource-heavy applications. Moving on to Docker components. The core components of Docker are: first is the Docker engine. This is the heart of a Docker, responsible for building, running, and managing Docker containers. It's available for Windows, Mac OS, and Linux. Docker images. These are the blueprints of containers containing the application code, libraries, and dependencies required to run the application. Last comes the Docker containers. Instances created from Docker images. They are lightweight, isolated environments where applications run. Now let's learn the architecture of Docker. Docker follows a client-server architecture that allows applications to be packed into containers. It consists of several key components working together to manage, build, and run containers efficiently. Here is an overview of Docker's architecture. First, let's learn about the Docker client. A Docker client is a primary interface for users to interact with Docker. Users issue commands like Docker build, Docker run, and Docker pull, while the client translates into API calls that are sent to the Docker daemon. The client can communicate with either the local Docker daemon or the remote one. The key role of a Docker client is they send commands to the Docker daemon using the REST API. Next, let's see about the Docker daemon, or it's also known as the Docker engine. The Docker daemon is the core service running in the background on the host system that manages Docker objects like containers, images, networks, and volumes. The daemon listens to API requests from the client and also handles all the container management tasks such as creating, starting, and stopping containers. It is responsible for executing the container lifecycle, including pulling images, building containers, and ensuring their isolation. The key role for the Docker daemon are: it executes commands, managing containers, images, and networks. Next is a Docker image. A Docker image is a read-only template that contains instructions for creating a Docker container. Images include everything needed to run an application, like code, libraries, environment variables, and configuration. The key role of a Docker image is that they are blueprint for creating containers. Docker container. A container is a runnable instance of a Docker image. Containers are lightweight and isolated, but they share the host OS kernels, making them efficient compared to virtual machines. The key role of a Docker container is that they are lightweight, portable, and isolated instance of an application. Next comes the Docker registries, that is a Docker hub. Docker registries are repositories that store Docker image. The most common registry is the Docker hub, a public registry maintained by Docker. Developers can push their custom images to a registry or pull pre-built images for use of their projects. Registries can be public or private, allowing organizations to manage and store their proprietary container images securely. The key role of a Docker registry is that they store and distribute Docker images. Moving on to the Docker Engine REST API. Docker's Engine API allows programmatic interaction with the server Docker daemon. The API can be accessed over HTTP, enabling developers and servers to manage Docker programmatically. All the communication between the Docker client and the daemon happens via the API. The key role of a Docker Engine REST API is that they enable automation and remote management of Docker through the REST interface. Docker Volume. Volumes allow data to persist beyond the lifecycle of a container, providing a way to store and share data between containers or with the host system. They are commonly used to store the database files or other data that are needed to persist even if the container is destroyed or recreated. The key role of a Docker volume is they have the persistent storage for containers. Last comes a Docker network. A network is a group of two or more devices that can communicate with each other either physically or virtually. A Docker network is a virtual network created by Docker to enable communication between Docker containers. If two containers are running on the same host, they can communicate with each other without the need of ports to be exposed to the host machine. They may use the Docker to manage Docker host in any platform manner, regardless to whether they run Windows, Linux, or the combination of two. The key role of a Docker network is to manage communication between containers and external networks. Now let's see the development workflows of Docker. Docker enhances development workflows through, first is a containerization, having packages, application, and dependencies into lightweight, portable containers, ensuring consistency environments across development, testing, and production. Next is the local development. Enables developers to replicate production environment locally, speeding up testing and debugging. Next comes the continuous integration or the continuous deployment, which integrates with CI/CD pipelines for automated build, test, and deployment process. Last is the version control. Supports versioning of images, allowing easy rollback and management of application versions. Now we'll see how to install Docker on our Ubuntu machine. Now let's start with installing Docker on our Ubuntu machine first. Now in order to install Docker on Ubuntu, there are some prerequisites. I would advise you to go to Docker's Install Docker Engine on Ubuntu. Click on the first link that you can see, Install Docker Engine on Ubuntu. Here you can see the documentation and check for all the prerequisites that are specified there. Once you're done with the verification, you can move ahead with the installation process. We'll be using the following: install using the apt repository process to install Docker on our Ubuntu machine. First, open the terminal on your Ubuntu machine. Now let's set up the Docker's apt repository. To do that, first we need to add the Docker's official GPG key. We begin by running a simple apt get update to refresh the package lists. So let's type sudo apt get update. This will refresh all the package list that is needed. Be patient until the packages are getting refreshed. So next we'll install CA certificates and curl on our machine. For that, let's copy and paste the command on our terminal. So as you can see that it's getting installed, type S to continue the installation. CA certificates in our command is a digital certificate that ensures your machine can communicate securely over the internet by verifying the authenticity of websites. The curl is a tool used for transferring data with URLs, allowing us to download files from the internet, such as Docker's GPG key. So now let's move to the next command, that is, we'll be creating the directory for storing the key rings. So for that, let's copy and paste the next command to the terminal. Now let's also add Docker's GPG key to it. We'll download Docker's official GPG key using the following command. Now let's also type the command to ensure that the GPG key can be read by the system. So we'll copy and paste from our documentary and paste it on our terminal. Next, let's add the Docker's repository to apt sources. So for that, we'll add the Docker's repository as the apt sources, and this step will allow Ubuntu to know where to find Docker's packages. So the command we just ran adds the Docker's repository to our apt sources list. This command will specify that the architecture of our machine to ensure compatibility. This part will extract the code name of our Ubuntu release, making sure we download the correct version of the Docker. Now, let's also update the package list again. Now that we have added the Docker's repository, we'll run another apt get update command to refresh the list of available packages from this new source. So as you can see, the reading package list is done. Now we'll install Docker by running the command below. This installs Docker Engine, Docker CLI, and the essential Docker tools on your system. Enter S to continue the installation. So be patient until the Docker's installation is getting installed. In our Docker installation command, we have Docker CE, that means Docker Community Edition, the main Docker engine. And the Docker CLI means the command line interface for Docker. Container.io is the core container runtime for Docker. And the Docker BuildX plugin is a plugin for building Docker images. Docker Compose plugin is a plugin to manage multi-container application. So let's be patient until all the packages in the Docker is getting installed. Finally, we can verify whether Docker was successfully installed by running the Hello World image. So let's type sudo docker run hello world. This command pulls a test image from Docker Hub, runs it inside a container, and displays a confirmation message. If the installation was successful, you should see the Hello from Docker message, indicating everything is working perfectly. There you have it. We have successfully installed Docker on our Ubuntu machine and verified it with the Hello World image. Let's clear the screen. Now that we have successfully installed Docker, let's clear our terminal and explore what happens when we simply type Docker. When you run this command, you will see a list of all available Docker commands. This list is incredibly useful when you're unsure about which command to use. There's also a brief description next to each command that will help you understand its purpose. Now let's go over some of the common commands. First is run. It creates and runs a new container from an image. This is one of the most frequently used commands in Docker. It allows you to run a container based on an image, which can be pulled from a registry or built locally. Next is the execute command. It allows you to execute a command in a running container. This is useful when you need to interact with a running container, such as opening a shell inside it. The ps command, that is the list containers. This command shows you all the containers that are currently running or that have been stopped. Next is the build. This command allows you to create a Docker image from a Docker file, defining the environment and dependencies of your containerized application. Next is pull. It allows you to download an image from a registry. Use this command to pull images from a Docker registry like Docker Hub. Push. It uploads an image to the registry. If you want to share your image with others, you can push it to a public or private registry too. Images. Images are the list of images. This command shows all the Docker images that are available on your local machine. Login. Authenticate to a registry. Use this when you need to log into a Docker registry, for example Docker Hub, to pull or push images. Logout. This allows you to log out from a registry. This logs you out from the Docker registry too. Search. Search Docker Hub for images. This allows you to search Docker Hub for pre-built images based on your requirements. Next is a version. Show the Docker version information. It provides details about the version of the Docker you're running. Last is the info. It will display system-wide information. This command gives you detailed information about your Docker installation, including how many containers and images are present, your storage driver, and other system-wide stats. Let's start by checking the Docker version. If you're not familiar with the version you're running, you can simply use this command, that is the Docker version. When you're running this command, it displays the current version of the Docker on your system. In case it shows a version 27.3.1, which is the latest version. Similarly, we can check more detailed system-wide information using the info command. So let's type sudo docker info. This info command provides extensive details about your Docker setup, including the number of containers, images, and other resources being used by Docker on your system. So as we progress through this tutorial, we'll dive deeper into many of these commands and understand how to use them in real-world scenarios. Now, moving forward, we'll build a Docker image using Dockerfile and run that image on your local host as a container on your system. And we'll also open a web browser to see our web page hosted after running the container. So the first step is to create a directory for our project. We'll use the following command, that is mk directory my app. This creates a directory named my app. So here you can see that my app is seen. Next, we'll move into this directory using the cd my app. Now we'll create a file named index.html. So for that, we'll type the command, that is touchindex.html. Once the file is created, we'll open it using the nano editor and write the content into the file. So I will be typing here, subscribe to Edureka. Then press Ctrl+X followed by Y to save and press enter to confirm the file name as index.html. To verify the content inside index.html, we will use the command, that is cat index.html. So here you can see that subscribe to Edureka is also visible. Our next step is to create a file named Dockerfile. For that, we need to type the command as touch Dockerfile. Then type ls to see. So here you can see that our Dockerfile in index.html is visible. After creating the Dockerfile, we'll open it in the nano editor and write some instructions into it. So let's type from Nginx. So Nginx is an open source web server that is widely used for serving static content, load balancing, and also acting as a reverse proxy. In this case, we are using it to serve our index.html file. Next, let's type copy index.html /user share nginx/html. So the copy instruction will allow you to copy our index.html file from the current directory into the HTML directory, which is the default directory where Nginx serves its web pages. If your index.html file is in a different folder, you will need to specify the correct file path in the Docker file. The Docker file is essentially a text file with set of instructions that Docker uses to build an image. So by typing cat Dockerfile, you can see the content that we have written in the nano editor. So next, we'll need to make sure that the Docker is running. If Docker is not running, you can start it with the following command, that is sudo service docker start. If needed, you can also stop the Docker by typing sudo service docker stop. So press Q to exit the status display. As we have stopped the Docker, let's start the Docker again. So let's type the command as sudo service docker start. We can also see the status by writing the command sudo service docker status. So here you can see that a Docker is active and it is running. Now let's proceed to build our Docker image. We'll use the docker build command, that is docker build -t my app. Let's write the command for the build, that is docker build -t my app and a dot. Docker build is a command that builds a Docker image based on the instruction provided in the Docker file. And the T flag is used to tag the image with a name. In this case, it is my app. This makes it easier for reference later. And the dot after my app refers to the current directory, in which the Docker file is located. So by running the build command, we can see that the error is occurred. So the error shows that the permission denied while trying to connect to the Docker daemon. It means that we need to connect as a super user. So let's type the command as sudo su and then write the command for build. So now you can see that my Docker is getting built. Be patient because it might take time. Now that we've successfully built our image, now it's time to run the Docker. Now let's type the command, that is docker run -d -p 6969:80 my app. -d flag runs the container in detached mode, meaning it runs in the background. And the p flag is used to map ports. In this case, we are mapping port 6969 on a local machine to port 80 inside the container, which is the default HTTP port for Nginx. This command essentially starts a container from my app image, allowing us to access our web page on the local host via port 6969. Now to check the container is running, we use the docker ps command. This will list all the running containers and you should see the my app container running. Finally, to see what we have hosted on the container, Open a web browser. Here we'll use Firefox. So on the search bar, let's type localhost 6969. So when you visit to this URL, you should see subscribe to Edureka displayed on the web page, confirming that our Docker container is serving the content successfully. Now, going back to our terminal. Now that we have successfully built and run our Docker image locally, let's move ahead and push this image to Docker Hub, where it will be publicly accessible and stored privately in your Docker Hub account. If you don't have a Docker Hub account yet, go to hub.docker.com to create one. It's a simple sign-up process. Once you have created your account, we can proceed with logging into Docker Hub from the Docker CLI. Now, to push our image to Docker Hub, we first need to log in to Docker from the terminal. We can do that using the docker login command. So let's type docker login -u and give our username -p with our password. The U flag is specified for username and the P flag is specified for the password. So once you're logged in successfully, the Docker will display a message confirming the login. Before pushing the image to Docker Hub, we need to tag our local image with a name that includes our Docker Hub username. This ensures that a Docker Hub knows which repository the image belongs to. For that, let's type the command that is docker tag my app, the username, my app : and then the version tag. Here my app : latest is the name and the version tag for the image. We are tagging this image as latest to indicate it's the most recent version. Now we can push our Docker image to Docker Hub using the docker push command. So let's type docker push with the username and the version tag again. This will upload the my app image to your Docker Hub repository. Docker will display the progress as it pushes the image layers. And once it's complete, you will see the confirmation message. So let's be patient unless the image is pushed. So here you can see a confirmation message telling that it is pushed. So after you have pushed the image to the Docker Hub, you can log out of your Docker Hub account from the CLI using the docker logout command. For that, let's type docker logout. This is useful when working on the shared machines or environments where you don't want your credentials to remain stored. To verify that our image is now available on Docker Hub, we can use the docker search command. This command allows you to search the Docker Hub for images. So for that, let's type the command as docker search, username, and my app. So here you can see all the images that we have published. So once the image is on the Docker Hub, we can pull it to any other machine or even to a current machine to ensure that it works as expected. The docker pull command allows us to download the image from the Docker Hub. So let's type the command as docker pull with our username and the image name with the version tag. This command will download the image layers from the Docker Hub to your local machine. So here you can see that our image is pulled successfully. After pulling the image, you can run it on your local machine, just like we did earlier using the docker run command. So now we can open our web browser and visit, typing the localhost 6969. You should see the same, that is subscribe to Edureka page, confirming that we have successfully pulled and run the Docker image from the Docker Hub. And that's it. You have successfully learned how to push an image to Docker Hub. Search for it, pull it, and run it on your local machine. Now that we have learned how to work with individual containers in Docker, let's introduce Docker Compose. Docker Compose is an essential tool when you're working with multi-container applications. Instead of managing each container individually, Docker Compose lets you define and manage all the services your application needs in a single YAML file called the dockercompose.yml. So here we have the command to install Docker Compose. The option -L makes the curl follow, redirects, ensures that it reaches the final download URL. And the uname-s part dynamically inserts the operating system name, such as Linux or Windows. And the uname -m inserts the system architecture, that is whether it is 64-bit or 32-bit. This ensures the correct version is downloaded for your system. The Docker Compose option specifies the output location where the Docker Compose binary will be saved. In this case, it is user local bin Docker Compose. Once the binary is downloaded, apply executable permissions, that is sudo chmod +x command. To verify that Docker Compose has been installed correctly, let's check the version. So let's type the command as Docker Compose version. So here you can see that the Docker Compose version is v2.29.7. That is the latest version. Now that we have installed Docker Compose, let's create a simple Docker Compose file. This file will define two services, a web server having an image of Nginx and a database that is Redis. So first, we'll create a new directory named Docker Compose file. So let's write the command for it, mkdir Docker Compose file. Then we'll go inside the directory. So type cd Docker Compose file. Inside this directory, we'll create a new file named dockercompose.yml using the touch command. So let's type touch dockercompose.yml. Next, we'll open this file with a nano editor and add the following content. So let's type services, web that uses the Nginx image, and the other file is the database which uses the Redis image. We'll save the file by pressing Ctrl+X, then Y to confirm and save, finally enter to confirm the file name. Before we run the file, let's check if it's valid using Docker Compose config command. This command checks the syntax error or misconfigurations in the YAML file. So let's type the command Docker Compose config. If the file is valid, you will see the content printed out. Now we are ready to run our services. To start both Nginx and Redis containers, we'll use the Docker Compose up command. We'll run it in the detached mode so the containers run in the background. So let's type Docker Compose up -d. So once the containers are up, we can verify by listing the running containers using the docker ps command. You will see two containers running, Nginx and Redis, which were defined in our dockercompose.yml file. Now to stop and remove the containers, we can use the Docker Compose down command. This command will bring down all the services defined in our Docker Compose file. So let's type Docker Compose down. Now let's modify our Docker Compose YAML file to expose a port for Nginx service so we can access it from our browser. So open the file again with nano. We'll add the following lines under the web service to map ports 8080 on our local machine to port 80 in the container. After making this change, let's validate the file again by typing Docker Compose config. If the file is valid, we can now run it again using the Docker Compose up command. If the file is valid, we can now run it again using the Docker Compose up command. Since the Nginx and Redis images are already downloaded, it will skip downloading and simply start the containers. Now let's go to the browser and type localhost 8080. So you will see a default Nginx welcome page confirming that our container is running and accessible on the port 8080. Once you're done, you can bring down the containers again using Docker Compose down command. Docker Compose comes with several useful commands. To see a list of available commands, we can use the help command. So let's type Docker Compose --help. You will see a list of commands like up, down, config, ps, and many more. These commands allow you to manage your Docker Compose services easily. So, that's a quick introduction to Docker Compose. We have seen how to install Docker Compose, create and validate a Docker Compose.yml file, run multiple containers with a single command, map ports for service access, bring containers down when they are no longer needed.
Now, before listing down a few features of Jenkins, let me tell you some fun facts about Jenkins. Currently, there are over 24,000 companies which use Jenkins. To name a few, there is Google, Tesla, Facebook, and Netflix. Now, there has to be a reason why such reputed and successful companies make use of Jenkins. Now, let's discuss a few key features and see why Jenkins is so important. All right. Now, the first feature is that it is an open source, freely available tool which is very easy to use. It has various features like the build pipeline plugin, which lets you graphically visualize the output. And apart from that, there is also a feature known as user input, which lets you interact with Jenkins. All right. Now, one major feature of Jenkins is that it implements continuous integration. Now, what is continuous integration? Every time a developer commits into a source control management, that commit is continuously pulled, built, and tested using Jenkins. Now, how does Jenkins do all of this? Now, Jenkins has over 2000 plugins which allow it to integrate with other tools like Docker, Git, Selenium, etc. So by integrating with other tools, it makes sure that the software development process is fully automated. All right. So it is also an automation server which makes sure that the software delivery cycle is fully automated. Now let's see how Jenkins works. So here you can see there is a group of developers committing their code into the source code repository. Now every time a developer makes a commit, it is stored in the source code repository. Now what Jenkins does is, every time a commit is made into the source code repository, Jenkins will pull that commit, build it, test it, and deploy it by using plugins and other tools. All right. Now, not only is it used for continuous integration, it can also be used for continuous delivery and continuous deployment with the help of plugins. So by integrating with other tools, the application can be deployed to a testing environment where user acceptance tests and load testing is performed to check if the application is production ready. And this process is basically continuous delivery. Now, it can also make use of plugins to continuously deploy the applications to a live server. So here we saw how Jenkins can be used for continuous integration, continuous delivery, and continuous deployment by integrating with other tools. All right. Now let's move on to what is Docker. Now, before we discuss about Docker, let's compare virtualization and containerization. Now, the goal of virtualization and containerization is to solve the problem of the code works on my machine, but it does not work on the production. Now, this problem happens because somewhere along the line, you might be on a different operating system. Now, let's say your machine is a Windows machine and you're pushing the code to a Linux server. Now, this will usually result in an error because the Windows and Linux support different libraries and packages. And that's why your code works on the development server and not on the production server. All right. Now, when it comes to virtualization, every application is run on a virtual machine. Now, a virtual machine will basically let you import a guest operating system on top of your host operating system. Now, this way you can run different applications on the same machine. All right. Now, you're wondering what is the problem with virtualization? Now, one major drawback of virtualization is that running multiple virtual machines on the same host operating system will degrade the performance of the system. Now, this is because the guest operating system running on top of your host operating system will have its own set of kernel and set of libraries and dependencies, which take up a lot of resources like the hard disk, processor, and RAM. And another drawback is that it takes time to boot up, which is very critical when it comes to a real-time application. All right. Now, to get rid of these drawbacks, containerization was introduced. Now, in containerization, there is no guest operating system. So instead, the application will utilize the host operating system itself. So basically, every container is going to share the host operating system, and each container will have its own application and application-specific libraries and packages. All right. So within a container, there's going to be an application and the application-specific dependencies. I hope this is clear, guys. Now that we've discussed containerization, let's see how Docker uses containerization. Now, Docker is basically a containerization platform which runs applications within different Docker containers. So over here, you can see that there is a host operating system on top of which there is a Docker engine. Now, this Docker engine will basically run container number 1 and container number 2. Now, within these two containers are different applications along with their dependencies. All right. So basically, within a container, every application is going to have its own dependencies installed. So it does not have to bother any other container. Okay. So basically, there is process level isolation that happens here. All right. Now, there are three important terminologies to remember when it comes to Docker. Now, the first is the Docker file. Now the Docker file basically contains the code which defines the application dependencies and requirements. All right. And through the Docker file, you're going to produce the Docker image which contains all the dependencies, such as the libraries and the packages of the application. Next is the Docker container. Now every time a Docker image is executed, it runs as a Docker container. So basically, Docker container is a runtime instance of a Docker image. So now let's look at a Docker use case. Now over here, you can see that I've created a Docker file. Now within the Docker file, I've basically defined the dependencies of the application. Now out of this Docker file, a Docker image is created. So basically the libraries and the packages that the application needs is installed within the Docker image. Now every time the Docker image is run, it runs as a Docker container. Now these Docker images are pushed into a repository known as Docker Hub. Now this repository is very similar to the Git repository, wherein you are committing code into the Git repository. In this case, you're going to commit Docker images into the Docker Hub repository. All right. Now you can either have a private or public repository depending on your requirements. Now after the image is published to Docker Hub, the production team or the testing team can pull the Docker images on their respective servers and then build as many containers as they want. All right. Now this ensures that a consistent environment is used throughout the software development cycle. Now let's look at what are microservices. Now guys, I'm going to explain what microservices is because we need to deploy a microservice based application in our demo. Just to take it up a notch, I've implemented microservices. Now first, let's look at the monolithic architecture. Now over here, let me explain this with a small example. Now on the screen, you can see that there is an online shopping application which has 3 services: customer service, product service, and cart service. Now these services are defined within the application as a single instance. So when I say single instance, it means that these 3 servers will share the same resources and databases, which make them dependent on each other. Now, if they share resources, obviously they're dependent on each other, right? Now, you must be wondering what's wrong in this architecture. Now, let's say that the product service stops working because of some problem. Now, because the services are dependent on each other, the customer and the cart service will also stop functioning. So basically, if one service goes down, the entire application is going to go down. All right. Now, when it comes to a microservice application, the structure of the application is defined in such a way that it forms a collection of smaller services or microservices, and each service has its own database and resources. All right. So basically, customer microservice, product microservice, and cart microservice will have their own database and their own resources. And therefore, they're not going to be dependent on each other. All right. So they are basically independent, autonomous microservices. All right. Now let's look at a few advantages of microservices. Now, the first advantage is independent development. Now, when it comes to a monolithic application, developing the application takes time because each feature has to be built one after the other. So, in the case of the online shopping example, only after developing the customer service, the product service can be started. So, if the customer service takes 2 weeks to build, then you have to wait until customer service is completed, and only then you can start building the product service. All right. But when it comes to a microservice architecture, each service is developed independently. And so you can develop customer service, cart service, and product service parallelly, which will save up a lot of time. All right. Now, the next advantage is independent deployment. Now, similar to independent development, each service in a microservice application can be deployed irrespective of whether the service before it was deployed. So each service can basically deploy individually. Now, fault isolation. Now, when it comes to monolithic application, if one of the services stopped working, then the entire application will shut down. But when it comes to a microservice architecture, the services are isolated from each other. So in case any one service shuts down, there will be no effect on any other service. Now, the next advantage is mixed technology stack. Now, each microservice can be developed on different technology. Now, for example, the customer service can be built on Java, and the product service can be built on Python, and so on. All right. So basically, you're allowed to use mixed technology to build your microservices. Now, next is granular scaling. Now, granular scaling means that every service within an application can be scaled independently. So basically, the services are not dependent on each other. They can be developed, deployed at any point of time, irrespective of whether the previous service is being deployed or not. So guys, I hope you're clear with the advantages. Now over here, we're going to compare how microservices can be deployed by using virtual machines and Docker containers. All right. Now, when it comes to a virtual machine, now let's say that we have a microservice application which has 5 services. Now, in order to deploy these 5 services on a virtual machine, we'll need 5 virtual machines. All right. Now, each virtual machine will be for one microservice. Now, for example, if I allocate 2 GB RAM for each virtual machine, then 5 of these virtual machines will take up 10 GB RAM. And the microservices may not even require so much of resources. So we'll just end up wasting these resources, and at the same time, you're occupying too much disk space, which will degrade the system's performance. Now let's see how Docker containers deploy microservices. So instead of running 5 virtual machines, we can just run 5 Docker containers on one virtual machine. Now by doing this, we're saving up a lot of resources, but when it comes to a Docker container, you don't have to pre-allocate any RAM. The Docker container will just utilize the resources that are needed. And another point to remember here is that Docker containers are lightweighted. They do not require additional guest operating system. Instead, they just share the host operating system. All right, so this makes them very lightweight when compared to a virtual machine. Now let's move on to the use case. Now basically, we're going to try and understand the problem with the help of an analogy. Now over here, you can see that in the favorable environment, the soil is fertile and the tree is watered at a regular basis. And as a result of this, the tree grows properly. But when the tree grows in an unfit environment, where the required dependencies for growing a tree are not present, then the tree will die. All right. Now, similarly, when an application runs on an inconsistent environment, which does not support the application dependencies, then the application will fail. All right, guys, now let's look at the problem statement with a small example. Now, let's say that a developer is building an application using Lambda. Now, after the application is developed, it is sent for testing. Now, this application runs properly on the testing server, but when it is deployed to production, a feature or the entire application fails. Now, this may happen because the Apache version of the Lambda is outdated on the production server. So due to the difference in the software versions on the production and development server, the application fails. Now, in order to get rid of the inconsistent environment problem, we're going to deploy an application using Docker. Now, Docker will make sure that the environment throughout the development cycle is consistent. Now, deploying a monolithic application can cause many problems. Like for example, if one of the features of the application stops working, then the entire application will shut down. So for this reason, we're going to create a microservice-based application and build it on the Jenkins server, and finally use Docker to maintain a consistent environment throughout the cycle. So over here, you can see that there are 4 microservices, and for each microservices, I've built a Docker file. All right. So first, let me discuss what each of these microservices do. Now, the account service and the customer service are the main microservices, whereas the discovery and gateway services are supporting microservices. Now, account service will basically hold the account details of a customer, and similarly, the customer service will have a list of customer details. Now, discovery service, which is a supporting service, will hold details of the services that are running on the application. And apart from that, it will also register every service in the application. Now, what the gateway service does is, on receiving a client request, it will route the client request to the destination service. Now, to be more specific, it will provide the IP address of the destination service. Okay. So now that you know how these microservices work, let's move on to the next part. Now, basically, these microservices are coded and their dependencies are put into a Docker file. Now, for each of these Docker files, a Docker image is created by packing the Docker image with the jar files. Now, how do you create a jar file? A jar file is created by running the mbn clean install command, which basically cleans up anything that was created by the previous builds, and it will run the pom.xml file, which will download the needed dependencies. So whatever dependencies are needed are stored in this jar file. All right. Now, once the Docker file is packaged with the jar file, then a Docker image is created for each of these microservices. So here we're going to use Jenkins to automate all of these processes. So Jenkins is basically automatically going to build and then push these Docker images to Docker Hub. Now, after the images are pushed to Docker Hub, the quality assurance or the production team can pull these images and build as many containers out of it. All right. So basically over here, we're going to create Docker files for each of these microservices, and then we're going to package these Docker files along with the jar files and create a Docker image for each of these microservices. All right. Now, after creating the Docker images, we're going to push these images to Docker Hub, after which the quality assurance or a production team will pull these Docker images onto their respective servers and build as many containers as they want. I hope this is clear. So now let's practically implement all of this. Alright guys, so I've logged into Jenkins and I've created 4 different jobs, each for one microservice. Alright, now let me just show you the configuration of one of these jobs. Now let's go to account service. Let's go to configure. So guys, make sure that you enter your GitHub repository here. So go to source code management, click on Git and then enter your repository URL over here. Now let me just show you what we're doing here. Now within the build step, I've selected execute shell. Now let me just show you how that's done. So it's simple, just go to add build step and click on execute shell. So when you click on execute shell, a command prompt will open like this and you can type this code on that. Now what I'm doing here is first I'm changing the directory to account services because I'm running the account service within this job. After that, I'm performing an MV and clean install, which I explained earlier. Now once we're done with that, we're going to build a Docker image and then we're going to push it to your Docker Hub account. Now these are the credentials to my Docker Hub account, where Zulekha is the username of my Docker Hub account and Edureka-demo is a repository that I've created in my Docker Hub account. Then click on apply and save. Now apart from account services, I've built jobs for the other services as well. Now let me just show you customer service also. Let's go to configure. Now within the source code management, like I said earlier, enter your repository URL. After that, go to the build steps. Over here, you can see that I'm changing the directory to customer service. Then I'll perform MV and clean install. So next I'm going to build Docker images. Now over here, customer is basically the tag of the image. So whenever this image is going to get pushed to my Docker Hub, the tag is going to be customer. All right. Now similarly for account service, the tag was account. Now I've done the same thing for all the other jobs. All right. Click on apply and save. Now guys, in order to run these 4 jobs as one workflow, I've created a build pipeline. Now this pipeline will basically execute these 4 jobs in one workflow. Now if you want to know how to create a build pipeline, please refer the video in my description box. I'm going to leave a link where you can see how to create a build pipeline. All right. Now let me just show you my GitHub account. Now over here you can see that I have account service, customer service, discovery service, gateway service, and also there's Zipkin service. Now guys, this service basically keeps a track of all the other services. So it's going to keep a track of where the requests are going and how the requests are getting sent from account service to customer service. Now within account service, you can see that I have a Docker file, Jenkins file, and a pom.xml file. All right, guys, now let's start building our application. Just click on run. Now here you can see that account service is getting executed. Now let's individually go to account service first. Let's click on account service. All right, here you can see that it's building this job. So basically here what we're going to do is we're going to change the directory to account service. After that, we're going to perform an MV and clean install. And then we're going to build an image and push that image to Docker Hub. All right. So guys, remember to provide your Docker Hub credentials. Now this job has successfully executed. Now after this job has executed, it's going to trigger the next job, which is customer service. Now let's look at the build pipeline. Now over here, this has turned green because account service has completed execution. Now customer service is currently running. So let's look at the build in customer service. So after the account service has completed execution, guys, you can also check the output of account service from here. Scroll down, it says success. Now after account service has finished, let's trigger the customer service. So customer service starts executing now. Now let's individually look at customer service. Now over here, you can see that customer service is building. Now in this job, we're basically going to change the directory to customer service. After that, we're going to perform an MV and clean install command. And then we're going to build and push a Docker image to Docker Hub. All right. So once this is completed, the next job in the pipeline will get executed. Okay. All right, guys. So this is successfully executed. Now you can see that customer service has also turned green, which means that it has successfully finished building. All right. All right, guys. So you can see that customer service has completed execution. Now let's trigger the build of discovery service. Now let's look at the output of discovery service. So guys, you can see the output from here itself. Let's click on console. All right, so within the discovery service again, we're going to change the directory to discovery service. After that, we're going to perform an MV and clean install. And once we're done with that, we're going to build an image and then we're going to push it to Docker Hub. Guys, make sure you have entered your Docker Hub credentials. All right, guys, so this is completed execution. You can see that it says success. Now it's triggering the new build, which is gateway service. So here you can see that gateway service has started execution. Let's look at the console output. All right, so similarly in gateway service, first you're going to change the directory to gateway service. After that, you're going to perform an MV and clean install command. And once you're done with that, you're going to build an image and then push it to Docker Hub. So guys, gateway service has successfully completed execution. Now the build pipeline has fully turned green, which means that the entire workflow has completed execution. Now let's go to our Docker Hub account and see if all these images got pushed to Docker Hub. All right, so I'm going to my Docker Hub. Now let's go to the Edureka demo repository. Now over here, you can see that the account, customer, discovery, and gateway services, all of these 4 images are pushed to Docker Hub. All right. So with this, we've come to the end of the demo. Now, after pushing these images to Docker Hub, any quality assurance team or any testing team can pull these images onto their respective servers so they can easily deploy this to production.
So first of all, let's talk about DevOps. So what is DevOps? Now, as most of you all might know by now, DevOps is basically a methodology. It's a set of practices to ensure faster delivery of software deployment. To stay relevant in the market these days, companies are expected to deploy quality software in defined timelines. Hence, the roles of software developers and system admins, or the dev and the ops team, have become extremely important. And a lot of juggling of responsibilities happen between the two teams. Programmer or a software developer is responsible for developing the software. So basically, he's supposed to develop a software which has new features, new security patches or upgrades, and bug fixes from the previous installment. But a developer may have to wait for several weeks for the product to get deployed, which is also known as time to market in business terms. So this delay may actually put pressure on the developer because he or she is forced to readjust his dependent activities like pending or old code, new features, and products. Also, when the product is put into production environment, the product may or may not exhibit some unforeseen errors. This is because the developer writes code in a certain development environment which might be different from the ones of the product environment. So from the point of view of an ops person or the operations team, who are basically responsible for maintaining and assuring the uptime of production environment, something that has been sent to them to test, which has been confirmed runs, is not running on their systems. When the code is deployed, the operations team is also responsible to handle these minor changes or minor errors on the code. At times, the ops team may feel pressured and it may seem like the developers have pushed their set of responsibilities to the operation side of the responsibility wall. But as we all know, it's all happening due to the inconsistencies in the environment, and no team is actually up to blame. Now, as the company keeps investing more time and money into products and services, the number of servers admins have to take care of also keep growing. And this gives rise to even more challenges because the tools that were used to manage the earlier amount of servers may not be sufficient to cater to the needs of the upcoming and growing number of servers. So we all are in a fix, right? But what if these two teams could work together? They could break down the silos, share responsibilities, erase inconsistencies in the environments, start thinking alike and work as a team. Well, this is exactly what DevOps does. It helps you get software developers and operations teams in sync to improve productivity. And if I pull out an official definition, DevOps is the process of integrating developers and operations team in order to improve collaboration and productivity. And all of this is achieved through automation of workflows and productivity, and basically continuous everything starting from development to delivery to deployment, as well as monitoring of an application. DevOps focuses on automating everything and lets developers write small chunks of code that can be tested, monitored, and deployed in hours, which is different from writing large chunks of codes that takes weeks to test and deploy. Now, that was all about DevOps. Now, let's talk a little bit about DevOps and cloud, or DevOps on cloud. Why do we need DevOps on cloud? Now, understand that DevOps and cloud go hand in hand. They can be implemented individually, of course, but DevOps becomes twice as much efficient and beneficial when clubbed with the cloud. It can help an organization deliver new software features much faster in a more effective manner. Many organizations try to fix their application development processes by shifting from waterfall to DevOps. Now, they have this understanding that DevOps alone won't be that effective. So public and private cloud solutions are now evolving together with DevOps. This brings in products at a faster rate to the market through quick access to development environment and streamlined developer processes. Infrastructure as code and automation together reduces the cloud complexity and maintenance of servers and resources, which our ops team previously was very concerned about. The security also highly increases with automated, repeatable processes that serve to eliminate error that can cause further issues. And even more importantly, it builds security controls from the very beginning to the very end of the process. Now, because you don't have any servers and your continuous operations are cloud-based, it also eliminates a lot of downtime. And last but not the least, scalability, which is one of the most important factors for applications as they are developed. When DevOps and cloud are clubbed together, it reduces the cost of infrastructure and global reach also increases with this. Now that you know why you need a cloud platform, let's go ahead and look at our cloud platform of choice today, which is AWS. So what is AWS? Now, back in the day, handling and storing data was way different than it is now. Companies preferred storing data using private servers, and that was obviously for security reasons. But however, with better usage of the internet, the trend has seen a paradigm shift for industries as they are moving their data to the cloud. Now, this enables companies to focus more on core competencies and stop worrying about storing and computation. For example, back in the day, if a streaming platform or a search engine platform, anything with a high volume database suffered a corruption, it would take days before their operations resumed. They would face problems scaling up, and only then would they realize the need for a highly reliable, horizontally scalable, and distributed system is what they need. But now, with cloud services and public cloud platforms, this wouldn't be a problem. Now, since every company has started to adopt cloud services, it can be claimed that the cloud is the talk of the town, and AWS in particular is the leading cloud service provider in the market. AWS, which stands for Amazon Web Services, is an Amazon.com subsidiary which offers cloud computing services at an extremely affordable rates. Therefore, its customer base is strong and it targets everyone from individuals to startups to tech giants running the IT landscape. If you might wonder what cloud computing is basically the use of remote servers on the internet to store, manage, and process data, as opposed to an actual physical server or a personal computer to do the same. As we are talking about AWS, it is kind of an IaaS or infrastructure as a service, which basically gives you a server in the cloud that you have complete control over. In IaaS, you are responsible for managing everything starting from the OS completely up to the application you are running. So now that we have discussed about DevOps and AWS, let's move on to our CI/CD pipeline. Now, what is a pipeline or CI/CD pipeline? It's nothing but a series of steps that must be performed in order to deliver a new version of the software. At its bare bones, at its most basic, you have your build, test, and deploy stage. The CI/CD basically stands for continuous integration and continuous deployment. So CI is basically continuous integration, which basically means bringing together all the developers' working copies to a shared mainline. All the developers working on parallel branches of a certain upgrade of an application merge their changes into one main branch. And CD stands for continuous delivery and deployment. Now, while the CI includes building and testing of your application, Continuous deployment is about the processes that have to happen after the code is integrated for the app to be delivered to the users. These processes involve testing, staging, and deploying the code. So at the end of this session, what we aim to do is build a CI/CD pipeline for our demo app on AWS. So for that, we will have to look at a few components of AWS. So DevOps, when implemented on AWS, becomes a lot more efficient and effective for a productive life cycle. And the steps that are involved in AWS DevOps are code commit, code pipeline, code build, code deploy, and optionally code start. So first of all, we have AWS Code Commit, which is a fully managed source control service, somewhat like GitHub, that hosts secure and highly scalable Git-based repository without the need of operating the system. It's mainly designed for developers who are supposed to store and version their code securely and reliably. For example, you have your IT administrators that store their scripts and configurations, and your web designers who can store their HTML pages and images, etc. The code commit is fully managed, has great availability, is secure, scalable, and pacens up your development lifecycle. For people not aware of code commit, think of it as versioning in your S3. But how it's different is that S3 supports versioning, but not collaborative file tracking features, which code commit obviously does. It manages batches of changes across numerous files made by multiple developers parallelly. How it works is that you create a repository in AWS Code Commit service via the console or CLI, and later using Git from the development machine, you can run git clone to connect the local repository and the AWS Code Commit repo. You can then modify your files on your development machine via the local repository and then run git add, git commit, and push it to the AWS Code Commit repository as you do with GitHub. Again, like Git, even git pull can be used here to synchronize the files in AWS Code Commit repository with your local repo, which ensures that you're working with the latest version of the files. Next on our list, we have AWS Code Pipeline, which is a combination of continuous integration and continuous delivery services for a quicker and more reliable infrastructure and application updates. It automatically builds, tests, and deploys a user code whenever there is a code change, and it is completely based on user-defined release process models. It also integrates with AWS services like AWS Code Commit, Amazon S3, Code Deploy, Elastic Beanstalk, OpsWorks, and AWS Lambda. You can configure the pipeline either with your CLI or your graphical user interface. And like most services on AWS, even with pipeline, you only have to pay for what you use. All of this is great and all, but why should you use Code Pipeline? Simple. By automating your software build, test, and release processes, AWS Code Pipeline enables you to increase the speed and quality of your software updates by running all new changes through a consistent set of quality checks. It automates your release process, it speeds up your delivery with quality, it allows you to choose your tools of choice, establish consistent release processes, and provide a pipeline history detail as your source of truth. Code Pipeline basically breaks up your workflow into a series of stages like your source, build, test, and deploy, and gives you a revision option as a deployable content. Each stage can process only one revision at a time, even though multiple revisions can be processed in the same pipeline. And each stage will have at least one action to be performed, which is some kind of task performed on the artifact. Once all of the actions that are configured in a stage is complete, the stage is considered as complete. After a stage is complete, it transitions the artifacts created in that stage to the next stage of the pipeline, where you can manually enable or disable it, so it prevents changes from running through an entire pipeline. An approval action is granted only by the IAM user, and if an action fails, it does not transition to the next action or stage at all. So when a developer completes working on his code, he or she commits it to the source repository, and Code Pipeline automatically detects the changes and builds those changes. After that, the build code is deployed to the staging server for testing, and then additional tests such as integration or load tests are run by the Code Pipeline. Once all of the tests are run, if the code receives manual approval, then AWS Code Pipeline deploys the tested and approved code to the production instances. Also, every time when a user creates a pipeline, the code pipeline creates a folder for that pipeline in an S3 artifact bucket in that particular region to store input and output artifacts. Next on our list, we have AWS Code Build. Now, this is a fully managed build service in the cloud, which compiles your source code, runs unit tests, and produces artifacts that are ready to deploy. It eliminates the need to provision, manage, and scale your own build servers. It provides pre-packaged build environments for the most popular programming languages and build tools, and scales automatically to meet your peak build requests. Now, one prerequisite is that you must provide the AWS Code Build with a build project, which should include information as to where to get the source code from, build environment, build commands, and where to store the build output. How it works is that the code build will use the build project to create a build environment. AWS Code Build then downloads the source code from the build environment and performs tasks that you would specify in the build specifications. If there is any build output, the build environment uploads its output to the S3 bucket, and while the build is running, the build environment sends information to Code Build and CloudWatch logs. You can use the Code Build console, AWS CLI, or AWS SDKs to get summarized build information from Code Build and detailed build information from CloudWatch logs as well. Now, that was all about Code Build. Now, finally, let's talk about Code Deploy. Now, AWS Code Deploy is a service that coordinates your application deployment and updates across the fleet of AWS EC2 of any size. It automates your code deployment to any instance, handles the complexity of updating them. It also avoids downtime during application development and rolls back automatically if failure is detected. Apart from that, it also integrates with third-party tools and AWS to make your job easier. It has 6 primary components to be specific. You have application revision, compute platform, deployment group, deployment configuration, and the code deploy agent. Now, the basic skeleton of how your deployment workflow pursues is as you can see on your screen. You basically create an application with a unique name and set up a deployment group by specifying the instances to which you want to deploy your application and the deployment type. If you're using the Lambda platform, you just deploy your deployment group's name, followed by which in your deployment configuration, you specify the success or failure condition of deployment and to how many instances you want to deploy parallelly. Then you upload the application specification file to the S3 and deploy your application as specified with the help of your code deploy agent, which is running on each instance on an EC2 platform, or as specified in your specification file to the deployment group when you're using a Lambda platform. And finally, you check your deployment results. And if you face any bugs or issues, you can always roll back and redeploy. Finally, let's discuss a little bit about CodeStar, which is basically a cloud-based development service that provides tools that you need to quickly develop, build, and deploy applications on AWS. It's basically a very templatized format where you start developing on AWS in certain minutes and you could choose from a variety of project templates. All of the software delivery is easily managed and you can work across your team very securely using the CodeStar. And apart from all of this, you also are provided with a project management dashboard to monitor your application continuously. All you have to do as an AWS CodeStar admin is create a project and add users. Your users or team members will commit changes, which in turn will be built and deployed. And through consistent monitoring of the application, if there are any updates required or any bugs, the developers take a decision, make updates, fix bugs, and then the loop closes back in on the team, and that's about it. The development process takes little to no time using CodeStar. Now that we have spoken about all of these different components of AWS DevOps, I hope building the CI/CD pipeline would seem a tad more tangible to you. If you're new learners, you can always sign up for a free tier, which is free for the entire year. Obviously, there are limitations to all of the services beyond which you shall be charged. but that rarely happens. So if you're starting out with AWS and want to try out all of its features and services, the free tier is a pretty good idea. We already have a video on how to create a free tier on the AWS console. If any of you want to know how to create a free account, you can just go ahead and check that out. So we're going to be building a CI/CD pipeline using AWS, using Code Pipeline. And I'll try to be as slow and verbose as possible, as comprehensive as possible, so as to help you guys to follow me each step of the way. So what we'll be doing here is that we'll be creating a demo application, platform as a service application, and we shall be deploying it using the Code Pipeline. So let's go ahead and create our application first. So to create an app, we will be using the Amazon Elastic Beanstalk, which basically has a bunch of templates ready for you. Now, since this is a demo about Code Pipeline and not web development, we'll be creating a pretty rudimentary app. So let's go ahead and type Elastic Beanstalk. Using Elastic Beanstalk, we can make simple apps very, very quickly. And if you have already created an application, created a few applications, they are going to appear right here on your screen. But since we have created no applications using this particular account, this is a screen that will greet you. So we're going to go ahead and click on Create Application. So let's call this Deployment App. We're not very original, are we? We're not going to put in any application tags. You could put them if you like, but currently they are completely unnecessary. On platform, let's pick PHP. And it automatically fills up the platform branch and version with the latest ones available. Then I'm just going to be using the sample application code and click on Create Application. Now this is a platform as a service app. So basically, once I click on Create Application, I wouldn't have to worry about any background processes or creating the infrastructure. Elastic Beanstalk is going to do that for me on its own. And here it's going to show you all of the steps that are taking place, like create environment is starting, using Elastic Beanstalk as Amazon S3 storage bucket for environment data, so on and so forth. Now this will take some time, so let's go ahead and parallelly do something else. I'm going to open another tab. Now the AWS console. Okay, thankfully it did not ask me to sign in again. So while my app gets created, what I'm going to do is I'm going to create the pipeline. So I'm going to type in Code Pipeline. And the funda is simple even here, guys. You're just going to put in certain details and your pipeline will be created for you. Now this is your dashboard. This is where all of your recent pipelines will appear. Since in this free tier, we have no pipelines created, hence you have no results to display. So first things first, I'm going to create a pipeline. So click on this big orange button which says Create Pipeline. I'm going to give the pipeline a name. Let's just call it Demo Pipeline. So as a default, I'm just going to fill in a role name, AWS Code Pipeline, service role, US East, demo pipeline. Then click on Next. So for source provider, I'm going to use GitHub. And for that, I'll have to connect to GitHub. And it'll ask me to authorize the code suite. Okay. Okay, once you have successfully authenticated the account, you can go ahead and search for the repository. Here, I'm going to choose the demo-code deploy app, which is actually a sample app I have forked from the AWS Code Pipeline repository. You can go ahead and look for it as well. It will be available in the AWS Code Pipeline's GitHub account. Yeah. And in the branch, let's select master branch and click on Next. Now we move on to the build stage. Because I have nothing major to build, I'm just going to go ahead and pick skip build stage. Then you will be prompted with a notification which will ask you if you're sure to skip your build stage. Now, since I have nothing major to build, yes, I am going to skip this build stage. And for deployment, here we are going to choose a deploy provider. So here I'm going to use Elastic Beanstalk and put in my application name and my environment name. Now our application name was deployment app and our environment name would be deployment app environment. This is something which gets created automatically. So we're going to go ahead and click on next. And finally, we are at the review stage where you can go ahead and review all of the details that you have just put in for your code pipeline. And I'm just going to create this pipeline. It's pretty simple to do. Now this might take a few moments, so kindly be patient. And then you are greeted with a notification which says, success, congratulations, your pipeline has been created. Now here you can go ahead and release changes if you want. Our IAM role is in place that we had created earlier. Our pipeline is a success. Now all we have to do is wait for our application to get created, and then we can go ahead and deploy our application. All right, with that, our application has been created. It has OK health, and you can see the platform here. You can see the running version. You can see all the details, all the recent information regarding the app. Now, this is a platform as a service. It basically runs all of your processes in the background. Now, if you would have gone ahead, created this app, configured your IAM user, configured everything else that was needed, this would have taken you a lot of time. But because you are using a platform as a service feature of AWS, this entire process is automated and your work is simplified. So if you go down and look at the recent events, one thing you can see is your instance deployment is completed successfully. Just in the line above that, you can see that your new application was deployed to running EC2 instances. So basically an instance is running on EC2. So let's go ahead and go to EC2, click on instances running. There is one instance running, obviously, we all know which one that is. And this is your deployment app. Now if we go ahead and click on it, here you can see the instance state, it's running, and your pipeline, your source has succeeded, your deployment has succeeded. You go here, you can go down, take a look at your IAM role, your subnet ID, so with that, your instance has been deployed and you realize that your demo pipeline has worked.
What is continuous integration and delivery? Now, basically, this approach comes into picture that fills in this void a little bit. What this approach does is it basically helps you split the entire code into smaller chunks and segments. Now, these are manageable pieces of code which can be actually integrated continuously and can also be deployed or delivered continuously. So there is a constant development process, and if there are any changes that are committed by a particular developer or made changes or certain changes that are incorporated by the operator, those can be committed right away, and you have a version control system that basically ensures that the changes that were committed, the latest, those changes or that copy is made available to everyone, so that there is no ambiguity or clashes between these two teams. Again, how does this approach work exactly? Well, basically, certain processes are automated. You have a source code repository, or think of it as a version control infrastructure where you can put in all your codes, and the versions of these pieces of codes are maintained. Again, you have something called as a build server and a mechanism that ensures that your software gets tested continuously. So all these things ensure that your software is built or your code is built, it is compiled, it is reviewed, it is unit tested, integrated, packaged, and this process happens continuously so that the process of developing software becomes easier, faster, and optimized. So this is what continuous integration and delivery does. Now next we have something called as, or a main topic of discussion, that is AWS code commit. Again, I just talked about AWS, I just talked about DevOps, and now I'm talking about AWS code commit. So you might be wondering as in what is the link? Now, DevOps being a popular approach and AWS being a popular cloud service, both were in demand or both are in demand. So when you talk about DevOps and when you talk about AWS, people wonder as in, can you implement or carry out this DevOps approach on AWS? Well, AWS responded to this request with plethora of services or a set of services basically that ensured that you could actually go ahead and carry out the process of continuous integration and deployment on cloud as well. And one of those services is AWS Code Commit. Now, in the previous slide, I talked about source code repository where you actually go ahead and dump in your versions of codes. So when you talk about this repository, in general, you have something called as Git, which is a version control infrastructure. Now on it, you can actually go ahead and push and pull all your codes, or these codes or pieces of codes are called as repositories basically. So you can do that on Git. What AWS thought was, what if you could have this kind of version control device that is in-house or that is something that runs on the cloud platform? So they came up with a solution to this and they had their own version control device, which was called as AWS Code Commit. Well, to go with the definition, when you take a look at AWS Code Commit's definition, it is a version control service which is hosted by AWS that you can use to privately store and manage assets. When you talk about these assets, these can be documents, your source code, your binary files, and you can actually go ahead and do all these things in the cloud. So yes, as I've already mentioned, it is an in-house repository or infrastructure rather that lets you host or hold repositories. So yeah, this is what it does. It basically gives you an environment where you can actually go ahead and commit your code, push it, pull it. What are its benefits basically? Well, what it does is it lets you store any type of code. I mean, there are very less restrictions on the type and the extensions of codes that you store, and you can do that anytime. And the other benefit that happens here is it is highly secure. Your code that you push and pull, it is basically encrypted. So security is something that you do not have to worry about. It ensures collaborative work. Now, what do I mean by this? Now, when you talk about collaborative work, yes, I talked about code commit where you can actually go ahead and push and pull your piece of code. So the fact that you can do it continuously and you can give proper access to people who can access this piece of code, who can make changes to it under different IAM users and under different security groups, this process becomes very collaborative, very engaging, and many people can work on it, commit on it, or comment on it rather, and actually go ahead and suggest quite a few things. Scale easily. Now that is the other benefit where the pieces of codes or your infrastructure that you have, when you talk about cloud platform and any service, it ensures scalability, and so does the amount of code that you push on this particular service. The best thing about it is it places your code in such locations or such places that it becomes very easy to integrate with your third-party tools as well. So guys, these are some of the benefits of using AWS Code Commit. So guys, I've gone ahead and I've switched into my AWS console. So in this session, we are going to go ahead and create a repository on Code Commit. We're going to push a piece of code. We're going to create a branch for it and probably commit certain changes to it as well. To do that, you have to set up your GitHub repository, or basically you have to set up your Code Commit repository. So how do you do that? You have to go ahead and create an IAM user and a security group, or a group basically under which you can have those users which have particular access to these resources. So I'm going to create one single user which lies under one group only. Let us see how do you do that. To do that, first type IAM. You can search it here and hit the enter button. Once you do that, guys, there is something called as users here. Go there and say create a user. Let us call it CC, that is Code Commit Demo, and I'm gonna give it AWS Management Console access only for now. It says create a group for that. Let's say okay, let's create one. So let's give it a name as well. Say CC underscore group, and we would need to select access policy. So AWS has some predefined policies. We can use those. I'm gonna give full access for now. If you are using maybe more secure data or something like that, you might want to customize your policies as well, which you can do. For now, let's stick to the basic one and say create group. So the group is created, guys. Now let us just go ahead and say next. Key value pair, I don't need it for now. Next again. And there you go, guys. A user is created. So when you actually go ahead and use this particular user, you can decide what kind of access do you want to have to your code commit repositories. Do you want to access it by SSH? You can use
SSH as well and HTTPS as well. So in this session, we are going to keep it simple, HTTPS. You can do it by SSH as well, but that is not for today's session. In the next session, probably we will be talking about how can you connect to your repository through SSH. So let's just go ahead and switch into the code commit service. So then you have your code commit basically. Guys, let us just go ahead and create a simple repository first. I say create. Let's name it, say, sample repository. I'm very bad at naming conventions, guys, so forgive me. And description for today's demo. The reason we put in these details is so that you can differentiate between different repositories, because while working on projects, you might have various repositories. I'm signed in as a root user, so I cannot SSH is what it says. We won't be doing that anyways. We're gonna go ahead and HTTP it for now. Here are the details. If you wish to avoid SSH, you can actually go ahead and go through the details as well. Or if you wish to don't want to go through all this process, you can learn more about it here basically. This is credential helper. Now our repository is empty, guys. We've just created a repository. So let's create a demo file for now. Let's say welcome to the session. Guys, there would be an actual code here. So this being a demo part, I won't be getting into the details. So this is not how the files look actually. Yeah, there you go. So guys, in our past 2 to 3 minutes, we've actually set up a code commit group user and we've created a repository, and now we are putting in data into that thing. So let's call this file, say, demo.txt. Author name, let's stick to my name. There you go. Just putting in a comment. And there you go, guys. My repository is created and there is a piece of code that has been pushed. It has been pushed to the master branch. You can create a pull request as well, guys, if you wish to. If you go to the repositories, you can clone this particular piece of code as well. If you wish to clone HTTPS, SSH, you can do that as well. If you go to the repositories part, you would see this repository here, and you can actually go ahead and do quite a few other things as well. You can create branches of it as well. Say, for example, I come here and I say create a branch. Let's call it, say, demo branch 2, branch from master, and I say create a branch, and a branch would be created, guys, right away. You can select that, open that, and that too will have a demo text file, right? So if I just say edit it, I can come here and I can just go ahead and say changes were made. There you go. And let me just scroll down. Let's say author name is again my name, my email address, and I say commit changes. So there you go. You've actually gone ahead and made changes to the branch. This is my sample repository. You can switch here and you can actually go ahead and make changes to the master branch as well. And if you wish, you can actually go ahead and pull this particular piece of code and you can just compare it with your demo branch as well. Compare. It's mergeable, it says. You can actually go ahead and say create. Okay, so now if I just go back to the branches, I come to my master branch. It looks like this. And if I go to my sample branch, there you go. If I go to the repositories part and then to the branches, I can come here. I can see all the changes that are here. So if I actually go ahead and make changes to my master branch, which I did not do in this case, I just made changes to my sample repository. If you actually go ahead and go back and make changes to your master branch or any of the branches, and then you actually merge those two pieces of code, you can actually get the refreshed copy, whatever you're using. And the fact that you've put in your email IDs and stuff like that, you would be notified. You can even actually go ahead and create a notification group using your basically, you have groups here in AWS that let you actually go ahead and pass messages. You can use SNS and stuff like that, using which you can actually pass in messages as well, so that in case if certain changes are made, you would be notified in the form of those messages as well. So guys, there you go. In this session, we've actually gone ahead and created a repository. We've actually gone ahead and created a branch out of it, and we've made changes to the branch as well. And then I've actually shown you people as in how you can go ahead and
merge the changes that are there and have the best copy with you so that you can actually go ahead and implement the freshest of copies that you wish to use. So guys, when you talk about AWS in particular, you have something called as AWS code pipeline, which lets you simplify this process. It lets you create a channel or a pipeline in which all these processes can be automated. So let's take a look at those processes as well. First, let's get through the definition part. Let's see what it has to say. I would be blankly reading this thing and then probably we'd be having the explanation part that follows. So as the definition says, it is a code pipeline, which is nothing but a continuous delivery service. We talked about continuous delivery already. And you can use the service to model, visualize, and automate certain steps required to release your software. Something that we've already discussed in continuous integration and delivery. So this is basically a continuous delivery service, which lets you automate all these processes. So as I mentioned, automating these processes becomes very important. So once you do use this service, these are some of the features it provides you. It lets you monitor your processes in real time, which becomes very important because we are talking about deploying softwares at a greater pace. So if this can happen at real time, I mean, if there is any change and if it is committed right away, probably you're saving a lot of time, right? You ensure consistent release process. Yes, as I've told you, deploying servers is a difficult task and time consuming task. If this can be automated, a lot of effort is saved. Speed up delivery while improving quality. Yes, we've talked about this as well. And view pipeline history details. Monitoring becomes very important, guys. So what code pipeline does is actually it lets you take a look at all the processes that are happening. I mean, if your application is built, it goes to the source, then it moves to the deployment. All these processes can be tracked in the pipeline. You get constant updates as in, okay, this happened at this stage. If anything failed, you can detect as in, okay, this is the stage where it is failing, maybe stage number 3, stage number 4. And accordingly, you can edit the stuff that has happened at that stage only. So viewing the pipeline history details actually helps a lot. And this is where code pipeline comes into picture. So this is what the architecture of code pipeline looks like. It's fairly simple. Guys, so some of this might seem a little repetitive to you people because the concepts are similar. The concepts which we discussed, those can be implemented by using code pipeline. So yes, I've talked about these things, but let's try to understand how the architecture works. And we'll be using some other terms and discuss some terms in the future slides as well, which we've already talked about. But each of these services, they do this task a little differently or help you automate these processes. Hence the discussion. So let's see to how much level can we keep it unique, and let's go ahead with this discussion as well. So let's see how the code pipeline works. Basically, there are developers, as I've already mentioned, these developers would be working on various pieces of codes. So you have continuous changes and fixes that need to be uploaded. So you have various services. One of them is code commit, which lets you have an initial source management system kind of a thing, which lets you basically take care of repositories and stuff like that. So it lets you directly connect with Git. I would be talking about Git, what Git is, but for people who know what Git is, if you have to manage your Git repositories, you have a service called as code commit. So this is what happens if there are any changes, those go to the source, your developers can commit those changes there, and then it goes into the build stage. This is where all the development happens. Your source code is compiled and it is tested. Then it goes to the staging phase where it is deployed and tested. Now, when I say tested, these are some final tests that have to be implemented before the code gets deployed. Then it has to be approved manually. It has to be checked manually whether everything is in place. And finally, the code is deployed to the public servers where customers can use it. Again, if they have any changes, as I've mentioned, those can be readily taken from them and it goes back again to the developers and the cycle continues so that there is continuous deployment of code. This is another look at it. It is very simple, but this is more from AWS perspective. So if there are any changes that developers commit, those go to the source. Now your data is stored in a container called as S3, that is simple storage service in the form of objects. So if there is any change that has to happen, the data is either fetched from the storage container, which is S3, and the changes are built. And then again, a copy of it is maintained in the form of zip. As you can see here, there are continuous changes that are happening and those get stored in the S3 bucket. Now S3 should preferably be on the region or in the place where your pipeline is. That helps you carry out the process of continuous integration and delivery with ease. in case if you are concerned with multiple regions, you need to have a bucket at each region to simplify these processes. So again, here to the code gets to the source. It is probably submitted to the build stage where the changes happen. A copy is maintained at S3, and then it goes to the staging. Again, a copy is maintained, and then it gets deployed. So this is how the code pipeline works. And to actually go ahead and implement all the actions of code pipeline, you have a service or these services, that is your code deploy, build, and code commit in AWS. So these services actually help you carry out some or most of these processes that are there. Let's take a look at those services and understand what do they do. So first and foremost, you have your code deploy, code build, and code commit. So this is not the order in which you deal with these things. Now, these things actually help you in automating your continuous delivery and deployment process. They have their individual commitments. Let's talk about them one by one. First, let's talk about code commit, which is last in the slide. So basically, I talked about moving your piece of code to a central place where you can continuously commit your code and get the freshest or the best copy that is there, right? So code commit, what it does is it helps you manage your repositories in a much better way. I mean, think of it as a central repository. So it also lets you connect with Git, which itself is a central storage or a place where you can commit your code. You can push and pull that piece of code from there, work on it, make own copy of it, submit it back to the main server or your main or central operating place where your code gets distributed to everyone. So that is Git. And what code commit does is it lets you integrate with Git in a much better way. So you do not have to worry about working on two different things. It helps you in automatic authorization, pulling in the repositories that are there in your Git account, and a number of other things. So yeah, that is what code commit does. Then you have something called as code build. As the name suggests, it helps you automate the process of building your code where your code gets compiled, tested, certain tests are performed, and again, making sure that artifacts or the copies of your code are maintained in your S3 and stuff like that. So that is what code build does. And then you have code deploy. As I've already mentioned, deployment is not an easy task. I mean, if we are stuck in a situation where we are supposed to manage the repositories, we are supposed to work on quite a few things. In that case, if we are forced to kind of take a look at the servers as well, spawn new instances, spawn new piece of servers, that could be a tedious task. So code deploy helps you automate these processes as well. So this was some basic introduction to these things. Let's just move further and take a look at the demo so that we can talk about some of these terms and the terms that we've discussed previously in a little more detail. Now, in one of my previous sessions, I did give you a demo on continuous integration and delivery. I believe there were certain terms that people felt were taken care of in a speedy way. Hope that I've explained most of the terms with more finesse this time and in more detail. As we go through the demo too, I would try and be as slow as possible so that you understand what is happening here. So let's just jump into the demo part, guys. So guys, what I've done is I've gone ahead and I've switched into my AWS console for people who are new to AWS. Again, you can have a free tier account with AWS. It's very easy. You have to go and sign in, put in your credit card or debit card details. A free verification would happen and probably you'd be given access to these services. Now, most of these services are made available to you for free for one complete year. Now, there is certain limitation on these services. So you have to follow those limitations. If you cross those limitations, maybe you would be charged, but that happens rarely. I mean, if you want to get started, definitely this 1 year free subscription is more than enough to get hands-on on most of the services. So I would suggest that you create this free tier account. If you've taken a look at my previous videos, you know that how to create a free tier account. If not, it's fairly simple. Just go to your browser and type AWS free tier, and probably you'll be guided as in what details have to be entered. It's not a complex process. It is fairly simple and it happens very easily. So you just have to go ahead and do that. Once you do that, again, you'd be having access to this console, guys. So once you have an access to this console, you have all the services that you can use. So in today's session, we would be working on a similar demo that we worked in our one of the previous sessions. Here we would be creating an application, a PaaS application, platform as a service application, and we would be deploying that application using our code pipeline. So there would be talking about other terms as well, like code commit, code deploy, and code build. So do not worry, we would be discussing those as well. So this is what the demo is for today's session. So guys, let's start by creating our PaaS application. To do that, we would be using Elastic Beanstalk, which lets you have a ready-to-use template and using which you can create a simple application. Now, this being a demo, guys, we would be creating a very simple and a basic application. So just come here and type Elastic Beanstalk. So when I come to this page, guys, if you've created an application, it would show you those applications. But the fact that if you're using it for the first time, this is the console that you'd be getting. That is why I have created this demo account, so that probably we get to see how you can start from the scratch. So if you click on get started, guys, creating an application here is very easy, like extremely easy. You have to enter in certain details only. It takes a while to create an application, understandable. I would tell you why it takes the time, but once it happens very quickly. So all you have to do is give your application name. Let's call it, say, deployment app. I'm very bad at naming conventions. Let's assume that this is good. You can choose a platform, guys. You can choose whatever platform you want. Say PHP is what I'm choosing right now. As I've told you, it's a PaaS service. PaaS, that is platform as a service, means that you have a ready to use platform, guys. And that is why you can just choose your platform, and your Elastic Beanstalk would ensure that it takes care of all the background activities. You do not have to set up your infrastructure. It takes care of it. So once I select the platform, I can use the sample application or use the code if I have. In this case, I would be using a sample code that AWS has to offer, and I say create. There you go, guys. This thing is creating my application. So whatever is happening here, it shows that these are the processes. Now it is creating a bucket to store all the data and stuff like that. So it would take care of all these things, guys. It might take a couple of minutes. So meanwhile, let's just go ahead and do something else. Let me just open AWS console again somewhere else. I hope it does not ask me to sign in again. I've already signed in. So meanwhile, that application gets created. Let me just go ahead and create a pipeline, guys. So code pipeline again. It's fairly simple, guys. What happens here is very easy. I just go ahead and put in certain details here as well, and my pipeline would be created. So do you want to use the new environment or want to stick to the old one? You can click on old, right? And you can go back and create it the way it was done, or you can use the previous environment. I'm going to stick with that. I was very comfortable with that. So let's just stick with it. If you want, you can use the new interface. There's not a lot of difference, certain little or minor differences. So you can just come here and add in the name of the pipeline that you want to create, say demo pipeline. I say next. Source provider. Guys, I would be using GitHub here because I want to basically pick up a repository from GitHub that helps me in deployment. So I need to connect to GitHub for that. It would ask me to authorize. If you have an account, you can always do that so that it can basically bring in all the repositories that you have. So just say authorize. If not, you'll have to sign in once. So my account has been added here, guys. Repository, I need to pick a repository. This is the repository that I would be picking. Do not worry, I would be sharing this piece of code. Or else what you can do is you can just go to GitHub and type AWS-code pipeline-S3-code deploy-Linux. Now it is a repository given to you by AWS. If you take a look at it and if you type it just the way it is named here from AWS, you should get that repository in GitHub. You just have to go ahead and fork it into your GitHub account, and probably you'd be able to import that repository directly. You can see that repository has been forked here into my GitHub account. You just type the name here, this name, search it, and probably there would be an option here, fork. I forked it, so it does not activate this option for me. In your case, it would be activated. You have to just click on it and the repository would be forked into your account. So I'm getting or importing a fork from my GitHub. I've authorized my account, and then I can just go ahead and do the stuff. Branch, master branch, yes. And just do the next step. Build provider, no build here. I don't have anything major to build, so I don't need to go ahead and provide a build provider. You can use code build, right? Guys, if you want to move or basically deploy your code to EC2 instances, you can use code build if you want. In this case, I have an application in which I have an EC2 instance and stuff like that. So I don't need to go ahead and do any building stuff, hence no build for me. So I say next. Deployment provider. In this case, my deployment provider would be my EBS. So we have that option. Yes, select EBS, Elastic Beanstalk, not EBS. EBS stands for Elastic Block Storage. That is a different thing, guys. Elastic Beanstalk, make sure you do that. Application name, deployment app was the name, right? Yep. And the environment. This is the environment. It creates the environment on its own. I believe that it has created the environment. It says it is starting. I hope the environment has been created. So guys, let's just see whether our application is up and running so that probably I can pass in the details. Yes, the application has been created, guys. So let's just go back and select this. Say next. Now create an IAM role is what it's saying. So let's say sample. Okay guys, so what happens normally is an IAM user gets created each time you create a role. So in this case, it is asking me to create one. It's access, create a new IAM role, AWS code pipeline, and I say allow. Successful. So a role has been created. Next step. Now it gives me the details, guys. Basically, it would tell me what are the stuff that I've done. So everything is here. I don't think I need to cross check it. You might just cross check the stuff that has happened and say create a pipeline. So guys, the pipeline has been created here. As you can see, these are the stages that have happened. If you want, you can just go ahead and say release a change. Now these things are happening, guys, and let's hope the deployment also happens successfully. We've just created an IAM user. Let's see whether it falls in place. Everything is in place. As far as the source part is concerned, it has succeeded. And now the deployment is in progress, so it might take a while. Meanwhile, just go back and take a look at this application. So if I open this application, guys, it would give me an overview of what has happened with this application, guys. As you can see, these were the steps that were implemented. Now the application is available for deployment. It successfully launched the deployment environment. It started with everything that it was supposed to do, like create or launch an EC2 instance and stuff like that. So everything is mentioned here, what happened at what time. So this is a PaaS service, guys, and it works in the background. I mean, if you actually go ahead and launch an instance on your own, configure IAM users, configure security groups, it takes a longer while. But what the service does is it automates that process. It understands that you need an EC2 instance. It launches that instance. It assigns security groups, VPCs, and stuff like that. All you have to do is run your application on top of it. As simple as that. So it has taken care of everything and run a PHP application for me. So yes, this is what has happened here. If I just go back here, meanwhile, let's see whether our code has successfully run. You can see what has happened here. I've released the change as well. And you can view the pipeline history if you want. You can click on this icon and all the details would be given to you, what happened in what stage. So these are the things that have happened till time. Now guys, let's just go back and take a look at something that we could. So I'm gonna come here and say service EC2 because my app launched an EC2 instance. So there should be an instance created by Elastic Beanstalk. See, one instance is running. It has a key pair attached to it as well. So these are the details, guys. I have a public IP associated with it. If I copy it, there you go, copy this IP, and I say run this IP, you have successfully created a pipeline that retrieved this source application from an Amazon S3 bucket and deployed it to 3 instances. It did not deploy it to 3 instances using code deploy. It deployed it to only one instance. You see this message that it deployed it to 3 instances is because the code or the repository that I used, it was supposed to deploy it to different instances if there are multiple instances, and hence this message would have made more sense then. But the fact that we've deployed it to only one EC2 instance, it should actually display that message. So the message that you're supposed to give, you can actually come back here and make change to the piece of code that you worked on. If you go to the readme md file, I think this is where the piece of code is. There you go. Okay, no, not here. Okay, where is that file that needs to be edited? Let me just take a look at some other files as well. Yeah, this is the file, sorry. So if you go to the index.file, here is the message, guys. So you can probably make a change to this message. Instead of saying 3, you can say 1 here, edit this piece of code, and then you submit the code again. So when you do launch or type in this IP address, probably that change would be reflected. So guys, what we've done is we've actually gone ahead and created a pipeline successfully. And in that process, we've actually gone ahead and moved or deployed our application from here. So guys, in case if I do go ahead and commit changes to the code that I just talked about, those would get reflected right away in my history when I talk about this pipeline. So it does give you continuous integration and deployment. So I hope that this session made sense to you people. And we've talked or touched upon most of the stuff that I wanted to talk about. What is AWS CodeStar? Now, in my recent times, I've talked about DevOps a lot. I've talked about different AWS DevOps services as well, as in how can you actually go ahead and use DevOps on AWS. I've talked about services like code commit, code build. I've talked about services that basically let you easily automate this process of continuous integration and deployment. So what is CodeStar and why are we talking about it? Let us move further and try to understand this point as well. So guys, what CodeStar does is it basically brings in different services that AWS has to offer to you in the DevOps space, like code commit, code deploy, code build, and code pipeline. For people who do not know what DevOps is and what are these services, well, basically what DevOps does is it lets you bring in an approach where you can continuously integrate a software, deliver it, test it, and also deploy it automatically. So to automate this process and to do it continuously, you need certain services, certain tools that let you automate and make this process continuous. So DevOps is this particular approach that lets you do this. Basically, it brings in the developers and the administrators or operations team together and does help you automate this process by using various tools. Now, AWS being a popular cloud service provider, it has actually gone ahead and incorporated this approach of DevOps as well. So you can actually speed up the process of software development and deployment. So these are some of the services that let you do it. You have something called as AWS Code Commit, you have Code Deploy, and you have Code Build. Now, Code Commit is more of a repository where you can actually put in your code and repositories that are there with you. So it is more of a version control device. Then you have Code Deploy and Code Build, which basically let you build the code, test it, and then deploy it. And Code Pipeline basically helps you have a pipeline, or basically think of it as a channel where you can practice all these things or carry out all these operations. So what is CodeStar and why is it needed? I mean, yes, we already have all these services with us, and the fact that everything is taken care of, why do I need a separate service that brings in all these things under one roof? Well, to keep it simple, instead of using all these services under different roofs and continuously switching amongst them, it is still a complicated process, right? I mean, if you're working on too many applications, too many projects, then continuously moving from one end to the other, one service to the other, can be irritating and can be time consuming. So AWS thought, why not bring these services which are used together under one umbrella? Now, what AWS CodeStar does is it basically gives you a common dashboard where you can access all these services from one place, and you can accordingly make changes or actually go ahead and perform CI/CD, that is continuous integration, delivery, and deployment using this one single service, that is AWS CodeStar. So this is what it does. It basically lets you develop applications on AWS within minutes. It works seamlessly across different teams, and it lets you manage software delivery as well. Plus, you can choose a variety of project templates. Now, as we move further and get into the demo part, you would probably take a look at the templates and the options that we have. But yeah, this is what it lets you do. So we've already discussed the definition as in what it is and what it does, but this is the basic definition as well, which says that it lets you quickly develop, build, deploy applications on AWS, and it also lets you integrate various services for better product development and tool chain management. So guys, this is what CodeStar is. It basically brings in different DevOps services on AWS under one roof, and it actually helps you save a lot of effort and time. Let us move further and talk about something else now. So guys, these are some of the important pointers that concern AWS CodeStar, or some of the components is what you can say. Basically, what we do is we have our projects, teams, extensions, dashboards. Now, projects are nothing but the DevOps projects that you're going to create, deploy, and work with them. Teams, the different teams who are concerned with this project, the access they have and stuff like that. Dashboard is a place where you can actually go ahead and maintain or bring all these services under one roof. And then you have extensions, which basically deals with quite a few things. As we move further into the demo part, I would probably discuss this part a little more. So I'm hoping that by now you have a clearer picture as to what AWS CodeStar is, what all it can do, and the remaining terminologies. So guys, this is what AWS CodeStar is, and these are the components it concerns basically. Now, who are the people that should actually go ahead and use this particular service? Well, there are no restrictions on it as in who should actually go ahead and use it. But then this service is fairly new. Now, saying fairly new might not sound very correct or won't sound that correct. The reason for that is it is still there in the market for more than a couple of years now. So it has been there for a while, but still there are quite a few things that still need work, and there are quite a few things that have been worked upon already. So basically, when you talk about this particular service, what happens here is if you take a look at the service a year back or so, probably they did not have a channel through which you could actually see what happened with your projects in the past. But recently they've introduced a proper pipeline flow where you can actually understand, as in, okay, these are the things that I've worked on and stuff like that. So the services are improving when you talk about this particular service, that is AWS CodeStar. But yeah, there is still room for some improvement. When you talk about businesses, for them, immediately migrating to AWS CodeStar might be a little difficult, because when you talk about big businesses and organizations, they are very rigid and not rigid, but they are working on platforms, and unless and until it is very important, they won't easily migrate to something else. So I don't see big businesses right away migrating to AWS CodeStar. But yeah, it is a positive step, and we see CodeStar being used more and more these days. Little more tweaks here and there, and probably businesses would soon move to it, because AWS is the need of the hour and people are using AWS. So they are going to use DevOps as well on AWS. And if you are an individual who basically likes trying out new things, who likes adopting new technologies, this is a very good service to learn, because as I've already mentioned, in near future as well, businesses would be moving to AWS CodeStar, and having this skill would be very beneficial for you as an individual as well. So yeah, who would use it or who should use it? I believe everyone should use it, but who would be using it? I feel for now, beginners or people who are working standalone or small businesses would find it easier to basically transition to AWS CodeStar. And with time, we are going to see various bigger businesses moving towards this direction as well. So yeah, again, if you are somebody who likes experimentation, trust me, this is a very good service to have. Having said that, guys, we've discussed quite a few pointers as in what this service is, what it does, what AWS is. Let us quickly switch into the console part and see what does this service has to offer to you in the form of demo. So guys, what I've done is I've actually gone ahead and I've switched into my AWS console. This is something I tell in all of my sessions. If you are completely new to AWS and DevOps, and if you wish to practice AWS or DevOps on AWS, you should actually go ahead and create a free tier account on AWS website. All you have to do is search AWS free tier in any of your browsers, and you would be navigated to that particular link. Open that link, and actually you have to just go ahead and fill in certain details, like why do you want to use this account, certain basic details like what your name is, what organization do you work for, and what is the purpose of you using this particular service or AWS services. And after that, one important thing is you would have to enter in your credit card and debit card details. Do not worry, AWS does not charge you unethically or without your consent. All it does is it provides you some of the services for free for one complete year, and there is certain limitation on these services. So if you exceed those limits, then AWS has the right to charge you. So basically what you have to do is you have to actually go ahead and first take a look at the limits that these services are in, and most of those services are in limits. So even if you use them properly or to a greater extent, you won't be charged unless and until you leave a particular server running for like hours, which is a paid server. You won't be charged. So make sure that you take care of these things. And you can also set in alarms where you'd be notified if you're reaching a particular limit for a particular service. In that case, you might be alarmed and you can turn that service off. So if you're worried about getting charged, do not worry. Just go ahead and create a free tier account. Once you do that, guys, you would be having an access to this console, which is very friendly and nice to use. Now, there are so many services that AWS has to offer to you. If you click on this services icon, you can take a look at all the services that are there. I mentioned that there are somewhere around 100 services. If you just come here and scroll down, probably you can access all those services that AWS has to offer to you. There you go. These are the services that are there. And most of these services, we've talked about these services in our previous sessions. So if you are interested in knowing about those services, you can visit our YouTube channel and probably look for those services as well to understand those services to a better effect. Having said that, guys, we are going to go ahead and talk about AWS CodeStar in particular, and we are going to see how easy it is to actually go ahead and carry out all the DevOps operations with a lot more ease using this particular service. So what do? We go to the search bar and type AWS CodeStar. It says the service isn't there. That is hard to believe. Yeah, there you go. So guys, this is what the beginner's console looks like. I've deleted all the applications that I had created in the past because I wanted you to have this fresher look to the service, as in how does it look when there's nothing or no application running. I mean, if you start fresh, this is what the console would look like, and it gets updated every now and then, so you can switch to a newer console as well if you want. So guys, let's just go ahead and create a project first. So what I'm going to do is I'm going to go ahead and create an application. Now when you create an application, guys, I've talked about that you have a project when you talk about CodeStar. I discussed this in the components part. So when you talk about these projects, basically you have various options when you create one, and you have n number of templates that are available. Say for example, you can see that there is a project template for Go. Go is a programming language, and these are the basic availabilities with it. So you're free to choose the programming language that you want to use. You are free to choose the platform on top of which you want to put in your application. You can see that there are options here as well for filtering those things, and you can decide what kind of application do you want to put on top of that particular platform. So you have all these options. If you scroll down, you would actually take a look at, or you can take a look at all the services that are there or types of projects that you can create. So should we choose one of these, or should we just go ahead and filter one for ourselves? So let us just go ahead and create a web application, guys. Where do I want to put it on? Let's say Node.js for now. And what is the platform? Let us have Amazon EC2, which is a basic virtual machine provider, or I would say a service that lets you create computation instances. So yes, we have these three. So when we select these three options, these are the options that we have. Let us create a web application using Amazon EC2, and then it would ask you for certain details, guys. Project name, so let us call it, say, my sample project. Maybe I'm very bad at naming conventions, so forgive me for that. And guys, with that, you would get this ID, which is very important. If you want, you can edit it right now. The reason I'm telling you this is it would be associated with all the resources that are created in the background. So you might want to keep a track of it, or if you want to edit it, you can edit it to suit your needs, because if you're working on multiple projects, at times you need to keep a track of all these things. So once you do that, guys, you've actually gone ahead and selected a template. You've put in the details. Which repository do you want to use? So again, guys, I've mentioned that with AWS, you have code commit, which acts as a version control device. For open source projects, people normally use GitHub, which is very popular. But with AWS, we normally prefer using AWS code commit. It is an in-house version control device. So let us stick to that for now. In case if you wish to know more about GitHub, again, you can take a look at my previous sessions. I've talked about these things. So repository name, this is what it is. And let us just go ahead and say next. So guys, these are the processes that are going to happen. You have your source, which is code commit. You are going to use services, not we, but this would happen in the background. But for build, we would be using code build. It would be tested. It would be deployed using code deploy, and you can monitor it with CodeStar itself, which basically uses various parameters from different services to do that for you. Once you're done with it, AWS CodeStar would like permission to administer the resources. In short, these services which I just mentioned. So we can just say create a project. Guys, this is important. We are mounting our application on top of AWS EC2, and to log into EC2, you basically need a key pair. So you can actually go ahead and visit the AWS EC2 service, and on the left hand side, you have an option of creating a key pair. It is fairly simple. You have to enter a name and download it and keep it with you somewhere safe. You can do that. We won't be needing this key to a greater extent today, but let us just go ahead and select one. So you can create one, or you can select the one that you have. So I'm going to select this sample SSH, which is already there. I acknowledge the fact, and then I say create project. So guys, the project is gonna go ahead and work. Now, I mentioned that there are some extensions and stuff. You can actually go ahead and pick up certain tools that help you work with the code. Say, for example, I wish to commit a change to a particular code. I need to change that code. So how do I do? I can use a particular editor like Eclipse. You can use Visual Studio if you want, or you can directly use command line interface as well. You have a choice to do that and configure this later as well. So if you want, you can just go ahead and say skip for now. The fact that we won't be working on a very big project, we do not need to do that. So let's just skip it for now. So as you can see, it says that no ID connected because I haven't selected one. And guys, this is going to go ahead and set up a particular project for me. So setting up a project takes a longer while. The reason for that is a lot of things happen. You have a particular piece of code and a number of codes actually I'm going to show you that piece of code as well once we go back, because a template application is being generated which would be available for display. So that is why it takes a longer while. And for now, the configuration part is also happening. I mean, it would actually go ahead and configure some of the resources, because there would be a particular server or a virtual machine on top of which your application would be hosted. Certain IAM rules or policies would be created that would give particular access to particular services. Subnets and VPCs, or virtual private clouds or networks, basically would be created. A network under which these instances would run and can communicate with each other. So all these things happen in the background, and that is why these things take longer than normal. So let us just hope that this application gets created quicker. I've just refreshed it, but no, it is still getting created. And this is a dashboard, guys. Once this gets created, probably you'd be having application endpoints, and it would give you complete detail as in what got built, what got deployed, and what all changes can you make. So meanwhile, we'll have to bear with it. And guys, while this happens, let us just go ahead and take a look at some other stuff. Maybe we can talk about certain things or discuss certain other things so that our time does not get wasted. So guys, I talked about creating a key pair. You can always visit this particular service, EC2, and once you do that, you would be taken to the EC2 management console. There are the instances and stuff, all the details that concern this particular service. So there should be something. Yeah, this is where the key pair option is. You can just click on it and just go ahead and create a new key pair. All you have to do is put in your name of the key pair basically, and you're good to go, guys. So this is what you can do: create a key pair the way it suits your needs, and once you do that, you would be good to go, guys. And if I just go back, yeah, there are quite a few other services. I talked about AWS DevOps in particular, right? And to do that, there are quite a few services. Say, for example, code pipeline, code commit, something that I've used recently. That is why you can see all these services in the history part as well. So let us just go ahead and see whether our application is up and running. My sample project. The project has been successfully created, guys. You can see that there is status update, initial commit made by AWS CodeStar during project creation and committed 2 minutes ago. So it was committed. You can see that this is the source code commit. It is getting built, and once it is built, it would be ready to deploy, guys. So once this happens, there are quite a few other things that we need to take care of. Say, for example, this is how if you click here, you would be taken to the dashboard, which we are on already. You have your IDE. If you're using any code commit, where you have all the details about the code that you're going to use and stuff like that. Basically your code build, something that builds your code. If you want to take a look at it, you can do that as well. Deployment, you can study that. Pipeline, where you can actually go ahead and add more stages to your project. Once we are done with the deployment part, probably we would talk about it a little as in what you can do with it. So yep, these are the things that are going to happen, guys. You can see the code is still getting built. So let us refresh it for now and see what is happening and where. There you go. So it was built already and now it is getting deployed. So half a minute or so, and guys, our application would be up and running. Now again, guys, if you are looking for maybe a structured approach when it comes to getting trained in this particular technology, if you are interested, probably you can take a look at this website by Edureka, where you have this particular course, AWS Certified DevOps Engineer. And in this training, probably you'd be covered with all the details that concern DevOps and all the services that are there. See, these are the topics that are covered here, and it talks about everything that is related to DevOps on AWS, like the services that are there and the operations that you can perform. And talking about AWS CloudFormation, this is something that has been used in a project as well that we've just created. I would talk about it as well. Getting back to this discussion for now, you can probably visit this place and take a look at the details that are there. So that is if you are interested, and probably you can get in touch with any of our executives, and probably they would guide you on how to proceed with it. I mean, what is the fees, whether there are any discounts and stuff like that, and how you would be attended in case if there is any problem related to customer service or any project details or any class details or stuff like that. So you can actually go ahead and visit this website and take a look at all the stuff that is here. I believe I've stalled enough time to, so let us just actually go ahead and see whether our code has been deployed or not. So let me just refresh it once more. I say refresh. It is still getting deployed, guys. will happen soon. Do not worry about it. And guys, then you have Jira as well. You can integrate with Jira. What it does is it lets you track your items and issues with AWS CodeStar, and you can actually integrate with Jira as well. So there are any commitments or any changes that you have to do using Jira integration, you can do that as well. It is fairly easy. Just connect to it and enter in few details and you would be more than good to go, guys. And once this application is up and running, probably your CloudWatch. I mentioned the fact that AWS connects with other services to give you monitoring details. CloudWatch is one such service which gives you all the details. So once this application is deployed, the changes would be visible here, as in what happened, how it got deployed, and all those things. Okay, this is taking longer than normal, guys. Normally it does not take this long, but yeah, it is taking this long for now. So the fact that our code has been committed already. So guys, let's just go back to the code part. So guys, in case if you wish to take a look at the code that you've used, you can actually come to this particular place and all the details, as in what does the sample project have. See, these are the files it has, all the files that concern your particular piece of code or particular piece of application that you would be using. So if you click on this readmd file and if you say edit it, so probably all the details, if you click on say view source, so this is the code that is there in this readme file, guys. You can actually go ahead and make changes to it. You can say edit and you can change this file as well. You can do that by using basically your CLI as well, which is your command line interface, where you can actually go ahead and commit all the changes that are concerned to this particular service. And you can see that all the pull request commits and branches are taken care of when you talk about this particular service. Coming back to this particular project that we've launched, which is taking very long than normal. Let us see what has happened. There you go, guys. So our project has been successfully deployed as well. So all the operations that concern this particular service are up and running. If you click on this particular endpoint and open it, you can see that an application has been deployed. We just created a Node.js web application using this particular service, and it is responsive, guys. You can go to home, that is, it will take you to AWS home and tell you about the services, and you can contact them as well. If you click on this thing, you would be redirected to Twitter basically. There you go. You have the Twitter details as well. So guys, yep, we've pretty much actually gone ahead and we've launched an application. Again, I've talked about the pipeline and stuff. So this is the pipeline. You can actually go ahead and make changes to this pipeline as well. So if I click on this pipeline icon, probably I can actually go ahead and add more stages to it, guys. So this is how the pipeline would look like. If I just say edit, it gives me an option of editing. So I can scroll down, guys, and probably I can decide what to do. Say for example, this is the deploy stage, this is the build stage. After build stage and before the deployment stage, say I wish to basically, okay, we have it here. Say I wish to approve particular pieces of codes or builds on my own. I can just say approval, say manual approval maybe, so that I can manually approve these things. So I say add this particular stage. The stage name is invalid. Let's just stick to approval for now. There you go. And I say add this stage. I can just scroll down and I can add action groups to it. I can decide what is to be added. I mean, you can add the action name, say approve deployment, and I say manual approval. Basically, it would ask me for the details. Do you want SNS topic ARN? That is, do you want to be notified each time manually you approve something, and do you want the notification to go to other team members as well? So you can do that. You can add those here. You can save the changes if you wish, and you'd be good to go, guys. Let's not do that for now. Let us just stick to the basic stuff. So you can actually go ahead and add those details, and that particular thing would be added here in the pipeline as well, guys. Once you are done with it, there are quite a few other things that you can do with this service. Like you have this dashboard, you can decide how do you wish to play with it. Do you wish to push and pull some other components so that you can decide what is the frequently used application that you're using? And if you commit the changes, those changes would be reflected here and here as well. So this is it, guys. And apart from that, you have the teams option here as well, which actually lets you decide if you wish to add more team members, what access to give to them and stuff like that. So which member gets what access to which service and how much is something that you can decide. And you can have all these details on your dashboard here and here. Again, guys, once you are done using all the services and if you are practicing, make sure you delete all the resources that are there with you and you won't be charged to any particular level. in case if a particular service charges you. So even before we leave, we are going to go ahead and delete all the stuff that we've created. But as far as this session goes, guys, we've talked about quite a few things and we've discussed what AWS CodeStar is. I believe you have some basic understanding to this particular topic. So let us just go ahead and delete our project first, and then probably we can bid adieu to this particular session. So when you say delete, guys, you'd have to enter your ID. So I'm just going to copy it from here and going to paste it here and say delete, and then it would delete this particular service for me. Takes maybe a minute or two to do that. Once the service is deleted, you're good to go. Why do you need AWS OpsWorks? Before we talk about this particular point, let us just quickly take a look at the definition of this particular topic so that probably we can relate to the topic in hand much better. That is, once we understand what is AWS DevOps, there might be quite a few people here who might be completely new to these terminologies. So it is important we understand what OpsWorks is so that we can probably relate to the bigger picture as in why do we actually use it. So let's just do that. Let us take a look at the basic definition first. When you talk about the definition, this is what it has to say. It says that it is a configuration management service that helps you build and operate highly dynamic applications and propagate changes instantly. So too many words here. Let me just simplify it for you. Now these days we build so many applications which are built consistently and constantly. So if you think about it from an infrastructure perspective, you might be required to maintain hundreds of servers, different applications on top of it, configure those applications and do n number of activities that you actually would not want to do. Because as a developer or as a business owner, your prime focus is on focusing on the business part and on the development part. So what if you could give these laborious activities to someone else to do it? Wouldn't that be nice? Well, OpsWorks, it exactly does that. I mean, it takes care of the configuration and the management part. And when you talk about this service, it specifically helps you in various DevOps related activities. Like it lets you deploy these codes as well, or these applications as well. You can do that manually, automatically, and a number of other ways. It lets you load balance your applications. So all in all, it serves quite a few purposes when you talk about DevOps. And when you talk about DevOps, these things can be done by using Chef and Puppet. So what this thing does is, that is AWS OpsWorks, it basically lets you use configurations that support these tools as well. And Puppet and Chef, that is which these individual tools are, they also let you use OpsWorks along with them. So that is what AWS OpsWorks is. Basically, it lets you configure and basically manage various deployment processes and the infrastructure that we're talking about. As I get into the demo part, I would actually give you a deeper explanation as to what you can do with Chef, what you can do with Puppet, and a number of other things. So this is what the basic definition is. Now let us go back and try to understand why AWS Ops works. Now, when you talk about AWS Ops works, let's consider this example. Suppose you have like thousands of servers that are running at a time, something that I talked about a while ago, as in you might be required to work with a number of servers. So in this case, suppose that you have somewhere around 1,000 servers, and probably you're supposed or you're made to deal with changing the properties of certain files on these servers. If you do it manually, actually there would be a lot of laborious activities involved in this task. But if you talk about OpsWorks in particular, what it does is it lets you automate this process and it lets you do this task parallelly on n number of services. So thus it helps you save a lot of time. And apart from that, it gives you following features. It is highly productive, it is highly powerful, it is easy to use and it starts easily, it is highly flexible, and it is secure as well. The plus point of it is you can run any kind of application on top of it. So that is not your concern. I mean, you do not have to worry about the kind of applications that you can run on top of it. Since you can run any kind of application, all you have to do is focus on the configuration part, then let go of the worry where you focus on what kind of application should I deploy. So guys, this was the reason why you should actually go ahead and learn AWS OpsWorks. We've already looked into the details of what is AWS OpsWorks. Let us take a look at certain components that are important to this particular service. So following are the components that this service focuses on. You have stacks and layers, then you have instances, applications, and cookbooks. Let me throw in some light on each of these terms individually. Stacks and layers. Now, when I talk about building applications, basically you're talking about so many things. I mean, you're talking about code, you're talking about configuration files, you're talking about installations and stuff like that. So all these things have to lie inside a container, right? Inside a box where these things can be managed. So that stack of these resources is called as a stack. I mean, the name remains the same, but that is what it is. And then you have something called as layers. Now, again, these operations that I just talked about, say, for example, you are supposed to install certain softwares. So you need to have a stack or maybe a substack that basically holds in these installation files, right? So that substack is called as a layer. It basically lets you have more classified approach towards the resources that you have. So a sub-classification inside a stack is called as a layer. And then you have instances. I've talked about instances already as in what it is. Again, if you talk about computation, I mean, you would be carrying out the operations that I just mentioned, right? So you need some source that lets you perform all these computations and a platform to perform these computations on top of these applications, right? So that platform is something that is provided to you by the instances that are there. Now, there are various types of instances. Let us not get into the details of those. But yeah, these instances, think of them as platforms on top of which you can put in your applications and carry out computation. Then you need certain applications that you can put on top of it. So these applications, again, you can build those on your own. You can use custom applications depending upon your need. AWS or most of the cloud platforms that you would be using, they would give you these options where you can have your customizations, or you can actually go ahead and use the default applications that are there on these cloud platforms. Specifically with AWS, it is definitely true. Cookbooks. Now, what are cookbooks? Again, you have various configuration files or basically files that tell your service what to do. I mean, what kind of operation do you want your service to perform? So this piece of information is a configuration file. And when you talk about a cookbook, basically it is a collection of recipes. Recipe, again, is nothing but a script, basically, or your configuration file. So if you have n number of such configuration files, which basically tell your service what to do, you can club them together so that you form a cookbook. Just like our normal routine cooking practice, right? If you talk about a cookbook, it would have a number of recipes and each recipe would tell you what different dish to cook, right? So if you apply this logic into OpsWorks, or basically if you apply this logic into configuration process, that is what recipes and cookbooks would be like. So yeah, guys, we've talked about all these things. We've talked about stacks and layers. We've talked about instances. We've talked about applications and cookbooks. Now let us just go ahead and switch into the console part and try to see what AWS OpsWorks have to offer to us, or has to offer to us. So guys, what I've done is I've gone ahead and I've switched into the AWS console. This is where we would be getting a walkthrough to AWS OpsWorks. Now, before we get into the details of AWS OpsWorks, for people who are completely new to Amazon Web Services, AWS, what they can do is they can actually go ahead and create a free tier account here. What AWS does is it gives you some of the or most of the services for free so that you can actually go ahead and practice these services. Now, when I say for free, these services are available to you for one complete year, and there is certain limitation cap on it where you can use these services for certain limits only. So what I would suggest is you actually go ahead and log into the AWS website, this particular website, or you can just go ahead and search for AWS free tier in any browser, and you would be redirected to this page. There you'd have to go ahead and sign in or probably sign up. And once you create an account, you would be having all these services made available to you. What is the process for signing up? You have to put in certain details like why do you want to use this account? Who are you by profession? And what is your intention of using this account? Plus, you'd have to enter in your credit card or debit card details because there is a certain cap on these services. And if you exceed those limits, you would be charged post that. But again, the limits are more than enough if you wish to get started. So I would suggest that you put in your details for your credit card and debit card and you won't be charged. You can stay rest assured about that as well. So guys, once you do have an account, you can actually go ahead and use the services that AWS has to offer to you. In this case, we would be going through OpsWorks. Now, when you actually move into AWS console, you have this find services option where you can put in the details of the service that you want to use. In this case, it is OpsWorks, right? So it would be there in the suggestion here for your use. If you've recently used it, it would be shown in that option as well, or in the recently visited services as well. So you can visit it either ways. Let us just click on this icon. Today, for some reason, the internet is a little slow, so few things are taking longer than normal. Now, if you've opened or used this service for the first time, or you're using this service for the first time, this is what would appear to you, a fresh screen for a beginner. I'm purposefully using this account because I want you all to see how it looks from a fresher's perspective. So guys, once you do that, this is where you have all the stuff that you can do. Now, in the previous part of this session, I've discussed about stuff like stacks. I've talked about recipes and cookbooks, right? So that is what we are going to do. We are going to go ahead and create a stack. We are actually going to go ahead and deploy an application and see how it works using AWS OpsWorks. So as you can see, if you are a fresher, you can actually go ahead and start fresh. With this, what it does is you create your first stack. And if you already have certain instances running and you wish to use those, you can register those instances as well. But for now, let's just go ahead and start fresh so we get to see what all can be done. So let's say add your first stack. So guys, you're given these options. As I've already mentioned, when you talk about AWS OpsWorks, it works with two services or two tools rather, that is your Chef and Puppet in a very good manner. Initially, it started on a great scale when you talk about Chef in particular. I mean, it was very easy to integrate with Chef, that is integrating AWS with Chef rather. And now the fact that Puppet is trending these days, you can actually go ahead and use Puppet as well. If you talk about adding a stack, you can actually go ahead and add a sample stack where a Node.js application would be deployed to the discussed instance or to the instance that you would be creating. And if you talk about the other options, you can actually go ahead and bring in your existing cookbooks and use certain community cookbooks as well that are there for offerings when you talk about AWS in particular. To do that, you'd have to use Chef 12 stack. And in case if you wish to use built-in cookbooks for the applications and deployments, you can switch to Chef 11 stack as well. So guys, we're going to stick with the basic application for now. Once you click or select this option, a Node.js app will be set up to help you explore the features and configuration options of AWS OpsWorks stacks. For example, layers, lifecycle events, and etc. So let's just go ahead and create one. What operating system do you want? Let's stick to any. I mean, we are not going to go ahead and explore these instances or these operating systems. So let it be Linux for now. It does not matter to any great extent. And say create a stack. So guys, these are the 5 processes that would happen. It would create a stack. The name would be my sample stack. A cookbook repository would be created basically, that is using Chef. A layer would be created. Node.js app server would be its name. Then probably a recipe would be assigned to basically using which you can actually go ahead and deploy your application. And finally, you'd add an instance layer as well, or you'd add an instance to the layer rather. So once you do that, let's just go ahead and say explore the sample stack. So all these things have happened, guys. Now, as you can see, you have a sample stack basically. So if you wish to explore, you can actually go ahead and go through these options as well. The important thing that you need to do is actually you need to go ahead and start an instance. So let's just say start the instance. So guys, this is the process which takes a long time. Meanwhile, let us just go through certain basics. If we are able to bide the time so that the instance gets launched in that duration, I mean, so basically there is a server that is getting installed here. So it's obviously going to take a longer while. So meanwhile, let's talk about certain terms and try to understand those. If we still have enough time, then I would probably pause this session meanwhile the application gets or the instance and the server gets up and running. So let us try to take a look at certain pointers when you talk about these stacks. Probably this is the layer that is there, which we have. We've talked about layers already. So again, if you come to this particular location, it would give you the information about the stuff that we are talking about. Let me just click on this thing. See, there's the information here as in what is a stack, what does it mean, layers as in what are the layers that you're using, what a layer is and stuff like that. So if you wish, you can add more layers as well. Instances, this is where you'd have information about your instance, which is getting booted right now or booting up right now. This is the IP address that we can use. Then there are 2 types of instances, guys. You have your time-based instance and you have your load-based instance where you can customize the way your application needs to be handled. If you wish to spawn in more instances or if you wish to give in certain instructions for your instance to react to, you can set in certain time variable parameters. And if you wish to load balance better, you can actually go ahead and load balance your instances as well. If you click on this icon, no load balance based instances is what it is saying. You can actually go ahead and add those. You can edit the configuration for the same as well. Now this is the information as in what happens with a load based instance. Then you have your time-based instance as well. Same for it as well, the information as in how it works. Deployments. This is something that we're going to do once instance is up and running. So we should wait for that. Monitoring. This is where you get all the information about what has happened once the application server is up and running. Let us just go ahead and see whether the instance is up and whether it's running. It is still booting up, guys. So I'm just gonna go ahead and kind of wait for this particular activity to happen. And once it does happen, I would re-continue the discussion. Okay, booting process is done. Now it is running the setup. So I'm hoping that it's gonna happen quicker. So guys, there you go. The Node.js server is up and running, and you can see the status is online. The instance that we are using right now is T2 medium. Now there are different families of instances that you use which serve different purposes. Certain instances are memory specific, certain are general instances. If I'm not wrong, T2 family instances are burstable instances which actually work at some reserved capacity in the initial phase, say somewhere around 20%. And if you require more computation, they burst into that mode where you can actually go ahead and utilize that instance 100%. Now, this is for cost saving purposes, but that is not the discussion for today. Let us just go ahead and see what we have here in store. Now, our instance is up and running, so let us move ahead and get into the deployment part. Let's just say deploy an application. Deploy this particular application. Yep. Command, deploy, comment, sample for today. There you go. And I say deploy. So yeah, this application would be deployed to our instance basically. So again, guys, the reason we use ops to work is what it does is it kind of simplifies all these processes. Now, this is where we've actually gone ahead and created a very simple application and we've deployed it. Again, as I've already mentioned, you have the freedom of choosing the instances that you use, choosing the application that you want to bring in, and you can actually go ahead and use all the recipes and cookbooks that you have. I mean, you can use configurations and instructions that you want to use that suit your need better. And your applications can be large, they can run on any kind of platform. So all these restrictions won't be there once you actually go ahead and deploy your application, or once you actually do go ahead and decide to use AWS OpsWorks. So yes, it is a complete service. Once this thing is up and ready, we can see what has happened. So the application is deployed, and if you wish to take a look at what has happened, the reason it took this long was these were the number of operations that were performed. See, you can take a look at the log. This is all that has happened, and this is what it has gone through, these many processes. So you can understand the amount of time it has taken. And when we say automate certain processes, it helps you take care of these many processes, guys. So yep, again, so if you wish to actually go ahead and see what has happened, you can kind of move to your instances. This is where your instance lies, right? So you can come here and kind of move to your IP. Now I've clicked on that IP and this is what I've got. You've successfully just deployed your first app with AWS OpsWorks. So this is it, guys. I mean, we've understood how OpsWorks works, what all it does, and at least the basic part. One more important thing that you need to notice, guys, when you do actually go ahead and create these applications, when you actually go ahead and do all these things, you should understand one thing, that these things might cost you. So it is very important that you actually go ahead and clear all the stuff that is there with you. So it is very important you stop your instances. It is very important you delete your applications that are there with you. So first and foremost, it is important you delete your application. Once you've deleted the application, guys, your next process is to actually go ahead and stop and terminate the instance that you're using, and you would be good to go, guys. So once you've deleted the instance, once you've deleted the application, then go ahead and delete your stack from here, because you might be charged otherwise. So ensure that you carry out these practices.
Say whenever you run multiple applications, it is certain that you require a server. So depending on the application that you are running, you might need only a few servers, or sometimes you might need 100 of servers. The number of servers are all dependent as per your requirements. Amazon Elastic Compute Cloud actually provides you those virtual servers, along with secure and resizable compute capacity in the cloud. Virtual in the sense that they are not physically existing, but you can use them anywhere in the world without any limitation. Now with Amazon EC2, it makes it easier for you to obtain these virtual server. You simply choose the instance types you want, the template you would like to use, which could be based on Windows, Linux or Ubuntu, and launch the quantity you need. You can do this with a few clicks from the AWS Management Console or automate the process via the API using SDK in your choice of languages. Now, within minutes, your instance will be up and running with full administrative control. Now, once you're done using your instances, you can simply terminate them and stop paying for them. Now, let's go on right ahead and see why EC2 is one of the most popular AWS offering. Now, with EC2, you can scale your instances up or down as per your requirement. Secondly, they can integrate with other services like S3, EBS, VPC, RDS, etc. And the best part is you pay only for the time your instances are running, so when you stop using your instances, you stop paying for them. Fourth part is you can launch your instances in one or more regions. As you already know, the global infrastructure is divided into regions, and inside the region you can have more than one availability zone, which is nothing but your data center. Fifth part is you have the freedom to choose different operating system like Windows, Linux, Ubuntu, etc. And lastly, EC2 comes with a tight security network, as EC2 works with virtual private cloud or VPC to provide you that secure network to all the resources which you are going to utilize. Now, moving on to the next topic, Amazon EC2 provide a range of instances which are designed for different use cases. Amazon EC2 provides instances optimized for compute, memory storage, and GPU processing. Now, they range from cluster compute instances designed for high-performance computing workload to small, economical instances for low-volume applications. You can see here the different type of instance size and its use cases for different purposes. We shall also discuss these instances pricing. The first type of pricing is on-demand pricing. Now, with on-demand pricing, you only have to pay for what you use. Now, when you stop an instances, you simply stop paying for them. You can use your instance either to launch, stop, hibernate, start, reboot, and terminate your instances. Now, coming to the next pricing, we have reserve pricing. With reserve pricing, you obtain a significant discount by bidding over the on-demand price in return for a low one-time payment. The third pricing is spot instances. Now, with spot instances, it lets you name the price you want to pay for your instances. You can do that by using market-based pricing, and it can allow you to obtain compute capacity at a significant discount to that on-demand pricing. And lastly, we have a new type of pricing, that is saving plans. Saving plans allow you to easily reduce your bill by making a commitment to compute usage, say for a period of 1 or 3 years term. Now, there are two types of saving plans. One is compute saving plan and another is EC2 instance savings plan. Now, compute saving plans provide the most flexibility and help reduce your costs up to 66% regardless of its instance family, its size, availability zone, region, operating system, or tenancy. Now, whereas on the other hand, we have EC2 instance saving plans that provide the lowest price, offering saving you up to 72% in exchange for a committed period of compute usage. I hope till here everyone is familiar with what EC2 is, its types and pricing. So let's quickly do a quick hands-on to see how simple it is to launch an instance. After that, I'll even show you guys how to host a server. Let's get started with the hands-on. And the first thing you need to do is go to AWS Management Console. From there, you can click on Amazon EC2. Click on Services, click on EC2 and open that in the new tab. From there on, you can click on Launch Instance. Click on Instance, then Launch Instance. So you simply click on Launch Instance. We give it a name for your instance. In this case, I'll be naming it as Ubuntu Demo. And scroll down and click on Ubuntu, which is a free tier by the way, and simply click a new key pair. Scroll down and set your key pair. If you guys don't know what is a key pair, you need not worry. I'll be explaining you guys what is a key pair and why do we need one in the later part of the video. So simply click on .ppk and click on create new key pair, and we'll name that as Ubuntu key for use. and click on create key pair. So we simply keep everything to default for now and click on launch instance. Once you click on that, simply wait for a few minutes. Until then, let me give you a brief walkthrough on EC2 dashboard. Once you click on that, simply wait for a few minutes. Until then, let me give you a brief walkthrough on the EC2 dashboard. You can see here in the dashboard the instance that is running in your AWS management console. Say its instances, then the security groups, IP address, etc. And to the right here, we have a region where you'll be able to select any region based on your location nearer to you. If you have an instance running, you will be charged as long as your instances are running. So how will you be able to check which region your instances are running? Now for that, EC2 provided us with the function EC2 Global View. Now where you will be able to see how many instances are running in which region without having to select each and every region. Now as you can see here, 8 instances are running in one region only. Now coming back to an instance, we can see that it is running. So the next thing that we need to do is host a website server. In order to do that, you simply copy the IP address and simply open PuTTY, and you simply paste your IP address, click on SSH and click on Alt, and then paste your key pair which you have generated a few minutes ago, and click here as Ubuntu for use. Click on OK, click on Open, click on Accept, and simply click here Ubuntu. You'll be logged into an Ubuntu terminal. Simply minimize the screen a bit so you guys can see. So before we host a server, the first thing you need to do is type this command: sudo apt get update. So once the message prompt is done, so the next thing you need to do is install Apache 2. So in order to do that, type on the code sudo apt get install Apache 2. Click on yes. And it's done. So in order for a server to be hosted, the next thing you need to do is go back to AWS Management Console, go to description, where in this part we need to change our security groups. Since we've been hosting a server, we will be needing an HTTP request. So in order to do that, you simply go on action and indit inbound rules and simply add on rule. Click on HTTP, and for custom, anyway IP version 4. Simply click on save. Once that is done, you can go back to your instance, Ubuntu demo, click on Ubuntu demo, and simply click on the IP address. Go back to a new tab and simply paste your IP address. As you can see here, we have been prompted with an Apache 2 default page. And if you guys wanted to replace this Apache default pages, you can do this file is located at /var www/html index.html. So we can do that by simply go back to PuTTY, C common directory. This is the direction of your Apache. As you can see here, this file is located at /var/www/html/index.html. So we can do that by simply go back here and write here HTML and use an ls, and you can see here the file name is index.html. Now in order for us to make some changes on the file, we simply have to remove it first. Sudo remove index.html, which is the name of the file. When that is done, we can simply edit it in the HTML template by typing the code sudo nano index.html. We are provided with an HTML template. Welcome to Edureka website. So that will be our heading, and simply provide a body. And say, put a new line. Right here is, hello guys, this is Damon from Edureka. Simply close the body, and we closed on the HTML. Exit. Type exit. Once that is done, simply reload this page, and you can see here you have already added that Apache 2 file. Hello guys, this is Damon from Edureka with that website name as welcome to Edureka website. So that is it guys for the hands-on on how to host a server. Now getting back to our presentation, we shall understand what is Amazon machine image. So what is an Amazon machine image? So just as its name suggests, Amazon machine image is basically a template or information of your operating system to launch your instances. So it can either be an Ubuntu or Windows, and then Java, Python, etc., where these files or these template will be converted to an AMI template and create an n numbers of AMI template. Now when you launch an instance, you must first specify that AMI. So whenever you launch an instance, you can use multiple instances for a single AMI. For the same configuration, in this case, we can use multiple instances for the same AMIs, say v2. Or you can use different AMIs to launch different instances for different configuration like v2, v3, v4, etc. Now in the next slide, we shall also see an AMI lifecycle. The first thing you need to do is create a template in Amazon EBS snapshot. Then you need to register your AMI. After you have registered your AMI, you can then use it to launch new instances, or you can use it to copy an AMI with the same region or different region. Now when you no longer require an AMI, you simply deregister your AMI. Now let's go back to the AWS Management Console, where I'll show you guys how to create your own AMI. So guys, let me show you how to create your own AMI. In order to do that, you simply go to your instance, click on your instance that you have just created, and click on action, click on image, and click on create image. So we'll provide that a name. That will be as an AMI image for demo. The size will be 8 GB. Set everything to default and simply click on create image. As you can see here, your image request has been created. Simply close that, go back to AMI, and you can see here your AMI image has been created and your status is still pending. So this is how you create your own AMI. Now coming back to the slide, we have Amazon Elastic Block Storage. So Amazon Block Storage is nothing but a level block storage. In today's session, we will be discussing about Amazon EBS Volume, Amazon EBS Snapshot, and EBS Lifecycle Manager. So coming to the first type, we have EBS Volume, which is a durable block level storage device that you can attach your instances. Now once you have attached a volume to an instance, the EBS Volume can be used as a physical hard drive. Now EBS Volume are flexible as you can dynamically increase size, modify the provisional IOPS capacity, which is nothing but your input-output operational per second. Now that we have understood what Amazon EBS Volume is, let us understand what Amazon EBS Snapshot is. Now EBS Snapshot are used for backing up data for your EBS Volume to an Amazon S3 bucket snapshots. When I say they are incremental backup, it means that only the block on the device that have changed after your most recent snapshots are saved. Now by doing this, it minimizes the time to create the snapshot. Thirdly, we have the Lifecycle Manager, which we can use to automate the creation, retention, and deletion of EBS Snapshot and EBS back AMIs. Now, secondly, it automatically copies snapshots that are created by a lifecycle policy to up to 3 AWS regions. With Lifecycle Manager, fast snapshot restores enable you to restore volume that are fully initialized at the creation and deliver all the provision performance. And the fourth point is automated cross-account snapshot copy, which means it uses cross-account sharing in conjunction with a cross-account copy event policy to automatically share and copy snapshot created by a policy across accounts. Now coming back to the hands-on demo, I will show you guys how we can modify the EBS volume. In order to do that, go back to your instances, click on Ubuntu demo, click on the IP address, open PuTTY, and simply paste your IP address, click on SSH, click on auth, and simply browse your key pair. There'll be Ubuntu key for use. Click on open. Here you can write as Ubuntu. Once the authentication has been succeeded, we will minimize the screen so you guys will be able to see. We'll type lsblk, and you can see here that our EPS volume is 8 gigabytes. So in order to do that, click on launch instance, click on the instance you have just created, go down to description, and you can see here an EPS optimize. Click on the root device, click on volume. As you can see here, size 8, click on action and click on modify volume, and in this case I'll be changing it volume to 100 GB, and simply click on modify and click on yes, click on close, and go back to PuTTY and type on lsblk, and you can see here our volume has increased from 8 gigabytes to 100 gigabytes of disk. So that is how you modify your EBS volume. Now coming back to the slide, we have networking and security in Amazon EC2. So the first networking that we will be looking into is host multiple website or multiple IP addresses. Now what this does is it hosts multiple websites on a single server by using an SSL certificate on a single server with a specific IP address. Now it operates network appliances such as firewall or load balancer. They have multiple IP addresses for each network interface. Now it redirects internal traffic to a standby instance in case your instance failed by reassigning the secondary IP addresses to the standby instances. And the second point we have is elastic IP addresses. Now what is an elastic IP addresses? Elastic IP addresses is nothing but a static IP address which is designed for dynamic cloud computing. An elastic IP address is allocated to your AWS account and is yours until you release it. Alternatively, you can specify the elastic IP address in a DNS record for your domain so that your domain point to your instance. So guys, let me show you what an elastic IP address does. So in order to understand what an elastic IP address does, first thing you need to do is click on EC2 and go to your instances. As you can see here, I've already stopped or terminate the instance dates. So in this case, I'll be using an Ubuntu demo. As you can see here in the description, there is no IP address for this following instance. So what if you require to add an IP address to this instance which have been stopped? So in order to do that, you simply go to an elastic IP and allocate an elastic IP address. Simply allocate. Once that is done, simply click on the IP address. So we'll be allocating this IP address to the stop instances, that is Ubuntu demo. So in order to do that, simply click on associate elastic IP address and choose your instance. This is an Ubuntu demo, and click here on associate. As you can see here is 3.7.138.126, right? So in order to check that, you can copy that and paste it in the next tab and go back there and simply click on your instance that you have stopped, that is Ubuntu demo, and you can see here that it's an IP address has been attached to your Ubuntu demo which have been stopped. As you can see here, 3.7.138.126, which is nothing but your static IP, elastic IP address. So that is how you associate your IP address to any instance which has been stopped or terminated. The next thing we have is security groups. A security group acts as a firewall for your EC2 instances. You can add rules to your each security groups that allow traffic from its associated instances. They control the incoming and outgoing traffic. Inbound rules control the incoming traffic to your instance, and outbound rules controls the outgoing traffic from your instance. When you launch an instance, you can specify one or more security group. If you don't specify a security group, Amazon EC2 uses the default security group. The next thing that we're going to look upon is key pair. So what is a key pair? A key pair is a set of security credentials that you can use to prove your identity when connecting to an Amazon EC2 instance. Now, a key pair consists of a public key and a private key. Amazon EC2 stores the public key on your instance, whereas you store the private key. The private key allows you to securely SSH into your instance. We shall see EC2 use cases in the real-life application. The first use cases is run cloud native and enterprise application. Now, Amazon EC2 delivers secure, reliable, high performance and cost-effective compute infrastructure to meet demanding business needs. And the second use cases is Sqoop for HPC application. Now, it accesses the on-demand infrastructure and capacity you need to run HPC application faster and cost-effectively. And the third use cases is developed for Apple platform. As the name suggests, it is used for building, testing, and sign on-demand macOS workload. Access environment in minutes, dynamically scale capacity as needed, and benefit from AWS pay-as-you-go pricing. And the fourth use cases is train and deploy ML applications. Now, Amazon EC2 delivers the broadest choice of compute, networking, and storage services purpose-built to optimize price performance for machine learning projects. Now, coming to the next part is how do we provision our EC2 instance. Now, Amazon Machine Image or AMI is supported and maintained image provided by AWS. It is basically a template for your instance to be launched. Firstly, we need to create an Amazon Machine Image, like I explained a while ago, which is nothing but a template for your software operating system. Secondly, we choose our instance type. We have already looked at a table of different types of instance in the previous slide, and basically the type is saying how powerful you want your machine to be, how many CPUs, memory storage, or GPU you want to have. Thirdly, you will configure the instances, how many instances you want, which subnet you want it to be, assigning your IP address, then its shutdown behavior, where you can stop, pause, or terminate your instances. Now, when you start an instances, it has to have an operating system, and that's a disk, which is basically a storage, and that storage is an EBS volume. When we launch an instances, we can add a tag. They are value pairs which allow you to simply identify your instance and classify it. And lastly, you review your instance. Launch detail. You can go back and edit changes for each section, or you can click launch to complete your process. This is just an overview on how to launch an EC2 instance, which I have already showed you guys with a hands-on demo. So in the next slide, we shall understand what is load balancing. In this video, I will only give you guys an introduction as to what is load balancing, since the topic itself is vast. So getting back to the topic, what does a load balancing does? Elastic load balancing automatically distribute your incoming traffic across multiple targets such as EC2 instances, containers, and IP addresses in one or more availability zone. What it means is that, say when you are streaming Netflix in India around daytime or evening time, the traffic will be huge. Since a lot of people will be streaming at the moment, what a load balancer does is it manages those traffic and distribute the load to another server, which is available in different region or zone, and increase the number of EC2 instances so the load is balanced without disrupting the overall flow, and it increases the availability and fault tolerance of your applications. Now, the next thing that we are going to discuss is auto scaling. Just as the name suggests, it monitors your application and automatically adjusts capacity to maintain steady, predictable performance at the lowest possible cost. So in order to understand what that means is, let me give you an example. So in the daytime, a lot of people will be using the server. When that happens, autoscaling simply monitors and add more EC2 instances. So the server can perform its tasks without failing, and when it's around midnight, the amount of people using the server will decrease, so the requirement of server is also decreased. So autoscaling scales out the extra server which is not required and scale up again if a lot of user is using it again. So that is basically what an autoscaling and a load balancer does. Now coming to the architecture, we will understand how we launch an EC2 instances. The first thing you need to do is select the region, whichever it's closer to you. Then we have a VPC, so we are simply using the default VPC in this case, and we have the availability zone. And each VPC has a number of public subnet. In this case, we can use 2. We can also have just one subnet. Now, if you guys are wondering what is the difference between a public subnet and a private subnet, in a public subnet, we attach an internet gateway and we have a routing table which point to that internet gateway. And our EC2 instances have public IP addresses. Those are the 3 things which you need. First, the EC2 instance must have a public IP addresses. We need to have an internet gateway which is attached to a VPC, but you need a route table entry which points to the internet.
So let us move further and talk about ECS a little more. It is a highly scalable, fast container management service, which makes it easy to run, stop, and manage Docker containers on a cluster, which actually lets you host your cluster on a serverless infrastructure. So let us talk about these terms as I always do. Let us discuss them, decode them, and break them into smaller chunks and try to understand them a little more. It is a highly scalable, fast container management service. So basically, it lets you manage your containers. As I've already mentioned, when you talk about Docker, you're talking about containers. So this service basically lets you manage those containers, those Docker images, and lets you deal with them a lot better. And the fact that it is highly scalable and it is fast, it meets in the changing needs of the applications that are there. I mean, if you wish to scale up, scale down, have more RAM, have more space, and stuff like that, it lets you deal with those because AWS is highly adept in providing you with the needs, or actually providing you with the requirements that you actually have. So yep, it is highly scalable, it is very fast, and it lets you manage your containers. What it does is it makes it easier for you to run, manage, and stop your containers whenever you wish to. And the fact that these containers, they run on top of a cluster, so you have a cluster which is nothing but, basically think of it as, again, a bigger container that lets you manage your containers better. What a cluster is, what do these things are, or what do these things mean? I would be talking about those in detail as we get into the demo part. But meanwhile, that is what the definition says. And the important part here is, and the important part in this definition is, it basically lets you host your clusters on top of serverless infrastructures. What is a serverless infrastructure? Basically, it is a place where you never get to know. That would be a wrong term to use, never get to know. I would say you are never required to worry about your servers. You're upscaling, downscaling, maintaining and monitoring your servers. Somebody else does it for you. So that is not your concern. And that is why we call these infrastructures as serverless infrastructures. Your AWS EC2 is a very common example for that. So guys, let us move further and try to understand some of the other terms, or let us just actually go ahead and move into the demo part. So probably we can understand these terminologies and the topics that I've been talking about in a better way. So guys, what I've done is I've actually gone ahead and I've switched into my AWS console, and this is how it looks like. This is what I tell in all my sessions. For people who are completely new to AWS, they can actually go ahead and create a free tier account, and they can have access to this portal for free for 1 complete year, where most of the services are free under certain limits. I mean, if you basically cross those limits, you would be charged, but if you stay in those limits, you would not be charged, guys. So if you're interested in practicing AWS, definitely those limits are enough, and I would suggest that you create a free tier account. How do you do that? Go to AWS free tier or search for AWS free tier on your browser, and then probably try to sign up or create an account. They would ask you to enter in details like, why do you want to use this account, who are you, and some other details. And then they would ask you to give in your credit card or debit card details. Yes, these are mandatory, guys, because if you exceed those limits, you would be charged, but that happens very rarely that you would exceed those limits. Plus, you can have certain alarms set that tell you that, okay, you're crossing a particular limit. If you wish to know more about that, you can take a look at our video called as AWS CloudWatch, which talks about these things in a lot more detail. So once you do have an account, you can join me back here and we can get started with this session. And the fact that I was suggesting you a video, one thing that also reminded me that I should suggest you is the fact that you can actually go ahead and take a look at one more video that we have, or 2 more videos that we have. One is, I think it is called as virtualization or virtual machines tutorial by Edureka, which basically talks about virtualization in general. And you can also take a look at one more video called as Docker on AWS, which talks about quite a few terms, that is containers, virtualizations, in a better depth or in more depth, so that you can probably understand those concepts in little more detail in case if you've not understood those in this session. Having said that, guys, now let us just go ahead and try to understand how you can actually go ahead and run your Docker images on top of ECS, which is Elastic Container Service. So how do we go there? We searched for it. We type ECS and it would take you to your ECS service. Again, guys, if you are completely new, this is how the console or your first page would look like. So if you've created more applications here, those would be visible. So the fact that this is a fresh account, let's just say get started. So guys, this is what we are going to do here. We are going to go ahead and create a container definition, task definition, service, and cluster. And then we are going to run our container on top of our cluster. When I say a container, you can think of it as your Docker image basically. So guys, what am I doing here? I'm basically actually going to go ahead and choose an image for my container. There are quite a few options. You can use your Nginx. You can actually use a Tomcat web server. You can actually go ahead and configure as well. If you click on this configure, you'd be entering quite a few details manually. If you wish to skip that, you can actually go ahead and use this image in general. Now, let's just go ahead and do that. It is a sample app. It says HTTP 2.4. Memory is half a GB, and that is the CPU details. So I select this and I scroll down. What is a task definition? It is a blueprint for your application. It describes one or more containers through attributes. Some of the attributes are configured at the task level, but majority of them actually get configured as per the container. So these are some of the parameters that are at concern. That is your definition name, network mode, your execution role, compatibilities, memory, and the CPU. So I say next. The number of desired tasks, I would say 1. And security group, well, let that be created automatically. And load balancer, guys, if I'm experiencing more traffic, I would want to balance it better. So your load balancer does it for you. Listener port is 80 and HTTP. Now these are networking details. I hope you are aware about it. And then I say next. So guys, by now we have our container definition and task definition. We now actually need to go ahead and configure our cluster as well. So let us just go ahead and give it a name, say sample for today. Forgive me guys, I'm bad at naming. Do I need to review the details? I'm just gonna go ahead and say create. So now guys, it would prepare somewhere around 10 services or 10 operations rather. So these are the operations that are happening here, and it might take a little longer than normal. So let us just hope that it happens quicker. If not, I'm gonna pause this video meanwhile, and once it gets up and running, I would get back to you. So guys, as you can see, we've actually gone ahead and run all the services that I mentioned, 10 out of 10. And this is what it has done. Additional service integrations, log group, you have CloudFormation stack, then you have basically your VPC, subnet 1, subnet 2 security groups, load balancer. So guys, a security group is created that takes care of security. Your load balancer ensures that all the traffic gets distributed evenly in case if there is a lot of traffic. You have your VPC that helps you connect all the instances that are there inside a particular network. You have your cluster, you have a task definition, you have your service, and quite a few other things. So guys, let us just go ahead and view the service that we've launched. If you come here, you would actually get a lot of details, like what task is running. You have your event details here as well, auto scaling groups if any, and what are the deployments that have happened, other metrics if any, what was the CPU utilization and stuff like that. So there would be a lot of things that would be under concern. For now, let us just go ahead and see how the application looks like and stuff like that. Before that, you have your cluster details here. You have your task definitions, EKS, that is for some other session. You have your clusters, you have your repositories and stuff like that. So if I just go ahead and click on this particular icon, not the icon, the link rather, there you go. I would be redirected here. If I just scroll down. So guys, basically this is your load balancing group that is here. And these are some of its basic configurations that are there. This is the name. This is the ARN that is there, which concerns this particular service, the ports and all that we've already assigned, VPC and your load balancer. These are some of its attributes that are there. We can actually go back or scroll up, and probably we can not scroll up. Let's just come down here somewhere. Yeah, description. You're actually gonna go ahead and take a look at some of the targets that are there. These are your availability zones that you can do. You have your health checks that are constantly shown, as in how healthy your service is. Some monitoring details again here if you wish to. CloudWatch gives you the details. I've already mentioned that it would also help you actually go ahead and set alarms that if you wish to, and you can just go back here. Okay, let's just go ahead and search for ECS again. There you go. So your cluster is here basically, guys. These are the other details. It is sample for today, bad name. We've launched it using Fargate. It works in tandem with your ECS, and these are the running tasks it says, and the number of services that are there. So you can just open sample for today. So yeah, this is the details about all the services that are there. And then you have your load balancer, which would let you actually go ahead and confirm whether your application or your container is up and running or not. So if you kind of scroll down here, there would be a DNS here which you can copy and you can put it here, and there you go, your application is up and running. So guys, this is how you actually go ahead and create a container, and basically you deploy that using ECS, and you can deploy Docker images. You can actually go ahead and deploy quite a few other types of applications and containers using ECS. One more thing that you need to know, guys, is you actually need to go ahead and delete your applications when you're actually using ECS service, or you're actually going ahead and using AWS. It is very important you understand the importance of deleting your services, because if not, you might be charged. We've actually gone ahead and configured a load balancer as well, so we need to delete quite a few things here. So this is our application, right? So if we come here, my application, what are the options that I have? I can say update, and number of tasks is 1. Set it to 0 so you do not miss out on anything important. Say next, next. So the service is updated. Let's just go to sample app service. The problem for me is navigating between these services, guys. I'm actually not used to using this interface a lot, and it kind of makes it irritating for me to actually go ahead and do all these things. So I'm just gonna go ahead and now select this and say delete. Say delete me. So this application would be deleted. Once you do that, you go back to your cluster, guys, and you can actually go ahead and delete your cluster as well. Where is the option to delete your cluster? Go to this sample for today and delete the cluster. So deleting the cluster takes a longer time than quite a few other things. Once you've deleted this, guys, you can go to your services, go to EC2 probably, and in the left side panel, you'd be given an option as in something called as load balancers. You can delete the load balancer there, and probably all the required tasks are done.
What are containers? Containers are an executable unit of software in which application code is packaged along with its libraries and dependencies. So it can be run anywhere, whether it is a desktop, traditional IT, or the cloud. Containers are small, fast, and portable because, unlike a virtual machine, containers do not include a guest OS in every instance. Now, as I've mentioned about virtual machine, let us take a look at container and virtual machines architecture. Here, virtual machine has a host operating system, its infrastructure, and a layer called the hypervisor, which is a software that creates and runs the virtual machine. Then it contains the guest operating system, which is the virtual copy of the hardware that the OS requires to run, along with that application and its associated libraries and dependencies. Now, when you look at containers, instead of virtualizing the underlying hardware, containers virtualize the operating system. So each individual container contains only the application and its libraries and dependencies. The absence of the guest OS is why containers are so lightweight and thus fast and portable. And also, container runtime is a software that executes the containers. Now that you have an understanding about what are containers, let us move on to the next topic and see containers on AWS. Containers on AWS can be divided into 3 categories: registry to store container images, orchestration that manages when and where the containers are run, And the third category is flexible compute engines to power the containers. Now let us discuss about these one by one in details now. First, in orchestration, we have Amazon ECS. Amazon Elastic Container Service is a highly scalable container management service that makes it easier for you to run, stop, and manage containers on a cluster. The containers in ECS are defined in a task definition that are used to run individual tasks or various tasks within a service. The task definition can be thought as a blueprint for your application. Now, to run your application on Amazon ECS, you must create a task definition. The task definition is nothing but a text file in JSON format that describes one or more containers that form your application. And here you can have only up to 10 containers. Now let us take a look at the working of Amazon ECS. Now you can see Amazon ECS schedules your task, which is usually done by Amazon ECS Task Scheduler. They are responsible for scheduling or placing your tasks within the cluster. Now you can see all the containers run within the ECS cluster. An ECS cluster is nothing but a logical grouping of tasks or services. And when you first start using ECS, a default cluster is created for you. Now you can see the container agent or the ECS agent runs on each container instances within an Amazon ECS cluster. The agent sends information about the resources current running task and resource utilization to Amazon ECS. Now the container images are then downloaded and stored in the container registry. The container registry could be Amazon ECR, Docker Hub, or a self-hosted registry. Now let us move on and take a look at Amazon EKS. Amazon Elastic Kubernetes Service is a managed service that can be used to run Kubernetes on AWS. And you can do this without needing to install, operate, or maintain your own Kubernetes control plane or nodes. Now let us first understand what is Kubernetes, then we can see what are the control plane or nodes. Kubernetes is an open source system for automating the deployment, scaling, and management of containerized applications. Kubernetes works by managing a cluster of compute instances and scheduling containers to run on the cluster. So in Kubernetes, containers run in logical grouping called pods. So you can run and scale one or many containers together as a pod. Now Kubernetes control plane software is a software which decides when and where to run your pods. They also manage your traffic routing and scale your pods based on utilization or other metrics that you define. Kubernetes will automatically start pods on your cluster based on the resource requirements and automatically restart pods if there are any instances that are running on fail. Now the advantages of using Kubernetes is because it is an open source project, you can use it to run your containerized applications anywhere without needing to change your operational tooling. These were the orchestration management tools. Now let us have a look at Amazon Elastic Container Registry. Now this is a fully managed container registry that makes it easier for you to store, manage, share and deploy your container images. Now if you're wondering what is a container image, it is an immutable file that contains the source code, libraries, dependencies, tools and other files needed for an application to run. Now due to its read-only quality, these images are also sometimes referred to as snapshots. Now the advantages of using Amazon ECR is you do not have to worry about operating your own container repository or scaling the underlying infrastructure. Amazon ECR will host your images in a highly available and high-performing architecture, which will allow you to reliably deploy images for your containerized applications. You can also share your container software privately within your organization or publicly worldwide for anyone to discover and download. Now let us move on to the next management tools, which are Amazon EC2 Instances and Amazon Fargate. Amazon Elastic Compute Cloud or EC2 is a web service that provides secure, resizable compute capacity in the cloud. The advantages of running your containers on EC2 instances is you have complete control on the compute platform. You can select the operating system, the memory required, the CPU, and many more. The billing is based on the cost of underlying EC2 instances. It allows you to optimize the process by taking advantages of billing models like spot instances or reserved instances. And you can also increase or decrease your computing capacities within minutes. Now on the other hand, we have AWS Fargate. Fargate makes it easier for you to focus on building your application. It removes the need to provision and manage servers. It will let you specify and pay for resources per application, and it also improves security through application isolation. The advantage of using Fargate is it will allocate the right amount of compute, eliminating the need for you to choose instances and scale cluster capacity. In Fargate, the billing is based on CPU or memory requirements per second. These were the container management tools on AWS. Now let us move on to the next topic and see some of the advantages of running containers on AWS. The first advantage is security. AWS offers 210 security, compliance, services, and key feature, which is 40 times more than the next largest cloud provider. It also provides strong security isolation between your containers, which will ensure you're running on the latest security update and give you the ability to set access permission for every container. The second advantage is it is reliable. AWS Container Services run on the best global infrastructure with 77 availability zones across 24 regions. They also have service level agreements for all their container services. The next advantages would be it gives you a variety of choices. It offers choices of services to run your containers. You can choose AWS Fargate if you want serverless compute for containers, or Amazon EC2 if you need complete control over a compute environment. You can also choose from ECS or EKS for container orchestration. AWS Container Services are deeply integrated with AWS by design. So you can use various AWS services. For example, for load balancing, you can use Amazon Elastic Load Balancing. For monitoring, you can use CloudWatch. For networking, you can use VPC and so on. These were just some of the advantages of running containers on AWS. Now let us move on to the next topic and see some of the use cases for containers on AWS. The first use case is microservices. Containers provides process isolation that makes it easier for you to break apart and run application as individual components called microservices. The next use case is batch processing. You can pack batch processing and ETL jobs into containers. Now if you're wondering what is ETL, ETL stands for three different terms, which is extract, transform, and load. This will allow you to start your job quickly and scale them dynamically in response to demand. The next use case is machine learning. You can use containers to quickly scale machine learning models for training and run them close to your data source on any platform. Moving on to a fourth use case, which is hybrid applications. Container lets you standardize how code is deployed, making it easier for you to build workflows for applications that run between on-premises and cloud environments. The final use case for today is application migration to the cloud. Now, container makes it easier for you to package the entire application and move them to the cloud without needing to make any code changes. These were some of the use cases for running containers on AWS. Now let us move on to the demo part and see how can you deploy a container on AWS. Now for the demo, let me switch to the AWS console. Now we'll start by searching ECS. Here it is. Now this is what the Amazon Elastic Container Service page looks like. So when we scroll down, we can see some of the advantages of ECS. It says you can run containers at scale. It provides flexible container placement and it is integrated and extensible. Oh, let's get started. Here we can see a diagram of ECS object which contains the container definition, task definition, service and cluster. We will look into this one by one. So first we have container definition. So container definition is choosing an image for your container. So you can start quickly and define your container images. So these are some of the sample container images. You can edit it from here. You can change your container name and also the container image. Next we have private repository authentication. It is an authentication for your private repository. So if there is a container image you want to pull from it, you should mention your secret manager ARN or the name of it. Next we have the memory limit, which is set to 512 MB. And after that we have port mapping. Port mapping is nothing but which allows your container to access port on the host container. Let us not make any changes in that and move on to the task definition. As I've mentioned before, task definition is a blueprint for your application. So here we have the task definition name and the network mode. The network mode is the Docker networking mode used for the container. Next we have the task execution role, which is the IAM role used by your task. The compatibility is the launch type you use. In this case, it is Fargate. You can also use EC2 instances. Next, we have the task memory, which is 0.5 GB, and the task CPU, which is 0.25 virtual CPUs. Now, if you want to make any changes in this, you can just click on edit and you can make some changes. But now I do not want to make any changes, so let me click on next. The next step is you define your service. A service allows you to run and maintain specified number of instances of task definition. For example, you can run and maintain 3 instances of task definition in an ECS cluster. Here you have your service name, which is sample app service, and the number of desired tasks is 1. Application load balancer distributes the incoming traffic across the various tasks running in your service. Now, if you do not want to use a load balancer, a security group is created to allow all the public traffic to your service only on the container port specified in the previous step. But if you want to use an application load balancer, 2 security groups are created to secure your service. In today's demo, let us not create any load balancer, and we'll click on next now. The last step is to configure your cluster. As I've mentioned before, clusters are logical grouping of tasks or services. First, we have the cluster name. Now let us change it into Edureka ECS. Next, we have the VPC ID and subnet, which will automatically be created. After we set this, now let us click on the next button. We will have to review our details now. Everything looks good. Now let us move forward and create our own container. We click on the create button here. Usually creating a service might take up to 10 minutes. Here you can see your cluster name, your task definition name, and in some time even your service name would be visible over here. And you can also add additional features after your service is created. Now you can see 7 out of 9 is complete. We're just waiting for 2 more. Now the loading is complete. Let us view our service. We click on view service. And here we have the detail of our service. Here we have the cluster name, the status, the task definition. We also have the launch type, which is Fargate, the service role, and is created by whom. As we have not used load balancing, you can see we have no load balancer. Here are the network access details. Now when we click on task, it will show you that there is 1 running task. And when we click on events, the first event is the task is started, the second is deployment is completed, and the third is it has reached a steady state. Now under auto scaling, you can see there is no auto scaling resources configured for this service. So moving on, we'll see what is deployments. Deployment consists of the task placement and the service deployment options. And in metrics, we have the CPU utilization and the memory utilization. As I have not assigned any tags, so even this would be empty. You can click on logs and see at what time what task was running. So now let us go to task and click on our task. Now here we just have to copy our public ID and paste it in a new window. Here, now your application is running on a container in Amazon ECS using Fargate. So this was our demo application. Now let us go back and see how you can delete the service and the cluster. Now just click on cluster over here. So here you have your cluster name and it is running on Fargate, and you can see the running task is 1 over here. So now let us click on the cluster name, and we have an option here to delete our cluster. So we click on this and type in delete me, and then click delete. This process might also take a few minutes. Now we get a confirmation message saying deleted cluster, your cluster name successfully. Now this is how you delete your cluster.
So what exactly is Docker? Now first, let us take a look at the basic definition, as in what does the definition has to say. Now, as far as the definition is concerned, it stands for a tool that basically lets you create, deploy, and test applications in different environments. Now, the second line here is very interesting. It says that it is nothing but containers which are lightweight alternatives to virtual machines, and they let you do that on one single OS. Yes, now for people who are completely new to Docker, they might wonder what virtual machines are, what containers are, And what am I talking about? Creating, deploying, and running applications in different environments. Well, to understand this particular term or these terms, let us first understand what virtualization is. And probably all these terms would make a lot more sense to you people. So let us first understand what virtualization is. Now guys, if you talk about virtualization, this is the scenario that existed before virtualization actually came into picture. Now, to consider computing or to consider software usage or development, we all know that we need a hardware on top of which we have a software and on top of which we run our applications, right? As simple as that. We all use laptops, computers, systems. So what we do is we probably have a system which is your hardware, on top of which you have an operating system which is a software, or basically an operating system which actually lets you go ahead and use your applications, whether it's your Java application, playing some games, playing music, whatever it is. For that, you need a basic operating system, which is a software. So when you talk about software development, this is what you need. You need a basic infrastructure, a hardware, on top of which you have an operating system, and on which you basically run applications. But when you talk about software development, it is not that simple. I mean, you're talking about a number of applications, a number of processes. Let us consider Amazon. Now, when you talk about Amazon, whether it's the e-commerce website, whether you're talking about Amazon Web Services, or the various applications they host on top of their platforms. Now, all these applications, they basically have so many parallel applications or small applications running. I mean, e-commerce website, for example, there you have your billing section, you have your different product section, you have customer service, and a number of other sections, right? So having a monolithic application actually makes our architecture very difficult to use, and also for the people who are monitoring it, maintaining it, it is a tedious task for them. The other disadvantage of this particular architecture is that the fact that there are multiple applications or multiple processes running on a single architecture, what it does is it kind of makes all those applications dependent on that particular infrastructure. Suppose if I wanted to use like multiple operating systems or different operating systems to run different kind of softwares. So if I was bound to a particular infrastructure, I wouldn't be able to do that. So what virtualization does is it basically lets you use one infrastructure on which you can run virtual softwares or have virtual environments running parallelly, so that you can run different operating systems. To give you a very simple example, we have our laptops, right, in which we have operating systems. What if I wanted to run multiple operating systems? Probably if I can install a particular software, something like a virtualization software, what that would do is that would basically let me run multiple applications on that particular hardware. So this is what virtualization does. It lets me run multiple operating systems, multiple kind of applications in a single environment. But the best part about it is when I'm using it as an individual, I do not realize that I'm working on a virtual environment. Instead, it feels like I'm working on a single system. That means if I'm using an operating system, say Windows, and running a particular software on it, parallelly if I have one more instance on which I'm running maybe a Mac OS, what I would feel is my Windows OS is running on a different system and my Mac OS is running on a different system. But that is not the case with virtualization. It is actually giving you that feel, but the underlying architecture is one, on top of which you are running multiple operating systems and multiple softwares on top of that. Now, if you actually go ahead and take a look at the architecture, this is what it looks like, virtualization in particular. Now, if you talk about a particular virtual machine which runs or is based on virtualization, you would be having a server host, that is your basic hardware, on top of which you'd be having a host operating system, and then a hypervisor. Now, what is a hypervisor? Your hypervisor is a middleware or a middle layer. Now, this hypervisor basically it acts as a middleware that communicates with your host applications, not host applications, your host infrastructure basically, and it also communicates with the operating systems or the applications that you want to run on top of it. So what a virtual machine does is it gives you the basic infrastructure, which is must. I mean, no matter what kind of application you are running, you need a basic infrastructure, that is your server where you can actually go ahead and host your applications, and on top of it you have your host operating system. So what virtual machines do is, using this hypervisor, they let you run n number of different virtual machines, which would have their own guest OS, which would have their own binaries, libraries, and applications that run on it. So what this approach does is, this basically helps you in to a certain extent where you can actually save in some money and some time as well. I mean, instead of having n number of machines running parallelly, you can have one machine, and on top of that machine you can have various virtual machines. So you're actually saving up costs for running various hardwares or various servers. Instead, on one server you can have various virtual machines. So yes, you're saving costs as well, and the fact that you can switch between different OSs and different instances or environments, that also helps you save time. But again, is this the most efficient way? For certain applications, definitely yes. If you need privatization, you need more private approach towards your applications, towards your operating systems, towards your binaries, libraries, then yes, virtual machine is a good approach. But in case if time is something that is very important to you, probably you wish to save more space, in that case you have a better option. That option is your containerization. Now take a look at this diagram, and probably I would again get back to virtual machines and have a discussion on these topics. Now when you talk about containers, it is similar to your virtual machines. Yes, so here too you have basically a server and a host OS. I mean, that is understandable. As I've already mentioned, you need an underlying architecture. So that is what you have. But on top of it, you do not have a middleware. Instead, what you have is you have a Docker engine. And the best part here is you do not see a guest OS. Directly what you see is you see containers instead of your virtual machines. And even in those containers, what you see is you see your applications, you see your binaries, you see your libraries, and those things. So how is containerization better? Well, what containerization does is it actually saves you from certain factors, like you do not need a hypervisor, you do not need a guest OS here. So that means the process, that is your virtualization process, in which virtual machines spawn a completely different guest OS, that takes time. But in case of your containers, that time is saved. How? Because you do not have guest OSs here. So if a virtual machine takes, say, certain minutes to launch, your so-called container would take seconds to launch. So yes, you're saving time, and the fact that you're not using extra resources. I mean, if you are spawning a guest OS, some space extra would be consumed and would be occupied. That is not the case with containers. So if you talk about more efficiency, yes, containers in certain aspects are more efficient. But again, guys, do not mistake me for the fact that I'm saying that containers are better than virtual machines. No, that is not the case. It depends upon the applications. What kind of applications are you using? For certain applications, virtual machines are better. For certain applications, containerization is better. So containerization or containers basically are good enough when you talk about speed, or you need faster deployment, faster creation and testing of applications. So in that case, containers serve much better. So again, what are the exact differences? Where should you use virtual machines and where should you use containers? Well, that is not the discussion for today. For some other time, probably we would have discussion on those topics. For now, our main focus is containers and Docker. So this is what a container is, and I believe by now you have a clearer picture as to what a container is, and if you go back, you would be able to relate to this definition in a much better manner. So back then I said that Docker is a tool which is designed to make it easier for you to create, deploy and run your applications. Now using containers, that actually becomes true. And the fact that containers are lightweight alternatives to virtual machines, probably this sentence is making a lot more sense to you people now. So yes, this is what Docker is. It basically lets you spawn these containers using which you can actually create, deploy and run your applications much faster by using containers. So again, what is the other benefit, or what is the anomaly that Docker containers overcome? Now, if you all know what DevOps is, which is an approach that brings in developers and operations team, what DevOps strives at is basically bringing in these two teams. Why? Because developers normally develop softwares and operations team probably maintains those softwares. So when you talk about maintaining that particular software, what happens is the software that is developed in your development environment might not work in the production environment. And one of the reasons for that is probably the change in environment in which you're running the software. So this is not the case when you use containers. Why? Because your container is nothing but it is a limited object, or think of it as a limited box in which you only have your binaries, in which you only have your application details or code. So basically when you pick up this container and if you run it on any machine that supports Docker, probably your image would run the way it ran. So testing your images, or rather your applications, becomes much easier when you use a container. So this is what Docker is, and this is what it lets you do. So by now we've already discussed what Docker is, we've understood what virtualization is, and we've gone through what containerization is. The fact that we are talking about Docker and we are talking about using it on AWS, let us try to understand AWS a little more so that we can probably relate Docker with AWS a little better. So let us not waste any time and quickly just switch into the demo part, shall we? So guys, this is what the AWS console looks like. Now, again, for people who are completely new to Amazon Web Services, let me tell you one thing, that Amazon Web Services gives you a free tier account using which you can actually go ahead and do quite a few things. You can understand how cloud computing works. You can actually host your applications. You can load balance those, scale down those applications, and a number of other things. You can set up networks. You can actually create security groups, make sure that all these services are secure, and quite a few other things. So yes, for people who are completely new, I would suggest that you actually go ahead and create a free tier account on Amazon Web Services. Now, these services are made available to you for free for 1 complete year. Yes, what Amazon Web Services does is it probably gives you certain services for free for certain duration. And if you exceed certain limits, only then you are charged. Otherwise, if you stay in the limit, you would not be charged for 1 complete year, and which I believe is more than enough if you just have to go ahead and practice these services or get sufficient hands-on on Amazon Web Services or cloud computing. So again, if you do not have an account, just go ahead and create an account. Do you need any details to create this account? Probably you'd have to visit the console. Just type Amazon Web Services console or Amazon Web Services free tier, and you can click on the first link that is available and you would be redirected to this page. This is not what it would look like. Instead, what would happen is basically a sign up page would come in where you'd have to enter your email ID, maybe what is the purpose that you're visiting this particular website, and probably they would ask you to enter in your credit card or debit card details. Do not worry, AWS won't charge you without your consent, and probably you can set in your alarms as well so that you do not exceed the limits that you use. So having said that, I would want you all to have an account on AWS because it is a very fun and nice platform to work on. So once you do have an account, this is what you have at your disposal. Let's have a quick introduction to what are the services that are here and what all can be done with it. Once we are done with it, we'll probably jump into the Docker part and we would see what we can do with Docker on Amazon Web Services. So guys, as you can see, there are quite a few services here. There are compute services. You have your EC2, Lightsail, ECR, ECS. We would be using ECS today, and to some part I would be talking about EC2 as well, which is your elastic cloud compute. I talked about virtualization, right? So what virtualization does is basically we create virtual machines. So cloud computing, or AWS in particular, lets you create virtual machines as well. And instead of calling them virtual machines, we call them instances here. So you can launch multiple instances, or basically environments on top of which you can run applications. So one way to actually go ahead and host your Docker applications or containers is you can actually launch an EC2 instance, and on top of it you can actually go ahead and probably install Docker and then host containers or have containers which you can run to run your applications. So that is the old school method where your EC2 acts as your system on top of which you're gonna go ahead and play with your containers. The other way is your ECS and AWS Fargate. Now these services, what they do is they completely cut off the process where you have to go ahead and spawn an instance on top of which you have to create security groups and do a number of other things. So in this session, we would be doing both the things. First, I would show you certain things, as in how do you get started with your Docker in EC2, and then I would switch to Fargate so that you understand Fargate in a better way and you understand why do we actually need to use Fargate. So let us do that. Let us just go ahead and launch a simple virtual machine. not a virtual machine, rather an instance using EC2. So if you click on EC2, this is what you'd be redirected to. You can launch an instance by clicking on this icon. So as you can see in the marketplace, you have quite a few options. You can choose AMIs. AMIs are nothing but images. Basically, when you create a template or create an operating system, it has a by default template which AWS saves as in the form of images. So these images are nothing but templates for your respective environments or operating systems which you might want to use. Now, when you talk about Docker, it has to be on Linux. I mean, yes, there is a way you can do it on Windows as well, but preferably it is Linux. So let us just go ahead and launch a Linux instance first. So this is a free tier eligible. That means I won't be charged if I launch this instance. So I do that. And then there are certain details. What is the family of your instance? There are quite a few families. You have T2 micro, you have various other actually families which you can actually go ahead and explore. Now again, if we keep discussing those families, this session would go too long. So let us just stick to the basic or the free tier resources that we have. You can actually go ahead and explore these resources if you want. If I go to the next button and I click on it, it would show me some other settings. For now, my main concern is this part. Yes, the security group. So when I launch an instance, I need to log into my instance to maintain security. So you have certain security groups which ensure that these are the rights users have when they try to access these kind of instances. So we need to actually go ahead and set up a security group to some extent. So there is one rule which says that I allow traffic from SSH. Protocol here is TCP, and this is the port it is using. I can actually go ahead and add one more rule. I can say HTTP. There you go. And allow traffic from anywhere basically. Now I can say review and launch. In order to sign into my instance, I need a key pair, which is a security measure. So I need to create a a key pair rather. And make sure one thing, guys, that if you do create a key pair, you save it properly. So say, let us name it, say Sam new. I'm very bad at naming conventions, guys, so please forgive me for that. Again, guys, you have to take care that this key pair is well maintained. You do not lose this key pair. So if you do create one, you just need to save it somewhere. And then I say launch an instance. So guys, what is happening here is my instance is getting launched. So once this instance gets launched, I can actually go ahead and install Docker on top of it and do quite a few things with it. Now the reason I'm going through this drill is because I want you to understand what is happening here. So this is like basically going ahead and just creating an instance on top of it, running your Docker and doing all those things, which was very relevant say 3-4 years back. Now there are better ways to do this, but first let us see how do we do it in this particular way. So if I go back to services, I go back to EC2, you can see that an instance would be here saying that there is a running instance which I just created. Let us see whether that instance is launched or it is still getting initialized, guys, but that is not a concern. I can connect it to connect to this instance. So guys, this being a Linux instance, I need to actually go ahead and use a key to log into this instance, and this being a Linux instance, I cannot use this PEM file. It needs to be in PPK format, and to do that we have a software. If you do not have this software, you can install this. It is Putty. So you have Putty software which lets you use this key or convert this key, and to generate a PPK key you need Putty Gen as well. This is the other software. So what you do is you just click on load and you select the file that we just actually downloaded. So it is not here because it is in different format. You can see PEM. I say open, and always save a copy of this key, guys. Do you want to save it? Yes. And what should be the name? Let's say sample12. I say save. So the key is saved here. Now I can actually go ahead and launch my instance. First, let us confirm whether our instance is up and running, whether it has initialized or not. Okay, it is still initializing. let it get initialized, and once it is done, probably we can actually go ahead and connect to this instance. At times this can be troublesome. I mean, you have to wait for certain things. So guys, again, as you can see, I've launched an instance. The launching process is taking time. When you talk about virtual machines, which I mentioned, it takes a while. Why? Because it boots in a guest operating system, and hence this time. I mean, the checks, the quality checks, the initialization process, all these things, they can take a little longer while than normal. Okay. So meanwhile, just let me tell you what we have to do. The fact that we have a key now, probably we can actually go ahead and connect to this instance by using this putty configuration. You have to enter in your host name, and you have to enter in that ppk file as well. So let us see whether these status checks are complete or not. Yeah, as you can see, the status checks are complete. So when I say connect, I get certain details. Now these are the important things. This is the stuff I need to copy. There you go. And I paste it here in this host name. Okay. And then I go back to this place. I click on data, and here, if I come back, the first part before at, I can copy that, and I can just come here and paste it here. Now I need to actually go ahead and select the ppk file which I saved. So to do that, I click on SSH, and in that I click on authorization. I browse, and here is the file. I say open. I say open. Yes. So guys, what it has done is it has launched a virtual machine, on top of which I'm gonna install Docker now. How do we do that? First, let us check whether I am the right person, or I have signed in as a right person. Yes, EC2 user, this is me. So I should say sudo yum update. Why? It would get in the necessary details that are needed to install Docker on top of it. Okay, it is almost done. It should be done soon. There you go. So next, what we do is I say sudo yum install Docker. Okay, I made a spelling mistake here. So when I go ahead, guys, what I can do now is I can just say sudo service docker start. Okay, I'm not doing it fairly well today. Sudo service docker start, and there you go, guys. It has configured your Docker service here. So guys, this is about configuration. I mean, back then when containers were new, this was actually still very fast and very effective. But as I've already mentioned, there are faster ways to do it. Now, by now, what we've done is we've just installed an instance, and on top of that instance, I've actually installed Docker. So that is the only thing I've done. But if I do it using certain services, this process can be speed up like anything. I mean, you do not have to worry about anything. Here we haven't created a cluster, we haven't done almost anything. So let us just go ahead and use one of the services, as in your ECS or your Fargate. Let us see what we can do using those services. So let's just close this for now. Yes. Again, guys, one more suggestion: if you do have your instances or services, make sure you terminate those, because that actually helps you basically save any costs that you might incur. This being a free instance, that wasn't the case, but still, let me just shut it down. I've done that. Now I'm gonna go to ECS. This is a fresh account, so you do not have any applications running here. So let's just say get started. So guys, this is what we are going to do. We're going to go ahead and create an image that is basically your container definition, as in your basic code, your application, whatever you want to run. In this case, we would be using a sample application. Then we would be having a task definition, where this task definition, what it does is it has some other attributes which are not there in my container definition or in my image, to manage my so-called containers or to run my so-called containers. And then you have your service, which tells your cluster or your Docker daemon rather to run a particular container image and use a particular task to do that. So we would be doing all these things, and we would be creating a cluster, and let us see how long it takes now. So guys, there is a sample application. You can actually go ahead and edit. You can use any kind of container definition you want. You can customize it to meet your needs as well. You see there's an option here which says customize. You can do that as well. For now, let us use the basic application, the sample application. So that is selected by default. Task definition, guys. Again, this would be basic or by default. You can make changes here. You can change the name. You can decide what network mode to use. You can decide what execution role you want. If you have any role, you can actually assign that particular role, where you can assign particular properties to it. And what are the compatibilities? In this case, it has to be Fargate, because I would be using Fargate. And this is the task memory that is allocated by default. So let us stick to those configurations, because we do not want to get charged unnecessarily. So yep, this is what it is. I'm gonna say next. Now it says define a service. A service allows you to run and maintain a specified number of simultaneous instances of a task definition in an ECS cluster. Something that I told when we did get started with this particular topic. Number of desired tasks, you can change it, you can edit it, you can have multiple tasks, just to be secure, so that if any of these tasks it goes down, if its health is low, you can actually go ahead and use the other task as well. But in this case, again, let us stick to one task only. Load balancer, if your website experiences high amount of traffic, you can balance that by using a load balancer. Let us create one for sample. So it would be using this port as the listener port, and protocol would be HTTP. So I say next. There you go. And then it says configure your cluster. Should I name it something? Let us say today's cluster. Again, guys, I'm very bad at naming conventions. Please forgive me for that. You have a VPC ID and subnets, which it automatically creates. You can let them do it for now, because again, this is a basic application. So I say next. And it asks me to review all these things. For now, I'm gonna say create, because I know what all details I have entered. So as you can see, guys, it is spawning a cluster and a container for me. And now let us see how long it takes to spawn a container. Now guys, there are 10 processes that are happening here, 3 of which are done. And let us see how quickly the other processes also take place. Again, guys, in this case, we are not worried about anything. I wasn't concerned about probably creating security groups. I wasn't concerned about creating a virtual machine. I wasn't concerned about using EC2. I wasn't concerned about anything. My only concern was, what is the cluster I want? What is the application I want to run on top of it? What is the image I'm using, and all those things. The basic information. And once you enter that basic information, your cluster would be created. Again, creating your images won't take that longer time. Yes, creating clusters might take. Now your cluster can hold multiple containers as well. So yes, certain processes might take a while. So in this case, we can see that 7 services are complete out of 10. Probably we are left with 3 more to go, which should be done very quickly, I'm sure. Maybe say half a minute more. One more thing, guys, once we are done with all these applications, creation of these applications, ensure that you actually go ahead and delete all the resources that you're using and all the services that you've used. And meanwhile this gets done, let us just quickly see something else. If you people are interested in a structured training, now again, on our YouTube channel, we have quite a few videos that talk about these things in detail. Even if you go through those details, probably you would be in a good state to actually go ahead and start with any course that we have at Edureka. But if you're looking for a structured training, probably Edureka would be a very good option, guys. The reason for that is the prices here are very affordable, and those are in real time. I mean, if you do participate in some of our competitions, you might get more discounts, and this price might seem very less. It is in Indian rupees. For dollar price, you can actually call our help center number, and probably they would assist you in a much better way. So this is a 4-week course, and you can see that these are the modules that are covered here, which you are free to actually go ahead and take a look at. So if you're interested in AWS and DevOps kind of a role, probably this is a very good course to take. Apart from that, guys, AWS or Edureka rather provides you with a certification as well, which holds a lot of value in the market. And then they have this 24/7 support. They have their LMS where you can access all these resources for lifetime, and a very helpful support team that actually answers all your queries right away. Having said that, guys, this was about your personal choice. You're free to decide on this. Let us just go back and see that whether it's completed, and you can see that our process is complete and it is up and running. So guys, let us view this service, what it has to offer to us. There you go. These are certain details. You have your task definitions. Again, Amazon EKS is something that you can use for Kubernetes, which is again a container service. This is not the topic of discussion today, so I did not get into details of this particular topic. But when you talk about this particular topic or creating your cluster is concerned, we have one with us, and there are the details, or here are the details about that particular topic. You have your tasks, the tasks that are running. There you go. It is still pending is what it says. Then you have your events. These are the events, your auto scaling groups, your deployments, and all the details that you need. So if I go back here and I click on this particular icon or the link, it would redirect me to this page. And if I scroll down, you can see that I have a load balancer. If I click on it, I have a DNS name here. I copy it and I paste it here. And there you go. It says that I have a sample application and it has been deployed by using a container. So it has created a container. On top of it, it has run this simple application. Now there is nothing much here, basic code. So you don't see anything too real time or too interactive, but there is enough of an evidence which says that an application has been launched and it is running on my container. So there you go, guys. This is what it is. Probably you have all the details. You can just go back and take a look at other things as well. If you wish to explore these services a little more, you can always do that. So let us just say ECS, and now it would show my cluster here, today's cluster. It was a very bad name, but forgive me for that. Yep. So guys, now that we have all these things, Again, if you are doing this for experimental basis, I would suggest that you delete all these things. How do you do that? You click on this icon. First thing that you do is you say update. This is just a security measure. Number of tasks, set it to 0 so that even if you miss out on deleting these, you won't incur too much damage. And then say update. Now that I've updated this service, I can go back and I can just say delete. How do you delete it? You say delete me. And then you say delete. There you go. And it has been deleted. Again, what do you need to delete? You need to delete your cluster as well. So say delete and the cluster would be deleted. It might take a while to delete your cluster. Before that, okay, let's just delete the cluster first. So once the cluster is deleted, guys, your next step is to actually go ahead and delete the load balancer as well, which again is not that difficult of a task. So guys, we are almost nearing the end of today's session. Once we are done with the deletion process, probably we would be bidding adieu to each other. Please let me know in the comment section how did you feel this session was. If you did like this session, please hit the like button and stay tuned with our Edureka channel, because on our Edureka YouTube channel we have quite a few sessions, quite a few videos that go live almost every day. And if you are somebody who likes to learn, who likes to explore new technologies, understand what is up to date in the market, probably you would have a lot of things to digest, a lot of things to learn when you talk about this YouTube channel. So the previous tech probably took a lot of time. As you can see that from 4 to we are just on 5 right now. Probably that was the process which took a longer while to delete. Now we are on 9. Probably we should soon reach 15. There you go. And the cluster is deleted, guys. Now we go back to EC2 console and let us hope that our load balancer is also deleted, because I deleted the application. So with that, the load balancer should also go. If not, we would delete it manually. Yes, it has been deleted. So all our resources have been deleted, guys. We've actually gone ahead and understood what containerization is. We've understood how Docker works and how you can actually go ahead and create a container, a cluster, and launch an application using AWS. And all this happened quickly because of Fargate, and we saw that EC2 took a longer while to do that. So I believe I've talked about quite a few things, and I hope that I've cleared quite a few myths that you people had about Docker and virtualization.
In this video, I'll demonstrate how to use AWS Lambda and API Gateway to create a REST API, showing how Lambda functions are triggered by incoming requests and also display results directly in the browser. Now let's take the example of Netflix, which is one of the world's leading entertainment services with over 260 million members in more than 190 countries, and is transforming its infrastructure with AWS Lambda. Netflix is no stranger to complexity. Each quarter, they deliver billions of hours of videos to millions of customers worldwide. Supporting this demand requires a powerful, agile infrastructure, and Netflix as an AWS customer relies on AWS Cloud Power to keep up. With Neil Hunt, Netflix's Chief Product Officer, leading the way, Netflix plans to use AWS Lambda to create rule-based, self-managing infrastructure to replace outdated, inefficient processes, reduce errors, and free up time. By integrating Lambda, they have set their sights on automating tasks that are once required hands-on management. With Lambda, Netflix now has the potential to improve efficiency, reduce costs, and also deliver a more seamless experience. Here's how Lambda has already helped solve some major challenges. First, we have is encoding media file. Netflix receives huge volume of media files from studios. With Lambda, every new file triggers rules that break down, encode, and reassemble content for streaming. This automation speeds up the encoding process, reducing wait times and manual effort. Next we have is backup for disaster recovery. Previously, data backups were time-intensive. Now, Lambda can trigger backups whenever new data is saved, ensuring all data is backed up automatically and securely, and rerunning failed backups when needed. Similarly, two more problems, security and conformity, and then dashboards and monitors. By building this rule-based, self-managing infrastructure with AWS Lambda, Netflix is turning its vision of a fully automated and efficient system into reality, serving millions of members with a smarter, faster, and more secure service. But how? You only have to spend running the code once. So, there is no wasted resources and no need to worry about under or over provisioning servers. Pretty cool, right? AWS Lambda really helps businesses like Netflix, Flipkart, which handle high-volume tasks without the stress of managing all the infrastructure. Now let's understand what exactly means by AWS Lambda. AWS Lambda is a serverless computing service provided by Amazon Web Services that allows you to run code without provisioning or even managing servers. Alright, let's dive into a demo where I'll show you how to use Lambda function and API gateway to create a REST API. We'll also see how it triggers the Lambda function and how it all works together. Let's get started. Now, as you can see this AWS platform, let's start with the first step. Now let's create a Lambda function. This function will act as our API backend. Now let's go to AWS Lambda service and click on Create Function and name it as New API Lambda. We have the runtime as Node.js. Now let's change the runtime to Python. Let's click on Create Function. For this demo, I'll keep it simple with a basic message response. But in a real-world setup, this function could hold any backend logic for your application. Add the desired functionality for your API in the Lambda function code. For this demo, add code to simply return the message here. By default, we have hello from Lambda. Now let's type into hello from Edureka as well. Moving forward, now click on deploy. So here you can see the deployment is successful. Moving forward, we have to create a REST API in API Gateway. For that, let's go to API Gateway Service in AWS and select REST API. Now, choose New API, name it as My First API and set the endpoint type to regional and click on Create API. Now we will create a method for the API. Select the /resource in the API gateway and click on Create Method. Then choose Get as HTTP method. For the integration type, select Lambda function. Choose the Lambda function created in the previous step, that is, New API Lambda. Click on the Create method. Confirm any prompts to grant API gateway permission to invoke the Lambda function. Here you can see that the API is successfully created by the Get method. Now let's configure the integration and test the setup. If you see here, this is how the API works. First we have the client. The client sends a request to the API. So in method request, the API checks the request like permissions and then an integration request. The request is forwarded to the Lambda function and then comes the Lambda integration. Lambda processes the request and returns a result. Next in the integration response. The Lambda output is formatted for the API. And in the method response, the API prepares the response for the client. At the last in, we have the client. The final response is sent back to the client. This is how the flow works from the client to the Lambda and back. So, we can also test this API. For that, let's deploy the API. In API Gateway, go to Actions, Deploy API, create a new stage. Let's put the stage name as Dev and click Deploy. Now the API is deployed. Now let's invoke the API. Copy the invoke URL from the deployed stage. Paste the URL in a browser like Chrome or a tool like Postman to test the GET request. Here you can see the response as status code 200 along with hello from Edureka. So this is a short demo using the AWS Lambda function and API gateway to create a REST API.
So first up, we have why do we need CloudTrail? So in today's world, business agility is the need of the hour. Now, every company wants business agility. Business agility means to achieve certain business goals by a certain period of time, which is completely improving your efficiency, and it shortens the time you take to complete one job, and therefore it is improving the organization's efficiency. Now, what CloudTrail is essential to simplify operational analysis and troubleshooting. So it is a service which directly contributes to achieving business goals. Next up, we have what is CloudTrail? So CloudTrail is basically a service provided by Amazon which enables the governance, compliance, and risk auditing as well as management auditing for the AWS account. So that basically means that it is a service that lets the user monitor user activity and the host activity about whatever is going on in the account. It might even be about API activity, and that is why CloudTrail gives the user a fair overview of what is going on in the account. Now, next we have the features of CloudTrail. Now, apart from the fact that CloudTrail can be used from any part of the world because of Amazon being worldwide. So when we talk about the feature of multi-regional, what we see is not that AWS itself is something which is global, but the fact that CloudTrail as a service allows the user to basically make trails from any part of the world and any number of trails. There is, though, a certain limitation to the number of trails that somebody can make. But apart from that, there is the choice of making the trails multi-regional, right? Next up, we have event history. Now, event history is a tab on the dashboard in the AWS CloudTrail, which basically helps the user see what is going on in CloudTrail and its integrated services, right? So it basically gives an overview of whatever is going on in CloudTrail and its integrated services like S3, like Lambda, like DynamoDB, right? And it basically shows, and it basically is used by the viewer to see if there is some unnatural activity going on in the account as well. The third feature is an optional feature, which is file encryption. Now, file encryption is basically done by AWS KMS, which is Key Management System. So this basically allows the user to encrypt the logs that are created to basically maintain the integrity of those log files. And finally, we have file integrity. Now, file integrity is a feature of CloudTrail which basically checks for file validation. Now it checks if all the files are not corrupt or not. Any form of corruption in any of the log files will destroy the integrity of the file. Now, these are the features. Now let's come to the functionality of how CloudTrail is working, right? Now, what exactly happens when you switch on, when you go to AWS CloudTrail? So basically, there is some sort of activity that's going on, right? Suppose you basically log into CloudTrail, or you do something, you delete a table with some of its integrated services like DynamoDB. Now, as soon as there is some sort of activity going on, CloudTrail captures these activities and records them as an event, right? And what happens then is these recorded events are then logged and dumped into an S3 bucket, right? What happens further is not just events from CloudTrail are logged and integrated, but as well as its integrated services, DB and Lambda, logged inside CloudTrail, and we can view them in event history as well. So these are the integrated services that was CloudTrail. First, we have AWS S3, which is secure storage service, basically a storage service provided by AWS, which is also with CloudTrail. AWS SNS is simple notification service which is used to basically notify users if there is some unusual activity going on in the account. Then we have DynamoDB. A DynamoDB is a NoSQL database which is also integrated with CloudTrail, and Lambda is similar to DynamoDB as well. So this is an example of how CloudTrail works in tandem with DynamoDB, right? So the first thing that the user does is the user logs into the AWS console, right? After that, they go to DynamoDB and create a table, right? After that, as soon as the table is created and there are certain inputs inside the table, these activities are simultaneously recorded by CloudTrail because of the fact that DynamoDB is completely integrated with CloudTrail, and this happens automatically. So the logs are stored in event history and then can be viewed later by the user, right? So this I will show you in the demo and you'll get a better understanding of how it works. Now this is the event history tab in CloudTrail along with the exporting of DynamoDB data into an S3 bucket. Now this, the second one, we don't think we need, but it's still something that we can do from DynamoDB. Next up, we have the limitations of using CloudTrail. Now, CloudTrail has a lot of benefits, but there are certain limitations to CloudTrail as well. Like we talked about CloudTrail being multi-regional, but the number of trails per region is limited to 5, right? The next one is 2 transactions per second. So 2 transactions per second can happen. That means 2 events can happen, work in tandem at the same time, right? That's a limit though. So the third one is event selectors. Selectors are basically used by the user so that they get to choose which events they want to work with. Now those event selectors are limited to 5 per trial. And finally, we have the event size, which is limited to 256 kilobytes, right? So up next, we have a demo on AWS CloudTrail. So this is basically your AWS management console. And here we can see basically the recent services that I have visited. So here we go to CloudTrail, right? Let's see what's there. Right, here we go to Trails. And we have here 1, 2, 3 trails that are there. So we have a limitation of 5 trails per region. So we can still create a trail, right? And of course, here we see that no data is being logged right now because it costs you extra to keep logging data. And this is a free account. So we go to create trail. Now, the first thing that you have to do is put trail name. Now that can be anything. For example, I can write it as trail X. You can have anything from underscores to @ in the names, but now you cannot have a space in between, right? So here you get an option for creating a new S3 bucket where the log data will be stored, or you can use an existing S3 bucket, right? So I choose to use an existing S3 bucket. So here we go. And here we browse for the existing bucket. This is the existing S3 bucket that I choose. So there's an optional feature called prefix. So this is basically log file encrypted. So this is basically log file encryption enabled, right? So this is encrypted. So this is enabled. I can choose to disable it or enable it. So I am enabling it, right? And let's say another key, KMS3 is my alias, right? So log file validation. So validation means log file integrity will continuously be checked, which is enabled, and notification is disabled. I can choose to enable it or disable it. We'll choose to disable it. So CloudWatch logs is also an optional feature where it allows the user to basically move the logs into CloudWatch, which is another service provided by AWS as well, right? So tags are completely optional here. So next we go to choose events. Now there are 3 types of events. We have management events, we have data events, and we have insights. Management events are free and can be viewed in the event history tab for 90 days, right? They basically show the user of how the management of the resources that are there present in the AWS account, they take place. So they are called management plane operations. Next, we have data events. Now, data events are not free to the user and cannot be viewed in the event history tab. So they are called data plane operations and give an insight to the user about how the data and the resources are being used in the AWS CloudTrail, right? And insights are basically any form of, let's say, unusual activity that takes place, right, in your account. These are recorded as insights. So here only management events are enabled. I can enable insights or not, because management events is the only thing that is free. So all of these data events and insight events will incur costs, right? So here we can both read and write the management events that are there, right? And we obviously don't want to exclude the KMS events because we have enabled KMS. So next up, we see the general details of what our trail is going to be like, right? And then we just go to create trail, and we have our trail X, right? So let's see if that gets logged. Let's go to dashboard. So this is logging data right now, right? Trail X. And as you can see here, it has already been created. So it basically takes some time to, log data into event history tab, right? So this just shows what happened when I logged into the AWS console. It shows me that I have logged into the console. So if you wait for a while, you will see basically what all you can do. So next up, we'll see what DynamoDB does and how it works in tandem with the CloudTrail, right? So let's just go to DynamoDB. So this is what DynamoDB looks like, right? Let's go to tables. Now there are some tables that I've already created, right? And we go to orders. Let's see what's there in orders. To see what's there in the table, we can go to view items, right? So this is one of the items that is there. So there are certain actions that I can take regarding this particular item. So I select this item, I choose to, let's say, delete it, and it's deleted. So there is some sort of change in the DynamoDB table that I've already created, right? So let's go back to CloudTrail and see if this is working, right? There we go. Right. Here we see a lot of things. Here we see that it is S3. So basically here we see what exactly is happening, which bucket I am using to store the logs. Here we see that we have created an encryption key for the encryption of the log files as well. Okay, so in a while, in 5 minutes, you will see that there is some sort of change in the DynamoDB folder as well, because it takes time. It takes at least 5 minutes. That might be a bit long for you, but it takes 5 minutes to basically to see the changes made inside the CloudTrail. Let's just try one more time. Right, so what we can do here is that we can go to trails and stop logging the data here, because what happens here is that you can incur costs if you go on and on. So we'll take the safer option and stop logging the data. But when you go back here, this is what you see. Now this is some activity that is taking place in DynamoDB as well, right? And this is listed as an insight. So it doesn't really know what is going on because there is no data in the table that is there, because there's only one item that was there in the table which got deleted. So there is some sort of insight. So this is basically what CloudTrail demo is like. Next, we come to CloudWatch versus CloudTrail. Now, CloudTrail and CloudWatch are two services that are provided by Amazon. Now, CloudTrail is a management tool which is basically used for the governance, compliance, and risk auditing. So basically, here you can continuously monitor what is going on in your account and your related accounts and integrated services as well. So this simplifies the security analysis, the resource tracking, and as well as troubleshooting, right? while CloudWatch is basically a monitoring and management service which provides data and actionable insights to monitor your resources. So what it does is, unlike CloudTrail, which keeps the requests of all the data in the AWS account, CloudWatch focuses more on the performance and how to optimize the resources that are already being utilized. So it is mostly based on operational health, right? Now, next we see the difference between CloudTrail and CloudWatch. Now, CloudWatch focuses mainly on monitoring the services and reporting their health and performance, while CloudTrail focuses on creating logs for every event that is there, right? Now, in CloudWatch, the user can analyze logs and optimize resources for better performance, right? And in CloudTrail, it is all about compliance support. So all the events are logged and can be viewed by the user to ensure business agility and adhere to certain standards that are there. Now, CloudWatch basically delivers data for 1 minute, in 1 minute for detailed monitoring and in 5 minutes for basic monitoring. While CloudTrail, as I said before, an event is logged into event history every 5 minutes. These logs are then further transported into the S3 bucket every 15 minutes, right? Now, finally, we come to a case study which is about Pacific Interlink, which is a Kuala Lumpur based organization. Now, Pacific Interlinked is an organization which is a diverse organization which is basically into trading, refining, shipping, manufacturing, etc. And they want their services from Asia to go to the global market. Now, they use AWS to deploy their workforces, which is basically using services such as CloudTrail, CloudWatch, and Lambda, which has resulted in excellent business agility for them and substantial savings. So this is a major plus point for Pacific Interlink in using AWS all the time, right? So business agility and resource optimization is the need of the hour in today's world. So there are cost-effective methods for resource utilization in cloud computing, right? Cloud computing is the future and Amazon is the front runner in global cloud services.
So what is Amazon Cognito or AWS Cognito? Now, Cognito is basically a medium which provides authentication, authorization, and user management for web and mobile applications. The users can sign in directly using a username and a password or through a third-party authentication such as Facebook, Google, Amazon, or Apple. Now, Amazon Cognito is a managed service. So it basically enables you to add users quickly from your mobile and web applications by providing inbuilt sign-in screens and authentication functionalities in your app. So obviously, it plays an extremely vital role in application development on the AWS cloud ecosystem. Now, Cognito has three basic functionalities, which is user management, authentication, and synchronization. So Cognito basically takes care of your security authorization and synchronization for your user management processes across devices for all of your app users. It can also be used for authenticating your users through external identity providers, which also includes counting social identity providers like Facebook, Twitter, Google, LinkedIn, so on and so forth if you wanted to. And the best thing about this is that it can also be used to authenticate identities for any solution that is in accordance with the SAML standard. So temporary security credentials can be provided to these authenticated users with limited privileges to securely access your AWS resources. Now, there are two important components involved in Amazon Cognito, which we are going to discuss in detail later in this session. These two components are user pools and identity pools. Now, user pools are basically directories which dispense sign-in and sign-up choices to the application users, and identity pools enable you to grant your users access to other AWS services. Both of these components can either be used separately or together, depending on your nature of requirement. Now that you know a little bit about what Cognito is, you might have gotten the grasp of the fact that Cognito enables developers with secure access to the application's resources. But why Amazon Cognito specifically? Why should you use it? As we all know how important today's security is, especially in the digital world, to have a secure sign-in into the application is the core requirement of the day and age. This is something which cannot be overlooked by the development teams. It may also come unvaryingly tiresome to create custom codes for these user interfaces. Thus, to simplify the whole process, Amazon Cognito comes into the picture. Developers use this managed service that already offers an inbuilt sign-in interface with indigenous AWS security features to monitor and manage activities. Cognito basically creates these plug-and-play options for developers. So with it, developers now have the liberty to maintain the application state, which could otherwise be extremely taxing when end users access apps from multiple devices. And it's not just security. You get consistent experience across multiple devices, which basically means if your application is multi-device, using Cognito would make your life as a developer much easier. Setting up a multi-device authentication using a single user account is especially hard. From a security standpoint, Cognito is built to handle multi-device authentication seamlessly, which enables your users to use the same login on the web and mobile and desktop applications. And in terms of your user experience, as well as ease of implementation, multi-device authentication is a big win for Cognito. Apart from this, you also get the advantage of guest logins and social media logins for users who would like to try out a product or a service before making a purchase decision. Cognito also syncs your guest user data into an actual account when the user decides to go through with full sign-up process. With its integration with third-party authentication systems like Google and Facebook, it provides you more options for your users while signing up for your product. Cognito also allows you to set up password policies to secure your user accounts, which prevents users from setting up passwords. It's usually advisable to force users to set a strong password to prevent them from being vulnerable to security threats. Multi-factor authentication can also be configured using AWS Cognito, which adds an additional layer of security. If your business handles sensitive data, using multi-factor authentication will help secure your data from being accessed by unauthorized entities. And finally, you have the advantage of marketing analytics. Cognito integrates with AWS Pinpoint to provide you with analytics on user behavior, helping you to better segment your audience or your demographic. You can also keep your customers engaged by sending them product-specific information, run targeted email campaigns, and reach your customers across all devices using multi-channel messaging, which includes emails, SMSs, and push notifications. All in all, AWS Cognito offers a complete user identity management system that allows you to build great user experiences for your customers across multiple devices. With a few cons here and there and a lot of pros, AWS Cognito is a great tool to implement a secure and scalable user authentication for your product or service. Now, as I had mentioned, there are two important components involved in Amazon Cognito. You have user pools and identity pools. So first up, you have a user pool. Now, a user pool is a user directory in Amazon Cognito. With this, your users can sign into your web or mobile applications either through Cognito or through your social identity providers like Google, Facebook, Amazon, or Apple. Whether your users sign in directly or through a third party, all members of the user pool have a directory profile that you can access through your SDK. After successfully authenticating a user, Amazon Cognito issues JSON Web Tokens or JWTs that you can use to secure and authorize access to your own APIs or exchange for AWS credentials. Apart from this, you have the Cognito identity pools or federated identities. Now, the Amazon Cognito identity pools enable you to create unique identities for your users and federate them with identity providers. With an identity pool, you can obtain temporary limited privilege AWS credentials to access other AWS services. So the Cognito identity pools support public providers such as Amazon, Facebook, Google, Sign-in, and Apple, Amazon Cognito user pools, OpenID Connect providers, SAML identity providers, and developer authenticated identities. Now that you know what user pools and identity pools are, let's go ahead and set them up on our AWS console. So today we will be setting up AWS Cognito, which is a custom login pool, such as your login with email. Now understand that Cognito is not a login manager for any type of login. It's only for custom logins. As I had mentioned before, what Cognito does for us basically is that it is an identity provider and user directory, all right? So it makes it very easy for developers to add sign-in registrations, sign-out functionality to their web applications or mobile applications. So Cognito basically provides identity tokens for signed-in users for authentication and handles the entire authorization backend for us. So in this particular demo, what we'll be doing is we are going to be creating a Cognito user pool, which is basically a database of users, and then using a client-side library to implement sign-in and sign-out registrations. We're also going to call the various Cognito API methods, and we'll do this all using JavaScript in the front end. Now, Cognito uses JSON web tokens to manage sessions and stores the tokens in a local storage on the client side. So the great thing is that there is no need to manually refresh or manage these tokens, as the library takes care of all of this for us behind the scenes. So for this particular tutorial, I am going to be using a starter app. You can get any starter bare bones app from GitHub, or you can create one using the AWS suite. What I have here is the code to a very bare bones React application. It's just a starter app. So you'll have a basic React application with basically a blank sign up page, registration page, login page, and that is all. So first of all, I am going to navigate to the folder where I want my app to live, and I am going to directly open git bash here. So let me just increase the font size. I hope this is visible enough for all of you. And then I'm going to simply start out by cloning the repository on GitHub where I have my app code saved. So what I'm going to do is I'm going to copy the URL here and git clone. So now we've cloned our Git project into this folder. So we are going to change directories to AWS Cognito demo. All right. So once we are inside this directory called AWS Cognito demo, I am going to install all dependencies using npm install. Now this will surely take some time, so kindly be patient with this. Okay, so now all our packages are added. So now we're going to go ahead and start the application. So npm run start. And this should basically open our application in our browser. So this is basically our homepage. This is what it looks like. And it has a couple other pages. But what we're really interested in here is the login and the registration page. Yeah. The login page is obviously where old users can log into their profile, and the registration page is for newer applicants. This is a very bare bones React.js application. Don't even worry if you've never used React.js. You'll still be able to follow along just fine. This is a Cognito tutorial after all. So now with that, let's go ahead and set up our AWS Cognito user pool in our AWS console. So here, back in the browser, I'm going to go into my AWS Management Console and type Cognito. Now here you can see the Amazon Cognito homepage. Now to initiate a user pool, I'm going to click on Manage User Pool. And as you can see, I just have one user pool. But for this particular demonstration, I'm going to create a new user pool. So I'm going to click on create a new user pool. So first things first, we are going to name our pool. We're just going to call it app pool because it's a pool for our app. So I've got my pool name now. So today we are going to go briefly through all of these steps to create a user pool. We have attributes. It basically is to define the way you want your users, your end users to sign in to your app. Now that is your choice. You can either have your users sign in via email, phone number, username, so on and so forth. So I'm just going to select the first option, which is also allow sign in with verified email address. So my users can use a username and optionally use their verified email address to sign up and sign in. I'm going to leave the rest as is and click on next step. Now the next step is policies. Now this is basically a certain guideline for your password. So we have the standard minimum length of 8, requires numbers, special characters, uppercase and lowercase letters, which is pretty much the norm these days. If you have noticed any of the sign up forms online, we can also choose to only allow administrators to create users. But for this exercise, we are going to allow users to sign themselves up and make some use of our registration page. And we are giving 7 days for the temporary password set by administrators to expire if not used. With that, we are going to our next step, which is multi-factor authentication, which basically refers to your OTP, phone SMS, and phone call kind of authentication, which is an added extra layer to your regular username and password type authentication. This sort of MFA is usually applied when we are considering payment gateways and such things, which are highly crucial to have a robust security. In this page, you can also choose how will your end user be able to recover their account if they lose it. And you have a bunch of different options. You have your email and phone and various different options. I'm just going to leave all of this as is and move on to my next step. Now the next page is for message customization. Now this comes into play when a new user signs up for your app, and the app sends them a confirmation email with a link in it. Or sometimes there's also a code. So here we are using default Cognito to send emails, and for our verification message, we are going to use link instead of code, because that's just easier for the end user. So apart from this, we are going to leave this page as is and go to the next step. We're not going to worry about tags right now. Devices. No, we don't want to remember any devices. Now you have app clients. Now here we have to add our app client, which in our case is the React Starter app that we have. This will be given a unique ID and an optional secret key to access this user pool. I'm just going to call it app, and I am going to uncheck this generate client secret box just because it doesn't sit well with the JavaScript app that we have. We're going to clear this and keep only enable SRP. So whenever we want to make changes using the CLI, it is going to let us. So now we are going to create app client and click on next step. Triggers, we are not going to do any. So we're going to move to the next step. And finally, we are at the review page. So for some reason, my user pool name has not been saved. So we're just going to call it app pool. All right. And save changes. So now we create the pool. All right, our pool was created successfully. And for now, this is all that we need to do using the AWS UI. Now, the next thing that we're going to do is add some of these IDs to our source code. So let's go ahead and open up our code using Visual Studio. Now you can see your source files on the left. What we are going to do is we're going to go to source code, components, auth, and open the auth.javascript file. So this is our auth.js file. It looks like this. You have an object called config.config set. For some of you, this might be a separate file depending on the boilerplate you're using. Under that, you have several properties. You have region, identity pool ID, user pool ID, and the client ID. So all we have to do now is go back to our user pool and pick out all the details and fill them here and save the file. Yes? So obviously our region is US East 1. We don't have an ID because we do not have an identity pool. Here is our pool ID, again, our general settings. You'll find it in your general settings too. Now for the client ID, we'll have to go to app clients, and here you'll find your app client ID. Copy that and paste as well. And don't forget to save your file. All right. So now this is our landing page, very bare bones, very basic. You can click on sign in or sign up and you see this page opens up. You can go ahead and sign in with your email and password. For new users, you can also sign up. And as we had mentioned, all of these fields are required fields. You can also sign up with your email and password. It'll suggest you a strong password. And that is how you configure your sign up form using Cognito. Now, you guys have to agree, this was way simpler than all of the backend coding that you could have done instead of it, right? And that is how you create a sign up form with a few simple clicks, all using the AWS Cognito. Now, the steps might vary a little depending on the code of your app, but the basics will remain the same. You have to log into your AWS console and follow all the steps with Cognito. And in the end, just pick the credentials from your user pool in AWS Cognito and fill them up in your configuration or authentication file in your app source code. It's basically 3 or 4 simple steps if you think about it to make sign-up, authentication, and syncing extremely easy for individuals who are not yet comfortable with backend coding, right? With that, let's move on to the next section. Finally, before we close the session, let's discuss a few best practices for Amazon Cognito users. Now, a user pool and a user directory is created and configured first in the Amazon Cognito, either through AWS Management Console, AWS CLI, or SDK. Once this is done, you can download, install, and integrate AWS Mobile SDK through your app on iOS and Android. You also have a choice to call application programming interfaces directly for Cognito if you do not choose to use the SDK, as it uncovers all control and data APIs as web services so that you can consume them through a client library of your own. You can also monitor Cognito metrics and log application programming interface activities in real time as Cognito integrates with CloudTrail and CloudWatch. This will enable you to take necessary action for any suspicious activity or security threat that you see in those logs. Apart from that, you can also add multi-factor authentication or MFA to user pools to protect the identity of your users. MFA adds a second authentication method that does not rely solely on your username and password, which includes your SMS-based OTPs and text messages as second factor authentication in signing in your users. You can also use adaptive authentication with its risk-based model to predict when you might need another authentication factor. It's part of the user pool advanced security features, which also include protections against compromised credentials, which you might need to take a look at if you want to use Amazon Cognito for more than educational purposes.
So what is static website and how is it different from a dynamic website? So when you talk about static website, what you can see is that static website are a series of HTML pages where each HTML page is representing a separate web page for the website, right? So it displays the same information to everyone who accesses the static website. So with static website, every user has same information displayed. The entire thing is consisting of HTML, CSS. So generally there is no servers used in static website. So up next we have dynamic website. So what is dynamic website? A dynamic website uses server technology like PHP. Now PHP is something like that dynamic websites use because they want to create the web pages that the user visit dynamically when they're visiting the website. So when you talk about dynamic website, it is unique for each user that visits. The content that is there is unique for each viewer. For example, if a static website is, let's say, a basic HTML hello world page, a dynamic website would be the Gmail homepage where you have different content for everybody. So the login credentials are different, the passwords are different, your themes there are different. So it changes and it's different for everybody, right? And server-based technologies is used like PHP and many more, and it's deployed through a web app. So this is the basic difference between dynamic website and static website. So if I had to sum up, what we can see is that in static website, the same info is displayed to the users, while in dynamic website, the information displayed is unique for each user, right? And then static website consists mostly of HTML and CSS pages, while dynamic websites is based completely on PHP and other such server technologies. So you can dynamically create the website, right? And finally, we see that in static websites, there is no need for servers, while in dynamic websites, it is deployed through a web app. So there is server technology that is being used. Up next, we come to why host a static website on AWS S3. So why do we have to host a static website on AWS S3? Now, if you look closely, S3 allows you to basically host static websites. So it only hosts static websites, whereas there is a significant cut in costs because it has no server technology and no server is used, right? And if you look at the other services that are there that allow web hosting, you can see that even EC2 allows static web hosting, right? So it hosts both static and dynamic websites. So the server costs are already incurred because you are using servers for a backend, for a front end, for server technology, PHP, all of these are there. So backend is always required when it comes to hosting on EC2, which is not the case when it comes to S3, right? And then there is Elastic Beanstalk. So Elastic Beanstalk helps deploy the web app, right? The server costs are definitely incurred because even in Elastic Beanstalk, even if there's a web app, there has to be a front end, there has to be a back end. All of this has to be there. So server costs are always incurred. And PHP is used as the server tech here, just like in EC2, but unlike S3. So what we can see is S3 and EC2 can both host static websites. So why do I need to host my website on S3, right? So if you look closely, why use S3, right? So using S3, you can keep track of deployed website with zero maintenance cost. So you don't need any sort of server costs that you can incur for your company or anything like that. So that is not there absolutely. So you can do it for free. So the next point here is once you actually made a website and deployed it using AWS S3, it will always be virtually available until and unless maybe you delete the bucket, right? Finally, we see there are no server costs incurred and there's a massive reduction on costs. So this is why one of the main reasons why people use AWS S3 is because of the fact that you do not need server technology. So you save up on a lot of money that you could have spent on server costs for either yourself or your organization, right? So after this, we come to what is AWS S3. So if we talk about AWS S3, it's nothing but a storage service that is provided by Amazon Web Services. and it is basically something which is free tier accessible. Now, free tier is something that Amazon Web Services provides its users, where you can access services and its features for a certain amount of time or for a certain capacity, right? Then we can see that if you are free tier accessible, you can have 5 GB free storage that is available to you when you use S3. And then we see that no servers are required when it comes to AWS S3, so it reduces costs as well, which is our final point, which makes AWS S3 the most preferred hosting service on Amazon Web Services, which is because it is cost effective, right? So next we come to a demo where we'll show you how to host a static website on AWS S3. So log into your AWS Management Console and go to S3. So once you've gone to S3, what you need to do is you need to create a bucket where we basically put all our HTML files in. So let's name this bucket my AWS bucket 98, for example. Now you can see here it's written that the bucket name must be unique and must not contain spaces or uppercase letters. So you cannot leave spaces in between this name, right? So then we see the other things, which shows the region where your website is going to be hosted. It shows the object ownership. Now this is disabled. So all objects in this bucket are owned by this account and not you in general, right? So you cannot track this if it is disabled. But what we can see here is public access is blocked. So we need to host a website where people can access our website through the internet. So what we need to do here is just untick it so you can allow public access and just tick this. All of this is bucket versioning, which are other properties of S3 that are there. Encryption is disabled. All of this is disabled. There are advanced settings that we can check out if you want. There's the object log. So we just create the bucket now. So your bucket's created. Now what we need to do is fill up this bucket with your HTML files. Now, before you do that, what you can do is you can just go to properties and go to static web hosting and enable this, right? So enable this. And since we have the index document, which is the home page that we'll be going to, index.html, then we have the error document, which is displayed when there's an error, right? So we can just save these changes. So bucket hosting is now enabled, static hosting. What we need to do now is create a bucket policy so that, public access is enabled and people can access it on the internet. So you can just edit this, right? Right. So what we can do now is I have a bucket policy here, so we can just copy paste this and put it here. So what you can see here is here you have to put ARN AWS S3 and the name of your bucket, right? Once that is done, what you can do is save these changes and bucket policy is now there and this is publicly accessible, right? So we can just go back to this and upload folders now, right? So you can add these files now. So these are my index and error files, which goes in here, right? And you can just upload them. So these are now successfully uploaded and you have your HTML pages in your S3 bucket, right? Now what we can do is go back here and just go here, right? So we can just check this if this is working now because this shows it's publicly accessible. You can see this, Right. So this is the web page that I have for the index page, which is basically the home page that you get to see. So, and this is the URL which shows my bucket and as a website in this region, right? So now let's now check if my error page is working. Let's say XYZ and just, yeah. So this is the other page that I have where it's just written error page because there's an error. So you've basically added something else other than your URL specified. And once the wrong URL has been typed in, you have an error, right? So that is basically how you host a static website on AWS S3.
So why should you actually go ahead and consider this amalgamation of AWS and DevOps? I mean, I talked about AWS in particular, where I said that it is a popular cloud service provider which provides you with various services. DevOps again is an approach which lets you have a different look at building software applications. So why combine these two? Well, actually these two go very much hand in hand. I mean, AWS provides you with the meat or with the metal to actually go ahead and build the applications and support DevOps approach in a very good way. Let's try to understand how AWS and DevOps go well together. Again, this is a piece of text. I do not believe in general definitions. I like keeping things simple. So I'm going to talk about these things in a very simple perspective again. Let's try to understand these pointers straight away. Again, when you talk about AWS CloudFormation, why do we need it? We've already discussed what DevOps is. That is, it supports continuous integration and deployment. That means you'd be developing, you'd be having various instances, you'd be dealing with a lot of resources. So how do you keep track of all these things? So there are two resources or two services that AWS has to offer to you, which would actually simplify your job a lot. Now, AWS CloudFormation, what it does is it lets you create JSON templates basically. Those templates would let you kind of group your resources or the services that you use into a bundle so that you do not have to worry about keeping a track of all those things. In simple words or nutshell, that is what it does. It lets you have a template for your application which can be recreated again and again so that you do not have to do repetitive tasks, and your classification or your organization works actually becomes simplified. The other service which I also want to talk about is AWS CloudWatch. Now, it is something that lets you monitor your applications or your services in a much better way. That means whatever happens on AWS, it can be tracked by using AWS CloudWatch. So you know what happened at what time. That way you can keep track of all the developments that have taken place on your application building process. Then you have something called as AWS Cloud Pipeline, or Code Pipeline rather, sorry. So what AWS Code Pipeline does is it actually helps you automate the process of deployment and again integration. That means you'd be having a pipeline which lets you put in data so that you can put that data or move that data to your instances, or in simple words, your servers, so that you can have replications and you can run various applications on various instances or servers parallelly. Now, for people who have worked in this domain, or for people who have worked maybe even on big data or something like that, they might have come across the process of pipelining, and they actually know how difficult it is to create pipelines. I mean, you have to write scripts for that. This is where AWS simplifies your job. It makes sure that pipeline creation is very easy, and that is why the process of DevOps becomes much easier with AWS. Again, AWS instances are something which are very important, and the reason they are important is you would be dealing with a lot of resources. So how do you do that? You have AWS instances which let you run any kind of machine, whether it's a Linux, Windows. You can actually go ahead and scale it up, scale it down the way you want to suit your needs. And this happens at mere clicks. I mean, think about just upscaling a particular instance. All you have to do is just go ahead and say that I need a larger instance, and AWS does that for you, and that too with minimal rates as well. So all in all, it is a win-win situation for you. That is why when you talk about AWS instances in particular, they play a very key role in building fault tolerant and scalable applications. So these are some of these services. Now, as I mentioned, some of the services, if you actually do go ahead and research AWS website, you'd have so many services that actually help you go ahead and perform DevOps with ease. And what AWS does is it lets you have all the DevOps approach incorporated into AWS, thus making AWS a very potent or a very powerful cloud service provider to have with you. And as I've mentioned, there are various other services as well, but these are some of the key ones which I wanted to focus on. And I hope that by talking about these things, I've justified my point as in why AWS DevOps forms a good combo. Now let's move further and try to understand AWS certified DevOps engineer, as in let's try to understand what would this particular individual do and why is this particular certification valued. Yes, when you talk about AWS certified DevOps engineer, well, if you've ever taken a look at how AWS certifications work, you'd realize that they have some associate level certifications, and DevOps on the other hand is an advanced level certification where you'd be expected to have advanced knowledge of maybe solution architecting, your admin roles, and your development roles. And once you combine these roles and then you move further, you get into advanced certification, which is called as DevOps. It brings in your operations, that is your admin team's approach, and your developers' approach together. So you would be expected to go through the basic certifications and then combine them into this particular role. So if you talk about these individuals, they're actually responsible for maintaining, monitoring, and building applications. And probably you can actually go ahead and make careers in either of these individual domains as well. Given the fact that if you are certified in this particular domain, you would be a well sought after resource rather. So what are the skills that you actually need to go ahead and do, or what are your responsibilities that you would be concerned with? Well, first and foremost, you are expected to implement and manage continuous delivery and deployment, which again is a key if you talk about DevOps. And then you need to understand how this implementation works, and you need to understand a very important process called as automation, because time is a constraint here and automation is something that helps you. Plus, as an individual, you need to have an understanding of what access rights you have, what access rights customers should have, and all those things, and accordingly you have to go ahead and build a particular application. Define and deploy monitoring metrics and logging systems. Yes, monitoring is an important part. As we move further, we will be discussing that as well, do not worry. And then you would be expected to build fault tolerant and scalable applications. Finally, it says that you should be able to design, manage, and maintain tools that help you automate and build these applications. And guys, an important point to note here is you should be actually having an understanding of doing all these things on AWS. And the reason you need to have an understanding of this particular thing is, as we move into the demo part, you'd be understanding how easy AWS makes DevOps approach. So guys, let's move further and do one thing. Let's just go ahead and see how we can use AWS to do something that relates to DevOps. Now guys, while I do go ahead and perform this particular demo, if I've missed out on certain pointers, that is, we haven't talked much about AWS certified DevOps administrator, so we would be discussing that as well. And parallelly, I would be going through certain pointers if I feel that I've missed out on talking about something. So let's quickly switch into the demo part and see how we can utilize AWS and DevOps together. So guys, this is what the AWS console looks like. For people who do not have an AWS account, I would suggest that you actually go ahead and create an account. AWS gives you a free tier account in which you have free tier limit where you can use certain AWS services for free for one complete year. Now again, I won't be getting into the details of how can you create an account. You can actually go ahead and take a look at the other videos that we have on YouTube, and you'd get a clear guidance as in what are the steps that you need to follow to create an account. Once you actually do go ahead and create this particular account, this is the management console that would be there at your disposal, and it actually does wonders. Let's walk through that first and then move further and take a look at the demo part as well. So these are the services that AWS has to offer to you. You can see that these services are structured or built in such a way that they meet particular needs. Like these are all the compute services that are there at your disposal. You have some blockchain services, you have management and governance services. You basically have your analytics services and various other services. Again, we would be dealing with code pipeline today, so let's stick to that. So let me give you a picture as to what we are going to do now. Firstly, we would be building an application. So we would be using a template application. To do that, we would be using Elastic Beanstalk. Now, what Elastic Beanstalk is and why are we using it? Once we create the application, we would be having some 5 to 6 minutes of buffer where the application takes to build. And in that time, we would be actually going ahead and discussing why we used EBS and all those things, not EBS, Elastic Beanstalk. So once we have an application, I would be using code pipeline, and then I would be basically deploying my application to my instances. So guys, let's just go ahead and create an application first. To do that, either type Elastic Beanstalk here and you'd be having that, or you can just click on your history if you've used that in your recent times. So guys, this is what it looks like. I've refreshed my account so that it starts fresh. So you'd be getting started here, else it gives you the details about the applications that you've created. Having said that, let's just get started. So guys, creating an application in Elastic Beanstalk is very easy because it is platform as a service. When I say platform as a service, it provides you with a platform on which you have ready to use templates. You just have to put in your code or use the existing code to build an application. So the process becomes simplified. Again, this is where AWS comes into picture because it simplifies your task. We will be talking about this particular thing in detail, but that is after we create the application. First, let's give it some name, say demo. It's a fairly odd name, but let's stick with it. Demo sample app is what I'm going to call it. Platform. Again, as I've told you, it's a platform as a service, so you get to choose a platform. So let's say we want to build it on maybe PHP. Do I need to use my code? Right now, I would be using a sample code so that it stays short and simple. You can actually go ahead and use your own codes as well if you have any plans. And then you just click on create. At times, these processes take time, guys, because the reason it takes time is it would be summoning an instance, creating an instance. And as you can see, there's a log here. It would be telling you what is happening in the background. So guys, what happens exactly here is an instance is created. Again, you have security groups that are associated with it. Plus, you have IAM users and all those things that happen in the background. So that is why this process takes a longer while. Now, again, it being platform as a service. Now, if you all know what cloud computing service models are, you would understand that this particular service, that is a PaaS service, gives you a platform which is nothing but a ready to use template in which you have to put in certain details and then create an application. So again, if you were to create an application on your own, you'd be actually creating your own instance, your own security group, you'd be creating your own IAM user, and then you'd be putting in your code and then you'd be developing an application. But this is where PaaS service comes into picture. It simplifies this process of creating application. It gives you ready to use or templatized platform which you can actually go ahead and use to build an application. Now again, this building process might take a longer while, guys, so let's move further and build a code pipeline meanwhile, or at least fill in certain details. So how do we do that? Again, we come back, we click on services, and then we need code pipeline, which is here in my history. So I would be coming here and switching to this particular part. So meanwhile, our application is up and running, or it is getting created. What we are going to do is we are going to go ahead and try to create a pipeline. So how do we do that? We click on this icon, create pipeline. Okay. It says, do you want to use a new console? I do not want to. I would be happy with using my previous console as well. If you need a better experience, you probably want to switch into something new, you can do that as well. You can always have this option of coming back to this particular interface as well. So guys, pipeline settings, I need a pipeline name. So let's call it, say, sample pipeline. There you go. Now it would ask me, do you want to use an existing role? If you had one, you could have used that. If no, you can create one. So by default, that is the one, and this is the role name that it is creating. Allow AWS Code Pipeline to create a service so that it can be used with the new services, what is asking, or the pipeline. Do you want to do that? I would say yes, let's stick with it. And again, where do you want to store your artifacts? Well, for now, let's store it in the default location. When I say the default location, what it does is it probably creates a bucket if there's none, and then it stores data into it. You can actually go ahead and specify a particular bucket as well. In case if you have certain data that you've already created and put it in a bucket, you can actually go ahead and customize the location and change it here. For now, let's stick to the default one so that it creates a bucket for this particular job. And then I say next. Source provider, guys, we would be actually going ahead and deploying our application. So for that, I need a piece of code which I'm gonna go ahead and pick from GitHub. Now again, I happen to tumble or fall across a particular piece of code and I would be using that. I'm not sure it is the best piece of code, but that should do my job for now. So let's just go ahead and say GitHub because I want to pick it from there. Connect to GitHub. I have an account on GitHub, so I would be authorizing that account. It has authorized that account here, and again it would be asking me for that particular GitHub file or the repository. Now repository is nothing but a piece of code that is there which you can actually copy and use for your own sake or make a duplicate copy of it. So I'm actually gonna go ahead and make a copy of it. So I probably have this particular link here. I'm gonna copy it and paste it. Not worry guys, I would be sharing the link with you people as well. Once the session goes on YouTube, you can actually have that link as well. So this is what it says. It is some old account, that is why it says Vishal ServiceNow, because I used to work on ServiceNow back then. And again, branch, pick it from the master branch is what I would say. Yes, there you go. GitHub Webhooks, stick with it, no problem. So when I say next, an application would be created here. No, wait, we have to actually go ahead and give in a build stage. In this case, we don't need to do that. So I'm going to say skip. Yes. And I need to find a deployment provider, for which we are actually going ahead and creating an application. That is our AWS Elastic Beanstalk. There you go, guys. So that would be approved. Application name, ours is demo sample app, if I'm not wrong. Yes. And the environment is demo sample app env. I hope I've entered this data correctly, but that is what it should be. Guys, let's check whether our application is up and running. I'm gonna refresh this particular piece of, yes guys, it's green. That means the application has been loaded. Now again, one important point that I would like to mention is I talked about everything getting created in the background. So you can have information about everything that is happening, as in at what time what happened. They've checked the environment health, as in whether the instances are up and running, whether the instance was launched successfully, how was the application, or what were the processes that were implemented, everything. See, it was waiting for EC2 instance to launch. Now that is a type of an instance which was launched. We would be taking a look at that as well. But see, it has notified saying that it might take few minutes. So meanwhile this was happening, we actually gone ahead and put in the details for our code pipeline. So guys, this application is up and running, and our code pipeline is also almost up and running or ready to go. So let's say next. It would give you a peek, as in, okay, these are the details that you've entered. Do you want to commit these details? And I would say, please create a pipeline. Guys, while it creates this particular pipeline, let's just go ahead and take a look at, okay, no, wait, I believe it has done the process quickly. So we can actually wait for half a minute. Maybe. So guys, first your source would get into picture and it would see whether the source jobs are done, that is getting in the GitHub repository and then actually going ahead and fetching in that particular repository. So it has done that. Now the next step is to deploy this particular application. So guys, meanwhile this application gets deployed on my instance, I would be showing you that, do not worry. Let's just take a look at something else. Now if you type AWS certified DevOps engineer, you come across Edureka's live. That is not something that you want to see. If you talk about AWS, this is the page I would want you to visit. For now it is in some other language. It asked me whether I wanted to translate it. I said no. You can actually go ahead and translate it to English if you know English. If you know this language, you can do that as well. So guys, here's the information where you can actually go ahead and find out, as in, okay, what are the roles and responsibilities? How does the exam shape up? What are the what is the fees? How much time do you need to invest in all those things? So you can visit this website and get all the information. Again, if you're looking for a structured training, there are people who normally prefer structured training. In that case, you can actually go ahead and try out this website as well, where at Edureka we have this course, which would be, it has already been launched, but the first session would start somewhere in the end of the month, and you can actually go ahead and take this particular session. The fees is very less, and probably if you stay tuned with Edureka's channel, you might get more discounts as well, because this price is very real time. Again, you can get all the information, as in what is the course curriculum and stuff like that, what are the topics that would be covered, duration and all those things. So if you wanna take a structured approach, which is a very good thing to do if you want to actually go ahead and succeed in this certification, this won't be that bad of an option. Let's just go back and see whether our pipeline is up and running. As you can see, guys, the code has been deployed. So you can actually go ahead and make changes to this particular stage, guys. When I say continuous deployment and integration, you can see you always have an option of editing, where you can actually go ahead and make changes to the piece of code that you've uploaded. You can actually go ahead and make changes to the storage, monitoring rules, and all those things, the IAM user that you've attached. So everything can be changed, and that is why AWS makes this DevOps process very feasible, because it helps you automate all these processes. So guys, now that our application is up and running and the code has been deployed, let's see whether it reflects. So how do we check? Well, you can just come here and click on this service, go to EC2. Probably there should be some instance that was launched by our application. You can see one instance is running. Demo sample. So this is our instance, guys. So if I just go ahead and copy this IP address here, if I just paste it here, if I click on it, it says congratulations, pipeline has been created and your instance through the S3 bucket has been deployed. Now there's one error here. It says 3 Amazon EC2 instances. The reason it does that is because, as I've told you, I've picked up a code from GitHub, and the fact that that person might have coded or hard coded this particular piece of application like that, or the notification like that. So you can actually just go ahead and go to your code pipeline, and you can make changes to the application that you've built. So I'm not going to go ahead and make changes to it, but I'm just going to tell you like how would you do that. I mean, what is the process that you actually need to do. So you can come here, you can say edit. You have this option of editing your source. You have your GitHub repository, which you can actually again go ahead and make changes. Suppose you have this particular session, you come here, you say edit. So you have your source, right? So again, this piece of code where, yeah, you've actually gone ahead and connected this particular thing. So this is where your repository lies, right? So this place, if you come here and you open your particular application, you'll realize that there's an index.html file. In that place, there must be code somewhere which says, okay, see, this is where the message has been displayed saying that this is what has happened. So you can actually make changes to the code, you can update it. And once you do that, you just come back here, you commit those changes, guys, and again, your continuous deployment, your integration, it continues.
Let's move on and compare AWS DevOps versus Azure DevOps. So let's talk about the services that it provides. The Amazon Web Services code pipeline is a continuous delivery service for fast and reliable application updates. Code pipeline builds, tests, and deploys your code every time there is a code change based on the release process models you define. On the other hand, Azure DevOps services for teams to share code, track work, and ship software. Azure DevOps provides unlimited private Git hosting, cloud build for continuous integration, agile planning, and release management for continuous delivery to the cloud and on-premise. It also includes a broad integrated development environment support. In the next comparison, we will talk about what category of tech stack do they belong to. As you can see, Amazon Web Services code pipeline belongs to continuous deployment category of the tech stack, while Azure DevOps can be primarily classified under integrated development environment tools. Now let's talk about the features of Amazon Web Services and Azure. As you can see, Amazon Web Services provides workflow modeling, AWS integration, and it also has some pre-built plugins in it. Whereas Azure, on the other hand, provides agile tools like Kanban boards, backlogs, Scrum boards, And it also provides reporting tools like dashboards, widgets, Power BI, etc. And it also allows you to integrate with Git, which provides free private repositories and pull requests. Now, why do people like AWS is because it is extremely simple to set up, whereas Azure, on the other hand, is a complete package. It's full and it's very powerful. Now, let's move on and check out the uses of AWS and Azure. As I've already mentioned, AWS is extremely simple to set up. It also has several managed services. It can be easily integrated with GitHub, and it also has parallel execution. Deployment is completely automatic, and there are manual steps available, so you're never lost. Azure, on the other hand, supports open source. It also has several integrations. That is, it can be easily integrated with GitHub and Jenkins. It also has several project management features. And the most important plus point of Azure is that it is free for stakeholders. I hope the uses between AWS and Azure are extremely clear. Now let's move on and talk about AWS and Azure clients. So Amazon Web Services is used by companies like PlayHQ, Affirm, Curo Education, Youppi, Ready4, and Bitbank Incorporation. Whereas Azure has clients like Microsoft, Kingsman Software, Evodeck Digital, Muse, Energy to Market, and QR Point. Now, the next important difference is with what tools that these cloud services can be integrated with. Amazon Web Services, as you can see on the screen, can be easily integrated with GitHub, Jenkins, Amazon EC2, Amazon S3, AWS Elastic Beanstalk, Run Sqoop, and CloudBees. Azure, on the other hand, can be easily integrated with Git and GitHub, Docker, Slack, Jenkins, Trello, and Visual Studio. Now let's move on and compare the salary of an AWS DevOps engineer and Azure DevOps engineer. As you can see on the screen already, the median salary for an AWS DevOps engineer is rupees 4,67,000 rupees, whereas the median salary for an Azure DevOps engineer is about rupees 6,04,000 rupees a year.
Now let's start with the basic level questions. The first question is, what is AWS? AWS is nothing but Amazon Web Services is a cloud computing platform offering over 200 services, including infrastructure as a service, platform as a service, and software as a service. It provides scalable, cost-effective solutions, computing power, database storage, and content delivery services. It helps businesses scale and manage their operations efficiently and affordably. Moving on to the next question. What is EC2? Amazon Elastic Compute Cloud is a web service that enables users to create and run virtual machines in the cloud. It aims to simplify web-scale cloud computing for developers by providing secure, resizable compute capacity. This allows developers to easily run applications and scale them as needed. The next question is, what is S3? Amazon Simple Storage Service is a cloud-based, scalable, and secure object storage service that enables users to store and retrieve data from anywhere. It offers industry-leading scalability, data availability, security, and performance. With S3, you can easily manage and scale your storage needs, making it perfect for backups, archives, and handling large amounts of data efficiently. The next question is, what is a VPC? A virtual private cloud is a secure, isolated private cloud hosted with a public cloud. It allows customers to run code, store data, and host websites. VPC roles define which peer devices process, bridge protocol data units, and respond to address resolution protocol requests, allowing for seamless integration with public cloud providers. In simpler terms, a VPC provides a private network within the cloud, giving you control over your resources, network configuration, and security settings, while still benefiting from the scalability and flexibility of the public cloud. Here is the next question. Explain AWS Lambda. AWS Lambda is a serverless computing service that allows users to build applications without managing servers. It's ideal for applications that need to scale up rapidly and scale down to zero when not in demand. It allows users to execute code in response to events like data changes. In other words, Lambda automatically handles the infrastructure for you. So, you can focus on writing code and responding to events without worrying about server management, making it cost-effective and flexible solution for modern applications. The next question we have is, what is autoscaling? Autoscaling is a cloud computing feature that automatically adjusts resource allocation based on a user demand, monitoring metrics like CPU usage and incoming traffic. It allows organizations to scale cloud services like server capacities or virtual machines up or down. In other words, autoscaling adjusts resources automatically to match your needs, ensuring efficient performance and cost savings. It helps handle changes in demand without manual intervention. Here is another question. What does ELB stands for? In other words, autoscaling adjusts resources automatically to match your needs, ensuring efficient performance and cost savings. It helps handle changes in demand without manual intervention. In simpler terms, ELB helps evenly distribute traffic to your servers, ensuring no single server gets overwhelmed. It automatically adjusts to handle traffic changes, keeping your applications running smoothly. Here is another question. Define CloudFront. Amazon CloudFront is a self-service, pay-per-use content delivery network service from AWS that securely transfers global content, including static and dynamic files, without long-term commitments or minimum fees, ensuring high performance and security. CloudFront speeds up the delivery of your website content to users worldwide and protects it with strong security measures, all while being cost-effective and easy to use. Moving on to the next question. What is RDS? Amazon Relational Database Service is a cost-effective web service that enables users to set up, operate, and scale relational databases in AWS Cloud. It enables efficient data storage, organization, and access for business purposes like modeling, reporting, and analysis. An easy way we can say, RDS makes it easy for you to manage your databases, handle your data efficiently, and focusing on using that data for your business without worrying about the underlying infrastructure. The other question we have here is, what is DynamoDB? Amazon DynamoDB is a serverless, key-value NoSQL database service optimized for high-performance applications. It delivers single-digit millisecond performance at any scale, improving relational database performance. Or in other words, DynamoDB allows you to quickly and easily manage your data, giving you fast access to information without the hassle of server management. So, you can focus on building great applications. Moving on to the next question. Explain Route 53. Amazon Route 53 is a DNS web service that connects user requests to internet applications on AWS or on-premises. It translates domain names into IP addresses, allowing computers to communicate and verify reachability, availability, and functionality. Route 53 helps you ensure that when someone types your website's address, it gets directed to the right place quickly and reliably, making sure your site is accessible and working properly. The other question we have here is, what are security groups? A security group in AWS acts as a virtual firewall for EC2 instances, controlling incoming and outgoing traffic. It filters traffic based on rules, allowing users to specify protocols, ports, and IP addresses. These security features are crucial in cloud computing to ensure the security of resources and maintain a secure network environment. In easy way, security groups help you protect your EC2 instances by controlling what traffic is allowed in and out, keeping your resources safe and your network secure. Here is another question. Difference between public and private subnets in AWS. The key differences between public and private subnets in AWS are: in public subnet, resources can access the internet directly. But in private subnet, resources cannot access the internet directly. The public subnet is connected to an internet gateway, but the private subnet has no direct route to any internet gateway. Lastly, public subnet used for public-facing applications like web servers, but the private subnet used for sensitive data and internal applications. Let's move on to the next question. What is IAM? AWS Identity and Access Management is a web service that enables users to control access to AWS resources and services securely. It is a cybersecurity discipline that deals with user access to digital resources and their usage. IAM systems prevent hackers and ensure users have the necessary permissions to perform their tasks ensuring that only authorized users can access AWS resources. Or in other words, IAM helps you manage who can access your AWS resources and what they can do, keeping your data safe and ensuring that only right people have the right permissions. Let's move on to the next question. Define EBS in Amazon. Amazon Elastic Block Store is a scalable, high-performance storage service from AWS that is designed for Amazon Elastic Compute Cloud instances. It allows users to create storage volumes and attach them to EC2 instances, enabling them to create file systems, run databases, or use them in various ways. EBS is easy to use and scalable. Or in other words, EBS provides you with flexible and reliable storage that you can easily connect to your EC2 instances, helping you store and manage your data efficiently as your needs grow. The next question here we have is, what is SQS? Amazon Simple Queue Service is a managed message queuing service in AWS that enables users to send, store, and receive messages between software components. Introduced in 2004, it decouples and scales distributed software systems and components, supporting programmatic message sending through web service applications over the internet. Or, in other words, SQS helps you manage communication between different parts of your application by queuing messages, making it easier to handle data flow and scale your system effectively. Let's see the next question. What is CloudFormation? AWS CloudFormation is a service by AWS that enables developers and businesses to create and manage AWS and third-party resources in an orderly and predictable manner. It provides templates for defining and setting up cloud infrastructure, allowing users to define and deploy applications and services as code, even without technical knowledge. It simplifies management, scaling, and updating of cloud resources. The next question is, explain Cloud Trial. Cloud Trial is a service by AWS that tracks user activity and API usage, aiding in auditing, security monitoring, and operational troubleshooting. It records all modifications and API calls in an AWS account, enabling the identification of potential security issues and compliance requirements. In simpler terms, Cloud Trial helps you keep track of everything happening in your AWS account, making it easier to monitor security, troubleshoot problems, and ensure you're meeting compliance standards. Let's see the next question. What is the shared responsibility model? The shared responsibility model is a framework that outlines the responsibilities of a cloud service provider and a customer in securing cloud services and data. It suggests that two or more parties play a role in ensuring security of distinct elements within the public cloud environment. AWS is responsible for protecting the infrastructure running all services offered in AWS Cloud. The last question in the basic level is, what is the well-architected framework? The AWS well-architected framework is a set of best practices designed by AWS to help businesses build and operate efficient, secure, and reliable cloud-based systems. It guides how well your architecture aligns with cloud best practices, covering aspects such as operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. In simpler terms, this framework helps you design and maintain your cloud systems by providing guidelines to ensure they are effective, secure, and cost efficient, covering all the key areas of the successful cloud setup. Now let's start with the intermediate AWS interview questions. The first question we have here is, what are EC2 Spot instances? In AWS, EC2 Spot instances is a virtual server that lets you use extra cloud capacity at a big discount, up to 90% cheaper than regular prices. You can place a bid to use it, and as long as your bid is higher than the current price, you can keep running your server. The next question here we have is, what is Elastic Beanstalk? Elastic Beanstalk is a service that helps you easily deploy and manage web applications on AWS. It supports different programming languages like Go, Java, .NET, Node.js, PHP, Python, Ruby, and even Docker. Elastic Beanstalk automatically handles the setup, such as creating a runtime environment, managing servers, and scaling the application as needed. Moving on to the next question, what is a NAT gateway? A NAT gateway is a service in AWS that allows your private servers to connect to the internet. For example, if your servers need to download updates or access external web services, they can do so through the NAT gateway. The next question we have is, what is an elastic IP? An elastic IP is a static, public IP address provided by AWS that you can assign to your resources, such as an EC2 instance, unlike a regular IP address that might change when you stop or restart your instance. An elastic IP remains the same, making it easier to manage your connections and ensure your server is always accessible at a consistent address. Here is another question. What are S3 lifecycle policies? S3 lifecycle policies are rules that you configure in AWS to automate the management of your data stored in S3. These policies allow you to automatically transition objects between different storage classes based on their age or delete them when they are no longer needed. For example, you can set a policy to move files that haven't been accessed in 30 days to a cheaper storage tier like S3 Glacier, or to delete objects after 1 year. The next question we have is, what is RDS Multi-AZ? RDS Multi-AZ is a feature in AWS that enhances the availability and reliability of your relational database. When you enable Multi-AZ, AWS automatically replicates your database to a standby instance in a different availability zone with the same region. Let's move on to the next question. How does Lambda scale? AWS Lambda scales automatically based on the number of incoming requests. When your function is triggered, Lambda runs an instance of it. And as more requests comes in, Lambda creates additional instances to handle the load. This scaling happens in real time, without any need of manual configuration. Lambda can handle thousands of requests per second, and it scales up and down as needed, ensuring that your application remains responsive under varying loads without any extra infrastructure management. Now let's see the next question. What is a network ACL? A network ACL, that is access control list, is a layer of security that acts as a virtual firewall for controlling inbound and outbound traffic at a subnet level within your VPS. Each network ACL has a list of rules that either allow or deny traffic based on IP address, protocol, or port number. These rules are stateless, meaning both inbound and outbound rules must be explicitly defined. Network ACLs help you protect your AWS environment by filtering traffic before it reaches your instances, adding an additional layer of security. Here is another question. How do you secure S3 buckets? Securing S3 buckets involves several best practices. First, set proper permissions, that is, ensure that only authorized users and services can access the buckets by setting appropriate IAM roles and bucket policies. Then is use encryption. Enable server-side encryption to protect your data at rest, and consider using SSL, TLS for data in transit. Then is enable logging. Set up S3 logging to track access requests, which can help you monitor and audit bucket activity. Let's see the last question of the intermediate level. What are CloudWatch alarms? CloudWatch alarms are monitoring tools within AWS that helps you keep track of your resources by sending notifications when specific metrics exceed defined thresholds. For example, you can set up an alarm to notify you if CPU usage on an EC2 instance goes above 80% for a certain period, or if the available disk space drops below a certain level. These alarms can trigger automated actions like scaling your application, rebooting an instance, or simply sending an alert to your email or SMS. Now let's move on to the advanced level, where we will discuss the scenario-based questions. So here we have the first question. How would you design a highly available, fault-tolerant architecture for a web application that requires minimal downtime during maintenance and unexpected failures? The answer here is, to design a highly available and fault-tolerant architecture, use multi-AZ deployments. Deploy your application across multi-availability zone to ensure high availability. For databases, use Amazon RDS with multi-AZ deployments to ensure automatic failover. Then, implement load balancing. Use an application load balancer to distribute traffic across multiple EC2 instances in different AZs. Then, auto-scaling. Set up auto-scaling groups to automatically adjust the number of instances based on demand and health checks. Next, health checks and monitoring. Use Amazon CloudWatch to monitor instance health and also set up alarms for automatic recovery actions. Lastly, we have blue or green deployments. Utilize AWS Core Deploy or Elastic Beanstalk's deployment policies for blue or green deployments to minimize downtime during updates. The next question is, your application requires low latency access to data stored in S3, but you have users distributed globally. How can you optimize the data access performance? The answer we have is, implement Amazon CloudFront as a content delivery network to cache and deliver S3 data from the edge locations closer to your users. Additionally, use S3 transfer acceleration to speed up uploads and downloads. Moving on to the next question. Describe how you would secure data in Amazon S3, ensuring that access is controlled and data is encrypted at rest and in transit. To secure data in Amazon S3, firstly, enable encryption. Use server-side encryption with AWS Key Management Service to encrypt data at rest. For in-transit encryption, ensure SSL TLS is used when accessing S3. Next is implement bucket policies. Set up bucket policies and IAM roles to restrict access based on user or service requirements. Then, use access control lists. Configure ACLs to grant or deny access to specific users or groups. Here is another scenario-based question. You need to ensure that a critical application can automatically recover from regional outage and continue to serve users with minimal decryption. How would you architect this solution? The answer is, deploy the application across multiple AWS regions using Amazon Route 53 for DNS failover and AWS Global Accelerator for global traffic management. Implement cross-region replication for databases and use auto-scaling groups across regions. Here we have the last scenario-based question. How would you architect a scalable, fault-tolerant data processing pipeline using AWS services? To architect a scalable, fault-tolerant data processing pipeline, first point is data ingestion. Use Amazon Kinesis data streams or AWS Glue to inject and process data in real time. Next is data storage. Store raw data in Amazon S3 for durability and cost-effective storage. Then we have the data processing. Use AWS Lambda for serverless processing or Amazon EMR for large-scale data processing tasks. Then we have the data transformation. Utilize AWS Glue for ETL operations to prepare data for analysis. Next, data analytics. Use Amazon Redshift or Amazon Athena for data acquiring and analysis. Last we have is the fault tolerance. Implement retries and error handling in Lambda functions and use S3 versioning to recover from data corruption. In summary, preparing for an AWS interview requires a solid understanding of core AWS services, architecture best practices, and hands-on experience with cloud solutions. As focused on key topics like EC2, S3, Lambda, IAM, and VPC, as well as concepts like scalability, security, and cost optimization. Practice explaining your real-world experiences and stay updated on new AWS features. With clear, concise answers and confidence in your knowledge, you'll be well equipped to tackle any AWS-related interview questions.
And with this, we have come to an end to this full course on AWS DevOps. If you enjoyed listening to this full course, please be kind enough to like it, and you can comment on any of your doubts and queries. We will reply to them at the earliest. And do look out for more videos and playlists and subscribe to Edureka's YouTube channel to learn more. Thank you for watching and happy learning.